Are you ready to master the Microsoft Fabric DP-700 certification? In this 11-hour course, you will learn everything you need to know to pass the DP-700 exam with ease. We will go through 26 episodes, each one of them covering a key topic about Fabric, using theory slides, hands-on tutorials, and realistic exam-style questions to test your knowledge. And now, let's get started and get you that DP-700 badge. Before we get started with the course, I will introduce myself quickly so that you know who is this guy behind the screen who is helping you to pass the DP-700 exam. So, my name is Aleksi Partanen and I have over 7 years of experience working as a data engineer and architect. Currently, I'm working for a top-tier Microsoft partner company with headquarters in Finland that provides state-of-the-art data platforms using Microsoft Data Platform Stack. I'm also one of the co-founders of the CertiAce platform that offers high-quality practice questions to Microsoft certification exams like DP-700. And I have been teaching Microsoft Data Platform topics on YouTube since 2023 when I uploaded my first Azure Data Factory tutorials. Nowadays, I only focus on Microsoft Fabric related topics and I have made over 100 different Microsoft Fabric videos on YouTube. And lastly, I have currently 6 different Microsoft certification badges, including the DP-700 badge that I'm helping you to get in this series. So I would say that I'm quite experienced with Microsoft certification exams and know what I'm talking about when it comes to preparing to those. Next, let's do a quick overview what we are going to learn in this course. First, we have the intro episode that you are currently watching, and here we cover the overview of the course. In the episode 2, we go through the scope of the exam to understand the skills we need to master in order to pass. Then in the third episode, we are going to cover the core terms and concepts of Microsoft Fabric in order to understand the basic building blocks of the platform. In the episode 4, we are exploring the different programming languages like SQL, PySpark, and KQL that are in the scope of the exam. Then we move on to event streams. This is where we learn how to capture and process real-time data in Fabric. In the episode 6, we dive deeper into event stream with windowing functions that are key concepts to understand with event streams in the DP-700 exam. After that, we cover data pipelines. This episode explains how to build end-to-end data movement and transformation workflows. Next, we take a look at Dataflow Gen2, which is a low-code way to transform and prepare data using Power Query inside Fabric. In the episode 9, we work with notebooks. We will learn how to run and test your code with this collaborative development tool. Then we go through Spark settings. This episode helps us to understand how to control performance and behavior of Spark in Fabric. After that, we dive into Spark structured streaming. This is a powerful feature for handling real-time data with Spark. In the episode 12, we explore the Lakehouse. That is one of the main data stores in Fabric. Then we move on to the next data store in the episode 13 and cover Warehouse. In the episode 14, we focus on data modeling and especially focus on slowly changing dimensions, since those you need to know in the DP-700 exam. Next is Eventhouse, that is a specialized data store for analyzing time-based data like logs and telemetry at scale. Then we move into mirroring, that is a very powerful data virtualization feature in Fabric. Then episode 17 is about access control. We will learn how to manage permissions and protect data in Fabric. In the next episode, we will cover OLS, RLS, and CLS. These are different ways to secure your data at object, row, and column levels. Then we talk about dynamic data masking. This feature helps you to hide sensitive information in your tables. After that, we explore governance features of Fabric like tags, endorsements, and sensitivity labels. Then comes version control, which means that we will learn how to use Git repos in Fabric. In the episode 22, we talk about deployment pipelines and learn how to deploy changes from one environment to another. Then we cover SQL Database Projects that offers an alternative method for doing changes and deployments with Warehouse. In the episode 24, we take a look at choosing tools and data stores. This helps you to pick the right tool for the right job inside Fabric. That is a key skill in the DP-700 exam. Next is Activator that allows building alerts and triggering items like notebooks and data pipelines based on events like file creations. And finally, we cover monitoring to understand what kind of monitoring features we have in Fabric to get information what is happening in our platform. And these are all the topics that we have in this video. But wait, there's more. And as a bonus, we have a special episode with tips and strategies to help you to pass the DP-700 exam with confidence, since things like time management strategy are crucial for passing this exam. This episode is for channel members and can be found on my YouTube channel. Also, all the slides that I will be presenting in this series are available for channel members to download. Next, let's cover the basic structure of each episode in this series so you get a better idea how you are going to learn things in this series. Almost every episode is divided into 3 sections. In the section 1, we are going to learn about the topic at hand. So this section is mostly going to be a slideshow about the topic. In the section 2, we are going to fire up Fabric and do some hands-on demos/tutorials there to get some hands-on experience with the topic to really understand what the topic is about. I would encourage everyone to do all the tutorials with me if you have the possibility to do so. Also, afterwards, I would encourage you to expand the tutorial a bit more, and I will try to give you some ideas that you could do on your own to get some more hands-on experience with the topic. Then in the last section of the episode, we are going to have some exam-like questions that are going to test your knowledge about the topic. These questions will be very similar in nature to those that you will see in the actual exam, and these questions will help you to validate that you really understood the topic in the episode, and you are ready to move on to the next topic. So the goal of each episode is to understand and get some hands-on experience with each topic, since after you have understood the topic, you don't have to rely on your memory so much in the exam. Next, let's talk about some helpful background knowledge for this exam. Since this is an associate level exam, it is already aimed at people who have been working in the field for a while. However, this doesn't mean that a complete beginner can't pass this exam. It will just require more work. First, I would say that if you know some data engineering basics, like how data flows from one data layer to another, then you have some solid background knowledge to learn the topics covered in this exam. Even though semantic modeling and Power BI are out of the scope for this exam, some data modeling basics are still needed, since this exam requires you to know the basics of dimensional data modeling. This exam will require you to know at least the basics of 3 programming languages, which are SQL, Python/PySpark, and KQL. We will cover the basics of each language in this series to help you to learn them if you are not already familiar with all of them. Then lastly, since this is an IT exam, some general IT skills are very beneficial, like knowing how to use version control like Git and how CI/CD processes and pipelines work. And also some general security practices like least privilege principle are very helpful to know in advance. And before we get started, I would encourage you to join my Discord server, where you can connect with other people taking the exam and share and discuss additional resources for passing it. The number one rule in that community is that no toxic behavior is tolerated, so it should be a helpful and welcoming place for everybody. Link to the Discord server can be found in the description. This is the episode 2 in this DP-700 exam prep series, and in this episode we will cover the scope of the exam and the most essential tools to know for the exam. After watching this video, you will have a solid understanding of what you need to know to pass the exam. But now let's get started. Let's first talk about what are the skills that are needed for this exam. Questions in this exam are divided into 3 different sections. All of these sections are roughly worth of a third of a points in the exam. The first section is about implementing and managing an analytics solution. Now let's dive a bit deeper into this section to understand what kind of things you need to know. First, you need to know how to manage Fabric workspace settings, which means managing Spark, domain, OneLake, and data workflow settings. This means that you need to have a solid understanding of Fabric settings and capabilities to do changes to those settings if needed. Next, you need to know about implementing lifecycle management, which means things like version control, database projects, and deployment pipelines. If you're working as a data engineering fabric environment and doing things even remotely properly, you should be encountering things like version control and deployment pipelines almost daily in your work. Thus, in my opinion, these things are an integral part of data engineering. Then you have to have some knowledge of how to configure security and governance, since data engineers should have the understanding of building secure data solutions in a world where new data regulations keep popping up every year. At least if you live somewhere in the European Union, you know what I'm talking about. So you need to know how to configure access on different levels from workspace level to very fine column and row levels. Then you need to know how to implement data masking and adding different sensitivity labels for your items and how to endorse different fabric items. Lastly, in this section, you need to know how to orchestrate your data solutions. That is obviously a huge part of building production-ready data solutions. This means that you know when to use different tools like data pipelines, data flows, and notebooks. Then you have an understanding about scheduling and running your data solutions with an event-based trigger. Also, this orchestration covers using some dynamic elements like parameters and dynamic expressions to make your data solutions more dynamic. The next section we have in this exam is about ingesting and transforming the data, which are the core activities that come to mind when thinking about what data engineering is all about. Also, in my opinion, this is probably the best part of data engineering, and I tend to enjoy this part the most. But let's break down this section to understand what all of these fun activities are that we get to do as data engineers. First, you need to know how to design and implement different loading patterns. For example, is your data solution fetching all the data from the source every day, which means a full load, or does it utilize some type of incremental load, which means that only a subset of the data is received daily? Even though data modeling is not playing a huge role in this exam like it is in DP-600 exam, we still need to understand some core principles of dimensional data modeling, since this exam will require you to know how to load data into dimensional data model. Then you need to know how to ingest and transform different types of data. First, we have the batch data, that is the most traditional form of data, and this just means that data is arriving in some type of sets, or in other words, batches. You have to know about different fabric tools and which data engineering tools to use in different scenarios. For example, which tools are you going to use to ingest the data, or are you going to use a data virtualization method like a shortcut or mirroring, bringing the data to available fabric without actually copying it over. Then you have to know about the different data stores like lakehouses and warehouses and choose an appropriate data store for your data. Then you need to have the skills to transform the data using the programming languages that are used in those different fabric tools. And in the scope of this exam, those are PySpark/Python, KQL, and two different dialects of SQL, which are TSQL and Spark SQL. Also, you need to know some basic transformations like grouping, aggregating, and denormalizing the data. And those who have done data engineering previously know that everything doesn't work seamlessly all the time, and there could be some duplicates in the data, or it could be missing or arriving late. And you need to be prepared to handle those kind of situations. And this is also measured in the exam. Next, you need to know how to ingest and transform the data, for which Fabric has also many excellent tools for. And you need to have the understanding to pick up the right tool for the job based on the situation. In the scope of this exam, we have event streams and Spark structured streaming. Also, the concept of windowing functions is typically important to understand when dealing with streaming data, and thus that concept is part of this exam as well. Then we move into our third and last section of this exam, that is monitoring and optimizing an analytics solution. First, this section covers monitoring different fabric items, which means monitoring the different parts of the solution flow from the ingestion to refreshing the semantic model. Also, configuring alerts is part of this, since usually people want to be notified when something goes wrong than manually observe things daily. And after something has gone wrong, we need to do something about it. And thus, identifying and resolving errors is part of this exam. This means that you have the understanding of solving problems with the most essential tools in this exam, like pipelines, data flows, notebooks, event houses, event streams, and TSQL. Also, when doing data engineering, things can be done in multiple different ways, and sometimes there could be a huge performance difference between different methods, and optimizing performance is one of the important aspects of data engineering work, and thus it is also part of the DP-700 exam. This exam measures how you optimize performance related to some of the core items and tools covered in this exam, like Lakehouse tables, pipelines, data warehouses, event streams, and event houses. Also, optimizing Spark and query performance are also covered. And tada! This is the overall scope of the DP-700 exam. So if you feel comfortable that you know all of these things in the Microsoft Fabric context, congratulations to you. You can now turn off this video and you are ready to take the exam, and most likely going to pass it. However, if you are a bit unsure about these topics, keep watching, since we are going to dive way deeper into these topics. I know that for some people the number of skills measured in this exam can feel quite overwhelming, and next I want to highlight some of the key Fabric items/tools that most of the questions in the exam are going to be about. We can roughly divide those tools into data movement and transformation tools, and then to data stores. Many of you were already probably able to identify at least some of these core tools from the previous slide, but let's make them clear for everyone here. As a first data movement and transformation tool, we have the data pipeline. That is this no/low code tool that is very similar to Azure Data Factory or Synapse Analytics pipelines, if some of you have experience about those. This tool is mainly for integration, data movement, and overall orchestration, since it has very little data transformation capabilities. Then as a next tool, we have another low/no-code tool called Dataflow Gen2, that compared to data pipeline tool has a lot of data transformation capabilities, but it's not well suited for overall orchestration like the data pipeline. Then we have the Swiss Army knife of data engineering, that is of course the notebook. What comes to the data movement and transformation, this tool covers you in every front. However, notebook is a code-based tool, and you will need to know how to write code to use this tool. Personally, this is my favorite tool of these three, but has a steeper learning curve compared to data pipeline and data flow, especially if you are new to programming. Next, we have yet another no/low code tool called Eventstream that is meant for moving and transforming streaming data. Then we have the data stores covered in this exam. First, we have the Lakehouse that can store many different types of data, since it has the possibility to store raw files in addition to the typical table formatted data in the Delta tables. This data store integrates well with all just covered data movement and transformation tools, but I would say that the most native way to operate this data store is using a notebook. Then we have a warehouse that reminds a lot of typical Microsoft SQL databases, and like with those databases, Microsoft's dialect of SQL called Transact SQL or TSQL is used to operate this database. Also, people familiar with other Microsoft databases know that you can build stored procedures in those databases, and warehouse is not an exception to this. So that means that this data store acts as a data transformation tool as well. This data store integrates best with data pipeline and Dataflow Gen2 of the data movement and transformation tools that are part of this exam. Then as a last data store, we have the Eventhouse, which is a data store meant for handling streaming data, which means that this data store is most well suited to integrate with the Eventstream tool. Most of the questions in the exam are going to be about these tools and their usage. So in this series, we are going to start learning about these tools and then expand our knowledge later on with those other aspects like deployment pipelines, version control, and workspace management, etc. after we have learned these core tools and concepts and use these hands-on in the tutorials/demos that we are going to have in this series. Next, let's open up Fabric and let's have a quick introduction/overview of these core tools to get a better idea what we are going to learn next in this series. Now we are in Fabric. Let's just do a quick overview of the key Fabric tools that are part of the DP-700 exam that I covered in that last slide. Let's start with the data pipeline. Let's go to Create page and let's create a new data pipeline and let's name that according to our naming conventions. And then this opens up this pipeline development canvas. And here we can start to build our pipeline. And we can just select one activity to this pipeline. I can add one copy data activity. That is one of the most important activities in the data pipeline tool. And like I mentioned before, this data pipeline tool is this no/low code tool where we can just add these nodes or activities to this pipeline canvas and then execute them according to this logical order that we define in this pipeline tool. For example, we can add some more activities here. We can, for example, add a notebook and data flow activities. By adding these notebook and data flow activities to this canvas, we can see that this tool integrates very well with other Fabric tools. And thus, this tool is great for organizing your data solutions. And we could also add here an activity for refreshing the semantic model. So basically, with this tool, we could organize our entire data flow by extracting the data from the source and then processing that data and afterwards refreshing our semantic model to get that data available to Power BI. And like discussed, this tool itself has very little data transformation capabilities, but for this kind of a data flow orchestration, this is a wonderful tool. And we can also define some conditional logic and add some loops to this tool as well, but those are more advanced topics that we are going to cover later on. But yeah, now we're just scratching the surface what comes to this data pipeline tool, and there are some depth to this tool as well, and there are some expression language and parameters and variables that you need to learn if you want to master this tool. But we're going to come back to this tool in this series. Next, let's talk about the Dataflow Gen2 tool, and let's go back to the Create page and let's create Dataflow Gen2. And this will open up the Dataflow Gen2 canvas, and here we could add some data to this canvas. And I will connect this to a one data store that I have in Fabric, which is going to be my Lakehouse here. And I want to connect it to that Lakehouse and get some data from that Lakehouse. And here we could select the data that we want from this Lakehouse. And I have been using this Lakehouse as part of my data engineering series, so I have some data here. And I can, for example, pick this animals table here and click Create. And this will then add that data to this data flow canvas. And as we can see, this Dataflow Gen2 is this Power Query based transformation tool. And if you're familiar with Power Query, you can find this tool to be very similar to that. And here we could actually start to do some transformations to this data that we added here. We just have a couple of rows of data and a couple of columns there. And here we could add some transformation and maybe choose some columns. I would probably could just pick the name here and click OK. So we can see that this tool is also this kind of a no/low code tool where we can do transformations by just choosing different options from this UI. But yeah, like with the data pipeline tool, we are just scratching the surface here, and there is much depth to this tool as well that we're going to cover later on in this series. Let's close this data flow for now, and we don't need to save that. And let's go to one notebook that I have here. Here I have a notebook. Notebook is this code-based tool. And like I said, I would describe this as Swiss Army knife of data engineering, because you can do pretty much everything with notebook, even though it's not always reasonable to do so. For example, Dataflow and Data Pipeline have many great built-in connectors to different source systems, and with Notebook you would probably have to code the logic to integrate to those source systems, but with Data Pipeline and Dataflow you have those connectors available there, so you don't have to do a huge setup to get the connection to the source system. But what comes to the data transformations, I usually prefer this tool since this gives you a lot more options what you can do with your data, since you are allowed to write your own code. Of course, like I said previously, the learning curve for this tool is way steeper because you have to know some programming in order to use this one. And what comes to the programming languages that we can use with this tool, we have plenty of options here. For the Spark, we have Python, Scala, Spark SQL, and R. In the scope of DP-700 exam, we are only required to know Python and Spark SQL. So Scala and Spark R are out of the scope for that exam. Then we also have some Python notebooks that don't have Spark pre-installed, and also TSQL notebooks available here as well. But yeah, like with data pipeline and Dataflow, we are just scratching the surface tiny bit with this tool as well, and we will come back to this tool in this series later on. Next, let's talk about the Eventstream tool, and let's go to the create page and let's create one event stream, and let's name our event stream and let's create that one. And here we have the Eventstream development canvas, and then we can use some sample data that we have available here in Fabric, so we don't have to import our own data. And we can, for example, use this bicycles data here, and let's name our data source as bicycles and click add. And here we can see the actual Eventstream development canvas. And as you can see, this tool is also based on those kind of nodes or activities that we had in the data pipeline and a Dataflow tool. So this is also this kind of a no/low code tool that allows doing transformations using this UI. And for example, here we could add some new transformation, for example, some filter or something, and then we would be able to set up this filter using these UI elements here without doing actual coding work. And next, let's talk about the first data store. And this data store is going to be Lakehouse. And with this data store, we have the possibility to store tables or files, which means that this data store is actually able to store files of any format. We can store here, for example, CSV files, Excel files, video files, audio files, or whatever files we want. Because under this file section, we have this file system where we could add any files that we want. For example, here I have some CSV files. And then under the table section, we have some table schemas, and under the schemas, we have some tables, and these tables are actually delta tables. And delta is pretty much the standard format the Fabric is using, but we will come back to that in a later episode. Then as a next data store, we have the warehouse. And this is the data store that most closely resembles traditional SQL database. And here we have our database schemas. And under these schemas, we have these very traditional database objects that are tables, views, stored procedures, and functions. Under the table section, we can see, for example, this movies table, and we would be able to query these tables using TSQL by defining a new query here and start writing TSQL queries and able to query the data out from that table. And then as a last data store, we have the Eventhouse. And this data store is basically this kind of a workspace of KQL databases. And here I have just one KQL database in this Eventhouse, and we could actually define new databases to this Eventhouse by using this plus database icon here and just giving our database name here, and then we would be able to create more databases to this Eventhouse. But yeah, just now remember that Eventhouse is this kind of a workspace of KQL databases and is meant for dealing with streaming and event-based data. And now we went through the most essential Fabric resources to know for the DP-700 exam. Now let's have some practice questions. Our first question today is, which one of these programming languages is not part of the DP-700 exam? A. Spark SQL, B. KQL, C. DAX, D. TSQL, E. Python/PySpark. Now think about the answer to this question for a moment and pause the video. I will reveal the answer to this question in 3, 2, 1. So, the correct answer is C, DAX. Since DAX language is used in Power BI in the Fabric context and Power BI is out of the scope for this exam, and thus DAX is not covered. All the other languages are part of this exam, and like I mentioned previously, this exam requires you to know the basics of two different SQL dialects that are Spark SQL and TSQL. But don't worry, since both of them are quite similar. This was really a warm-up question, since I don't see them asking anything about the exam scope in the actual exam. Next, let's have a question that could be actually in the exam. And this question is, which one of these Microsoft Fabric data stores can store raw CSV files? A. Warehouse, B. Azure Blob Storage, C. Eventhouse, D. Azure SQL Database, E. Lakehouse. Now think about the answer to this question for a moment and pause the video. I will reveal the answer to this question in 3, 2, 1. The correct answer to this question is the E, Lakehouse, since it has the possibility of storing raw files like CSVs or any other types of files. Warehouse and Eventhouse don't have this possibility. In Azure Blob Storage, you could store CSV files, but it is an Azure resource and not part of Microsoft Fabric. Also, Azure SQL Database is not Fabric data store, and you can store raw CSV files there. This is the episode 3 in this DP-700 exam prep series, and in this episode we will cover the basics of Fabric terminology and structure. This episode aims to give you a solid foundational understanding of Fabric so that things that we cover later on in this series make more sense. Many of the topics that we mention in this video will be covered more in depth in later episodes. So don't worry if this episode doesn't answer to all of your questions about the structure and especially governance. Like in every episode in this series, we will start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Let's start by covering the core terminology and structure of Fabric. If you're working in a Microsoft Fabric environment, you will hear terms like tenant, capacity, workspace, domain and subdomain, etc. thrown around. And if you're not familiar what those terms mean in Fabric context, those conversations can feel quite confusing. But now let's break down this Fabric rabbit hole so that those terms don't feel so scary anymore. Let's start this rabbit hole from the Microsoft Entra tenant. Basically, if you're using any of Microsoft's cloud services, you have to have a tenant. You can think of a tenant as a dedicated playground that Microsoft has given for your organization to build those services into. Also, with the tenant, you get some identity and access management for your organization. For example, if the company you're working for is using Microsoft Cloud services like Microsoft 365 services that cover very commonly used services like Outlook, Word, Excel, and Teams, you know that you can use your organizational account, meaning basically your email, to log into all of those services, and that is made possible by having a tenant on the background. You could say that tenant is like a backbone for all of your Microsoft services. So, in very briefly summarizing, tenant is a control center for managing users and security across Microsoft Cloud services. There is also a possibility that organizations could have multiple tenants, but let's not complicate this example with those, and for now it is just good to know that that is possible. And like Teams and other Microsoft Cloud services, Fabric is also one of the cloud services provided by Microsoft, and it is deployed/enabled to be used for your organizational tenant like those other services. And at this point, I hope you already know that Microsoft Fabric is a data platform service provided by Microsoft. So this means that there is only one Microsoft Fabric per organization if single tenant is being used. That is the most typical scenario. Now the question could be, does it become very messy if entire organization is using just one data platform, and how you could have some separation per business unit or per person? Compared to other Microsoft services like Teams, it would be very problematic if entire organization would only have one Teams channel and everybody would be having discussions there. Also with Fabric, things can be separated, and the way to separate things in Fabric is to use workspaces. By default, every Fabric user gets their own workspace called My Workspace that can be used to build stuff inside Microsoft Fabric. Also, other workspaces can be created based on needs. For example, your organization might want to separate finance stuff from supply chain stuff by dividing things into their own workspaces. Then these workspaces will act as containers for different Fabric items that those specific business areas are using to build their specific data solutions that fulfill their business needs. And those data solutions on those workspaces require compute in order to work, and thus those workspaces consume Fabric capacity. And this is the next term that we are going to cover in this rabbit hole. Basically, capacity is the thing that powers up Fabric, and the size of the capacity determines how much compute power you have under the hood for your Fabric resources to use. And of course, bigger is better, but in this case also more expensive as well. And the capacity happens to be the main cost driver, and the majority of cost associated with using Fabric comes from running the capacity or capacities. If we come back to the workspaces, this means that every workspace has to be attached to capacity in order for you to be able to do anything within that workspace, because without compute, nothing happens. Also, in many instances, it is smart to have multiple capacities and not just rely on one. There are multiple reasons why this is the case, but for example, organizations could want to separate different countries to their own capacities due to multiple reasons like data regulations or cost tracking, to name a few reasons. Also, in many cases, it would be a good practice to separate production workloads from development and testing workloads to different capacities so that development and testing doesn't accidentally eat up your whole production capacity and cause issues in your production environment and with some business critical reporting and data solutions. Also, we have a possibility to group workspaces by using domains. This adds one more governance layer on top of the workspace and makes it possible for different business areas to manage their data according to their specific regulations, restrictions, and needs. Then in Fabric, we have also possibility to add subdomains inside domains that allows fine-tuning this grouping even more. And now finally in this rabbit hole we get to the juiciest part where the action happens. Inside every workspace we can create Fabric items like data pipelines, data flows, notebooks, event streams, and also we can create data stores like Lakehouses. Every item in Fabric has to be created to some workspace, and these items are the building blocks of this platform, and different items provide different types of capabilities like for storing the data or transforming it. However, the rabbit hole doesn't end here, because inside some of those items we can create objects. The most easiest example is the Fabric warehouse, since to that data store we can create objects like tables, views, and stored procedures. And these objects allow us to fine-tune our governance and access to this very fine level. And now we have completed our entire picture here. And now somebody could be wondering that this looks quite complex. And what is the reason for all of these layers here? Well, the simple answer is that since we have only one Fabric per organization, we want to have multiple layers that allow us to build and enforce governance and access management. And to those topics we are going to dive way deeper in later episodes in this series, but I hope this walkthrough helped you to understand the basics of Fabric structure and how these different concepts relate to each other. Now, some of you who know a thing or two about Fabric could be wondering where is OneLake, and some of you who are newer to Fabric could ask now what is even OneLake? Well, that is going to be the next major topic in our Fabric journey. Let's start with basics. OneLake is this unified data lake for entire organization. And like the name implies, there is only one OneLake per Fabric. If you are familiar with Azure Data Lake Storage, you can basically think about OneLake as SaaS or software as a service version of Azure Data Lake. Basically, OneLake is built on top of that same technology, and Microsoft has just made it easier for organizations to use without needing to manage Azure infrastructure related to managing data lake there. And like with Azure Data Lake, we can store files and tables to OneLake, and the default data format for tables there is the Delta Parquet format, that is this very powerful open source format capable of handling huge amounts of data. This is the same format that is used, for example, in Databricks, that is another huge player on data platform scene and can be found on Microsoft Azure. And like with Azure Data Lake, storing data to OneLake costs money. And in Fabric context, OneLake storage is also generating costs along with capacity consumption, but usually these costs are significantly smaller compared to the capacity costs. All of the things that we have mentioned until this point about OneLake could be more or less achieved by just using Azure Data Lake. But OneLake has some aces in its sleeves, and one of the most notable and interesting of those is the possibility to create shortcuts. And what are these shortcuts, one might ask? Well, these shortcuts are a way to show data in one lake that is actually sitting in some other place physically. In other words, this is a way to virtualize data using OneLake. This feature is very powerful in many ways, but one of the main advantages of this method is to eliminate data duplication that tends to happen when organizations move their data from one place to another. Also, the big vision behind these shortcuts is to make OneLake a portal to all the data that organizations have. Currently, Fabric has already shortcut possibilities to many different external systems, and to name a few, you could now create a shortcut to AWS S3 Bucket, Microsoft Dataverse, or to Azure Data Lake. There are also other external systems that are already supported, like Google Cloud Storage. Also, some data store mirroring capabilities in Fabric utilize shortcuts as the method that brings the data to Fabric, but we are not going to dive into mirroring in this episode. Okay, cool. Now we have some data in our OneLake, and now we would need to access that data. How do we do that? The answer is that on top of OneLake, we have a serverless compute layer that is powered by Fabric capacity that provides the compute for Fabric. And like in many modern data platforms, the compute and the storage have been separated from each other, and so is the case with Fabric. This compute layer provides many different interfaces for accessing that data in OneLake, and we have interfaces like Spark, TSQL, KQL, and analysis services that can be used to interact with data in OneLake. Also, since OneLake uses Azure Data Lake storage architecture, we have possibility to use interfaces like ABFSS to access the data in similar way we could access data in Azure Data Lake. Then we have to have some data consumption activities that use this compute layer to access the data stored in OneLake. So on top of the compute layer, we can add a layer for data consumption. And from this consumption layer, we can access the data in OneLake using the compute layer. The most typical way in the Fabric context is use one of the tools that Fabric offers, like data pipelines, data flows, notebooks, or event streams that are also in the scope of this DP-700 exam. Also, Power BI is one very typical way that the data is accessed. Of course, the data consumption could happen from a third-party service or application, or maybe user could be accessing the data using one of those interfaces. And now, some of you could be wondering, why do we need OneLake? Since we have those data stores in Fabric like Lakehouses, warehouses, and Eventhouses, and we can just store our data there. Well, when you're storing your data to those data stores, you are actually storing your data to OneLake, and those data stores are just the primary way of accessing the data in OneLake. And even though data formats in those stores might look different, all of them use Delta Parquet files in the background to store their data. The exception here is of course Lakehouse, where you can store some raw files as well, but the tables in Lakehouse are also stored as Delta Parquet. This same thing applies to warehouses and KQL databases as well, and all of that data is Delta under the hood. But we are going to dive way deeper into all of those data stores in this series, so things will be made a lot clearer in later episodes. This wraps up the theory section of this video, and next let's take a look at these concepts that we have covered in Fabric to get a better idea about them in practice. And now we are in Fabric, and this is the main UI that opens up when you open the Fabric portal. And here we can see all of these different Fabric experiences like Power BI, Data Factory, Data Engineering, Data Warehouse, etc. But basically these experiences don't really matter, because all of the Fabric tools can be found in every experience. But basically, when you open one of these experiences, like data engineering, you get the tools here that you will most likely need to build your data solutions with that experience. But yeah, those experiences are quite a nice way to provide these different developer experiences, even though they don't matter that much. And now when I open this data engineering developer experience here, I can see that I would be able to create some items like Lakehouses, notebooks, environments, Spark jobs, data pipelines. And these are the tools that the data engineer would most likely need to build his or her data solutions using Fabric. And here on the left bar, I can see that I have my workspace open. And every Fabric user gets this my workspace by default. So you have this own workspace where to build things here in Fabric. And now I would like to change the workspace to this new DP-700 workspace that I just created here. And I can open up that workspace. And now I have switched to this DP-700 workspace where I have some different items that I had in that previous workspace. And I have created this workspace to be this kind of a dedicated container for everything that I will be teaching in this series. And to this workspace I can create all the items that I'm going to need in this series, and I have created just a Lakehouse and a warehouse to this workspace because I'm going to use them to demo things today. Next, we can talk about Fabric capacities. Basically, Fabric capacity is this capacity resource that is created to Microsoft Azure. And here I can see on my Azure subscription that I have created this capacity here. And it is just one of the Azure resources available in my resource group in Azure. And we can open up that capacity and see how does it look. Basically, we don't have many options here. This just tells where is this capacity located and what kind of tier we are using for this capacity, or what is the size of this capacity. Here this says F2, and we will come back to these tiers quite soon. And here I could actually start my capacity because now it is paused. And if I would click resume, my capacity would start up and it would start to generate costs. And now we can see that the capacity is running. But yeah, I'm going to pause this capacity since I'm actually using a trial capacity in my workspace and I don't actually need this capacity right now. And here we can actually see this tab where we could change the size of the capacity, and we can open up that. And we can see that we have different tiers of this capacity, and we can see that the price and the capacity units increase with every step. And here on the right, we can see the estimated monthly cost for each capacity if we would run it all the time. And we can see that things would get quite expensive if we would get the biggest capacity that is available here. Also, it is good to keep in mind that Microsoft offers these capacity reservations so that you could commit for using a Fabric capacity for a certain period of time and then get a discount from these prices. So basically, you are just seeing the starting prices here for these capacities. And one thing to note about these capacity tiers is that most of the fancy features in Fabric, like using AI features like copilots, require this F64 capacity to be enabled. So basically you are paying quite a lot if you want to utilize those AI features like copilots and some other features that are locked behind this F64 capacity. And if you would like to create your own capacity to Azure, you can just create a resource group that I have created here and then click this create button and then just search for Fabric capacity here, and here you can find that and then start to create this Fabric capacity using this portal. But yeah, I'm not going to create a new capacity right now, so let's exit this. Then, like I explained before, every workspace has to be attached to capacity in order it to work. So basically we need compute for every workspace. And how do we manage that? And we can open up this settings tab to manage those things. And keep in mind that this is behind admin portal. So you would need an admin access to Fabric to do this, or very elevated rights. And here we can basically manage many different things related to Fabric and enable some preview features, for example. But now we're interested in workspaces, so let's open up that tab. And here we can see my DP-700 workspace, and we can see that we have attached that workspace to this trial capacity. And here we're able to manage this capacity and maybe assign it to a different capacity if we would want. But basically now it is using this trial capacity here. But here we have the option to select the Fabric capacity and then just select the capacity that we want to attach this workspace to. But yeah, this is the way how you would change the capacity to a workspace if you would like to do so. And remember that every workspace has to be always attached to capacity. Next, let's go to this domain tab of our admin portal. And here we have all the domains that we can see in this tenant. And I have to blur out some of these domains here because those would show some of my colleagues' names here, and I don't want to show them on my YouTube channel. But yeah, I have created this Alexi test domain, and now let's open up and manage that domain. And remember that we could assign workspaces to domains to logically group them together. And here we could actually select workspaces that we want to assign to this domain. Basically, we have few ways how we can assign workspaces to this domain. We have the possibility to just manually search the workspace by name and then add them to this domain. Or we can assign them by using the workspace admin. Basically, this would assign workspaces to this domain based on the domain admin. And then lastly, we can assign workspaces based on capacity, so that workspaces in certain capacity would be assigned to this domain. But now I would like to assign the workspaces by name and then just search the workspace here. And here I would be able to find the workspace that I have here. But I'm not going to assign this to this domain now, because I have also created this subdomain under this Alexi test domain. And like I explained previously, we can also assign workspaces to subdomains to fine-tune this logical grouping even further. And here we would be able to assign workspaces by using the same options that we had for the domain. And now we can actually assign our workspace to this subdomain and just see how does it look. And now we can see that we have assigned one workspace to this subdomain. Next, let's talk about fabric items a bit. So now I have that DP-700 workspace open here, and to this workspace we would be able to create some new fabric items, even though I have already created few items here like the Lakehouse and Warehouse. We could click this new button here and then start to create new items, like for example a data pipeline or a data flow or a notebook to this workspace. And then those items would be part of this workspace, and we would be able to use those items in this workspace to build our data solutions. And also we have the possibility to create data stores to this workspace that would then store their data to one lake, like I explained previously. But yeah, we will be creating a lot more items to this workspace in later episodes. But now let's close this new item tab here and let's open up one of these data stores, and let's start with Lakehouse. And like I explained previously, Lakehouse is this data store that supports storing files and tables. So we have this section for tables and then we have this section for files. And under this file section I have created this folder called episode 3. And under that we have two folders. In this source folder, we just have one CSV file, and we can preview the file here. This just illustrates that we can store raw data to Lakehouse. But this other folder is a bit special. If you can see that little icon there, that means that this folder is actually a shortcut. And I can open up this folder and see where it leads. And this says that this file is in Azure Data Lake, and we can preview this file. And it says I'm a file in Azure Data Lake. And what I've done here, I have actually created a shortcut by using this UI here and clicking a new shortcut, which will allow us to create a shortcut to this Azure Data Lake storage. So I have already done that, and this is actually pointing to this storage that I have in this same resource group where I have that capacity. And I have created this shortcut to this data lake container in this storage account. And in this storage account I have the data lake container, and in that container I have this TMP folder, and that file that I just showed to you there is actually sitting in this folder. So it is not actually stored in OneLake. So this is an example of OneLake data virtualization by using a shortcut that I mentioned in the previous section. But yeah, we can also create shortcuts for tables. So we have possibility to create a new schema shortcut that would also point to these same places, but then we would have to use Delta Parquet format to bring Delta tables to Fabric using these shortcuts. And also under this episode 3, I have this one table. This is not shortcutted table, and I have just loaded in that CSV file that I had here to a table. And in this table, I have the same data, but now in Delta Parquet format stored in OneLake, and we're accessing that data using this Lakehouse here. Remember that all the data basically in Fabric is stored as Delta Parquet, except these raw files that we can store here in the Lakehouse. But yeah, here is the CSV data in the table format. And now let's go back to our workspace and let's open up the Warehouse. And Warehouse in Microsoft Fabric is this very traditional database looking data store where you can store tables and create stored procedures and create views like you could in a traditional SQL database. But remember, even though this looks like a very traditional database and we would be able to query these tables using TSQL queries, for example, selecting top 100 from this table, this data is also stored as Delta Parquet files in OneLake, even though we are using this TSQL interface for accessing that data. But yeah, this wraps up this demo/tutorial section of this video. And next, let's have some questions about the topic that we covered today. Let's start with this question. Which of the following best describes the role of capacity within Microsoft Fabric? Is it A, capacity is optional and only required for creating advanced data models? B, capacity powers compute resources for workspaces and is the primary driver of costs in Fabric. C, capacity is used exclusively for storing data in OneLake. D, capacity governs user permissions and access management across all Fabric workspaces. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. And the obvious answer for this question is B, since capacity provides the compute resources necessary for all activities in Fabric, such as creating and running data pipelines, notebooks, and accessing data in OneLake. It is also the primary cost driver in Fabric. And what comes to the incorrect answers, A is incorrect as capacity is mandatory for any activity within Fabric, not just for advanced data models. C is also incorrect as data in OneLake is stored independently even though capacity is used for processing tasks related to that data and needed for accessing it. But capacity can be used for other things in Fabric as well that doesn't access that data in OneLake at all. D is also incorrect since Fabric capacity provides mainly compute and not user permissions and access management. Next, let's try a bit more challenging question. Your organization is planning to adopt Microsoft Fabric for its data platform. Which of the following statements are true regarding Fabric structure and its relationship with other Microsoft services? Choose 2. A single Microsoft Fabric instance requires multiple Microsoft Entra tenants for its different services. B, workspaces in Fabric act as containers for different Fabric items that are required to perform data processing within Fabric. C, each workspace in Fabric can function independently without being tied to a capacity. D, OneLake serves as a unified data lake for the organization built on Azure Data Lake technology and supports the creation of shortcuts for external data sources. E, Fabric domains allow organizations to bypass the use of tenants for workspace access and governance. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer for this question are B and D. B is correct because workspaces are essential in Fabric for organizing and isolating different business workloads. They act as containers for data pipelines, lakehouses, notebooks, and other Fabric items that are used for creating data processing logic. D is also correct since, like I explained, OneLake is a unified data lake for the organization. It is built on Azure Data Lake technology and introduces shortcuts for visualizing data from external sources, reducing duplication. Then we have our incorrect answers. A is incorrect since Fabric requires only one Microsoft Entra tenant to function. C is also incorrect since every workspace has to be attached to a capacity. Then lastly, E is incorrect since domains don't allow bypass of the use of tenants for Fabric management and tenant is always required. This is the episode 4 in this DP-700 exam prep series, and in this episode we will cover the programming languages that are in the scope of DP-700 exam. This episode should be way easier to follow if you already know how to use SQL, KQL or PySpark, since we are going to compare their syntaxes between those languages in order to understand quickly how those languages work and what are the major differences in their syntax. If you already think you know the basics of these three languages, you can skip this episode, since this is meant for people who are lacking with at least one of these, so that later episodes are not so confusing when we use these languages. And obviously I'm not going to be able to teach you how to program in this short video if you know nothing about these languages to begin with. So don't expect that kind of magic from this episode. Like in every episode in this series, we will start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now let's get started. In the scope of DP-700 exam, we have three programming languages that are SQL, KQL, and PySpark. For this exam, you need to know at least the basics of these three programming languages. Let's first cover what are these languages and what are their main uses in Microsoft Fabric. We will start with SQL, since I assume that most data engineers or people looking to become one are most likely familiar with it. Also, in my opinion, this is the most important language to learn for data engineers. So, SQL. It stands for Structured Query Language, and it is mainly used with structured data, and this has been the traditional language used in relational databases for ages. Since this language has been around for so long and being used in multiple different databases and environments, many different dialects of this language have evolved, which basically means that there are just minor differences in the SQL syntax and functions, etc., that can be used with those different dialects. In the scope of DP-700 exam, we have two of those dialects, and those are Spark SQL and TSQL. Spark SQL is one of the languages used to interact with Spark engine, and in the Fabric context, this means that this language is mainly used in notebooks, and the go-to data store with notebooks, Lakehouse. TSQL, on the other hand, is the Microsoft dialect of SQL, and in Fabric it is used with warehouse, TSQL notebooks, TSQL endpoints, and also it can be used with Eventhouse/KQL database to some extent as a replacement to KQL if you prefer SQL. And speaking of KQL, it is the next language that we are going to talk about. KQL stands for Custo Query Language, and unlike the two other languages here, it is a read-only request language that is meant for fetching, filtering, analyzing, and visualizing data. This language excels at handling large volumes of structured, semi-structured, and also, to some extent, unstructured data. KQL is mainly used with event houses and its different features in the Fabric context. I would say that if you are starting completely from scratch, this is the easiest language to learn, but I would still say that learning SQL is more worthwhile. Then we have PySpark. That is basically the Python API for Apache Spark. So when you write PySpark, you are writing Python. But since Python is a very versatile and huge language, we are just scoping it to this specific set of functions and functionalities that PySpark covers. Since PySpark is Python, this is the most versatile language out of these three, and you can really do many things with this language that you can't really do with KQL and SQL. However, the downside is that this language is the most difficult to learn for a beginner, in my opinion, and I think most of you can agree when we compare these languages side by side shortly. Since this language is used to interact with Spark engine and it is used in similar fashion to Spark SQL, which means that it is used in notebooks and interacting with Lakehouse. Next, let's compare these languages side by side to highlight the differences in their syntax. And here we have our input table/data frame that we are going to read or query using these three languages. Let's begin with SQL. With SQL syntax, we would write select name and age from person, which would then result as having all the rows that we have in our input, but by just having only the specified columns that are name and age. So, for those who are not familiar with SQL, the syntax reminds a lot of English language that you write in a bit weird way and describe what you want to do with your data. Next, let's check out how to get this exactly same result by using KQL. Using KQL, we would say person and then pipe, project, name and age. And with KQL, we first specify the table we want to query and then we add these operators with pipes. In this example, we just need the project operator that corresponds somewhat with the select statement in SQL. And you can use it to select the columns you want to have in your output. Then lastly, we have PySpark. Since it is Python, we use this object notation with this language. So we say person.select, that is our function here, and then we specify the columns we want for our output. Also, in order us to see our data, we have to wrap it to a display function that is very similar to a print function, and it will display our data with this nice table format. Next, let's have another example. In this example, we are using the same table/data frame, and again, let's start with SQL query. With this query, we would be able to get the number of rows from our table to a new table and with just one column called count, and one row that shows the number of rows. We are also renaming the count star function as count to make it look better in our output. With KQL, we have already an operator called count that shows the same result very easily. With PySpark, things get a bit more complex and we have to use aggregate function for our person data and then rename the result column from that function as count instead of count1. Then again, we wrap this to a display function to get that nice table format output. Also, I know that with PySpark there is easier ways to show the number of rows in a data frame by just using built-in count function, but now we want to have that as table and not as text output. Let's continue to talk about filtering data with these languages. With SQL, we can filter the data by using where statement, and for it we can, for example, say that we want only the rows where name equals Alexi. This will then produce an output where we have only one row with the columns name and age that we specified in the select statement. With KQL, we can achieve this by using the where operator that works in a very similar way to SQL and then project the columns that we want to our output. In PySpark, we can use the filter function to filter name column in the person data frame and then selecting the columns that we want to the output. Also with PySpark, there are multiple different ways how this same result can be achieved, and now I'm just showing one of those here. In the next example, we are going to cover ordering our output rows with these languages. With SQL, we can add order by statement and say that we want our output to be ordered based on age. And I want the order to be ascending. With KQL, we have order by operator, and with that language we can order the data in very similar way. With PySpark, things work also in similar way, but now we have order by function for which we give the column we want to use as an argument, and then set ascending to be true. In the last example in this theory section, I want to talk about combining tables with joins. That is a very common operation when working with data. In this example, we have the same table we had previously, but now we have another table as well called person info. Now we would like to combine these tables using the name column. With SQL, we can specify a join command in our query and add our person info table there. Also in this query, I'm giving aliases to my table so I can refer to them in my query without writing their full names. After the join command, we have to specify the on, which we use to tell how these tables can be joined or combined. And there we are using name column from each table as the key for our join. Then in the select, I'm specifying that I want name and age column from the person table and info column from the person info table. And this will then produce the output we wanted. With KQL, we have very similar join operator that can be used to achieve the same result. With PySpark, we have the join function, and for it, we give the data frame we want to join as an argument, and then as a second argument, we provide the columns that are used to join the tables. And lastly, with the select function, we pick the columns we want to have in our output. This was the last example that I had in this theory section. Next we will go to Fabric, where we are going to use all of these languages and highlight few more things about their differences. Now I have my DP-700 workspace open here, and to this workspace I'm going to create a new item, and that item is going to be a warehouse, and let's find the warehouse from this list, and there it is. And then next we have to name our warehouse, and I'm going to name it VHDP-700, and then let's hit create, and this will create this warehouse for us. And also remember that if you want to follow along with me, all the materials that I will be using in this tutorial can be found by clicking the link in the description. And since in this episode we are going to focus on programming languages, I'm not going to focus on these data stores that much, and we will come back to these in a later episode. But first we need to set up this warehouse so that we have some data here that we can query using SQL. And for that, we can create a new query, and here I have this setup script that I will run that will create a database schema here and then create a few tables that we can use to query with SQL and demonstrate some SQL queries in this episode. And now let's run this setup script here. And now this setup script is done, and we should have a new schema there, and there we have that new schema, and under that schema we should have some tables that we are going to query soon. And there we have employees, departments, projects, and assignments. And then let's create a new query and start to query those tables. Let's start with these very basic queries. And here I have 4 queries, and all of these queries will query the entire table that we have here. And SQL, we can use this star to indicate that we want to query all the columns that we have in that table. And now we can run this and let's see how does the output look. And now they are done. And here we can see the employee table where we have the employee ID, name, department ID, hire date, and salary. And then in the result 2, we have the departments. And in the departments, we have the department ID, department name, manager, and location. Then we have the assignments table, and in that we have assignment ID, employee ID, project ID, assigned date, and role. And then in the 4th result, we have the projects table where we have project ID, project name, department, budget, and start date. Next, I would like to query the employees table and select the rows where salary exceeds $75,000 per year. And then I'm also using this concat function to add this $ before my salary and making this new column called salary string. And let's see how does this look when we query this using SQL. And here we can see that now we only queried the rows from the employees table where the salary exceeds that 75,000 and created that new column salary string. And with SQL we can use multiple functions in this select statement to create new columns with some type of logic. This concat is just one simple example of that. Next, I want to demonstrate how to combine 2 tables with joins. And here we are combining the employee table with departments table. And we are joining them by using the department ID that can be found from the both tables. And then we are just selecting the name column from the employees table and also the department ID from the employees table and then the department name from the departments table. And now let's run this query and let's see how does the data look. And this is a very solid example of combining 2 tables with joins. That is a very common operation when working with data. And here we can see the output. And here we have those names, departments, and then the department names. And these department names were not present in the employees tables, and that's why we have to get them from the departments table if we want to show them in the same data set. And next I want to demonstrate this one cool feature in SQL that we can actually nest these queries, so that I will have the query that we had just there as a subquery for this upper level query that will basically use this result that we just created there to query that even more. So this way we can combine these queries together and build queries on top of queries to get just one result. And in this upper level query, when I'm querying this table that we had there as a result, I'm just counting the number of employees per department by using this group by statement. So I want to group by my data using the department name and then count the number of rows in each department to get the number of employees in that department. And now let's run this query and let's see how does the data look. And here we have the department name, and there we have the number of employees in that department. Also, it is good to keep in mind that SQL is not only a query language, and we can also manipulate the database objects like views and tables, and also grant permissions, etc. It's quite versatile language to work with databases. And for example, in my setup script, I already used these data manipulation features of SQL to create tables and insert data into tables. But these are the topics that we are not going to dive into this video. Also, if you're not familiar with SQL that much, you can start to query these tables that I have created here by using that setup script and set up this in your own warehouse. And you can, for example, try to combine these different tables with each other and come up with queries to train your SQL skills. Next, let's create an event house to this workspace so we can try out our KQL skills there. And let's find the event house. And now let's create this event house, and then we want to name our event house, and then let's hit create, and this will create the event house for us. And then we want to add some data to that event house. And here we just have some get started things. I will click this through so we get rid of this. And now we have that KQL database already created to this Eventhouse. And like with warehouse, we are not going to dive deep into what is an Eventhouse, and we will do that in a later episode. Now we will just focus on KQL and how that differs from SQL and PySpark to highlight those syntax differences here in Fabric. But yeah, now I would like to add data to this KQL database that I have here. And we can add data to this KQL database by using this get data feature and selecting local file. And I have those same datasets that we had in the warehouse as CSV files that I'm going to upload to this KQL database. And all of those CSV files can be found by clicking the link in the description. But now I want to add a new table to this Eventhouse and call that employees, and then I want to drag and drop that employee CSV file here. And there is the CSV file, and now it is uploading it, and then we can click next, and now we can see that our data looks a bit funky right now, and we have to click this first row as a column header so that now it looks correct. And this is the same data that we had in our warehouse. And now we can click finish, and then this will create that data to the KQL database. And now it is done, and we have that employees table here. And now let's repeat this same process to every file that we have here. And I'm not going to show this, and you can do that on your own. So we are going to upload 4 files here. And now I'm uploading the last project CSV file here, and same thing, first row as column header, and then we click finish, and then we should have all the data in our KQL database. And there we have those 4 tables, exactly the same tables we had in our warehouse. And now we would like to query these tables, and we can just click these 3 dots here and this query table. And we can, for example, show any 100 rows from the assignments table. And this will create this KQL query that will show the first 100 rows. And of course, we don't have 100 rows in our assignments table. So that's why it shows all the rows that is in that table. And this is also the take operator here that can be used to select the X number of rows. For example, we can just say take 1 and we will only see 1 row here. But yeah, let's clear this here and let's start to query our KQL table. And with KQL, we can just say the table name, for example, assignments, and query it that way. And this will actually query that table, and we don't need to specify any operators. We can just say the table name and then run, and that will query the table. And here we have the queries for these other tables, and we can run this one by one to see that we have the same data we had in those warehouse tables. So let's do the same thing we did with the SQL, and I want to select the persons from this employees table whose salary is 75,000 or more. And let's add a KQL query that would do that. And here we have that. So we are saying the employees, and then we have these operators. So we use this where operator and then salary greater or equal than 75,000, and then we want to project only the columns that we want. And also here I'm using this cat function that basically is the same function that we had in SQL as the concat function. And this is able to combine 2 strings together. For example, we're combining that $sign with that salary to get the same result. And now we can query this and see how does it look. And here we have basically the same result we had with that SQL statement, but by just using KQL and the KQL language here. Then the next thing that we did was to join those tables together, and here we have the corresponding KQL syntax. So we are starting from the employees table, and then we are doing a join, left outer join to be exact, to departments table using departments ID here. And then we are specifying the columns that we want to project from this data as a result. And now we can run this and see how does it look. And here we have exactly the same result that we had with our SQL statement previously. And remember, next with SQL, we did that subquery to be able to count the number of employees per department. With KQL, that looks a bit different, and we don't have to use that kind of a subquery structure. So basically now we're starting from employees, and then we have exactly the same join statement that we had previously. And then we are using this summarize operator here that will actually count the number of employees by using this count function. And then we are going to summarize by using the department name. So this corresponds to this kind of a group by statement statement that we could use in SQL. And now let's run this query and let's see how does it look. And here we can see the same result that we got with SQL. Also the same thing here, that if you want to start practicing your KQL skills, you can use these tables that we uploaded here and use them to do different kinds of queries and try out these different kind of KQL operators to really understand them and to be able to answer to some questions in the DP-700 exam related to KQL syntax. Next, we want to create a Lakehouse to this workspace, and we can select the Lakehouse here, and then we want to name our Lakehouse, and then we are actually going to use Lakehouse with schemas, because I predict that sooner or later we are only going to have Lakehouses with schemas, and that's going to be the standard in Fabric. But like with those other two data stores, we are not going to focus on Lakehouse as a data store in this episode, and we will come back to it in a later episode. But yeah, let's enable those schemas and let's hit create, and this will create that Lakehouse for us. And now to this Lakehouse, I want to first create a new schema, and we can create that schema DP-700 episode 4, and then we want to also create a new folder to this Lakehouse with the same name under this file section and call that DP-700 episode 4. And to this folder I'm going to upload those exactly the same CSV files that we used with our KQL database. And we can use that upload files, and with this browse functionality I'm going to find those files and add them here. And now I have added those files here, and then we can click upload, and now they have been uploaded. And we can close this, and they are now in this folder here. And now we can actually turn them into delta tables so that we can more easily use them. And we can select this load to table and new table, and then we select our schema and we use these default settings here, and then we click OK. And then we have to wait that finishes, and now I'm going to do the same operation for every CSV file here. So we will come back to this in just a moment. And now we have loaded in that projects table as well, and now we should have 4 tables in this schema. And there we have these delta tables that we create based on these CSV files here. Next, I'm going to create a notebook, and we're going to use that notebook to query those tables and use PySpark to transform the data in a similar fashion we did with SQL and KQL previously. And here we have a blank notebook. And again, we are not going to dive too deep into what is a notebook in this episode, and we will come back to notebooks in later episodes. But now we just want to demonstrate the programming languages. And here I have already attached that Lakehouse to this notebook, since it is attached by default since we created this notebook from the Lakehouse UI. And I want to note one thing about notebooks before going forward, that we can use different languages with these notebooks. Like I described previously, we have different languages for interacting with Spark. In this case, I want to use the PySpark API, but we have also the Spark SQL. So basically, we would be able to use SQL to query these delta tables here. Now I add these statements here that utilize Spark SQL to query these tables here into data frames. And then we are going to use these data frames in our PySpark code and do those same kind of transformations for those data frames. But yeah, let's run these and let's run them into these data frames here so that we can start our work here. And now our code has executed, so we have now these 4 data frames where we have basically all the data that we had in those delta tables. And then we can add some code and display these data frames that we have here. And for that, we can use the display function that I showed you earlier. And by running this, we would be able to display all of those data frames in this very nice table format, like we did in those theory section slides. Here we can see exactly the same data that we have been seeing already previously by using that display function here. And next, I would like to get those employees with that salary 75,000 or above. And for that, we can add a new cell, and to this cell, we add this PySpark code. And here I'm importing these PySpark SQL functions as F, so we can refer some of the functions that we have in this library. Like for example, the concat function and the lit function and the call function. But yeah, with this code, you would be able to get those employees whose salary is equal or greater to that 75,000. And with this PySpark syntax, we're first referring to the data frame, and then we are using this object notation to do some things to that data frame. For example, we are first filtering that data frame, and then we are selecting the columns that we want from that data frame that will then actually display them using this display function here. Also, we are using a concat function to add that $sign before that salary and naming that salary string. But yeah, let's run this code and let's see how does the data look. The result should be the same result that we had with SQL and KQL previously, but by just using this PySpark code here and the PySpark syntax to query and read that data. And there we have that result, and the result looks exactly the same that we had previously, but now using a different language once again. And also I want to remind you that this is just one way of doing this with PySpark, and with PySpark we have some flexibility that we can do with our data, and we have some different options, but this is just one way of achieving this result. And here I want to demonstrate another way of getting that same result by using this select expression function, and now we don't have to import those PySpark functions, and we can just use this select expression and here do some things and use those pipes to combine those two columns together. And by running this, we should get exactly the same result that we had above, but using just a different way of doing that. And there we can see that these are exactly the same. Next, we want to do those joins to those employees and departments data frames, and this will go in this manner that first we start with our employees table, and then we are using the join function, and then we are going to give the departments data frame as a first argument, and then we are going to combine them by using department ID from both tables, and then we are specifying that this is a left join. And then we are selecting just those columns that we want from each data frame by using the select statement. And now let's run this and let's see how does the data look. The result should be exactly the same that we had with KQL and SQL previously. And here we can see the same result. And again, I want to demonstrate the different way of doing that same thing with these PySpark functions and using these aliases for those tables. And with this code here, we get exactly the same result we got here, but now using a different syntax. And now we are actually using that select statement that we already used previously. And then we're using that column function from this PySpark functions library here. But the result is same by just using a slightly different syntax this time. And as a last exercise, we wanted to count the number of employees per department. And that we can achieve with PySpark by first starting with the employees table and then having that join statement. And then we're having that group by statement in very similar fashion to SQL. And then we're specifying that we want to group by department name. And then after that, we are going to have that count function. And then we are also going to rename the count function output to number of employees so that we don't have this column called count and we have the number of employees there. And now let's run this and let's see how does it look when we run this. And here we can see the result from this query. And I was just wondering, did I do something wrong? But actually we didn't see the last row here. So it is basically 2 employees per department. And I was a little bit confused here that did I make a mistake, but I didn't. And with PySpark, we have multiple ways of doing this same thing. And here's another way of using those aliases and those PySpark functions, and this will achieve actually the same result we had there by just using this different syntax, and here we have the same result we had there. And again, the same thing, if you want to practice your PySpark skills, try to do some different things with these tables that we have here to practice some of the syntax here so that you're prepared if they ask something about PySpark syntax in the DP-700 exam. Next, let's have some questions related to today's topic. And let's start with this question 1. Which TSQL query will produce the following output? And here we can see that we have this animals table, and in that animals tables we have the animal column, then we have the group column, and then we have the habitat column. And in the output we only have the group column, and then we have the number of animals in that group. So we would like to get that by using SQL. So, are we able to achieve this result by using the query A, or query B, or query C, or query D? Now think about this question for a moment and pause the video. And I will reveal the answer in 3, 2, 1. And we can see that the answer C is correct this time. And here I'm highlighting what are the issues in those other queries. In the query A, we are using that group using that is not a proper SQL syntax. So it is group by and not group using. And in the query B, the problem is that we are only selecting the count as number of animals, but we are not selecting the group column at all. And in the D query, we are using this equal sign instead of S. That is the proper SQL syntax way of saying that we want the count as number of animals and not count equals number of animals. Which PySpark code will produce the following output? And here again we have that animals table, and in the output we have only the chameleon row now. And now you need to know which PySpark code will be able to produce this output. Is it the code A, or code B, or code C, or code D? Now think about the answer to this question for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer to this is the code D. And again, I'm highlighting what are the issues with these different codes. If we start from the code A, we can see that we are using this take function that is obviously incorrect since we would need to use filter function. In the code B, the problem is that we are saying animal is chameleon, and that is operator is incorrect there, and we should use a double equal sign there. And in the code C, the order is wrong because we will start from the data frame that we are going to filter and then saying dot filter and using that filter function to that data frame and not other way around. This is the episode 5 in this DP-700 exam prep series, and in this episode we will cover Eventstreams. That is this no/low-code tool for ingesting, transforming and loading real-time data in Fabric. Like in every episode in this series, we will start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. First, let's talk about the different components of Eventstream, and here on the screen we can see the Eventstream development canvas that can be used to configure and develop Eventstream. Let's first highlight the actual Eventstream block or node in this development canvas. This block is the Eventstream to which we are able to then connect our other blocks into. On the left-hand side of our Eventstream block, we have our data sources for this Eventstream. Eventstream actually supports adding multiple data sources for a single Eventstream, but we will talk more about those shortly. Then on the right-hand side of our Eventstream block, we have some transformations that can be added to this Eventstream flow, but they are really optional, and we could be using Eventstream without doing any transformations for our data. Then lastly, on the far right, we have the destinations for our data. And like with sources, we could actually have multiple different destinations for one event stream, but in this example picture, I just have one. So here we have the core components of event streams. And like I already mentioned, this is a tool meant for real-time data or near real-time data, depending on the definition of real-time data. So with these blocks or nodes in Eventstream, we can tell it where the data is coming from and what kind of transformations need to happen for it and where we want to send it/write it. So in a sense, this is very typical data engineering work, and the only major twist here is that we are dealing with real-time data and not batch type data like we typically do with traditional data pipelines and data engineering workflows. Next, let's talk more about data sources for event streams. There are a few different types of data sources that can be used for event streams. First, we have many different types of external services that are supported by Eventstream. These include many familiar Microsoft Azure services like Event and IoT hubs and different Azure database change data captures or CDCs. However, also many services outside Microsoft ecosystem are supported as well, and these include some AWS or Google Cloud Platform services that use, for example, Kafka protocol. But we are going to take a closer look at these services in the demo/tutorial part of this episode. Eventstream is also a very handy tool for processing events that are produced by Fabric itself. So Eventstream can capture and process various Fabric and OneLake events. For example, it can capture events from item creations in Fabric workspace, data changes in OneLake, and events associated with Fabric jobs. With this functionality, Eventstream can be used to build alerts based on things happening in Fabric or OneLake, but more about this later. Then we have support for custom endpoints, which then expand the integration possibilities even more, since you can connect your own application or process to Eventstream using one of the supported protocols that are EventHub, AMQP, or Kafka. In the demo section, we are going to actually use these to connect some custom code to Eventstream. Then lastly, Fabric offers some sample datasets that can be used to try out different features of event streams. Also, keep in mind that one event stream can have multiple different sources, and you can mix and match these different types of sources if you want. Next, let's talk about data transformations that are optional in event streams, but can be very useful in many cases when you want to do some data processing before writing to a destination. Eventstream supports 7 different types of transformations, and those are filter, manage fields, aggregate, join, group by, union, and expand. And I think that for many seasoned data engineers, these transformations are quite obvious what they do, but let's go them through so that everyone is on the same page. Let's start with filter. That is a filtering transformation like the name implies, and it allows filtering events based on the value of a column in the input. Depending on the data type, number, or text, the transformation keeps the values that match the selected condition, such as is null or is not null. This transformation is great if you want to filter out some unnecessary data. Then we have manage fields that allows adding, removing, renaming, and transforming columns in the data. Manage fields also supports many different types of transformation functions that can be used on column level. This functionality is very similar to SQL select statement, where you can use functions like concat, substring, etc., and then change data types and rename columns. Then we have aggregate that allows aggregating data using aggregation sum, minimum, maximum, or average over a period of time. Also, aggregate allows renaming calculated columns and partitioning aggregations based on other columns in the data. Next, we have join transformation that is very similar to SQL join command and allows combining data from 2 streams based on matching conditions between them. Then group by allows more complex aggregations using time windows or windowing functions. And these windowing functions we are going to cover in a separate episode since they deserve some special attention. Also, group by allows renaming calculated columns and grouping aggregations based on other columns in the data. Next on our list is union that allows combining 2 or more inputs with shared columns that have the same name and data type. Also, keep in mind that columns that don't match are dropped and not included in the output. And lastly, we have expand function that is very similar to an explode function in Spark, and it allows creating new rows for each value within an array. Next, let's shift our focus to Eventstream data destinations and talk about those. Like with sources, we can have multiple different types of destinations, and we can also add multiple destinations to a single event stream. Firstly, we can of course write the data from Eventstream to Eventhouse. That means basically writing data to a KQL database that is in that Eventhouse. Eventhouse/KQL database is the most native way of storing and exploring event-based data, and thus this is probably the go-to choice as the Eventstream destination for many. Then we are also able to write data to another Fabric data store, Lakehouse. This way we can write data directly to a delta table in Lakehouse, and we have that data in the same place with other data that is already there and easily combine them. Lakehouse could be a good option as a destination in some cases, but for event-based data it is less optimal than Eventhouse that is especially designed for this type of use cases. We can also chain event streams together by using derived streams as our destination. However, we have to add at least one transformation before using this, since it wouldn't make any point directly stream the data to another event stream. Then, like I mentioned briefly before, we can use event streams to build some alerts and triggers, and here Fabric Activator steps in the picture. We are going to cover Activator in more detail in later episode, but with it we can send emails, Teams messages, and trigger other Fabric items using Eventstream data as our source for those. Then lastly, like with our sources, we can use custom endpoint as a destination and stream data to some custom application using one of the supported protocols that are Eventhub, AMQP, and Kafka. And now we have covered the basic components of Eventstream, and we are ready to go to Fabric and talk more about event streams there and try it in action. Now I have my DP-700 workspace open here, and I would like to create a new item to this workspace, and we are going to create an event stream here. And let's create that event stream, and next we would have to name that event stream. Let's add a name for it, and then we can hit create. And this will then start to load up the event stream development canvas here. And now we would have to pick a data source for our event stream. We have these three options: use external source, use sample data, use custom endpoint. I'm just going to click this custom endpoint since that is what we are going to use today. And then I have to name our custom endpoint. And I'm going to name this CE temperature because I'm going to send this simulated temperature data to this event stream. And then we can click add, and this now opens up the actual development canvas for our event stream. But before we start to send data to this event stream, let's talk about event streams a bit more here. And we can click this settings button here because there are some settings here that can be used for event streams. We have these typical Fabric settings like about, endorsement, tags, and then we have these event stream specific settings here, and these are retention and event throughput. The retention is actually a setting that defines the time that event streams keeps the messages that are sent to it. So here we can specify the retention time we want to have those settings retained in the event stream, and we can specify there a date between 1 and 90. So the 90 days is the maximum that event stream can retain the messages. Then we have this event stream throughput setting here. That is not loading up for some reason. I don't know if there is some type of bug going on in Fabric, but with this setting you could adjust the throughput that is specified for this event stream. And also remember that more throughput means more capacity consumption. And also with event streams, it is good to keep in mind that event streams consume quite a lot of capacity. So I wouldn't try to use event streams with those lower capacities like F2 or F4. I would opt for something higher than those. Because if you, for example, try to use event stream with F2 capacity, you will run into issues quite fast. You can try that at home and see what I'm talking about. But yeah, this throughput setting doesn't seem to be loading up. I don't know what is the issue here, but yeah, basically there are a few options that can be chosen for the throughput here. But yeah, let's not wait for that and let's move forward. Before we start to configure our custom endpoint source, we can talk a bit more about these different sources. So we have these three options: external sources, sample data, and custom endpoint. Let's first talk about these external sources here. And like you can see, we have quite a many different external services supported here. Mainly these are some Azure services that we can use as a source for our event stream. But we also have some Fabric workspace item events, Fabric job events, and then we have also Fabric OneLake events. And these Fabric events are especially good for building up some alerts or triggering some actions in Fabric based on arriving data or item creations, etc. But that is something that we are going to take a look at later on. Then we can close this external source, and then we have also this sample data. And here we could pick some sample data provided by Microsoft here in Fabric. So we have some bicycles, yellow taxi, and stock market data, and we could use those to try out the event stream features without having some actual data coming from anywhere. And like I already mentioned before, we could actually add multiple different sources to this event stream, but now I'm going to just have this custom endpoint. And next I will connect my custom code to this endpoint. But to be able to do that, you would have to click this publish button or change to the live mode here. And in this live mode, we can see these protocols that are supported for the custom endpoint. We have Eventhub, AMQP, and Kafka. But today we are going to use this Event Hub endpoint and connect to it. And we are going to use this SAS key authentication. And here we can see all the details that we need for it in order us to connect to this endpoint. So basically we have the Event Hub name here, and then we have these secrets that are primary key, secondary key, and then the connection strings for those. Today we are going to use this Event Hub name, and then we are going to use this connection string primary to connect to this custom endpoint using the custom code that I have built. And here in my VS Code, I have that custom Python code that I have built for this demo. And this custom code can be found by clicking the link in the description if you want to follow along with this tutorial. But let's talk a bit more what this custom code does. So basically this custom code sends these kind of messages to our event stream. And this sends these kind of fake temperature readings based on the configuration that we have here. And for example, if we have configured our country to be USA and our city to be New York, they will be added to the data. And then we also add this timestamp when that reading was created. And then we get these fake temperature readings from these sensors that are simulated here. So we have maximum of 3 sensors here. And then we send some temperature data that is between these min and max temperature values that we have there. And then we specify the sleep time. That is basically the time in between messages when we send those to the event stream. But yeah, when we run this, you can see that we get 1, 2, or 3 sensors when we send the data, and it is not all the time 3 sensors. And I will use that to demonstrate few things in Eventstream later on. Also, we get this event ID, that is this strong hash. That is an ID for this kind of one message that was sent to the event stream. But yeah, here is the rest of the code. It's quite simple Python code, and feel free to modify it if you want to try out your own things. But in order us to run this code, we would need to first install this Azure Event Hub using pip. I have provided the pip command here, so you could use that to install Azure Event Hub. And then we are importing these libraries. And now we would configure Event Hub name and Event Hub connection string here. And I will configure them now, and they can be found here. So basically we have the Event Hub name here, and then we have the connection string primary. And keep in mind that these connection strings are secrets, so you don't really want to expose them. And now I have copied those values, and I will save my code, and then I can start running it. So we just execute it with Python, and it will start running and sending data to that custom endpoint that we have defined there. And now it will start running, and we can see the messages that are being sent here. And so we can see that it's now sending data for 3 sensors. Let's see if we get some messages with less than 3 sensors here. Let's see, now it is sending all the time 3 sensors, but there is a possibility now. There we can see that there is 2 sensors. But yeah, now we are getting this data to our event stream. And now we can go there and do some stuff with it. And let's go to this event stream, and then let's go back to that edit mode, and here we could actually already preview the data. Let's see, let's click that test result, and we can see soon that data is coming in. And here we can see that we are getting some data, and we can see that we have different amounts of sensors that are providing that data. And now we would like to do some transformations for our data and write it to a source. So let's add some transformations. First, I would like to use the expand transformation and expand this array to its different rows, so that instead of having this one array here, we would expand these two to their separate rows. But yeah, let's add that expand transformation here, and we need to set up that, and we can do that by clicking this pencil here. And we can just leave that as expand, and then we can select the array we want to expand in our array data. And that's going to be the temperature readings. And here we could set, do we want to create rows for empty or missing arrays? But yeah, in this case, we don't have any missing arrays, so we can just leave it as default, and it doesn't do anything special in our case. Then we can click save, and then we could actually click this refresh button here and see the results. It is actually throwing this error message because we haven't configured like input for this expand, but we should be able to see the data here once it loads up. And here we can see the data, and here we can see that we have this temperature readings from those sensors on their separate rows. For example, these three here have the same event ID, but they are now on their separate rows. They used to be on the one row, so we used the expand function to expand on their own rows. But yeah, next let's add manage fields here, since I want to filter out some unnecessary columns from this data. For example, we don't need these technical columns that are added there when we are sending that data. For example, this event processed time, partition ID, and event enqueued time. And I'm going to drop out those using this manage field. So let's configure that. And we can add some fields here by clicking this add fields, and then we can select some fields here. First, I want to pick something from that object that we have there where our sensor is located. I want the sensor, then I want some temperature, and then I would like to also have the timestamp, event ID, country, and city. And I think those are all the columns that we need for now. And then we can click add. And I also want to do some light data transformation for these columns. For example, I want to change the temperature data type and have that as double, since that is actually this kind of a float value and it is not a string value. So that's probably better that way. And then I want to transform the timestamp from string to date time value. And then for the event ID and city, maybe we can also use the one function for this city and actually have that as uppercase. So we have these different functions available here in the event stream, and we have these string functions, for example, here, and we can use these to do some light data transformation. For example, we can pick this upper function here and select our city there and have that city as upper value. Remember, I wrote that New York there as lowercase. So with this function, we are able to convert that to an uppercase, and we are going to have that as string. And we are going to have that as city. So we are not going to rename any columns, even though we could. And then we can click save, and then we can click refresh and see how does the data look after our manage fields. And here we can see that now we have picked only those columns that we wanted, and we have that New York there as capitalized, like we have the country already there. But yeah, that was due because we did that transformation for it. And next, I would like to calculate the average temperature per event ID, because we have those 1 to 3 temperature readings per event ID, but now I would want to calculate what's their average. And let's do that, and let's add a group by here, and we can use that to calculate that. And we can configure the group by here and then create this kind of an aggregate function. And for this, I want to use average, and then we are going to select the temperature because we want to use the temperature, and we can actually rename our temperature as AVG temperature as lowercase, so we have the same naming conventions for all the columns, and then we can click add. And now we have added this aggregation for this group by, and then we have to configure what we are going to use to group them by. So in this case, we are going to use event ID. And then we are going to specify the time window, and we are going to come back to these time windows in a later episode. But for now, let's select snapshot, because basically with the snapshot, we just use the event ID and group those values with it. These other window functions are a bit more complex, and we will cover them later on. And now let's refresh our data, and we should have average temperature for each event ID here. So once again, we are getting only one row per event ID when we use this group by statement. This is very similar to this kind of a SQL group by here. And there we can see we have event ID, and then we have the average temperatures for those event IDs. And next, I would actually like to use the join transformation and join this group by back to this data that we had there previously, so that we would have average temperatures on these rows, so that we would know what is the average temperature for each row when we have those different temperature readings here. But yeah, we can do that by adding a join transformation here, and here we could drag first our manage fields, And this upper level here is this kind of left side of the join, and this lower level is going to be the right side of the join. If you know how the join logic works, for example, in SQL, so we are usually using the left join here or inner join, but in this case, we're going to use the left join. And here we can see that we have only two options. We have inner join and then we have left outer join. So this means that we're actually joining this group by data to this manage fields data, because this is the left part of the join and this is the right part of the join. And then we have to select the columns we want to use as the join keys, and then we are going to use event IDs for both, and then we have that left outer join selected, and then we could specify the amount of seconds within the join is happening. But since we are getting those events at the same time there, this doesn't matter in our case. But if we would be getting a stream of events with some random times there, this could play a role in that event stream. But in this case, this doesn't matter since those events are arriving at the same time. But yeah, we can click save, and then we can see how does the data look. And like we saw, we couldn't configure any renaming of columns with the join transformation, and it's going to add some column names here that we can see shortly. And here we can see that the join added some column names, and it added these left prefixes to the columns that came from the left part of the join, and then added these right ones there that came from the right part of the join. And we were not able to pick any columns that we wanted here, so it just by default added all the columns that were coming in. And now I would like to add one more manage fields here and only pick the columns that I want to have in my output. So let's click add fields and let's click this imported schema. So I want to have the sensor, temperature, country, timestamp, event ID, city, and then I want to have the average temperature there. And then we can click add, and then we can rename these columns so that we don't have that left or right prefix there. So let's do that. And now I have renamed all of them, and then we can click save, and then we can check out how does the data look now. And here we can see the data. So now we have renamed those columns and only picked the columns that we want. And we have that average temperature in every event row here. But yeah, next I would like to configure the destination for this data. And we can click here and add destination. And we have these four options here. So we have the Lakehouse, Eventhouse, Activator, and Stream. And we already covered all of these in the theory section. But this time I want to use the Eventhouse. And remember that we could of course have multiple destinations for our event streams. And we could actually add some destinations here to some other point as well. So we would do some transformations after we are already sending data to some destination. But yeah, this time I want to use this Eventhouse destination. Let's configure our Eventhouse destination. First, we have to provide a name for our Eventhouse destination. It is going to be that. And then I want to pick the workspace where our destination is going to be. And it's going to be in this workspace where we are right now. And then we are going to pick the Eventhouse in this workspace. And then we are going to select the SQL database in that Eventhouse where we are going to write that data. Then next we want to create a new table to that SQL database. And now our destination configuration should be correct. And we can click this save button. And then we can click this publish button so that we will publish this event stream and it will actually start ingesting data to that SQL database from this event stream. And let's click that publish so that it will publish it and we will start to ingest that data to that SQL database. And now it will start to load that destination and it will start ingesting that data. And this will take a little moment until we can see that data there, since it is now creating the table and setting everything to be ready there. But yeah, shortly we will have some data in our SQL database. And after a little wait, we can see that now our destination is actually active and we are ingesting data there. So let's go to our Eventhouse and let's check out how does the data look there. So let's open up our Eventhouse and then let's open up the default SQL database in that Eventhouse. And here we can see this temperature table here. And it is actually saying that table is empty, but I think there is actually already some data. I think that is just a bug. And let's click that that show 100 records, and we can see that there is some data. And now we have managed to ingest the data to this Eventhouse's SQL database. And here we could actually start query this data and see what kind of insights we would be able to get from that data. But yeah, since Eventhouse and SQL database are not topic of today's video, we are going to come back to those later on, and now we are not going to start query this data anymore. And next we are going to have some questions about event streams so that you can test your knowledge and see that did you learn everything what I covered in this video. Our first question today is, which of the following event stream transformations allow you to rename columns? Is it A, expand and manage fields, B, filter and manage fields, C, join and manage fields, D, group by and manage fields? Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, group by and manage fields, since they both allow renaming columns. However, with group by you can do this to a less extent than with manage fields, since it only allows renaming columns that are created by it, but it allows renaming columns. Expand, filter and join don't allow you to rename any columns, so that's why A, B and C are incorrect. Let's have another question. Which statement is true about event streams? A. Event stream supports using custom endpoints as a source, and supported protocols for it are Kafka, AMQP, and IoT Hub. B. Event stream can forward data to another event stream using the derived stream destination if no transformations have been added to the event stream before it. C. Supported event stream data destinations include custom endpoint, Lakehouse, warehouse, and Activator. D. Event stream data transformations include following transformations: union, group by, manage fields, explode, join, and filter. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B, since you can't forward data to another event stream using derived stream destination if you don't add any transformations before it. What comes to our incorrect answers, A is incorrect since supported protocols include Kafka, AMQP, and Event Hub, not IoT Hub. C is incorrect because warehouse is not a destination option. And finally, D is incorrect because there is no explode transformation in event stream, but there is expand transformation. This is the episode 6 in this DP-700 exam prep series, and in this episode we will cover event stream windowing functions. In the previous episode we covered the basics of event streams, and in this episode we will expand that topic more and cover event stream windowing functions that are core topic with event streams and processing real-time data. Like in every episode in this series, we'll start with the theory section, followed by demo/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now let's get started. Let's first start by covering what are windowing functions in Mux Fabric event stream context. Basically, windowing functions are used in real-time stream processing to group events into time-based segments for analysis. They help in processing continuous unbounded data by applying aggregations like count, sum, average, max, min, etc. Instead of treating the stream as an infinite flow, windowing functions divide the data into manageable chunks. And this chunking or grouping happens in the group by transformation of event stream. And in that transformation we have 5 different windowing functions which we can use, and those are tumbling window, hopping window, sliding window, session window, and snapshot. Next we are going to cover all of these in more detail to understand how they are different. Let's first start from tumbling window. That is one of the easiest one to understand. In tumbling window, there are fixed non-overlapping time intervals, which means that events in the stream are grouped into fixed size time windows, for example 5 minutes. And the rule is that each event can only belong to exactly one window, because these tumbling windows can't overlap. These tumbling windows are triggered at regular intervals, and new window starts immediately after previous one has ended. For example, if you're using a 5-minute tumbling window starting from 12 o'clock, the window will be from 12 to 12:05, and then from 12:05 to 12:10, and from 12:10 to 12:15, and so on. Tumbling windows are best for periodic aggregations like counting, summing, and averaging data over fixed time periods. And like I already mentioned, the key thing to remember here is that these windows can't overlap, and the one event can only belong to one tumbling window. This window type can be used to answer questions like how many orders were placed in 10 minutes, what is the total revenue generated every hour, what is the average temperature recorded every 30 minutes, how many failed login attempts occurred every 15 minutes. So basically, if in the DP-700 exam you get a question about something that points to a fixed time intervals without any overlap, then go for the tumbling window as your answer. Next, let's break down visually how these tumbling windows work. Let's have a tumbling window with count aggregation and duration of 10 seconds, which means that we just want to count the incoming events in 10-second windows. Then here we have our timeline that runs from 0 to 40 seconds. And on this timeline, we have many events that occurred, so every green dot on this timeline represents an incoming event. You can, for example, think of these as messages that are being sent to our event stream. Then we want to see how these messages would be grouped if we use that tumbling window with 10-second duration and just count the number of messages using the count aggregation. Our first tumbling window starts from 0 and runs to 10-second mark, and it is exactly 10 seconds long. In this 10-second window, we have 4 events that are A, B, C, and D, which means that using the count aggregation, the value for this tumbling window would be 4. Then we have our second window that starts immediately after the first one ends, and in that window we have also 4 events. Then in our third window we have only 1 event, and lastly in our fourth window we have the remaining 2 events. So starting from the first, the aggregate values counted by the tumbling window are 4, 4, 1, and 2. Next, let's go through the same situation but now in table format. Here we have the table representing exactly the same events using the same timeline that we had on the previous slide. And then we use exactly the same configuration for the tumbling window and get the same result that we had on the previous slide. Also, when using windowing functions with event streams, we get that window end time column to our output with the aggregate function results. In this case, we only had one aggregate function, that is count, so we only get 2 columns to our output. To clarify things even more, let's highlight from the table on the left which events belong to which rows on our output. So the first 4 events belong to the first aggregation, since all of them are in the first 10-second window. Then the next 4 events are in the next 10-second window, so they belong to the next window and are aggregated to the second row in our output. This logic continues for the rest of the rows, so that all of them belong exactly to one tumbling window and are part of the aggregate made in that window. Next, let's cover the brother of tumbling window, hopping window. Like tumbling window, this window also uses fixed time intervals, but the major difference compared to tumbling window is that these windows can overlap, and events can belong to multiple different windows. Like tumbling window, this window is also triggered at regular intervals, but for this window we have to configure the duration and the hop size. Hop size decides how long it takes for another window to start after the previous one has started. For example, using a 5-minute window with 2-minute hop size, the first window will be from 12 to 12:05, and then the second window will start 2 minutes after the previous one started, so that they overlap, which means that with this configuration the second window will start 12:02 and run until 12:07, and the third window will start 2 minutes after the second window, which means that it will run from 12:04 to 12:09, and so on. This window type is particularly useful for continuous monitoring and for applications that need frequent updates on the recent data. These overlapping windows allow analyzing smoother trends by avoiding abrupt changes between time periods. This window can answer to questions like how many website visits occurred every 5 minutes, updating every minute. What is the moving average of CPU usage every 10 minutes, updated every 2 minutes? What is the total revenue generated in the last hour, refreshed every 10 minutes? What is the average temperature in the last 20 minutes, updating every 5 minutes? So, if in the exam you get any questions that describe fixed time intervals with more frequent updates than the interval itself, then go for the hopping window as the answer. Again, let's do a visual representation of hopping window. Let's have a hopping window with count aggregation, hop size of 5 and duration of 10. And then let's have our timeline and then our events on that timeline. And by the way, these events are exactly the same we had in the previous tumbling window example. Now let's see how these events would go into our hopping windows. Our first window starts from 0 and runs to 10-second mark. 4 events belong to this window. Then now our second window is triggered 5 seconds after the previous window, which means that it starts at 5-second mark and runs to the 15-second mark. This means that these two windows overlap and we have event D that arrived at 7-second mark and thus belongs to both windows. And then we have those 3 events that happened between 10 and 15 seconds and also belong to the second window. So the aggregated count for both of these windows is 4. Then these windows will continue to hop forward from here and events can belong to 2 different windows with these parameters. And of course we could have, for example, 10-second window with 1-second hop and then one event could be part of even more windows. But this visual representation would get very messy very fast. Next, let's again go through the same situation, but now in table format. That is the format you are seeing in the event stream. So we have again our incoming events with their timestamps, and then we have our hopping window configuration. And like we went through, the first 4 events belongs to our first window, but also the last of those events, the event D, belongs also to the second window. And then we keep adding those windows according to our parameters of hop size 5 and duration of 10, and see that there is quite a lot of overlap and thus we get way more rows as an output than in our previous example with the tumbling window. Next, let's cover sliding window. And I have to warn you, since this window type is the most confusing, at least it was for me to understand. So now pay extra attention if you want to understand this one and get your points in the exam. So, sliding window is triggered dynamically based on incoming events. So, the window opens when a new event arrives and is detected. Then the window will look back in time the specified duration and see if there are other events, and those will then belong to that same window, if they are within the range of the specified duration. Also, the event that triggered the sliding window will trigger a new window after the event that looks forward in time the specified duration. However, since the triggering event will only belong to the window that looks back in time, it is possible that forward-looking window is dismissed if there are no other events happening in the specified duration after the event. So unlike tumbling and hopping windows, these sliding windows don't start at fixed intervals and they are triggered by events themselves. These are the best for continuous real-time calculations and ideal for calculating moving averages, trend analysis, and anomaly detection. These windows will overlap naturally if there are many events that are happening in clusters, which will then trigger multiple windows to that point in time. And this allows more granular real-time insights compared to the fixed interval-based windows. This window type answers to questions like what is the moving average of stock price in the last 10 minutes, recalculate whenever a new trade occurs. What is the average temperature recorded in the last 20 minutes, updated every time a new sensor reading arrives. What is the total energy consumption over the last hour, updated every time a new meter reading is received. So if in the exam you have a question about updating or calculating something based on event arrivals and receiving new data, then go for sliding window. And especially if it talks anything about calculating something X amount of time backwards from the event itself, definitely sliding window. Next, the same thing we did before, let's visualize this. Let's have a sliding window with count aggregation and duration of 5 seconds. And here we have our timeline and then events on that timeline. This time let's have fewer events so that this won't be so confusing. Now you can think that sliding window will start to scan for events. And it can't find any events within the first 5 seconds. So no windows are triggered and it will continue move forward. It finds the first event on 6-second mark, which will then trigger a window that will look back 5 seconds. And this time only event A will belong to this window since there are no events before it. However, right after event A, a new window is triggered that looks forward 5 seconds, and this will find event B in the 10-second mark. But also event B will trigger another window that will look back 5 seconds, and it will also include event A, since it is in that 5-second window looking back. B will also trigger forward-looking sliding window, but since there are no events after B, this window will be dismissed. Our actual fourth window will be then triggered by event C, and that will be the only event in that window. Then these events in this cluster will start to trigger multiple sliding windows that overlap. And finally, the event E will trigger the forward-looking window that doesn't find any events and is dismissed as a result. Next, let's go through this in table format. Here we have our input with the same events that we had on the previous slide, and then we have the same sliding window configuration and the same output. And like we went through, the first window is triggered by a message A, so that window will end at the same time the message A is received. Then from A we had that forward-looking sliding window that gets only B. And from B we had that backwards-looking window that has both A and B. And then we continue from here in a similar way we did on the previous slide. Also, I will add here a number corresponding to the window on the previous slide so that it makes it easier for you to break this down more if it still feels a bit confusing. Good thing to know that this was, in my opinion, the most difficult window to understand, so it will get easier from here. Next we have session window. These windows have dynamic size based on inactivity, which means that these windows are not fixed and they can end if inactivity threshold is reached. For example, if specified, window can end after 10 minutes of inactivity, or in other words, no events in 10 minutes. These windows will start and end dynamically. New window starts when event arrives, and it will start to look forward from that event. These windows will keep running until the max duration or inactivity threshold is reached. These windows are best for analyzing user behavior and sessions, ideal for tracking user activity, customer interactions, or machine uptime. For example, group website visits into sessions based on user inactivity, so that 30 minutes of inactivity means that it will be a new session. These session windows can overlap if used with optional partitions, which means that we would divide data into sessions based on, for example, user or device ID, so that we would be able to track those sessions independently and not count them into one session. This window helps to answer questions like how many website visits were part of the same browsing session, how long does a machine remain active before downtime, what is the average duration of streaming sessions before a user disconnects, how many transactions were completed within each user session. So if the exam asks something about different sessions or calculating something based on downtime, then go for the session window. Again, some visual representation of session window. Let's have aggregation as count again, max duration of our window as 10 seconds and timeout of 5 seconds. This means that our window will end after 5 seconds of no incoming events, or it will have a hard stop at 10 seconds if there is a constant stream of events. Here we have our timeline, and on our timeline we have a bunch of events arriving at different times. Now let's start to add session windows. Our first session window is triggered when event A arrives, and this window is able to reach event B, since it is received 4 seconds after the event A, so that the timeout is not reached. After the event B, our window closes at 11-second mark, when the max duration of 10 seconds is reached. And also the timeout after the event B would be also reached. Then our second window is triggered at 12-second mark by event C, and it will include also event D and E. However, after D and E, we have some gap before event F. So that's why our window will close 5 seconds after our D and E event, which means that the total duration was now only 7 seconds. Then we have our third window that will run that full 10 seconds from event F and include events G and H also. As we can see now, we don't get any overlap since we are not partitioning this data anyway, but it would be possible that we could have different types of events coming in, and then we would start sessions for those independently and have some overlap in our sessions. Next, let's go through this in table format. Again, here we have our input and then our session window transformation and then our output. And based on the parameters and window end time, we can see which message belongs to which window in our output. And here I have also highlighted those messages like in the previous example, so it is easier to break down. Then we have our final window, snapshot. This window is a bit different to previous ones, but very easy to understand. In nature, this is not a window, since this function groups events together that happens exactly the same time. No time duration can be defined for this function, and it is just based on the events that happen at the same time. Snapshot is triggered when a new event arrives. For example, if 3 events arrive exactly at the same time, then they will be grouped into one snapshot window. This window is best for analyzing simultaneous events. It can be used to detect some anomalies, for example, orders that are placed exactly at the same time. Since these are just snapshots, there can't be any overlapping windows because window ends at the same time it starts. If events arrive even slightly different times, they belong to different snapshots. This window type answers to questions like which order were placed exactly the same time, how many error logs were generated at the exact same moment, what is the total value of orders placed at the exact same timestamp, what is the average temperature recorded across multiple sensors at the same time. So if in the exam you see something about events that happen simultaneously, then snapshot could be your answer. Again, let's visualize the snapshot. For snapshot, we have to only define the aggregate function. That is going to be the familiar count in this case. Then we have our timeline and the events on that timeline. Then we would start to run our snapshot function for these events. The first snapshot would only capture event A, and the second snapshot event B, and the third snapshot event C. Assuming that events D and E arrive exactly at the same time, these two would be then captured by our fourth snapshot, and the aggregation would be count of 2. Then our last 3 snapshots would have only 1 event per snapshot, so that those would have the count value of 1 each. Next, same thing as previously, let's go through this on table and row level with the same events. Like we covered on the previous slide, all the other aggregate values will be 1 except the fourth one that captures events D and E, since they arrive exactly the same moment. And here again I have highlighted those rows, but in this case I think this is pretty obvious which events belong to which snapshots. Then on the next slide I just have a table comparison of these different windows. I'm not going to go through this table row by row and column by column since we have already covered all the points here. This is here just to highlight the key differences of those window types, and you can pause the video if you want to go through this table. Otherwise, we will jump into Fabric and check out how these windowing functions work in action. Now we are in Fabric, and here I have this event stream that I have already configured, and this event stream has this custom endpoint that is receiving this message data from this Python script that I have running on my computer. And here we can preview the data, and here we can see that we have these columns that are generated by event streams, and then we have these columns that are coming from that Python script that I have running. So we have the timestamp, and then we have these text messages here, and then we have also message ID for those messages. And I can quickly show you that Python script that I have running there locally. And here we have that Python script that is running on my computer. And this is very similar to that script that we had in the previous video. And if you'd like to get this script and run this by yourself, you can go to the link in the description, and there you can find the materials for this episode. And for this you would need to install that Event Hub with pip if you want to run this, but basically you would need to configure this in a very similar fashion that we did with the last time. So you would need the Event Hub name from your custom endpoint, and then the connection string that is actually a secret, so in some cases you don't really want to expose this, and then you would start to run this script. And this script will start to send messages to that custom endpoint by using these min and max delay parameter values here. So this will send messages every 0 to 10 seconds, and those messages will be combined from these strings that I have in these lists. So it will generate this random string based on these here and send it to the event stream. And here we can see that it's sending events and waiting that specified second amount that is random between these two amounts. But yeah, let's go back to Fabric. And here I have this event stream that we are running, and here I have already configured these window functions that are processing that data to the Eventhouse. And also I'm sending that raw data directly to that Eventhouse as well. But yeah, let's go to the edit mode and check out those configurations. And here we have these group bys that are actually used to configure those windowing functions. So basically from this transformation list you would need the group by to be able to configure some windowing functions. And to this first one I have configured the tumbling window, and we can check out the tumbling window configuration here. So for the tumbling window we can specify the aggregations that we want to do, and here we can add more aggregation functions to the same tumbling window if we want. And here we have a bunch of different aggregation functions that we can use. And then we would specify the field that can be used for those aggregations, and then the output name for the column that comes out as a result of this aggregation. But I'm now just using this count all rows and have that as count in the output. But yeah, then we have these options here to specify a group by column if we want to group by the data like we would do in a SQL group by sentence. And here we have the window configurations, and like discussed, the tumbling window only needs that duration. And then we also have this offset setting that can be used to offset the window a bit so that it will take the events that happen in the beginning rather than in the end of the windows. And then I have configured the output of this tumbling window to be written to this SQL database and this table E6 tumbling window. And then we can go to the hopping window, and very similar configuration here, nothing really new except the hop size has to be configured so it will hop that specified hop size that we covered in the theory section. Then let's move forward to the sliding window, and here we only have to specify the duration, and we can also specify the group by here as well if we want. But yeah, this is a very basic configuration, even though the sliding window is, in my opinion, the most confusing one. But we already covered how this functions in the theory section. And then we have the session window, and for this we have to specify that max duration and also that timeout that we discussed. Then we have also that partition option, so we can track different partitions so that we could, for example, track session per customer ID or device ID, so that we would keep them as individual sessions and not track everything in one session. That doesn't probably make sense in most scenarios. And then lastly we have the snapshot, and here we can't really configure much since now we are just taking those snapshots here. And one thing that I want to note here, that this development view in this event streams for these window functions is a bit buggy, so it always shows that these windows have arrived on the exactly the same moment when looking at them in this development view. But we can of course check the results in the SQL database to see that we actually have those windows there and we have some correct amounts. So for example, with the tumbling window, we don't have like 713 events that occurred in one 10-second window. That is not correct. But yeah, we can go to the SQL database and here check out how those look. So here we have the raw data, and here we have those raw values that are coming in, and we can see that they are flowing and their interval is a few seconds or so. So like specified in the script, these events are being sent from 0 to 10-second intervals. And then first we have the tumbling window, and here we can see that now we have some proper amounts here, that these are the events that have occurred in the 10-second window. And then we have the hopping window, and here we have also events that have occurred in these hopping windows, and here we can see that their interval here is 5 seconds because we defined that hop to be 5 seconds, so that we can see that every window ends between 5 seconds. And then we have the sliding window, and here we see that these are now random, these window end times. Since sliding window will begin from the event itself, so that these events can occur quite random times, so that these times are not so sharp like they are in this hopping and tumbling window here. But yeah, then we have the session window, and also here we have some random times because this will also occur from the event itself. And lastly, we have some snapshots, and these snapshots all have count of 1 since we are not sending any more than one event at a time. So it is not possible to have anything than 1 here, because it is not possible that 2 events would leave out from that script at exactly the same moment. Next, let's have some questions about these windowing functions. But before we do that, I would like to tell you about this service or website that I have made with few friends called certiace.com. Here we can find some practice questions to, for example, a DP-700 exam. And here we have over 100 different practice questions for that exam. So if you're interested in getting some free custom-made practice questions for DP-700 exam, go check out certiace.com. And this site works well on mobile as well, so you can use it on your phone wherever you are. And here we basically have some multiple choice questions related to topics covered in the DP-700 exam. And here you can start practicing to the exam with these questions. And we also have a link to the documentation and some explanation about the correct answer here. But yeah, go check out this website. Our first question today is, the requirement is to calculate the average temperature over the last 5 minutes, but only when a new sensor reading arrives. Which windowing function should you use in the Eventstream group by transformation? Is it A, tumbling window, B, hopping window, C, sliding window, D, session window? Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, sliding window, since these other Windows types won't allow you to look backwards from the event creation with their windows. Let's have another question. A security team is monitoring a banking transaction system for potential fraud. They need to detect accounts that perform multiple high-value transactions in rapid succession but remain inactive for at least 15 minutes before making another transaction burst. Which windowing function should you use in Eventstream? A, tumbling window, B, hopping window, C, sliding window, D, session window. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, session window. Session window is best suited for this scenario because it groups events based on periods of continuous inactivity and closes when inactivity exceeds 15 minutes. Tumbling window operates on fixed intervals, so they wouldn't correctly group bursts of activity. Hopping window uses fixed overlaps, but they don't dynamically adjust based on inactivity. Sliding window looks back a fixed time, for example 15 minutes when a new event arrives, but they don't define sessions based on gaps in activity. This is the episode 7 in this DP-700 exam prep series, and in this episode we will cover the data pipeline tool that is one of the main tools covered in the DP-700 exam. Like in every episode in this series, we will start first with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in the episode, so that you can test your knowledge. Before we get started, I want you to know that in this episode I cover the basics of data pipeline tool from the point of view of DP-700 exam. But I have also done over 3-hour-long course on this tool that I highly recommend to watch after going through this video, if you really want to make sure that you get all the questions correct about this tool in the exam. Link to my over 3-hour-long free data pipeline masterclass can be found in the description. But now, let's get started. Let's start by talking about what this data pipeline tool is all about. Here on the screen we can see the data pipeline development canvas that is used to build data pipelines in Fabric. Data pipelines are built by adding activities to this canvas, and here we can see some example activities that have been added to this canvas. Also, there are many more activities that can be added from the top bar. And data pipeline tool integrates very well with other Fabric tools like notebooks and Dataflows and can execute them as part of its execution flow. Also, it can execute actions in some Azure services as well, like Databricks notebooks, Azure functions, or Azure Data Factory pipelines, to name a few services. As you can probably guess from the UI of this tool, this is a low/no-code tool that is mainly operated using this drag-and-drop interface. And key thing to point out that this tool is mainly for data movement and data flow orchestration. And it has very limited data transformation capabilities, and those transformations can be done with other Fabric tools like notebooks and data flows, and then they can be executed as part of the data pipeline, and they will then do the data transformations that is required of that data pipeline. In this tool, you can define dependencies for different activities in the pipeline, and the most typical way is to define that some other activity is executed after the previous activity has been executed successfully, and these green arrows on this example represent those dependencies. There is also the possibility to define other dependencies, for example, that some activity is executed after the previous activity has failed. And on this canvas, we have that Office 365 Outlook activity that is defined to be executed if the copy data activity fails. These dependencies on the data pipeline make sure that these activities are executed in a logical order. This tool supports using parameters and variables that allow building extra logic to the data pipeline. And since this is a data flow orchestration tool, it can be, of course, scheduled and triggered. But yeah, here we talked about some of the core features and functionalities of data pipeline tool. And now let's dive a bit deeper into them. Let's start with activities. Like mentioned, these are the building blocks of data pipeline, and without these activities, data pipeline doesn't do anything. Microsoft divides activities into 3 different groups, and those are data movement activities, data transformation activities, and control activities. To be honest, I'm not the biggest fan how these activities are grouped into these different categories, since it is a bit confusing. But basically, the copy data activity is the only one that is classified as data movement activity, since it can copy data from source A to B. Then we have those data transformation activities that include activities that do some type of data transformation, like execute Fabric notebooks and data flows, or run stored procedures or SQL scripts. But the confusing thing is that copy data is also considered to be part of this category as well. Things get even more confusing when we talk about the last category, control activities. Here we have activities that control the pipeline's logical flow like loops and if conditions. And then we have activities that help to build logic to the pipeline like set variable and get metadata activity. But then we have activities that I would consider to be data transformation activities like Azure Databricks and function activity. Luckily, these categories don't really matter that much, and if you're interested in checking out those, go look at the activity overview documentation on Microsoft Learn to see which activity belongs to which category. Like I already mentioned, activities can run different Fabric items like notebooks, data flows, stored procedures, SQL and KQL scripts, and it is also possible to nest data pipelines, which means that in a data pipeline you can execute another data pipeline. Activities also extend to external services as well, and they can be used to execute things in an external compute environment like Azure Databricks or stored procedures in some external SQL database. Also, many different external data stores are supported, and you can copy data from them or into them with a copy data activity. Also, there are some generic activities like webhook and REST that can be used to interact with APIs. However, most of these activities that do things in external systems that are outside of Fabric require connections to be made. So let's talk about those. As the name implies, these connections or connectors are links to external systems and services. For data pipeline, there are already quite an extensive set of external systems to connect using a variety of authentication methods, and Microsoft is constantly adding new connections to choose from and new authentication methods to all connections. Also, some of the connections will require on-premises data gateway that acts as a bridge between Fabric and those external systems. Good thing to point out is not all the activities are supported for each connection. For example, some connections can be only used as a source, and you can only copy data from there to Fabric, but not the other way around. Also, other activity support varies quite a bit. For example, some external database connections support running stored procedures using stored procedure activity, and some not. Data pipelines also support passing external values into them via parameters. Parameters are very handy if you want to build more dynamic data pipelines that can serve multiple purposes. Also, like mentioned, you can nest these pipelines, and with parameters you can pass information from a top-level pipeline to a lower-level pipeline. It can be mentioned that many different data types are supported for parameters. Also, there are variables in pipelines that can be used in a bit similar fashion to parameters. The main difference between parameters and variables is that parameters are used to get information outside the pipeline into the pipeline, and variables on the other hand are defined inside the pipeline and have to be set during the execution using setVariable activity or using default values for them. Like parameters, variables also support many different data types, but option for different data types is a bit more limited compared to parameters. Pipeline parameters and variables can be referenced in other activities by using pipeline's expression language. This expression language allows adding more logic into pipelines and making them more dynamic. Very simple example of using this expression language would be adding dynamic timestamps to file batch when copying data from an external system to Lakehouse's file section. Since the pipeline is an orchestration tool, it is obvious that it can be scheduled to run at set time intervals. And by default, your new data pipeline doesn't have a schedule defined, and it has to be turned on and configured if you want to have one. Schedule supports configuring it from the minute level all the way up to month level. Currently, both start and end date and time have to be defined, and those define the period during which the schedule is active. Then schedule has also the option to configure time zone that can be used to select the time zone for schedule that automatically adjusts to summer and winter times if that specific time zone uses those. Also, good thing to mention here is that we have the possibility to configure triggers, which means triggering a data pipeline based on action rather than schedule. But triggers we are going to cover in a dedicated episode later on. Also, another topic that I just mentioned very briefly here is monitoring, since for that we are also having a dedicated episode that covers way more than just the data pipeline monitoring. But yeah, data pipelines can be also monitored from the monitoring hub, but more about this in a later episode. But now it is time to open up Fabric and do some demos/tutorials there. Now we're in Fabric, and here is the DP-700 example workspace open. And here I'm going to first go to the Lakehouse, and because I want to create here a new folder and upload one file to that folder. Let's first name this folder to DP-700 episode 7 folder, and to this folder I'm going to upload one file, and this file is going to be this movies.csv that just contains a few rows of data, and we have already used this in a previous videos on this channel. And now I will upload that to this folder, and we can take a look at that file. And in this file I just have few rows of data and a header, and this is following this pretty standard CSV format. So this is the file that we are going to use in the tutorial that we are going to have. And like always with my tutorials, this file can be found by clicking the link in the description that will take you to this Google Drive where I have all the materials for my tutorials. But yeah, let's continue with this tutorial, and next let's create a new data pipeline. And here we can find a data pipeline, and let's name that data pipeline according to our naming conventions, and let's hit create. And here we can start to build our data pipeline. I'm going to actually start with the data pipeline activity and with a blank canvas. But let's discuss a bit these other options that we have here. And let's start from the templates. Microsoft is already providing us these example templates for some example operations that we could do with data pipelines. And you could select here the template that you want to use. And by selecting one of these templates would add those activities already to your pipeline canvas and configure them a bit. So it is easier to get started with some things. For example, if you want to bulk copy data from some database, you could use this template. But yeah, we are not going to use these templates for now, but it's good to be aware that this is a possibility. And then we have the possibility to practice with sample data, and this will basically copy some sample data from Microsoft so that we can use it to practice our skills without having any actual data that is coming outside or is our own. And lastly, here we have this copy assistant, and this can be used to build data pipelines fairly quickly. So basically here you just select some data from the source you want, and then you configure the destination for that data, and then you configure a few things, and then this will build you the data pipeline that you can use to copy that data from your source to destination. This is something that you can try on your own if you want, but basically this is kind of an accelerator of building these data pipelines. But yeah, we're not going to use this in this tutorial. So I'm going to start with the pipeline activity, and the activity that I want is the copy data. That is this activity that allows you to copy data from place A to B. But yeah, before we start to configure this copy data activity, let's talk about the pipeline UI a bit. And here we have this pipeline development canvas that we covered already in the theory section. And to this canvas, we can add those activities like discussed. For example, we have this huge list of activities here that can be added here. So there is actually quite a lot of depth to this tool, even though this is this no/low code tool that is operated via this drag and drop interface. And from here, we could actually drag and drop other activities to this canvas. And here, for example, I have this simple wait activity that just waits the X amount of seconds that is specified here. And then we could connect these activities by using these dependencies here so that the copy data activity would execute first, and then we would execute this wait activity here. And like I already mentioned, this pipeline can be also scheduled. And here we could define that schedule when we want our pipeline to run. And here we can configure those different time intervals, for example, hourly or daily. And then we would, for example, select the time of the day we want that pipeline to run. And then we can go all the way to the week level and select the days we want this pipeline to run, or then we could even go to this month level here and configure some other stuff here. But yeah, this time we are not going to schedule these pipelines, so we are going to just discard settings here and go back. Then we have also possibility to trigger this pipeline based on some storage events, but we are not going to talk about triggers in this episode since we're going to cover them in a later episode. Also, one more thing that I want to show you here before we start to configure the copy data is that this pipeline is actually this JSON code or this JSON configuration on background. So basically, when we're dragging and dropping those different activities to that canvas, it is just generating this JSON code on the background. For example, here we can see the JSON block for that copy data activity, and here is the JSON block for that wait activity. And this is how you would see these pipelines in a version control like Git if you've connected this to Git. And you could actually use these JSON configurations to do some bulk operations to your pipelines if you know what you are doing. For example, replace something in all your pipelines that are in that specific folder in your version control. But this is a bit more advanced topic, but it is good to know that these pipelines are these JSONs on the background. But yeah, let's cancel this for now since we don't want to make any changes to this pipeline JSON here. And now let's go into our copy data activity. And when we click this activity, we get some more tabs here that are used to configure that specific activity. And on this first tab, we have just some general settings like what is the timeout and do we retry that pipeline, and some advanced settings here like the retry interval and do we have secure output and input for that activity. And on the source tab, we are going to configure the source for our copy data activity. And here we can actually configure some external systems if we click that more button there. And here we can see that there are possibilities to create these connections to many different places. And we can click this view more and see that these are the connectors that are currently supported. And these are some external systems. And here we have plenty of Azure databases and services, but also many things that are outside of the Azure ecosystems, like DP2 database and Snowflake and SAP HANA database. But yeah, this is an ever-expanding set of connectors and connections to different systems that can be used here in the data pipeline tool. But in this tutorial, we are not going to connect to any external systems, and we are actually going to use the Lakehouse where I just uploaded that file previously, and it's going to be the Lakehouse that I have in this workspace. And here we have to configure, are we using the Lakehouse table or file section? And I uploaded that file to the file section of the Lakehouse, so we are going to use that. And then we can use this browse button and find our file there. and here should be our file, and then we can click OK. And then we just need to configure some things about this file. Now it is saying that our file format is binary, so it is treating it as a binary block and not really caring about the contents of this file. So this means that we could copy that file as a binary block, so it wouldn't matter if that's an audio file or video file or a flat file that we have here. And here we have some different file formats that are supported for copy data. But yeah, now I'm going to pick this delimited text, and then we would configure these delimited text settings here. But I already know that my file follows these default settings that we have here. And we can confirm that by clicking this preview data button here. That will actually preview that CSV data there and show that in a table format like the data factory would read it. So that we can see that we have the header there and our columns look correct. So our data looks fine. So basically we are ready to copy that data. Then next we would configure our destination, and our destination is actually going to be the same Lakehouse that we use as our source. But this time we are going to do a slight data transformation, since we are going to copy that data from that CSV file to a Delta table in our Lakehouse. So the data format will actually change. And this is an example of this very limited data transformation capability that copy data has. If you would need some more advanced data transformations and do some calculations or something like that, then you would need to look into some other tools in Fabric like Dataflows and notebooks. But like I already mentioned, they can be added as activities to this pipeline, so everything can be orchestrated with this pipeline tool. But yeah, I'm going to create a new table to that Lakehouse since I'm not going to use any of these existing tables. So I click this enter manually, and then I'm going to define the table here. And I'm going to say that I want to write that movies.csv file to this movies table. And here under advanced settings, we can just select some table actions. And in this case, I want to always overwrite that data. So I don't want to append that data to that table. I want to override it every time this pipeline runs. Then let's talk a bit more about these limited data transformation capabilities that this copy data has. And let's open up this mapping tab, and here we can import the schemas of our source and destination. And this will actually do the schemas for us. And here we can see that now we are copying data from these columns to these columns. So here we actually could rename some columns and also change their data type. And we can, for example, do some slight data type transformations here if we want. I can just change our year to be integer, and maybe the rating I'll change as double, because those are actually integer and double values, even though in the CSV file everything is string. And here we could of course drop some columns that we don't want to copy. So this is another example of this very limited data transformation capabilities that copy data has. But basically things with the data transformation capabilities do not extend much further from here. Then lastly, in this copy data, we have this settings tab, and here we can, for example, change the parallelism of this copy data activity, because copy data activity also tries to do these parallel copies. So it will run things in parallel so that things are way more efficient. And also here we can optimize the copy data a bit. But yeah, these optimizations and parallelism settings are a bit more advanced topics that we are not going to cover in this video. And now we could actually run this pipeline and see what happens. Let's click this run button here and let's see that does everything goes correctly. So we have these two activities here that are going to run. So the copy data and wait activity. And now our pipeline is running, and then we can monitor the run here from this output here. And now our copy data will start to run. And after a little while, our copy data has succeeded, and also our wait activity has succeeded. And we can see that that wait activity waited until the copy data activity went through successfully before executing, because we have defined that dependency for those two activities. And by clicking this copy data activity here, we can get some more information what happened during that copy. So basically one file was read and one file was written, and there we can see how many rows were written as well. And now we could actually go to our Lakehouse, and here we could see probably a new schema if we refresh our schemas here, and there we should have a table, and here we have that movies table, and here in the movies table we should have the same data that we had in that CSV file. And here we have our data, so we can see that we have exactly the same data we had in the CSV file, but we can see that those data types have now changed, so only the film column is a string. And now let's go back to our data pipeline and let's do a few more things. And let's take this pipeline a bit further. And let's talk about parameters and variables. And like I discussed, these parameters and variables can be used to make the pipeline a bit more dynamic. Let's create two parameters to this pipeline. And let's name those parameters. And first is going to be file underscore name. And the second one is going to be table underscore name. And then we can, for example, give some default values for these. And for the table name, I'm not going to give a default value since we are actually going to change that a bit when we run this pipeline. And then we could also define some variables here, and we could define some variable, for example, ABC, that could be set here. And we can set a default value for that variable to be 1, 2, 3. But these variables and parameters are slightly different because if I would hit this run button, we would have to define the parameters before this pipeline runs. But as you can see, we don't define those variables when this pipeline runs, because those variables live inside the pipeline and the parameters are coming from outside to the pipeline. But yeah, these topics I cover in way more detail in my 3-hour-long data pipeline masterclass. So go watch that after watching this video. But yeah, now I would like to use these parameters in my copy data activity. And as you can see, when we click this fields active, we can see this add dynamic content pop up here. And we can click this and open up this pipeline expression builder. And here we could, example, use these different functions to build some logic to these different parts of the pipeline. But yeah, now I want to only use these parameters that I have defined here. And here, because we are talking about the source, I want to use the file name parameter and have that there. So instead of hard coding that file name here, we are passing that as a parameter to this specific field. Then to the destination, we want to do the same thing, but now for our output table. And here we want to select the table name parameter. So instead of hard coding that, we have that as a parameter. And then we can click OK. And then we could click this run button, and then we would have to save again our pipeline and then run it. And then we can define something else to this table name than movies. We can, for example, say movies underscore 2. And now we can click run. And now our pipeline should be running soon. Let's see, it should start. And now we can see that our copy data is running. And here we can actually see this input that went into that activity when we defined that. And this is also this kind of a JSON here where we can spot things that we have happening in that and we have configured for that specific activity. And if you know how to read this, you can spot that now we have this movies 2 there instead of that movies that we had originally, since this value came from that parameter dynamically. But yeah, this is also a bit more advanced topic and we're not going to discuss this input and outputs much more in this video. But yeah, now our pipeline has succeeded and we can go to our Lakehouse and we should have a movies 2 table here. And there we have movies 2. So now we dynamically change the table name in our pipeline. And let's talk about these different dependencies that can be defined here in the pipeline. We can see that we have these different dependencies like on skip, on success, on fail, and on completion. And now I want to give a brief introduction into these dependencies. So let's copy a few more wait activities to this pipeline and let's define some other dependencies between these. For example, we can define that this wait activity will only run if this activity will fail. And because this is a wait activity, this won't probably ever fail. So in most cases, this won't ever run. And then this other activity we can define to be run if this activity is skipped. So this skipped means that if this activity doesn't run at all, then this activity should run. So in this case, when we have the dependencies built like this, that this wait activity will run after this copy data succeeds, and this will run, and then this won't run because this won't ever fail, and because this won't run and is skipped, then this will run. And then we have also that on completion dependency that can be used, and this means that this wait activity will run if this wait activity either fails or succeeds. So it is just completed, but if it's skipped, then this won't run. And one other thing that I want to show is that we can deactivate activities, and we can click this deactivate button here and deactivate this copy data. And then we can see this icon here that this activity has been deactivated, and it's also grayed out. And we can see that this icon here means that this activity will be marked as succeeded when this pipeline runs, even though it doesn't run and is deactivated. It would be also possible to mark this something other than succeeded if we delete this dependency here and activate this once again, and then we use this onFail dependency here, and now we deactivate this. Now this would be by default failed activity. And also this should work if we define the skip as well, and then we activate this and deactivate, and now this will default to that skip button. It would be nice to have here an UI option to choose this, but with this way we can choose how does the activity look when it's deactivated. But yeah, we are just going to have that as succeeded and now deactivate that. And then we can just add one more wait activity here and add, for example, onFail here, and see which of these activities will actually execute when we run this. And now we can run this pipeline and let's see what happens. And let's click save and run, and then we would have to define those parameters, but since we're skipping that copy data, it doesn't matter if I don't provide anything to that table name. And now since we're skipping that copy data and it doesn't execute, we are going to complete this very fast since those copy activities will run. And here we can see that we skipped that copy data, so it was inactive. And then we run this first wait activity here, but this wait activity doesn't run because this succeeded. And this wait activity ran because this wait activity was actually skipped. And this wait activity ran because it was defined to be on completion, which was that this activity either fails or completes. So this ran, and this wait activity didn't run because it was marked to be on fail, and our copy data was already succeeded by default since it was skipped. But yeah, I hope this dependency thing is not too confusing, and really this is very logical. If you just try to break this on your own, if you didn't understand it from my maybe a little bit confusing explanation here. But I apologize if I didn't manage to explain this very clearly. But yeah, like mentioned, most of the topics that I mentioned here just very briefly are covered in way more in depth in my 3-hour data pipeline masterclass. And next we could have some exam-like questions about the data pipeline tool. But before we do that, let's open up this Certia's website that I have built with a few of my friends. And on this website you can find some free practice questions to DP-700 exams. So here we have these 5 different modules, and under these modules we have plenty of different questions that are these kind of a practice questions for the DP-700 exam. And these questions are custom made by me and my friends. So you can use these questions and practice for the exam and test your knowledge before taking the actual exam. But now let's go to those example questions in this video. What will happen when a data pipeline with only these 2 activities is executed? A. Wait 1 will run first, and then if it fails, wait 2 will run. B. No activities will be executed. C. Only wait 2 will be executed. D. Only wait 1 will be executed. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B. No activities will be executed. Let me clarify this a bit, since this could be a bit confusing to some why nothing will run in this case. I will highlight the key things to pay attention to in this picture. The first thing is that the wait 1 is actually deactivated, so it won't be running. Then that green circle with the check mark means that this activity will be marked as completed when the pipeline runs, even though it won't execute. Then the last thing is that wait 2 has onFailure dependency to wait 1, which means that it will only run when wait 1 fails. And since we have defined wait 1 to be successful even though we don't actually execute it, the wait 2 will not run. This means that when this pipeline executes, nothing will actually execute. Here we can see how does the output look when this runs. Let's have another question. Which of the following statements is true about the copy data activity? A. Copy data activity only transfers data between cloud-based data stores. B. Copy data activity supports data movement from both on-premises and cloud-based data sources. C. Copy data activity is primarily used for complex data transformations and aggregations. D. Copy data activity doesn't support parallelism or performance tuning options. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B, since copy data indeed supports data movement from both on-premises and cloud-based sources. Option A is incorrect since it talks only about the cloud. Option C is also incorrect since copy data is not capable of complex data transformations. And finally, option D is incorrect since copy data supports both of these. This is the episode 8 in this DP-700 exam prep series, and in this episode we will cover Dataflow Gen2. That is one of the main data transformation tools in Fabric. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials in Fabric, and then we end the episode with few questions related to topics covered in the episode, so that you can test your knowledge. But now, let's get started. Here on the screen we can see how the Dataflow Gen2 development view looks in Fabric. As you can probably tell from the UI, this is a no/low code tool like the data pipeline tool that we covered in the previous episode in this series. However, the main difference compared to the data pipeline tool is that Dataflow Gen2 is packed with data transformation features. Dataflow Gen2 uses Power Query online to perform data transformations for the data, so that's why some of the elements in this UI might seem familiar to people who have been using Power Query in other tools like Excel and Power BI. But now let's take a bit closer look at the different elements in this Dataflow Gen2 UI. Let's start from the top where we have the Power Query ribbon. With this ribbon you can manage sources and destinations for the data flow and perform different kinds of transformations for the data like filtering, sorting, merging, pivoting, splitting and appending, to name a few transformations that you can do. But basically there is a vast selection of transformations that can be applied to the data. Next we have the queries pane that shows the different queries that we have in this specific data flow. Queries contain X number of steps or transformations that are done for the data. For this example we have 3 queries. The first 2 queries both read one CSV file and then do some transformations for the data, and then the third query merges the results of those 2 previous queries together and then does even more transformations for the data. And this thing that I just described can be seen quite easily in the diagram view of the UI. That is the next element in this UI I want to talk about. Diagram view allows you to visually see how the data sources are connected and the different applied transformations. This view can be turned on or off, but in my opinion this is a very helpful feature for understanding on high level what is happening in the data flow. Then below the diagram view we have the data preview pane. It shows only a subset of data to allow you to see which transformations you should make and how they affect the data. You can also interact with the preview pane and use it to do some data transformations for the queries. The data preview shows you how the data would look for the selected query after transformations have been done. In this case I have selected the merge query and this data preview shows the preview for it. Then the last element that we are going to talk about is this query settings pane. And like with the data preview pane, we can see the query settings for merge query, since in this screenshot I have it selected. In this pane each transformation is represented as a step, some of which are automatically applied when you connect to the data source. Depending on the complexity of the transformations, you might have several applied steps for each query. Most steps have gear icon that allows you to modify the step. Otherwise you must delete and repeat the transformations. Also in the query settings pane you can see a data destination option. That is a Lakehouse in this example. And here we have now covered the very basic elements of the Dataflow Gen2. Next, let's talk about data sources for it. Since Dataflow uses Power Query as its engine, there are many different sources from which it can fetch data, and here on the screen we can see only a subset of those connectors, since currently there are over 100 different supported sources that can be used with Dataflow Gen2 with different authentication methods. Probably from this screenshot you can already spot quite a many familiar systems and services that are supported. And at this point Dataflow supports way more different sources than Data Pipeline tool that we covered previously. Also, it is good to keep in mind that many on-premises sources will require adding a gateway that we are not going to talk about in this video. Next, let's talk about destinations for Dataflow. For destination side, we currently have only 5 supported connections that are Fabric Lakehouse, Fabric Warehouse, Fabric SQL Database, Azure SQL Database, and Azure Data Explorer. In the future, this destination list can change, but these are the currently supported destinations when filming this video. Data to these destinations can be written using either append or replace method, and the only exception here is that Azure Data Explorer doesn't support replace method, and data can be only written there using append. Also, some of the destinations support using dynamic schema for the data, meaning that when Dataflow writes data to a destination, new columns can be added to the table. Also, Dataflow can create new tables when writing data to a destination, but this currently has some limitations that, for example, creating a new database schema for the table is not widely supported, and Dataflow will write the tables to default DBO schema. Then next talk a bit about mQuery, that is the functional programming language used in Power Query that the Dataflow Gen2 is also based upon. This language is also called M language. The good thing to know here is that the Dataflow actually generates mQuery in the background when you are defining new queries in the UI. So Dataflow is actually just a visual tool for generating mQuery. However, it is not really mandatory to know how to write mQuery or even read it to use Dataflows, but this can be helpful in some cases. Also, the current iteration of DP-700 exam doesn't require you to know the syntax of mQuery. Then a bit about scheduling and running data flows. Of course, data flow can be triggered manually from the Fabric UI, but there are also other more sophisticated ways of running them. One way would be to schedule the data flow in a very similar fashion to a data pipeline, and just to define a schedule from minute level all the way up to month level for your data flow. This would then run your data flow according to your schedule, and then you could monitor the run from the monitoring hub. The other way would be have the data flow as an activity in a data pipeline, and then schedule and orchestrate the run with that data pipeline. This is my favorite way of using the data flow, since this allows the data flow to be a part of a bigger data solution that is being orchestrated by the data pipeline tool. And this was the last slide I had on this theory section today. There would be so many more things to talk about this tool, but since DP-700 doesn't require you to know this tool in very detailed level, let's end the theory section here, and next let's go to Fabric and do a demo/tutorial on this tool. Now we're in Fabric, and here I have my DP-700 example workspace open. And let's start from my Lakehouse, to which I have created this new folder called DP-700 Episode 8 folder. And in this folder I have 2 CSV files, departments.csv and employees.csv. And let's check out the contents of these files. In these files I just have few rows of data and a header. So we are going to use both of these files in our tutorial and build data flow by using these files here. And I have already used these files in a previous tutorial in this series, and these files can be found by clicking the link in the description that will take you to the Google Drive where these files are. But yeah, let's hit the create button here and let's create a new data flow to this workspace, and we're going to create the Dataflow Gen2 here. And first we would have to provide a name for our data flow, and then I'm going to enable these preview features for the data flow, since some of the features that are coming to the Dataflow Gen2 are still in preview, but they will be available for the data flow quite soon, I imagine, and I don't want this video to get outdated very fast. So we are going to just enable those preview features to have them available there for now. But yeah, let's hit create, and this will create a new data flow for us. And here we have this Power Query canvas to which we can start to develop our data flow. And here on the top, we can see that Power Query ribbon that allows us to do some transformations and all kinds of things for our data. But let's start with our sources, since we want to get those CSV files here to the data flow so that we can start to work on those. And we can click this Get Data button here, and we can select some more options that we have here. And here we can actually view all the sources that we currently have available for data flow. And we can see that we have quite an extensive set of sources available. And here are many different types of sources. And not all of these sources are very traditional database sources, so many of these sources can provide some semi-structured data, like for example some JSON type data out of them. But yeah, for now we are going to actually use one of the Fabric sources. We are going to use the Lakehouse as our source here, and we are going to connect to Lakehouse that I just showed to you. That is in this DP-700 dev workspace. So here we can navigate and find that Lakehouse, and there it is, and there we can find the file section, and in this file section we are going to find that folder that I have created there, and there should be our CSV files. Then we are going to pick both of those files and then hit create, and this will then create those queries that are needed to fetch data out from those CSV files to this data flow. And when looking at our data in this data preview pane, we can see that the data doesn't look correct. We can see that the first row actually has our header, and we can actually fix that by clicking this use first row as header when we have this query active here. And we can click that, and then this should fix the issue that we're having with that header. And now we can see that that data looks a lot better. And we can also expand these queries and see all of the steps that we have here in the queries and see how does the data look after each step. And here we can see that when we apply that final step, then our data starts to look correct. And if we expand this department CSV here, we can see that we don't have that many steps here. And in this last step, we still have those headers on the first row. And we can do the same operations for it and click this use first row as a header. And then it will also change the data types at the same time, since it figures out that the department ID is actually a number data type. It did also automatically same thing to this other employee CSV data. And now we can minimize those, since we have now prepared the data to be ready to be merged together. So that is the next thing that we are going to do. So we are going to merge these data together by using the department ID. Since I want to join the values from this department CSV to this employees.csv. And we can actually use this merge queries options here and use merge queries as new. So we define a new query when we merge these two queries together. So let's do that. So now we select the employees CSV data here, and we select the column that we want to use for this merge statement. And we want to use the department ID. And then we select the right table for the merge, and that is going to be the departments CSV, and for that we are also going to select the department ID. And here we can see those typical SQL type of joins here that will be then used for that data. So if you're familiar with SQL joins, these will make a lot of sense for you. But yeah, then we have also these fuzzy matching options here that can match values if they are not entirely the same, but we are not going to use this feature today. And then we can hit OK, and then we should have that new query here called merge, and that will actually merge those together. And now we can see that our data looks bit funny here, since we have all the columns from the employees CSV, and then we have this department CSV attached here. And then we would have to expand this department CSV here so that we get those columns to the same level as those other columns are that are coming from the employee CSV. And we can use this data preview pane to do that transformation by clicking that expand button here. And here we can select all the columns that we want, and we can hit OK. And then this will actually add that expand step to this query there. And this is one example how you can also use this data preview pane to do some transformations for the data. Next, we can demonstrate another transformation. We can see that we have this name column here. Now I would like to split this name column to the first name and last name. And we can assume that we have the first name and then we have the space and then we have the last name, since this data is very simple. Of course, in the real scenario, that wouldn't probably the case. But this is a very simplified example what we can do here. So let's add that transformation there. So let's click this name column active and then hit this plus button here, and then let's find that split by delimiter here. And then we are going to say that we want to split it by space. And then we can hit OK, and let's see what happens. Our query is again modified and we have a new step there. And this step will split that name column. And then we see that now we have two name columns here. We have name.1 and name.2. And then I would like to rename these columns so that the name 1 is first underscore name, and then the name.2 is last underscore name. And again, this modified our query there a bit and added this rename column step there. Next, I would like to write this data to our destination, but I don't want to keep all of these columns here. I just want a few of them, so we can add this choose column step here. And we can, for example, select the employee ID, first name, last name, and then we can select the department name and the location. And then we can click OK, and this will again add a new step to this query here, and here we have the result of that query. And we can also expand this query settings pane here and see all the steps that have been applied to this query. And if I would click these other queries active here, we would see the steps that are in those queries. But yeah, now we're interested in this merge query here. And now I would like to define a destination for this query. This can be done by clicking this Add Destination button here. And here we can see all of those destinations that are currently supported in the Dataflow Gen2. I would like to choose the Lakehouse to be our destination for this query this time. And I'll choose the Lakehouse, and then we can click Next, and then we can find the same Lakehouse from which we read those data from, but this time we are going to write a table there. As you can see, we have some different schemas for the existing tables that we have in that Lakehouse that we have added there in the previous episodes in this series. The current minor downside with Dataflow Gen2 is that we cannot actually write a new table to any other schema than DBO schema. So we cannot use this three-part naming convention here and say that we want to write our table to this DP-700 episode 8 schema and then say .table, for example. It doesn't accept this. We just have to provide the table name and then it will write it to a DBO schema. That is a bit bad in my opinion, and I hope this will be fixed at some point. But yeah, I'm going to write this one table to that DBO schema, and I'm going to rename that table so that I know that it is tied to this specific episode that we are currently doing. But yeah, this is going to be the table name that we are going to use. And we are going to select this Lakehouse DP-700 to be the destination for this table. Then we can click Next, and then we can adjust these settings for writing the data. We can actually untap this Use Automatic Settings and see that we can actually use the append and replace method. And then we have also the possibility to use the dynamic schema or the fixed schema. This means that if we would use the dynamic schema and there is a new column coming in from our source, then this will be automatically added to the table to which we are writing the data to. But for now, we can use those automatically applied settings that are replaced and use dynamic schema there. So we are going to go with those settings. And here we can see how does the column mapping go, and here we could actually do some slight changes to the data types if we want. But for now, we don't want to do any changes to those data types. So we can save these settings. And this will then add this destination for our data flow. And now we are done with our data flow. Before running this data flow, let's check out a few more things about the UI. And here in the View tab, we can just modify things that we are seeing here. For example, we can disable this diagram view here if we want, but in my opinion, it is a very helpful feature to have. And also here we can see a bit more of that M query if we choose this query script or step script here to be available. Remember that this is generating this M query on the background when you are creating these queries here in the visual UI. But yeah, let's have that as step query there. Also, we have the possibility to open the advanced editors and make changes to this query here directly if we know what we are doing. But yeah, this is an advanced feature that we are not going to use in this tutorial. So let's hit cancel. And like I said, this tool is packed with features and there would be many other things that we could cover in this video if we wanted to. But since DP-700 exam doesn't require you to know this tool in that very fine level, we are just going to cover the necessary parts of it. But yeah, now we can go back to the Home tab and we can actually hit this Save and Run button. That will actually trigger a run for this data flow immediately, and we can soon see did it went through okay or did it fail or what happened. But yeah, now that data flow should be actually running, and we can see from here the recent runs and we can observe what is happening there. And here we should see that this data flow is running quite shortly when we refresh this page here. And there we see that now that is running. And now let's wait that this data flow finishes and then we can go check out our Lakehouse. Do we have that table there that we wanted to write there? But yeah, it will take a little moment this one to finish. And now after a little while our data flow has succeeded and we can go check out our Lakehouse. Do we have that data there? And this would be added to our DBO schema. Like I described, that we cannot add new tables to any other schemas than DBO, since that writing doesn't support that two-part naming convention. And here we should be able to see the data that we wrote here using our data flow. And here we have that data that we created using our data flow by combining those two CSV files now in this Delta table here in our Lakehouse. But yeah, let's go back to our workspace. And if we would like to schedule our data flow, we could click these three dots here and then define a schedule for it using a very similar scheduling feature like we had with the data pipeline tool that we covered in the previous episode. And next, let's have a couple of questions related to Dataflow Gen2 so that you can test your knowledge. But before we do that, I'd like to tell you about this website that I have created with few of my friends called certiace.com. This website actually provides some free practice questions for Microsoft certification exams like DP-700 and DP-600. Go check out certiace.com after watching this video. But now let's have those practice questions. Our first question today is, which of the following is not part of the Dataflow Gen2 UI in Microsoft Fabric? A. Data Preview pane. B. Query Settings pane. C. Query Development Canvas. D. Power Query Ribbon. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, Query Development Canvas, since all the others are elements of Dataflow Gen2 UI. The element that allows you to visually see those queries on the canvas is called Diagram View and not Query Development Canvas. Refer back to the first slide in the presentation if you want to recheck these elements. Let's have another questions about Dataflow Gen2. Which of the following statements is true about Dataflow Gen2 in Microsoft Fabric? A. Dataflow Gen2 supports both append and replace update methods for all the destinations. B. Dataflow Gen2 only supports structured data sources. C. Dataflow Gen2 allows defining transformations visually, but it automatically generates mQuery in the background. D. Unlike Power BI data flows, Dataflow Gen2 relies solely on SQL-based transformations. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C. Dataflow Gen2 allows defining transformations visually, but it automatically creates mQuery in the background. The option A is incorrect since Dataflow doesn't support both append and replace for all destinations. Option B is incorrect since Dataflow supports other sources than structured ones also. Finally, D is incorrect since Dataflow Gen2 also uses Power Query and not SQL-based transformations. This is the episode 9 in the DP-700 exam prep series, and in this episode we will cover notebooks that are one of the most essential data transformation tools to know in the DP-700 exam. Covering all the features and things you could do with notebooks could take several hours, if not days, since notebooks are the most versatile data engineering tool in Fabric, since they allow you to write code very freely. I tend to refer notebooks as the Swiss Army knife of data engineering, since they can be used for pretty much everything what comes to data extraction and transformation, and I would consider them to be my favorite tool for doing data engineering. But like said, notebooks are a very wide topic, and in this video I'm going to cover the most essential parts of them to know for DP-700 exam. However, if you want to make sure that you ace every question about notebooks in that exam, you can check out my over 3-hour-long masterclass that I have made on notebooks. This masterclass covers many of the topics that we are going to go through in this video, but in greater detail. For example, topics like running notebooks with parameters and exit values and using notebook utils are covered in that series. So after watching this video, go watch my Microsoft Fabric Notebook masterclass to learn more. But now let's shift our focus to this episode. Like in every episode in this series, we will start with the theory section followed by demo/tutorials in Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now let's get started. Here on the screen we can see how does the notebook UI or development view looks in Fabric. And like mentioned in the intro, notebook is a code-based tool, so in order to use it you have to know how to write code, which makes this tool harder to get started with if you are not comfortable writing code when comparing to low/no-code tools like Eventstreams, data pipelines and Dataflows that we have covered in the previous episodes. Development in notebooks happens by creating these cells of code that we can see here. To these cells, developer writes their code. After the code has been written, these cells can be executed individually or by running them all from top to bottom or beginning from a certain cells. Also, there are different types of notebooks in Fabric and different language options for notebooks. On the top bar we can see that we have chosen PySpark to be default language in this notebook. And from here we could also change the default language to be something else. Currently in Fabric we have 3 different types of notebooks: Spark notebooks, Python notebooks and TSQL notebooks. We are not going to dive into differences between these notebooks in this video, since Spark notebooks are the main focus in the current iteration of DP-700 exam. If you want to learn more about TSQL and Python notebooks, check out my Microsoft Fabric Notebook masterclass video. But yeah, with Spark notebooks we also have 4 different language options. In the DP-700 exam you only need to know about PySpark and Spark SQL, since Scala and Spark R are out of scope for that exam. Also, somebody could be now asking what is Spark and what it has to do with notebooks. In this episode we are not going to focus on Spark, since we are going to cover it in a later episode, but just very briefly, Spark, or more correctly Apache Spark, is an open source parallel processing framework for large-scale data processing and analytics. Basically, it is a very powerful engine for processing data and support these different programming languages. When we have selected, for example, PySpark as our default language for the notebooks we are developing, we can see that by default the right corner of our cell says PySpark. The cool thing is that we can mix and match these languages in one notebook and use magic commands to change language per cell, like we see in our second cell where a magic command %SQL is used to change the language to Spark SQL, and this is also reflected in the right corner of the cell as well. Notebook is not only a great tool for data engineering, since it is also an excellent tool for data exploration and data analysis, since you can use it to view data and also visualize it. So that's why many data analysts also prefer using notebooks for their work. You can also interact with all different data stores in Fabric using notebooks. For Spark notebooks, the most native data store to interact with is Lakehouse. And we can see here on the UI that I have attached a Lakehouse to this specific notebook that allows easy access to that data in that specific Lakehouse. And the code that I'm having in this notebook first reads some raw CSV data from that Lakehouse and then uses Spark SQL to show that data that was read from that CSV file. Next, let's talk about using parameters with notebooks. These parameters work by toggling one cell as a parameter cell from the notebook UI. Then default value for the parameter are defined as variables to this cell. Different data types are supported for these parameter variables like string, integer, float, and boolean. Then, when the notebook is being executed by another process like another notebook or a data pipeline, the execution engine adds a new cell beneath the parameter cell with input parameters that then override those default values. And here we can see how that cell looks if you observe that notebook that has been executed by using another process and has that parameter cell defined. Another essential topic for DP-700 exam is notebook utils. That was previously called MS Spark utils. Notebook utils is an integrated package in Microsoft Fabric notebooks designed to streamline common tasks such as file system operations, environment variable access, notebook chaining, and secret management. There are many different utilities available, and now I'm only going to talk about the most essential ones. First, we have the file system utilities. These utilities allow you to interact with file systems like Azure Data Lake Storage or ADLS in short. And since OneLake is using that same technology under the hood, you can interact with OneLake's file system as well. If you're familiar with Unix command, you most likely find these utilities very easy to use, since the commands are pretty much the same here. The syntax for using these utilities is notebookutils.fs. the command you want to use. With these commands you can, for example, create directories, move and delete files, etc. Then next we have notebook utilities that are accessed by saying .notebook after notebook utils. These utilities allow you to run notebooks that we're going to talk more about shortly, set exit values and create notebooks, etc. Basically interact with notebooks like the name also implies. Then we have credential utilities that allow getting access tokens and managing and getting secrets from Azure Key Vaults. Then we also have some other utilities like Lakehouse utilities that allows interacting with lakehouses, and runtime and session utilities for getting some information and managing the current session. Next, we can discuss a bit about magic commands in the notebooks. Like I already mentioned, notebooks support using different magic commands, and there are actually quite many different magic commands, and we are only going to go through some of the most essential ones here. We can divide magic commands into two different categories, and the first category is the cell magic commands. These magic commands apply changes to cell level and changes what the entire cell does. These cell magic commands begin with double percentage mark and are placed at the beginning of the cell. The most relevant cell magic commands are the ones that change the cell language from the default language to something else. And here we can see a few examples of these commands that change languages. Next, we have the other category that are the line magic commands. These are commands that do operations on a single line of a cell. There can't be anything else in that specific cell than those commands. The most relevant of these commands are the pip and run. Pip allows you to use Python package installer called pip, and run command is one of the ways to run other notebooks that we are going to talk more about on the next slide. And like with cell magic commands, there are many commands that we are not going to cover. Also, it is possible to create your own magic commands, but this is also way out of scope for this video. Next, let's talk a bit about running and orchestrating notebook runs. There are few ways that notebooks can be run. The first obvious way is to run them manually, by running the notebook cell by cell or triggering the entire notebook that will then execute the cells from top to bottom. Another way would be to run notebooks from another notebook. For this, we have multiple ways of doing this. One way is to use that run magic command to run a notebook. When you run a notebook this way, it will have the same execution context, meaning that if you declare any functions or variables in the notebook that you're running, they will be also available in the notebook that does the running. Then we have few different ways of running notebooks using notebook utils notebook utilities. With notebook utils, the execution context will be different, and the things declared in those notebooks won't be available in the notebook that does the running. First, we have the notebook utils run command that just runs a single notebook, and you can also specify timeout and optional parameters for it. Then we have the run multiple command. That can just take an array of notebooks to run, and it will run all of those notebooks simultaneously. Also, we can use this DAG/JSON notation for running multiple notebooks and configure way more things per notebook run. This DAG notation is one important thing to know in the DP-700 exam, so let's break it down. To this DAG, we specify the notebooks we want to run to the activities array, and then one notebook execution is one object in this array. For each activity/notebook, we must provide a name that will be the unique identifier for that specific activity. This name doesn't have to be the same as the notebook name, but it has to be a unique one. Then next we have to specify the notebook path, aka the notebook name we want to run. Then we have a bunch of optional properties that already have some default values, so that you don't have to specify them if you are going to go with the default values, but you can make some changes to them if you want. We can, for example, specify timeouts per cell when we execute the notebooks and give parameters for our notebooks. Also, we can add retries per notebook so that the process will try to execute it again if failure happens, and then we can specify a retry interval for those retries. Also, this DAG allows you to build dependencies on these activities. And in this DAG, I have specified that the last activity is dependent on the previous two and won't execute before they have been executed successfully. Then lastly, we have some process level properties, and with those we can configure a timeout for the whole process and also the amount of concurrency we want to have, meaning how many notebooks we will be running at the same time with this process. Also, I want to mention that running these notebooks from another notebook is a topic that I cover in way more detail in my 3-hour-long notebook masterclass. So if you didn't quite understand everything, go check out that section in that video. The link is in the description. Then we can also run notebooks as part of a data pipeline and have a notebook activity there, which is one of my favorite ways of running notebooks, since it allows tying notebooks to other activities happening in my data pipeline. And you can of course pass parameters from the pipeline to a notebook and then pass exit values from the notebook back to a pipeline. Then notebooks can be individually scheduled by using the same scheduling feature we have already covered with data pipelines and data flows. This feature allows you to define a schedule for a notebook from a minute level all the way up to a month level. And this feature also supports using time zones and automatically adjust for daylight savings, meaning moving from summertime to wintertime and vice versa. This was the last slide that I had in this theory section, so next let's go to Fabric and let's do a small demo/tutorial there to get some hands-on experience with notebooks. Now we're in Fabric, and I have my DP-700 Lakehouse open here. And to this Lakehouse I have created a new folder, and in that folder we have two CSV files. We have the animals.csv with few rows of data, and then we have the movies.csv with few rows of data. And we are going to use these files in this tutorial to demonstrate some capabilities with notebooks. And also, if you would like to get these files, these can be found by clicking the link in the description. That will take you to the Google Drive where these files are. But yeah, now let's go to a notebook. And here I have a notebook that I have already attached to this Lakehouse. And you can attach Lakehouses by clicking this plus button here and then attaching the Lakehouse you want, so that you can easily access the data in that Lakehouse. And also keep in mind that you can use notebooks to interact with the Eventhouse and also with the warehouse as well, but those are the topics that we are not going to cover in this video. But keep in mind that that is possible also, so you don't have to just use the Lakehouse. And we already covered the most relevant things about this UI in the theory section, but basically here you could change the notebook default language to something else than a PySpark, but the PySpark is one of the main focus in the DP-700 exam, so that's why we are going to use it. Then if you would individually want to schedule your notebook, you can go to this Run tab, and here you can find the schedule, and here define a schedule for your notebook when you want it to run. But yeah, like we discussed, there are some other options to run notebooks as well, and we are going to cover one of them in this demo section. But yeah, also one cool feature here are these code snippets that Microsoft is providing to us, and here are some typical operations that you could do with notebooks and some code for those. those provided here. For example, using notebook utils and what kind of things you can do with them. And here are some pre-made code for those. And also for Lakehouse interaction, like reading data and writing data to a Lakehouse. But yeah, you can check out these and learn more about notebooks using these. But yeah, let's close these for now since we are not going to use those. And also, as you can see, we can add these markdown cells to notebooks that allows us to create this small documentation or add these better comments to our notebooks. And also, these markdown cells will then create a table of contents for our notebook, so we can hop on to the section we want to check out in this notebook. But yeah, that's also a cool little feature with these notebooks that we are able to create this table of contents and easily navigate the notebook. And now let's talk about these notebook parameters. And here in this first cell, I have just defined this regular Python variable called dataset and provided values movies for it. And why this is a parameter? Basically, I have clicked here and clicked this toggle parameter cell that will then toggle this to be as parameter cell. And we can see that it says parameters here next to that PySpark language. And these other cells won't say that parameters. And later on, when we run this notebook as part of a data pipeline, we can see how does this parameter cell behave when we run this and pass down this dataset parameter for this notebook. But yeah, this is how you would define a parameter cell for your notebook. And next, I'm going to read some data from a Lakehouse. But for this, we need to start a Spark session. And here we can connect this notebook to a Spark session and start running the code in our notebook. And then this will now start the session, and this will take a little while for our session to be running here. And while that session is starting, we can reveal this next cell. And here basically I'm using Spark to read that CSV file from the Lakehouse path that I just showed to you. Basically this episode 9 folder here, and there we have those two CSV files, and we are using this dataset parameter or variable dynamically in that file path, and with this value we are going to read that movies.csv file using this code here. And we're also specifying some options for that CSV file, for example saying that we have a header in that file so that the header won't be on the first row and it will actually use the header for the column names. And now our session has started and we can start to run the code in our notebook. Let's first define this dataset parameter slash variable here, so we have that available there, and then we can read that CSV file from our Lakehouse. And this will read it to a data frame. And now if we want to display that data, we can use this display command in PySpark to display that data frame and see the contents of it. So we can see that does the data look good. And we can see that data looks fine. Also, like I already mentioned, we can visualize data here in Notebook as well using this chart feature here and do different kinds of charts based on that data. And since I only have 3 rows of data there, we cannot really do that many like very nice visualizations here. But it's good to know that these visualizations are natively available here in Notebooks and very easy to use. But yeah, let's go back to that table view. And then let's continue forward. And like I said in the theory section, we can use other languages here in the PySpark notebooks than just PySpark. But first we need to do some preparations for our data. With this command here, we are actually creating this kind of a view out of this data frame that we just read in called df_view. And what this command does, it will create this temporary view that will exist here until my session is over. And this view there is then accessible with the Spark SQL API, meaning that we can query it using Spark SQL. And in this cell, I'm actually using that magic command to turn the language in this cell to Spark SQL. And we can see there in the right corner that now our language has changed from the PySpark to Spark SQL, but it's only applicable to this one cell where we are using that magic command. And now we can query this temporary view that we just created there by using this magic cell here. And we are now running the SQL command here and querying that data and defining a new column. And oops, I forgot to run this previous cell to define that view, and now we can run this again and see that it should work. And here I'm defining a timestamp to this data that has the current timestamp there in that TS column. Then we have also another way of using Spark SQL with PySpark that I want to also show to you because it's quite important. Here I'm using this kind of a spark.sql function and then passing that Spark SQL query to that function and doing the same thing that I did in that magic cell. But notice that now we have this PySpark cell here and this is not a Spark SQL cell here. So basically now we are doing the same thing that we're doing there but using a different syntax. And now let's query this and then display that data using the display command. And here we can see that we get the same result that we did here, except the timestamp has changed a bit since some time has passed since we ran that query there. But yeah, this is one way how you can use Spark SQL with PySpark. And also this is a topic that I cover in way more detail in my 3-hour-long notebook masterclass. Then we can of course write data to Lakehouse, and here I have demonstrated how we can write data to a Lakehouse table. Here first I'm using a Spark SQL statement to make sure that we create a schema to this Lakehouse, since we don't have this episode 9 schema available there, and if we would just run this command here, this would fail since it is not able to create that schema. So we first need to make sure that we have that schema available there and create it first before running this data frame writer here. And this write command is very similar to that read command, except here now we are saying that data frame.write, and then we are specifying the mode, and we are saying the override mode, which means that we will overwrite the data in that table. And then we are specifying the format to be delta table, that is the default table format in the Lakehouse, and then we are saying save as table, and then we are providing the table details. And again, we are using that movies parameter there, so that we are dynamically saying that it's going to be that movies table. But yeah, let's run this and let's see what happens. And soon we should have that new schema in our Lakehouse, and then we should have that data there as well that we just created there. So we should have that timestamp column added here. And let's refresh our Lakehouse. And here we have that movies table. And now we could of course read that data from that table using, for example, Spark SQL or that kind of a read function that we used to read that CSV data as well. And here with the Spark SQL, we read that data and display that data to see that everything looks correct in that table. And here we have that data that we just wrote there in that previous cell. And then I have this one demonstration here how we can use the notebook utils that we talked about in the theory section. And here I'm defining this exit value for this notebook that just says dataset, and then the dataset name was processed OK, exclamation mark. And this will return back to a process that will be running this notebook. And we're going to demo this shortly when we run this notebook as part of data pipeline. But yeah, let's run this and let's see what kind of print it will provide. It just says that the exit value was that exit value that we configured there, meaning that we just get that movies instead of that data set there. Next, let's create a pipeline and add this notebook to a pipeline. We could of course go here and create a pipeline from here, but we can actually create a pipeline directly from this notebook UI by clicking this add to a pipeline button here. And here we can select that we want to add this to a new pipeline. And then we provide the pipeline name and then we hit create. And this will create a new data pipeline with that notebook there. And here we have that pipeline template and we already have that notebook activity here. And here we could actually specify some parameters for our notebook. And remember, we had that dataset parameter for this notebook. So I'm going to say dataset, and then we're going to specify the type is going to be string. And when running this notebook here, we're actually going to provide a different value than movies here. Now we are going to process that animals file. So I'm going to write animals here to this value section. So now that parameter value will be animals instead of movies, since we just used that parameter value everywhere in our notebook. So we should be able to process that animals files by just changing the parameter value for that notebook. Then we also have these advanced settings here for the notebook, and we have this session tag setting here that would allow us to specify this session tag if we would have multiple notebooks as part of this data pipeline, so that they would use the same Spark session and not spin up a new Spark session per notebook. But yeah, this is an advanced topic that we are going to cover when we talk more about Spark in this series. But yeah, let's close that advanced settings for now. And now we are actually ready to run this, and let's see how does that run will go. So let's click this save and run button, and now we are going to run this notebook with that different parameter there. And soon when this starts running here, we should be able to check the input for our notebook. And here it says that the parameters were this dataset and the value for it was animals. And this is now passed for that notebook when it runs. And then we now need to wait for this notebook to complete in order us to see that we get that exit value and to see what happened there when that notebook executed. So let's wait it to execute. And now our notebook has executed, and it took 1 minute to execute that notebook. And here we can actually check out the output. Did we receive that exit value out from that notebook? And this exit value can be found in this object. And here we can see the exit value property, and there we see that dataset animals was processed okay. So everything should have went fine in that notebook. And we can get more information about that notebook execution by clicking this name, activity name here, and then we can go to this notebook snapshot URL, and this will open a new tab, and here we can observe what happened during that notebook execution. And here we have that notebook snapshot, and here we can see that the input parameters were now dataset and animals. And here we have that parameter cell, like we can see here. And here we can see that this execution now created this new cell under this parameter cell and overwrite the value of that variable with that new value that was coming from the data pipeline. And now the dataset value was animals instead of that movies. And now we started to process that animals file in this same notebook that we used to process that movies file. And here we can see that now we have that animals data here, and we are doing the same operations that we did for that movies file here. And then we also wrote that data to that Lakehouse and also read that data from there. And lastly, we returned that exit value out from this notebook back to that data pipeline. And then we could actually reference this exit value in our pipeline if we would want to, and use that in the following activities if that's something that we want to do. And yeah, we can go to the Lakehouse and check out that we have that new table there as well, called that animals. And here we have that animals table there that we wrote there using this data pipeline. Next, let's have a couple of questions about notebooks, but before we do that, I would like to tell you about this website called certiace.com that I have created with few friends that offers free practice questions for DP-700 and DP-600 exams. Also, we have DP-900 exam coming in very soon. So after watching this video, go check out these practice questions on certiace.com and start practice to that certification exam. And now let's have those questions. Our first question today is how would you complete the DAG? And there we can see the DAG with one spot covered, and now you would need to come up with the correct property there. Options are A, depends, B, depends on, C, depend on, D, dependencies. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, dependencies, since that is the correct property name there and the others are not correct. Let's have another question. You are working with Spark notebooks in Microsoft Fabric. You need to execute a Spark SQL query within a PySpark notebook cell while keeping the language in the cell as PySpark. What is the correct way to achieve this? A. Use the SQL magic command at the beginning of the cell. B. Use the Spark SQL function within a PySpark cell. C. Change the default notebook language to SQL in the settings. D. Store the SQL query in a string variable and then pass it to notebookutils.sql.run. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B. Use the Spark SQL function within a PySpark cell, since this will allow you to run Spark SQL code in a PySpark cell. Option A is incorrect, since it will change the cell language to Spark SQL, and that is not what was wanted here. Option C would change the language of entire notebook, and option D is incorrect, since there is no such thing as notebookutils.sql utilities. This is the episode 10 in this DP-700 exam prep series, and in this episode we will cover Spark, and more specifically Spark settings. In the last episode we covered notebooks and only mentioned Spark briefly, but in this episode we will dive deep into this powerful data processing engine that powers up those notebooks under the hood. Like in every episode in this series, we will start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Let's first cover what is Spark with a simplified example so that everyone will understand what we are learning to configure in this episode. Let's use ordering pizzas as an example here, since when this episode releases I'm on a holiday in Italy and hopefully eating some delicious pizza there. So in this example we have a data engineer who has been building data pipelines in Microsoft Fabric all day, and he would like to order 2 pizzas from a pizza shop. So he decides to call there by phone and order those 2 pizzas. Then that pizza shop will use some ingredients and make those pizzas and deliver them to our hungry data engineer here. But what if this data engineer is throwing a party with fellow data engineers after they have gotten all their data pipelines to production that they have been building for many months? Now there will be need to have 100 pizzas instead of just 2. Again, the data engineer calls the pizza shop and orders 100 pizzas to be delivered. However, this time the pizza shop says that they can't make and deliver that many pizzas, so the order gets rejected. Our data engineer doesn't give up, and he does another call, and this time he calls to this food service that uses many different pizza shops to fulfill bigger orders, and then these pizza shops start to prepare those pizzas simultaneously, and then they will be all delivered at the same time to our data engineer. And now you could be wondering what these pizzas have to do with Spark. Well, we can replace that pizza order with, for example, a Spark SQL query, and that phone with the Microsoft Fabric notebook that the data engineer uses to run that query. And of course, we are not sending that query to a food service, and we can replace the food service and those pizza shops with computers or nodes that will process the query. And instead of using food ingredients, we use data that gets processed in parallel using these different compute resources. And then the result of the query is returned back to the data engineer. And here we have a simplified version of a Spark pool. In this pool, the computer or node that does the organizing of this processing is called driver or head node. And then those nodes that do the processing are called worker nodes. So like in the pizza example, the point of Spark is to divide processing to different nodes, so it can do things way more efficiently when there are multiple nodes working in parallel rather than just having one node. So in this episode we will be discussing the different settings and configurations that can be done for this Spark pool here. We can, for example, configure how many worker nodes we have in the Spark pool, or what is the size of those worker nodes, and do we allow Spark pool to auto-scale if there are huge demand for it, and a bunch of other settings that we will be covering that are in the scope of DP-700 exam. Also, before moving forward, it is good to understand a bit how the processing happens in the individual nodes of the cluster, since there are things we can optimize on that level as well. Like we covered on the previous slide, in Spark clusters we have nodes that were those individual pizza shops in our pizza example, and those nodes work in parallel based on the instructions that are coming from the driver/head node. And we can add more nodes to the cluster/pool if we want to get more things done. So this is one option for scaling our pool. Also, we have some possibilities to add bigger nodes with more compute resources that we are going to explore also in the following slides. In these nodes, we have these things called executors that you can think of as chefs working in the kitchen that process those pizza orders and make those pizzas. And of course, in one pizza shop, we can have multiple chefs, so we can have multiple executors that do processing in one node. Each executor gets a portion of node CPU and memory resources. In the kitchen, one chef could be making multiple pizzas at the same time, and in the Spark world those pizzas are called tasks that executors complete so that we can have multiple tasks running at the same time per executor. I hope this highlights that Spark is a very powerful data processing engine where parallelization is happening on multiple levels in a single Spark pool. Next, let's talk about the starter Spark pool that is created automatically for your workspace. This pool uses compute that Microsoft keeps constantly running on on the background. So this pool is always pre-hydrated, which results to a very fast startup time since there is no need to wait for those computers that are needed for processing to start up. So typically when you use this starter pool in your notebook, the startup time is around 10 seconds, which is very fast thanks to those compute resources that Microsoft keeps up and running all the time and worldwide. But this doesn't mean that this starter pool will consume your Fabric capacity all the time, and it is only eating Fabric capacity when you use the pool. Also, this pool is set to automatically scale and dynamically allocate executors if needed. So the pool will automatically add more nodes or pizza shops using our pizza example, and also more executors for nodes or chefs to a pizza shop in the pizza example. Also, this starter pool can be customized a bit, and you can, for example, set what is the maximum number of workers this starter pool will use and how many executors it can allocate. Keep in mind that your Fabric capacity sets the upper boundaries for these settings, so that you can't have a huge Spark pool if you're using one of the smallest capacities. And on this table, we can see the upper boundaries per Fabric capacity for the starter pool configuration. And like with everything, more we pay for our capacity, meaning the higher the tier is, more compute power we get for our Spark as well. Then we have the possibility to create a custom Spark pool. This allows customizing the pool configuration even more. With a custom pool, you can change the node size to smaller or larger from the default medium that is being used in the starter pool. When you have created this custom Spark pool, it can be then set to be the default pool for the workspace. But since you are now creating a custom pool for your needs, the compute resources for it will be provisioned on demand. This means that this pool won't be using those same always-on compute resources that are being used with the starter pool. This will then result to a startup time that is significantly longer than with the starter pool. So we're talking about a few minutes that it takes this pool to start. What would be then a reason why you would want to create a custom pool in the first place, since we already have that nice default starter pool that starts up extremely fast? Well, there could be several reasons, and some of them could include things like that you want to consume less of your Fabric capacity when running things. Since with this custom pool you can use smaller nodes, or other option could be that you have some heavy or big data that requires a lot of compute so that you need those bigger nodes for it. Or you could want to separate your workloads to different pools so that they won't be eating the same resource when they run. The major downside with using and creating custom Spark pool this way is that it doesn't support CI/CD, and you can't deploy these settings from one environment to another. But for this, we have another way of configuring custom Spark pools that actually supports CI/CD deployments. That other way is using environments. When creating a new environment, you will actually create a new item to a workspace like you would when you create notebooks, data pipelines, or data stores like lakehouses and warehouses. For this environment, you can then configure Spark on very granular level. You can, for example, set the runtime used in that environment, libraries that have been pre-installed for it, select the use of native execution engine, specify Spark computer settings, add Spark properties, or even share files. Into one Fabric workspace, you can create multiple environments, and then you could be using the same environment in different notebooks or use different environments in different notebooks. This creates a lot of flexibility so that you can have vastly different Spark configurations in use per notebook. Next, let's talk about high concurrency setting for Spark. For Spark settings, you can enable high concurrency so that notebooks can share the same Spark session when they run. This allows better resource utilization when Spark is not spinning up new Spark session per notebook. This will also result in a faster execution since the session is already running when the execution starts. This high concurrency can be used also in data pipelines with session tags that we are going to look at more closely in the demo section of this lesson. However, there are some conditions that have to be met before the session can be shared between notebooks. Same user must be running those notebooks, and those notebooks have to have the same default Lakehouse. Also, these notebooks have to have the same Spark compute configuration, and the same libraries have to be installed for both on environment level, which means that you can still have some inline library installations using, for example, the pip magic command that we covered in the previous episode in this series. Currently, you can share a session between maximum of 5 notebooks if all the conditions for those are met. Next, we have some settings for managing Spark jobs. First, we have the setting for reserving maximum number of cores for active Spark jobs, and this setting can be turned on or off. If this setting is on, then Spark estimates what is the maximum number of cores it needs to complete that job and reserves those for a specific job. This will give some reliability and faster execution in the context of that job, since it is very unlikely that Spark wouldn't have enough compute resources to complete those tasks that is running. However, the downside is that some of the compute that Spark reserves might be used less optimally, since those jobs might not need that many cores and the other jobs might have to wait for those resources to free up. When turning that setting off, the opposite happens. Spark estimates the minimum number of cores it needs to complete those jobs. This will result in having less reliability and slower execution times for jobs, but the compute will be used more efficiently, and more jobs could be running at the same time. Then we have a setting for Spark session timeout, and this just determines the time after inactive Spark sessions are terminated. This setting defaults to 20 minutes. And this was the last slide in this theory section, and next let's go to Fabric and discuss more about these settings that we covered here, and cover a few additional topics about Spark and its settings in Fabric. Now in Fabric, and here I have my DP-700 example workspace open. Let's start by first navigating to workspace settings, and here we can find data engineering/science settings, and under here we can find the Spark settings that we have been discussing in this video. And here we can see those settings that we discussed in that previous theory section. So first we have here the pool settings, and here we could manage settings for that default starter pool that we discussed in the theory section. When we can click this pencil icon here and do some changes to the starter pool. But as you can see, some of the settings for the starter pool are locked. For example, we cannot change the node family or the node size for this pool, since we are using those pre-hydrated nodes that Microsoft keeps up and running, and then we just connect to them so that we get these very fast Spark startup times. But yeah, here we could actually change those number of nodes that we have and what is the number of nodes this would auto-scale, and do we dynamically allocate those executors. But yeah, we discussed this in the theory section already. And here we could actually create a new pool, and this will actually create that custom Spark pool here. And I could create a new pool here so we can see how that works when we open up Notebook a bit later. And here I have now given a name for my pool, and then we cannot change the node family yet. I imagine that at some point Microsoft will introduce some other node families here than just this memory optimized. But we can actually change the node size to something else than that medium, and we can go with the small. And then we can tune a bit these settings here, and we can, for example, say that we only need this to auto-scale until 3 workers, or we can disable the auto-scaling altogether and have fixed amount of workers there. We can actually do this and just have a 1 worker for our custom pool here. And then we can hit create, and now it will create that after we save the settings here. And now after I've saved those settings, we have that custom pool here, but we can keep this starter pool here as the workspace default pool. So let's resave those settings here. And then we have this customized compute configurations for items setting here that I didn't really discuss in theory section. But with this, you can allow users to do their individual Spark configurations in the notebooks that they are running. For example, change some Spark settings that can be changed after the Spark session is already running. Then we have also some other settings that are fixed and you cannot really change those after the Spark session has started. But with this, you allow some flexibility for developers to do some fine-tuning for the Spark if they know what they are doing. Then next here we would have that environment tab, but let's not cover that yet. Let's go to jobs. And here we had those jobs and we had this reserve maximum cores for active Spark job setting that we discussed in the theory section. So basically, do we want those Spark jobs to be very selfish and reserve the maximum amount of nodes that they might need, or do we want them to think about others and only reserve the minimum amount that they possibly need for completing that specific job? And then we had that timeout setting that can be changed to something else from this default 20 minutes. On the next tab, we have those high concurrency settings. And these settings we covered quite thoroughly in the theory section, so I'm not going to talk more about these. But we can enable this high concurrency for pipelines since we are going to do a bit of a demo about that quite soon. Then we have these automatic log settings here that is not in the scope of DP-700 that much, but this is a feature here that allows you automatically to track some machine learning experiments and models. But these things are more for machine learning experts and data scientists than data engineers. But it is good to know that this setting is found here in the Spark workspace settings. But next, let's go to this environment tab. And here we could actually set the runtime version that is used in this workspace. And here we have some different runtimes, and Microsoft keeps adding more runtimes here when we get some new versions of Spark and Delta. And currently the latest runtime version for Fabric is 1.3 that uses Spark 3.5 and Delta 3.2. But yeah, it is good to keep this runtime up to date so that you have the latest features available for your developers to use. And over here we have the possibility to set a default environment for this workspace. And remember that we covered that environment is this Fabric item that is created to the workspace that can be deployed then with the CI/CD functionalities to another workspace, for example. And it can be added to the version control. And here we could actually enable a default environment for this workspace. And then we already have this workspace default here, but we can actually create a new environment by clicking this new environment here, or then we could navigate from the Fabric menu where we create the data pipelines, notebooks, etc. and create a new environment from there. But I can click this new environment here now. And then we have to provide the name for our environment, and I will use my naming convention here. And this will now create this environment resource where we can configure many things. We can, for example, set the Spark runtime that is being used in this environment when notebooks attached to this. Then here we can see all the built-in libraries that have been already installed to this environment by default. And these are the libraries that come with Fabric pre-installed, and you don't have to install them individually. Then we have also the possibility to add more libraries by using this public libraries feature here. And click this add from puppy, and then we would search for the library we want to add, and then just select that library and add the version, and then it will pre-install that to this environment when a notebook uses this environment, so that you can just import that library there without needing to do some type of pip install or something in the notebook itself. But yeah, now we are not going to install any libraries to this environment. And then we have also the possibility to add custom libraries here. So for example, if you have made your own libraries for your specific data processing needs, you could upload, for example, a wheel package to this section here, and then that wheel package or the library in that wheel package would be pre-installed to this environment and would be ready in all the notebooks that are using this environment. Next, we have things about Spark Compute that we can configure. We can, for example, enable this native execution engine. And now you could be asking, what is this native execution engine here? I'm not going to dive too deep into this native execution engine this time, but this is this kind of Fabric's native Spark accelerator engine that should make your queries perform faster. However, this is a very new feature, and there are some things that are missing from it. For example, it doesn't have a support for all the Spark functions, and for example, you cannot use the merge statement with this engine yet. But I think this engine is improving quite rapidly, and those things might be supported already when you are watching this video. So it is good to check what is the state of this native execution engine if you want to use it. On the next tab, we can configure some Spark Compute settings on more granular level, and for example, change the Spark driver memory to something else and Spark executor memory to something else, and configure way more things that we can do with just of those pool configurations. And on the next tab, we could set some Spark properties here that are also predefined when the Spark session starts. And then we have this resource tab here, and this we can actually use to share some files if we would want to share, for example, some configuration or some wheel packages across all those notebooks that are using this same environment. But yeah, here we would be able to upload those to this environment. And like said, if we go back to our workspace, we can see this environment here as another item in our workspace, like we have those items that we have been creating in the previous videos. And this means that we can deploy this Spark environment to different workspaces using CI/CD, for example. So you can think about this environment that we're kind of wrapping all the Spark settings to this one package that we can then take forward if we want. And next, let's create a new notebook to this workspace, and I want to show you a few things there. And here we have that notebook, and let's rename that notebook to something else than notebook 1. And here we can actually change the environment that this notebook uses. And here we could actually choose that environment that we just specified here, rather than just use the workspace default. And of course, we could actually specify this environment to be the workspace default environment, but this time I didn't do that. And we could click that. Also, when we're connecting this notebook to a session, we can choose here if we want to start a new standard session or a new high concurrency session. And here we would be able to see if we have any high concurrency sessions running that we could use, for example, in this notebook. But yeah, if you would use the high concurrency session, you would potentially be able to run some other notebooks in that same session as well, like we discussed in the theory section. Next, let's create one new data pipeline to this workspace, and let's name that data pipeline according to our naming conventions. And then we want to start with the blank canvas and maybe just add a notebook activity to that canvas. And here we have a notebook now in this pipeline, and then we can copy that notebook. And remember when we talked about that high concurrency for pipelines when running notebooks, and here we have the setting tab for the notebook activity, and here we have these advanced settings, and here we can specify this thing called session tag, and this session tag can be used to identify which notebook can use the same session when they are running. And here we could just provide a random string, for example ABC, and then add this same ABC tag to this other notebook, and then this would potentially use the same Spark session when they will run. And how this will work in action. So when we start to run this pipeline, this notebook 1 here will actually start that Spark session. So most likely this will take a bit longer to run. And if we are using some custom pool, this will take significantly longer to run because we have that longer startup time. If in this example we are thinking about the execution time for both notebooks should be around the same if the session is already running. But after that session is already running and we have the same session tag for this notebook should finish way faster since it doesn't have to wait for that Spark session to start, and it can use the same session that this notebook 1 already started. And next I want to show you some capacity level Spark settings that we didn't discuss in the theory section. So let's go to the admin portal and then let's go to the capacity settings. And then I want to select the trial capacity when this loads up, and then I will select my trial capacity. And here we can find some data engineering/science settings, and here we can open Spark settings. And here we have two settings that we can control on capacity level, which then affects those workspaces that are tied to this capacity. So the first setting is that we can turn on or off custom pool creations for the workspaces attached to this capacity. Also here we can disable Spark starter pool for those workspaces as well. Next, let's have a couple of questions related to topics covered in this episode. But before we do that, I would like to tell you about this website that I created with 3 friends called certiace.com. In this website, you can find free practice questions for DP-700 and DP-600 exams. So go check out certiace.com after watching this video to get more practice questions for DP-700 exam. But now let's have those 2 practice questions in this video. Let's have our first question. What setting in Microsoft Fabric allows multiple notebooks to share the same Spark session? A. Reserving maximum cores. B. Dynamically allocated executors. C. Creating an environment item. D. Enabling high concurrency. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, enabling high concurrency, since this is the setting that allows multiple notebooks to share the same Spark session if the conditions are met that we covered in the video. These other settings won't allow you to do that. Option C is something that could help you with that, but still it doesn't allow that unless high concurrency is enabled. Let's have another question. Which of the following is not a benefit of using the starter pool in Microsoft Fabric? A. Full customization of Spark node size. B. Uses pre-hydrated compute resources. C. Fast startup time. D. Automatically scales based on workload. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is A, full customization of Spark node size, since this you can't do with the starter pool, since Microsoft has those specific nodes running 24/7 worldwide that are used for the starter pools, and you cannot affect those. The other answers here are some of the benefits of using a starter pool. This is the episode 11 in this DP-700 exam prep series, and in this episode we will cover Spark structured streaming. That allows you to stream data directly to a Delta table using a notebook or a Spark job. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. First, let's imagine a simple data processing setup in which we have our data source and then we are going to read data from that source using Spark, which in Fabric's context means using notebooks or Spark jobs to process that data. And then after that processing is done, we are going to write that data to our destination. That could be one of the Fabric's data stores, like for example a Delta table in a Lakehouse. And for this process, we want to define a schedule that when we want to run this. For example, once per hour. Now let's imagine that we start receiving data from some external system which is writing data to our source location of our data processing pipeline. We start to accumulate data to our source, and that data doesn't get processed yet since our scheduled time for our processing is not reached yet. Clock keeps ticking and finally we reach our scheduled time. And this starts our Spark cluster and kicks off the Spark processing and processes this entire dataset that has accumulated to our source. If there would be some issues in this process, the process would have to be rerun, or some retry policies would have to be defined for it to try to rerun the process again. After the processing is done, our Spark cluster can go sleep and those compute resources are no longer needed. And this scenario is a simplified example of a typical batch processing. That is one of the core concepts in data engineering. Now let's clean up this situation and imagine that instead of running this process in batches, we would use Spark structured streaming to process this data. In this case, the situation changes a bit, since now we will need to have our Spark cluster running constantly if we want to process the data. Then when the process is running, it will start to listen to the source and start to process the data when it arrives, without waiting that our source accumulates the data like in the batch example. Actually, in this case, we are also processing data in batches, but those batches are way smaller and are called micro batches, which will then seem like that we are streaming the data through our process. And this is a very simplified example how Spark structured streaming works. This is quite a wide topic with many settings and configurations that can be used with this process, and in this video we will only cover the most essential and relevant topics of Spark structured streaming from the point of view of DP-700 exam. For using Spark structured streaming, we must have an incoming data stream. And what exactly is a data stream in this context, one might ask? Well, it can be actually multiple of things. It can be a message service like an Event Hub or Kafka that are used to handle event-based data and are capable of ingesting it and forwarding it. However, this data stream can be also a table, for example a Delta table, to which data is appended by some process. Also, it is possible that this data stream consists of flat files like CSVs that are being written to, for example, Azure Blob Storage or Fabric's Lakehouse's file section. There could be also some other types of data streams, but in nature this data stream or a streaming source is a data source that provides data feed that we are able to read using Spark. In our example, let's imagine that we have a constant stream of JSON files arriving to our Lakehouse's file section that are being written there by an external system. These files keep arriving to our Lakehouse's file section every second. And now we would like to set up a Spark structured streaming so that we can read these files and write them to a Delta table in our Lakehouse. First, we have to start up a Spark cluster and use a tool like Notebook or a Spark job to implement logic for our stream. We write some PySpark code that is able to read our streaming source and read those two JSON files that are already sitting in our Lakehouse files. You could now realize that this code here looks very similar to typical Spark read operation, where we would define a data frame by saying spark.read. But in this case, we are saying spark.readStream, which will then treat this data source here as unbounded table, which means that Spark understands that our source data can keep growing and data tier is not static and it can read more incoming data once it arrives. On the background, this logic also keeps track of the data that has been already read, so that there won't be duplicates, but we will come back to this a little bit later on. We also specify one option for this reader, which is max files per trigger, and we set it to 1, which then means that Spark reads in every file that arrives and doesn't wait for more files to arrive. With this option, we can get the minimal latency for our stream, since files are processed pretty much immediately when they arrive in our source folder using default trigger time that we are not going to change to anything else in this example. But it is good to know that trigger time for the stream can be also configured. And like I said, there are many options for streaming that we are not going to cover in detail in this video. Then we want to do some transformations for our data and add a timestamp to this data when this data was processed. We write the code for that logic in the same way we would write it when processing batch data and using regular data frame. Now we are happy with our logic here and we would like to stream this data to a Lakehouse Delta table. For that we need to specify some write logic. We write our PySpark code for writing our data stream to a Lakehouse Delta table, and as you can probably tell, this code looks very similar to a regular Spark write function, but now we are saying dataframe.writeStream instead of dataframe.write. Then we are specifying checkpoint location as an option for our stream that helps in the error handling so that the stream knows where it has to continue the processing if some errors or downtime occurs. Also, this logic will keep track of the data that has been already read from the source, like I mentioned previously. Also, we are going to check out this checkpoint functionality in more detail in the demo section of this video. Then we have to specify that we want to start streaming by using a start function, and for it we also specify the table to which we want to write our data to. Also, you could be wondering why we specify this delta stream object when we run this function, and what is the point of it? Well, this delta stream object is called streaming query, and it gives us this handle that we can use to monitor and control the streaming process. And this handle we are going to check out in the demo section shortly. Now we are happy with our code and we can start running this streaming process, which will then write those first two rows to our Lakehouse table, and they will get exactly the same timestamp since those files were there when we started streaming and new files have not yet arrived. Then our third file arrives and our stream picks it up immediately and processes it. After that, our fourth file arrives and it is also processed immediately by our stream, and this process continues until it shuts down or some problems occur. As you can see, this is a quite nice and relatively easy way to ingest and process incoming data in near real time. However, keep in mind that the cost for this is that we have to have our Spark pool running constantly, and this will then consume our Fabric capacity. I hope you now have a fundamental idea what Spark structured streaming is about, and we can go into Fabric and dive a bit deeper into this topic and do a demo/tutorial together to learn more about it. Now we're in Fabric, and we're actually going to do a bit similar thing that we had in the theory section. So I have here a code that will write some JSON files to our Lakehouse's file section, and then we are going to use another notebook and use streaming there to read those files. And here in this notebook, first I have some configuration for this code, and we set the output folder where we want to write those files. And then we specify the number of files we want to write and what is the interval during which it writes those files. So here I'm specifying that I want to write 10 files and I want to have 5 seconds between those writes. And here we have the code that will generate those JSON files, and those JSON files will have 3 properties that are ID, temperature, and timestamp. And then this will just write them to that file section there. But yeah, let's kick start a Spark session here and let's run these these cells here so that we can already write some JSON files to that location before our stream starts running. And also, like always, all the code that I will be using in these tutorials can be found by going to the link in the description that will take you to the Google Drive where I have all the code for my tutorials. But yeah, our Spark session should start shortly. And now our Spark session is running and we can run this notebook and see how does those JSON files look in our Lakehouse. Let's run everything in this notebook and now it will start to write those JSON files to our Lakehouse. And we can open up our Lakehouse and see that we have now created that folder there and we have some files coming to this source folder under here. And we can see that we already have 3 files here. And if we take a look at one file, we can see that we have those 3 properties like I showed to you. So we have the ID, temperature, and timestamp. And this temperature is always randomized, so there is this kind of a random temperature time there. But yeah, now we should have already more files if we refresh this folder. And as you can see, there's already quite a many. And now it has written all the 10 files to that folder and we are done with this. And next we can go to another notebook and here I have actually the code for the actual streaming. And here we are first doing the necessary imports that I need this code to work. And then we are defining some variables. We are defining the source path from which we want to read the stream. And this is the same path where we wrote those JSON files previously. And then we are defining the checkpoint path. And we're going to come back to this checkpoint, but basically this is the place where Spark stores the information, what it has already processed. And this acts like a memory for Spark so that it knows from which file to read if there is problems or something or the stream goes down. And then we specify the schema and the table name to which we want to write our data to. And then we also specify a schema for our JSON data so that we are able to read it conveniently. And then we make sure that our schema exists in our Lakehouse because I'm using schema-enabled Lakehouse here as a default Lakehouse in this notebook. And this is the same Lakehouse that I just showed to you. And here we have actually that streaming code. And we can run this first cell here so that we have that already done. And then we can talk about this streaming code here. But yeah, here in this code, we are defining first this raw stream data frame. And here we are using that function readStream. So we are saying spark.readStream. That will then make sure that we are treating this incoming data frame as this unbounded table. And Spark knows that there could be data coming into that table so that it doesn't treat it as a static table, like we would do in a traditional batch processing scenario. And then we are also specifying this option where we say max files per trigger 1, so that every file this process sees, it will process. And then we are using this file schema that has been defined here and also using that source path that I said there from which we read that data. And next we have this small transformation where we add this processed timestamp to that data so that we know when the data was processed and we can compare that processed timestamp to that timestamp that we added when we wrote those files there so that we can see how much latency there is when we actually read the file from that point when it was written to the folder. But actually the main point that I want to emphasize with this code is that we can use the same logic that we would use for a regular data frame. It also applies for a streaming data frame. So basically we would write here entirely the same code we would do in a batch scenario, but this time we are just using streaming data. And Spark does that handling on the background and makes sure that things goes correctly even though we are streaming the data and not reading static data. And then here we are writing that data to our Lakehouse files. And like I said, instead of saying dataframe.write, we are saying dataframe.writeStream, which will then stream that data to our Delta table. And we're specifying that our output format is going to be Delta, and then we are saying that our output mode is going to be append. There are actually some other output modes that can be used, but in this case we are only going to talk about append because it is the most simple one. And here we are actually using that checkpoint path to specify this checkpoint location for our data. And then we are using that start function and specifying the table to which we want to stream our data to. And this will actually start this streaming process. And here we are defining that stream query that gives us that handle that we can use to monitor what's happening in our stream. But yeah, let's run this and let's see what happens. This should process all the data that is sitting in our Lakehouse files folder and process that immediately, and then it will start to wait, do we have some new data there? And let's run this and let's see what happens. Now it is running and we can see that this command already executed. So this cell doesn't stay in the executing stage, but the stream is now running on the background. And first we could actually refresh our Lakehouse and query that table that we have here. Now we have that temperature stream table there, and we can just query that table quickly, and we can remove the limit there, even though it wouldn't really matter to have that there. And then let's run this and let's see that we have data in that table. And here we have that data, and we can see that we have the timestamp and then we have the process timestamp, and those process timestamps are actually slightly different since there is a little delay when those were processed, but basically they are almost the same. And now we could use this delta stream handle here to check whether our stream is still active. And it has this property is active, and we can query it like this and see that it returns true. This means that our stream is actually running. Then we can also check the status of our stream by using this same streaming handle here. And we can see that now it says waiting for data to arrive. So it is currently not processing anything because we are not writing new files there, and it is not reading those old files there. And then we have this property for last process, and here we can see some information about the last process that was done. And we can see the batch ID for the last process was 10 because we have done 10 processes there because we processed basically 10 files. So this batch ID here grows incrementally there. And then we see some other things related to that last process that ran. And for monitoring our stream, we could write code like this that would keep looping while our stream is active. And this will print some information about our stream to the log here so that we could see that what's going on with that stream. And this would actually throw that stream has stopped if we would stop that stream. But we are not going to stop that stream right now. And let's clean this output here because I don't want to have that here. And if we would want to stop our stream, we could use this delta stream.stop. And remember that this delta stream is the streaming handle that I have defined there. So it can be basically any string that you define here. So it is not always delta stream if you don't define it to be delta stream. But with this command, we could actually stop our stream from running. But I'm not going to do that yet. Next, let's go back to that other notebook and let's run it again so that we have some new data arriving to our Lakehouse. And we can see that our stream will start to process those. If we would, for example, start to refresh this log here, we can see what happens. So let's put this running. We can see that now the batch ID is 11, so it is processing the 11th file there. And this keeps running here, and now we can see that is already 13, and now it is 14, so it is processing some new data there. But it is not processing those old files that we had already sitting there. And that is handled by that checkpoint that I have defined, and here the Spark Streaming has actually created this checkpoint folder. And in this folder, it keeps the information about the offsets and the files that it has already processed. And this checkpoint would work in a similar way with other streaming sources. So for example, we could have an event hub or Kafka where some events would be arriving and we would be use Spark structured streaming to read that stream. And then this checkpoint would also keep track of those and know from which event it would need to resume reading if there would be an error. But the key thing here to remember is that this checkpoint will act as a memory for Spark so that if you would delete this folder, Spark would forget which files it has already read. So don't delete this if you don't want to reprocess the files or reprocess whatever stream you are reading. But yeah, we're not going to dive too much deeper into this checkpoint, but this is just a folder path that you have to define when streaming. And now we can go back to our notebook and see that it is now running and it has already processed 20 of those files. And let's stop this monitoring there. I want to cancel it, yep, and then I want to clear the output. And now we can check the last processed here, and we can see that 20 there, and I want to clear also those output here, and then we can check the status, waiting data to arrive, and the stream should be active. And now we can actually run this deltastream.stop. And now we should have some new information here. Delta stream is active is now false, and the status is stopped, and the last process should be the same. Yeah, it is the same, but now the stream has stopped. And then we can also query this table and see that we have some new rows there, and we should have 20 rows here. And yeah, we have 20 rows there that have been processed by our stream. And one more thing that I want to really emphasize here, that the notebook is not probably the right tool to run streaming in some production level data pipelines. For those, I would more likely to look into Spark jobs. But because Spark jobs are not this interactive tool that I can use to demo these things easily, I just use notebook for that reason. But otherwise, if I would have this production ready data pipeline, I would rather have a Spark job that handles that streaming than a notebook. Notebooks are great for like a batch processing scenario, but not for streaming. And like I said earlier, there is a lot of depth to this topic, and we're just scratching the surface when it comes to Spark streaming here. But I would encourage you to play around with Spark streaming and maybe set up your own event hub and try to read that stream from there. But yeah, that is way out of scope for this video, since pretty much this is everything you need to know about Spark streaming from the point of view of DP-700 exam. And next, let's have some practice questions for the exam related to Spark streaming. But before we do that, I would like to tell you about this certiace.com website that offers free practice questions for DP-700 and also DP-600 exam. Here you can find some practice questions that you can use to test your knowledge and are you ready to take the exam. This website can be found at certiace.com. And keep in mind that these questions are custom made so that they are similar to those that you would see in the actual exam, but not actually the same. And I have made this website with few of my friends, so if you have any feedback about this service, let me know that in the comments below. Let's have our first question. Complete the missing line in the following code. And here we have this delta stream write code, and then we have to specify that missing option there. And is this missing option A, checkpoint directory, B, checkpoint path, C, checkpoint location, D, checkpoint? Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, checkpoint location, since that is the correct option and others are incorrect. Let's have another question. You're building a Spark structured streaming pipeline that reads files from a folder. You want to ensure files are only processed once, even if the stream restarts. Which of the following are required to prevent duplicate processing? Choose 2. A, unique checkpoint location. B, option max files per trigger 1. C, output mode append. D, don't modify source files after they have processed. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answers are A and D. Checkpoint location makes sure that no duplicates are written, and if you would modify the source files after they have written, they might be reprocessed. That could lead to duplicates. B is incorrect, since if we would set this to something else than 1, Spark would still make sure that we won't end up with duplicates. It wouldn't just process the files immediately when they arrive. Option C is also incorrect, since this doesn't really prevent us from having duplicates. This is the episode 12 in this DP-700 exam prep series, and in this episode we are going to cover one of the main data stores in Fabric, Lakehouse. Like in every episode in this series, we will start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in the episode so that you can test your knowledge. But now, let's get started. Let's first cover an overview of Lakehouse and then dive deeper into specific parts and concepts related to it. First, we have to have a Fabric environment to which we can then create a Lakehouse. The cool thing about the Lakehouse is that it can store files and tables. So basically in this data store we have two main sections. Good thing to rehearse here is that when we are storing data to Lakehouse, we are actually storing it to one lake under the hood. And using Lakehouse is just one way of storing data to one lake. That is the underlying data store in Microsoft Fabric. That is basically this unified data lake for entire organization. And there is only one lake per fabric, like the name implies. Also, good thing to know is that one lake is based on the same technology than Azure Data Lake Storage, and Microsoft has just repackaged it into Fabric to this software as a service or SaaS Azure Data Lake. So, like said, we can store files and tables to Lakehouse. This means that we can store data in very raw formats like CSV and JSON files, and thus Lakehouse is an excellent data store for ingesting and archiving data, since you can land the data there in any format you want. So, typically in Medallion architecture, Lakehouse is used as the bronze layer data store for this reason, and of course it can be used for silver and gold layers as well. And when I say that you can store data in any format you want, I really mean that. And you can store more untraditional data there for data engineering purposes like video and audio files, if you so desire. For tables, Lakehouse uses Delta Parquet as its default data format. Delta Parquet is this very powerful and optimized open source data format, and it is the same data format that is being used, for example, in Databricks. Delta Parquet is also default data format used in the entire OneLake. And when we cover more Fabric data stores and mirroring, we will run into Delta Parquet format over and over again. Also, later in this episode, we will talk about optimizing and maintaining those Delta tables, since that is a key thing to know in the DP-700 exam. One cool thing about the Lakehouse is that it has some very nice data virtualization capabilities. This means that we can use Lakehouse to access data that is physically sitting in some external system and/or data store. This technology is called Shortcut, and we can create shortcuts to, for example, AWS S3 bucket or Azure Data Lake and bring data to Lakehouse and Fabric using this method. This will then mean that the physical data will stay in the external location and is only shown through the Lakehouse and OneLake. So from the Fabric UI, you would be able to see those files even though those files are actually sitting somewhere else. There are many benefits of using shortcuts, and we will cover it in more detail in upcoming slides. But to name a few benefits, data doesn't need to be duplicated, and it stays always up to date. Also, the cool thing is that this technology is not only for files, and you can shortcut tables as well. Cool. Now we have data in our Lakehouse, and we would like to access it. Well, there are several different interfaces that can be used to access data in Lakehouse. We can of course access the data using Spark that we have been doing a lot in this series. Then we have the TSQL interface that provides similar interface than with Fabric Warehouse. But the limitation is that it allows only reading data, so this interface does not allow writing data back to the Lakehouse. And since OneLake and Lakehouse are based on Azure Data Lake, we can use ABFSS or Azure Blob File System API to access the data. Then we have some other endpoints like REST and analysis services that can be used to interact with Lakehouse and its data. Also, key thing to remember here is that these interfaces are powered by Microsoft Fabric capacity. So if you don't have a capacity running, you can't access the data either. Then lastly, we have the consume layer and different tools that can consume data in Lakehouse. Almost every tool in Fabric is able to at least read data from a Lakehouse. And you can use tools like data pipelines, data flows, notebooks, and event streams to interact with Lakehouses. And I would say that the most native tool for accessing this data store is Notebook, since it allows using Spark to access the data that we have already covered in this series previously. Also, you can access the data in a Lakehouse using Power BI and then have that data on your reports. And this access is not only limited to Fabric services, and we can use those different interfaces to access the data with many different external tools and services like with Azure Databricks or Data Factory or with some custom applications to name a few services. Next, let's talk more about the shortcuts, since they are one of the core concepts to understand in the exam. Many of the core features we already covered on the previous slide, But as a quick summary, shortcuts allow virtualizing data from external systems via Lakehouse, which eliminates the need for data duplication and makes sure that the data is up to date with the source since it is not physically copied. These shortcuts support ever-expanding number of sources, but at the time of making this episode, the supported sources are other Fabric data stores, ADLS or Azure Data Lake Storage, Amazon S3 or S3 compatible sources, Dataverse, Google Cloud Storage, and as a newest arrival, Apache Iceberg. And then these shortcuts can be used to bring in files or tables depending on the source. There is also one core topic with the shortcuts that is very essential in the DP-700 exam, and that is shortcut caching. This is a workspace level setting that can be turned on. In practice, this cache will store frequently accessed data locally in one lake. For example, in our picture, if we would be reading the JSON file from the S3 bucket via shortcut, and we would have the shortcut cache enabled, if we would read it once, this file would be stored to the cache and following reads would then use that cache rather than the file that is actually sitting in the S3 bucket. This would improve the performance of our shortcut since we wouldn't have to do repeated reads to the external S3 location. This process is happening entirely under the hood, and if you are not aware of this caching, you won't be able to tell any difference than maybe that you can read data a bit faster in some cases. So this cache is completely invisible for users. Also, you don't need to worry about that you would be reading some old data when using the cache, since the cache knows if the source file is updated and it will then direct reads to that external location and then cache that new file. These cached files are then kept for 1 to 28 days depending on your configuration. Also, files larger than 1 GB are not cached at all, and currently this caching is only supported for Google Cloud Storage, S3, S3 compatible, and on-premises data gateway shortcuts. Next, let's cover the basics of delta tables, since they are good to understand in order to understand optimization and maintenance topics that we are going to cover next. In this example, we have a delta table called person, and it's in the DBO schema of our Lakehouse. Even though this table looks like a traditional database table when using and interacting with it, it is actually Parquet files in a folder under the hood that store data in a columnar format. Then we have a delta log that keeps track of those files. Then we can use delta tables in a very similar way we use traditional database tables. But what happens under the hood is a lot different. For example, if we insert some files to the delta table, the load logic will actually write new Parquet files to our delta tables folder and then also update the delta log about the new files. And then when we keep doing more and more inserts to our delta table, more and more files will appear. Other operations like updates, deletes, and merges work a bit differently. For example, if we want to delete data and run a delete statement to our delta table and delete one row there, the delta logic is not actually going to delete any data. And instead it will mark the file where that specific row is an old or not in use anymore, and then create a new file without that row to replace that old file. Then also delta log is updated to know that there is a file that is no longer used in the latest version of the table. So in a sense, we start to build version history of the data. And you can think about delta table as this smart version control table. And due to this nature, delta tables have some cool features, like time travel that allows you to look at the past versions of the data. Also, delta tables support ACID transactions, which means that you can reliably use and read the data even though somebody would be writing it at the same time. Then schema evolution is supported that allows adding new columns to the table based on the incoming data. However, the issue what might happen over time is that the delta table will get very large and have many small files, and some of those files could be irrelevant since they are older versions of the current data. Luckily, there are ways to maintain and optimize delta tables that we are going to look at next. The first command or method that we can use to make sure that our delta tables stay in good shape is to use the vacuum command. This command will clean unused data files from our delta table folder. Basically, it will delete old files that are no longer used by the latest version of our delta table. This will have an effect to the time travel feature of the delta table, since this will physically delete data based on the configured time period. We can, for example, run vacuum for files that haven't been part of the latest version of the data in 7 days. Of course, after running this, we can use the time trial feature to travel only to that point in time and no longer backwards, since that data no longer exists. The primary goal of the vacuum is to free up space in our delta tables and in OneLake. Next, we have a command called optimize that will combine smaller files into bigger ones, so that when we're querying the table, there is less files to scan, which will then result to faster query speeds. Lastly, we have a V-order. That stands for vertical order, and it is a write-time optimization and can be ran with optimize command. Also, it can be turned on so that it is ran always when writing data. V-order will group similar values together so that they are faster to query, and it will especially speed up queries with filters. The minor downside is that when turned on, it will slow down writes a bit, around 15%, but should make reads significantly faster, and thus V-order is a good option to have turned on. And it is actually enabled by default in Fabric, which in my opinion is a good thing. Then we have the OneLake File Explorer that integrates directly to your Windows Explorer, and you can use it to interact with files in OneLake storages like Lakehouses. I wouldn't use this to directly interact with Delta Table folders other than maybe delete them, since Delta Tables are not meant to be interacted with this way. However, this tool is great for updating and adding new files to Lakehouse's file section where the raw files are. I can see that this tool can be beneficial to business users that want to update some reference data that is sitting in a Lakehouse. Next, we are going to hop into Fabric and check out Lakehouse in more detail there. Now we're in Fabric, and here I have my DP-700 workspace open. And here I have this Lakehouse that we have created in the previous videos. Let's open this Lakehouse and let's check it out. So, as we know, we have the tables here and we have the files here. And we have been actually writing data and using this Lakehouse in the previous tutorials. So if you have been watching those, you should be already somewhat familiar with the Lakehouse. But today we are going to dive a bit deeper in the specific features that we have in the Lakehouse that makes it different from the other data stores that we have in Fabric. And like I said, the big thing with Lakehouse is that we can store there any type of files we want. Basically, we can store there, for example, audio files, video files, CSV files, JSON files, Excel files, any files we want, because we can just treat those files as binary objects and not care about their contents. Also, let's go back to this workspace, and we can see that under this Lakehouse, we have these two additional items here. First, we have this default semantic model here that is created when you create a Lakehouse, and this is basically a Power BI dataset that is sitting on top of our Lakehouse so that we can start using Power BI with our Lakehouse very conveniently without doing a much configuration here. Then we also have this SQL Analytics endpoint. And this is the TSQL interface that I was talking about in the theory section. Basically, this gives this warehouse type of interface on top of the Lakehouse that we can then use TSQL to query the data in our Lakehouse. But remember that this TSQL interface is read-only, and we cannot use this to write data. But this is one way of accessing the data sitting in the Lakehouse using TSQL if your developers or end users are more familiar with TSQL and prefer working that way. But the limitation is that it's read-only. And now let's go back to that Lakehouse view, and like I said in the theory section, we can create table shortcuts. For example, if I would like to create a table shortcut to this DPO schema, I could click these three dots here and choose a new table shortcut. And this will then prompt this selection from which I can select the source I would like to use for my shortcut. But this time we are not going to create a new table shortcut here. And we are also able to create file shortcuts. So if I would click here one folder, we would be able to define a new shortcut here. And this time we are actually going to define one new file shortcut. So let's create a new subfolder here called DP-700 episode 12, and let's create that. And now I want to create a shortcut to this folder, and I want that shortcut to point to the Azure where I have this storage account, and to this storage account, and in this storage account I have a container to which I want to create that shortcut. And this container is called Data Lake. But before you start to do this shortcut, please check that you have the appropriate access to that. storage account. And if you're going to use your personal account for the shortcut, you can go to the access control of the container and then you can click this view my access, and you need to check that you have, for example, this storage blob data contributor. That should be very much enough for creating that shortcut. And now let's close this, and then we want to check from the properties this connection URL. Actually, we need to edit this a bit and change this blob here to DFS. But yeah, let's take this URL here and we will edit it shortly. And this is going to point to that container to which we are going to create that shortcut. Now let's go back here, and then we are going to select a new shortcut, and then we are going to select Azure Data Lake Storage Gen 2. And then we are actually going to create a new connection. And then this will load up. And here we can see that we need to input this URL in the .dfs form rather than .blob. I'm not going to dive into specific details about that too much in this episode, but let's change that blob there to .dfs. And it is actually prompting me for this connection that I have already made, but I want to actually create a new connection so that you can see how does this happen. And then we would have some options to choose another authentication method. And some of these are way better than my organizational account, but I will now just go with this for the demo purposes. And then let's click next, and then this should create the shortcut to that container. And then we have to select to which folder we want to actually create that shortcut to. And I want to create that to the root folder called Data Lake. And let's click next here, and it will then create that shortcut there. And then we are able to see the data sitting in the Azure storage account. So now we have created that shortcut, and that shortcut is pointing to this specific container, and we can see these same files that we have via this shortcut here. So there's the temp folder, and in that temp folder we have that file in Azure Data Lake.txt. That is the same file that we can see here. And this way we can see how this data virtualization happens via shortcut and how to configure a shortcut. Next, let's quickly check out where we can find that shortcut cache that I was talking about, even though the shortcut cache is not actually applicable to the Azure Data Lake storage. But yeah, the shortcut cache is actually a workspace setting, and I will move my face from there and we can open up the workspace settings here. And here we can see the OneLake, and here we can see enable cache for shortcuts. And I can turn this on, and then we would be able to define the retention period between 1 to 28 days, how long those files would be locally stored in OneLake if we would use the cache for them. And we can, for example, set here the 28 days, and now that setting is saved. And here is also an option to reset the cache if we want, so that those all files would be removed from the cache. But yeah, now we have configured that cache as well, and it can be found here from the workspace setting and OneLake settings, and here is the enable cache for shortcuts. Let's go back to the Lakehouse, and now let's talk about those vacuum and optimize commands that we covered in the theory section. And let's first cover how to run those commands from the UI. Let's use, for example, this table that we created here in the episode 11, this temperature stream table. And we can click these 3 dots here, and then we have this maintenance option here. And we can click that maintenance. And this will then open up this view from which we can then choose to run, for example, the optimize command and also run the V order at the same time. And then we are also able to run this vacuum command here. And then we are able to specify the retention period for those old files, meaning that this would then delete the files that have been being used in the latest version of the data since that period. But yeah, I would, for example, run this for 7 days, and then I could click this run now, and it would start to run these optimize and vacuum commands for that table. And let's run that. But as you can probably tell, this would be quite a heavy process if you would have multiple lakehouses with, for example, thousands of tables. This would be then a huge task for somebody to go through all of those tables and click through those optimize and vacuum commands for every table. Luckily, we have the code way of running these commands as well, so we don't have to rely on the UI only. Next, let's create a new notebook and let's use that notebook to run those commands. Let's clean this here and then let's attach the Lakehouse that we are using to this notebook and let's choose that Lakehouse. Now it has been attached and then we can start to run those vacuum and optimize commands for the tables we have here. And here we can see a one way how we could run those vacuum and optimize commands from a notebook. So basically we can use, for example, Spark SQL and specify those commands and run them to the table we want. So let's run these and let's see what happens. And finally, my session started after 4 minutes, and then this command took like 36 seconds to run. But yeah, basically this is how you could run those programmatically from a notebook. Then with vacuum command, we are also able to specify that amount of hours we would like to retain when we are running that command. For example, here I'm saying that I want to retain 200 hours in that table, so that we would be able to travel 200 hours backwards with the time travel feature if we so desire. So we would keep some old data sitting there just in case. And a best practice here is that you don't use really tight retain hours when you run this vacuum command. For example, if I would try to run this, for example, 2 hours, I think this would throw us an error message or something. Yeah, it throws this error message and tells that, are you sure you would like to vacuum files with such low retention period? Basically, the issue there would be that if somebody would be still using those files, for example, there would be a process going on that would be still using those files that are relatively new, then that process could fail or there could be some issues if you try to delete those files at the same time. But yes, there are some options that you can use to override that, but I don't see any point of like using this vacuum command with really tight retention periods. And of course, you can use these commands to build yourself some maintenance runs that would be run periodically and run for all the Delta tables that you have. Also, a cool little library that I want you to know about is this Semantic Link Labs that has many features, for example, optimizing Lakehouse tables. But I don't think this is part of the DP-700 exam, so if you're looking to build some runs that would optimize and make sure that your Delta tables are okay, then check out this Semantic Link Labs library. But not more about this time. Next, I want to show you this OneLake file explorer that you can install to your computer. And with this, you are able to access to OneLake data using this file explorer here. And we can, for example, go to the workspace that I have been using here now. And then we can see all the data stores here that I have in that workspace. And then we can navigate to that Lakehouse that we have been currently using. And then we can see, for example, these files and tables here. And then we can navigate to the file section and to the folder that we just created. And here we can actually navigate to the shortcuts as well. So when I'm navigating to this data lake folder here, now I'm actually navigating to a storage account in Azure. And here I have that file that I have sitting there. And now I would be able to modify this file that is sitting actually in the Azure storage account using my own computer here. But yeah, we can go back here and we can also check out those Delta tables here. For example, this episode 11 folder where we have that temperature stream Delta table. And here we can see that we have those multiple Parquet files here. And then we have this Delta log here. So this is how the Delta table looks under the hood, like we went through in that theory section where I talked about these Parquet files under this Delta folder here. But yeah, this OneLake File Explorer is a pretty cool feature and I would encourage you to explore this on your own and things that you can do with this. Next, let's have a couple of questions about the topics covered in this episode. Let's start with the first question. What happens when a cached file used in a Lakehouse shortcut has not been accessed within its retention period? Is it A, the file is permanently deleted from the source system? B, the cache is refreshed and the retention timer resets. C, the file remains offline but shows a warning about the retention. D, the file is removed from the cache and fetched again on the next access. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D. The file is removed from the cache and fetched again on the next access, since this is how the cache will behave once the retention period is reached. A is incorrect since the file won't be deleted from the source, B is incorrect since there is no such functionality and the cache will refresh only if the data is accessed, but this opinion doesn't mention that. C is incorrect since no warning will be shown. Let's have another question. What does the vacuum operation in a delta table primarily target? A. All transaction logs that are no longer referenced. B. Unused or outdated metadata definitions. C. Physical Parquet files no longer referenced by the latest version. D. Rows marked for deletion in delta tables. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C. Physical Parquet files no longer referenced by the latest version, since that is how the vacuum operation works and these other options here are incorrect. This is the episode 13 in the DP-700 exam prep series, and in this episode we will cover Warehouse. That, alongside with Lakehouse and Eventhouse, is one of the main data stores in Fabric. In this episode we will cover what is Warehouse and how it can be used. In this episode we are not going to focus on access control, dimensional data modeling, data masking and monitoring, since for those we have dedicated episode coming up. The focus of this episode is in the data ingestion and reading and using the Warehouse as a data store. Like in every episode in this series, we will start with the theory section, followed by demo/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Let's talk about the Warehouse in Microsoft Fabric. On the side, we can see how does the Warehouse look in the Fabric UI. Out of all the data stores in Fabric, the Warehouse is the one that feels most like a traditional database, and many of the things that work in the traditional databases work here as well. But there are also many differences, since the technology behind the Warehouse is a lot different from a traditional database. Actually, under the hood, Warehouse is storing data in Delta Parquet format to OneLake, just like the Lakehouse we covered in the previous episode. We will do a full side-by-side comparison of Fabric data stores in a later episode, but here is the main thing to remember for now. The Warehouse is built for structured tabular data. That means, unlike with the Lakehouse, you can't drop in just any file format you like. It is not meant for raw, unstructured data like images or nested JSON files. Instead, data here is stored cleanly in a relational tables. Because of that, Warehouse is typically used in the silver and gold layers of Medallion architecture. You typically bring a cleaned and transformed data, not raw data, from a source to Warehouse. If you have used SQL Server or any relational database before, the Warehouse in Fabric will feel right at home, but now it is packaged into Fabric and backed by open, modern storage format. Now let's talk about what lives inside a Warehouse. You will find the usual database objects like schemas, which act like folders that group your tables and other objects. Then we have tables, where the actual data is stored. Then views, which are just saved SQL queries that behave like virtual tables. Then functions, which return a value based on some input, like calculating a fiscal quarter. And then lastly, stored procedures, which are blocks of SQL logic used to do things like update data or automate processes. Now let's talk about the different ways you can ingest data into a Fabric Warehouse. There are several options available, and many of the tools in Microsoft Fabric support Warehouse as a destination. First up, data pipelines. You can use them to copy data from a wide range of sources directly into Warehouse tables. The same goes for Dataflow Gen2. They are low-code, visually driven, and you can also write data straight into Warehouse. Then we have notebooks, which give you multiple options. In Fabric, you can use TSQL notebooks to write SQL commands that load data into a Warehouse, and we will come back to these TSQL approaches in a moment. Notebooks also support a Spark connector for a Warehouse, which is currently in preview. And if you prefer, you can use generic interfaces like ODBC within your notebook code to write data to a Warehouse. As I mentioned earlier, Fabric supports TSQL directly, and that includes the ability to do cross-database queries. So, for example, you can load data from another warehouse, or from a Lakehouse using its read-only TSQL interface. The current limitation with this method is that you can only read data stored within the same Fabric workspace. If you're working with Azure Blob Storage, There is also the copy into command. With it, you can load files like CSV or Parquet files directly into warehouse tables using TSQL. And finally, there are a few other methods that go beyond the DP-700 scope. For example, you can use Fabric copy jobs, Azure Data Factory, or connect using more generic interfaces like ODBC or JDBC, which let you integrate with a variety of tools and platforms. Reading data from a Fabric warehouse is simple and familiar if you have worked with any relational databases before, and especially with Microsoft SQL Server or Azure SQL Database. You can use TSQL queries to explore and retrieve data just like in SQL Server or Azure SQL Database. This means that you can run select statements, join tables, filter data, and even use views and functions, all using standard TSQL syntax. Fabric also provides an SQL Analytics endpoint, which allows you to connect using tools like Power BI and SQL Server Management Studio. You can also read data using different Fabric tools like data pipelines, Dataflow Gen2s, notebooks, etc. And finally, many external tools support using ODBC or JDBC, which means that you can connect to the warehouse using your favorite BI tools, apps, or programming environments, and run queries in a similar way you would do with any SQL database. Then I want to cover two features in Warehouse that are quite unique in this context, and not typical features in traditional SQL databases, and those are time travel and table cloning. Both of these features are made possible the fact that we are using delta tables under the hood. If you want to learn more about delta tables, check out the previous episode, where I covered Lakehouse and talked about delta tables more in depth. Let's first take a look at the time travel feature. This feature allows us to look at the table as it existed previously. This means that, for example, if we have added or removed rows from the table, we would be able to query and look at the table how it looked before those operations were made. So this feature is great if you have made some accidental operations like deletes or even truncate, and you would like to recover a previous state of the table. This means that there is less need for manual backups or versioning. Currently, this time travel feature supports traveling back in time 30 days, since after that Warehouse will automatically clean the history. The other feature that I want to talk about is the table cloning feature that allows creating instant copies of a table. This feature supports using time travel as part of it, and you can create a clone for a previous version of the table. These copies are so-called zero-copy clones, which means that they basically copy only the table metadata and are physically pointing to the same one-leg files as the original table, and thus storage cost for these clones is very minimal. These table clones will then inherit properties like row-level security, dynamic data masking, etc. from the original table. Currently, there are some limitations with table clones that you can only create them within the same workspace. But please check out the current limitations if you are watching this video long after I have released this. Next, let's go to Fabric and let's do some demos/tutorials together and try out these concepts and features that we talked about here. Now we are in Fabric and I have a warehouse open here. And those who have been working with traditional databases probably find many of the things here that we are going to cover very familiar. But as we can see here, we can see how does the warehouse look in the Fabric UI. So basically we have here our database schemas that act like a folders in a database and group these objects together, like for example tables, views, functions, and stored procedures. So schemas make the access control, for example, in a database easier, so that we can, for example, grant accesses to specific schema rather than to specific objects. So we are able to organize things better when we have some schemas in our database. The default schema is called a DBO schema, and we can see that there, but I have also created this additional schema here, and then we have these kind of like technical schemas or these schemas that are created as a default and contain, for example, some tables that we can use to query and check out the query activity or some like information about the warehouse, what's going on. But those kind of things we are going to cover in a later episode. Then we are of course able to query our warehouse. And here in the Fabric UI, we have few different possibilities how we are able to query this warehouse. We can create a typical new SQL query here, or then we can create a new visual query. We're going to check out this very shortly. And then there is also a possibility to create a query in a notebook. And that way we can actually create a TSQL notebook and query our warehouse using a notebook and all kinds of cool features that we have in notebooks. Like for example, we can use their markdown cells, etc. And now let's check out this visual query quickly here. And with this feature, we are able to create a visual query and add some tables to this visual query here. And this way we can visually create our SQL queries. Of course, this is actually creating some SQL on the background. As we can see, this created this SQL statement here that we can see here on the screen. But with this, we would be able to add new tables here, and then we would be able to, for example, do some joins between these tables, and then we would be able to create our SQL visually here. This is a quite handy feature if you are not so efficient or know SQL that well, so that you can use this to create your SQL. But personally, I still prefer writing my SQL. But maybe at some point I will try to explore this feature more. But it is good to know that this is one possibility to query warehouse. But yeah, let's close this. Then, like we discussed in the theory section, we can actually connect to this warehouse using tools like SQL Server Management Studio. And here we can find this SQL connection string that can be used to connect to this warehouse. And I actually have already SSMS or SQL Server Management Studio running, and I have connected to this warehouse using that connection string there. And here we can see that I have connected to this warehouse, and we can also see these other data stores that we have in this same Fabric workspace. So we have this, for example, this Lakehouse's TSQL endpoint, where we can also connect with using SQL Server Management Studio. And here we are able to query the warehouse and also do some changes to the warehouse if we so desire. But we are not going to use the SSMS today here and query our warehouse, and instead we are going to use the Fabric UI, since probably not all the people watching this video have this installed. So let's minimize this here for now. And now we would be able to choose to create a new SQL query, or then we would be able to query this warehouse using TSQL notebook. Actually, this time I'm going to use this new SQL query and query this warehouse this way. So let's create a new SQL query, and I have written this SQL query that we are going to use to try out the features in the warehouse. So I will paste that query here. And here we have that query, and we are going to start from the top. So what we are first doing here? So we are preparing our data. We are first creating a schema for this episode, and then to that schema, we are first going to create a table, and then we are going to add some data to that table. And we are going to add some few rows of employee data here. So we have there 6 employees that we are going to add to that table. So let's run this first part here, and let's click run. And it should be done very shortly, and then we should have a new schema here after this is done. And now this is done, and we have that episode 13 schema here, and in that schema we should have table. Let's refresh that, and there's the employees table. And now we can then query that table if we want. But for now, we are actually going to create a view on top of that table. And like discussed in the theory section, if you're not familiar with views, they act like these kind of virtual tables. So basically, view is this stored SQL query, as we can see here. So we are defining a view, and then we are defining this SQL that is used for that view. So every time somebody will interact with that view and use it like a table, it will actually execute this SQL statement that I have here. So this means that views are basically always up to date based on the data they are created on. So let's create this view here first, and let's run this. And now we have created one view here as well. And I have prefixed that view like this so that we can tell those apart that this is actually a view and this is a table. And then we are able to query the view like we would query a table here. And we should see those like these like seniority levels here that I defined in that view query based on the current date and the hire date. So we can see that we have mostly seniors working in this company, and one mid-level. Emma is actually a mid-level person. But yeah, let's move forward. And next, we are actually going to create a stored procedure. And these stored procedures are these kind of SQL logic that are wrapped to this object. And these are similar to views, but unlike views, these cannot be used like virtual tables. So for example, here I have this stored procedure that will actually take in parameters. And this is one good thing to know about the stored procedures, that you can define some parameters for them. And here I'm just defining this stored procedure, get employees by seniority. And here we are just returning employees based on these parameters that we are going to give to our stored procedure. But yeah, let's first create this stored procedure. And now we have created that stored procedure and we have it here. And then we would be able to execute the stored procedure that would then run this SQL statement that we have in that stored procedure. And actually a good thing to note here that with stored procedures, we could have many different SQL logic wrapped into them. So we don't have to only use the select statement. For example, we could have a stored procedure that would update the data or delete the data or do some kind of other database operations. So they are great for like automating some tasks, for example. But yeah, let's query that stored procedure and we will run it as saying the exec and then the stored procedure name, and then we are going to pass a parameter for it. So let's run that and get the seniority level senior. And actually for this like a department ID, we have defined that there is a default value of null for that parameter, so we don't have to define it. So basically, when we query that way, it doesn't care about the department ID. And then we can also run this with the department ID parameter and then define that we want the employees from this department. And there we can see those employees who are on the seniority level in that department. And next, I want to talk about the copy into statement, that we can actually use and copy data from an Azure Blob Storage to Fabric Warehouse using TSQL. And here we have this example copy into statement, and we can use this to copy some CSV data from our blob storage in Azure to this Fabric Warehouse. And we can check out that blob storage in Azure. And here I have created this container called DP-700, and in this container I have this folder, and in that folder I have this employees.csv file. And if we are not specifying any authentication methods to this copy into statement, it will by default use your Entra ID credentials, meaning your user account, to query that blob storage. So that you would need to make sure that you have the sufficient access to that container that you are querying. So you can go here and view my access and check that you have, for example, storage blob data contributor access like I do, so that you are able to query that data. But yeah, there are plenty of different authentication methods available for this command, and using the user account is not probably the best way, but you can explore those different ways on your own. But we can check out quickly the documentation and see that we can define quite a many different options for this copy into statement. So this is one very simple example with one very simple CSV file that we have in this storage. And here in this file, we just have few rows of data, as we can see here. So basically, we are adding some more employee data to our employee table. And as we can see, the target is that employees table that we created. So let's run this statement that will actually copy that CSV file from that Azure to that table. And this should be done fairly soon. And now it is done. And now we can, for example, query the view that we created and see that we should have some new rows in our employee table or in this view that we're querying now. And we can see that now there are 9 employees instead of those 6 that we had previously. So we have added 3 more there. And next, let's talk about the time travel feature that we can use to travel back in time and check out the previous state of the table. And remember that this is possible because we are using delta tables under the hood, and with delta tables we only have basically insert operations. So by default we are not actually deleting the data, as we covered in the previous episode. But yeah, here I have these 2 different time travel queries. So these are our typical select statements, but we have to define this option, and we can define this option for timestamp as of, and then we define a timestamp in UTC time, and we use this timestamp to indicate the time of the previous state we want to take a look at. So now I would have to adjust these timestamps a bit so that we can check out how did the employee table look before we inserted in these rows. So I have to go back in time a few minutes here. So I will do those adjustments here quickly. And now I have adjusted those timestamps so that we travel to a time before we did that insert to that table using that copy into statement. So let's query our employees table. And here we can see only those 6 rows that there were previously. And what is cool here that we can use this time travel to a view as well. So now we are querying that employees view and checking out that previously, and we can see only those 6 rows here. And if we would query the current state of the table, we can see those 9 rows there. So this is how the time travel feature works. But remember that currently there is a limitation that you cannot travel back in time over 30 days, because after the 30 days there is an automatic process in the warehouse that will clean up older data so that there is no data after 30 days. Next, I would like to demonstrate some cross-database queries, but for that we need to create a notebook first, because I want to add some data to our Lakehouse and actually use that Lakehouse's TSQL endpoint and read data from that using a cross-database query. So let's set up this notebook and let's add this Spark SQL code to this notebook. And then let's attach that DP-700 Lakehouse to this notebook. So that is the default Lakehouse that is being used here. So here we are using Spark SQL and creating a new schema to this Lakehouse and then creating a new table to that Lakehouse and then adding 2 rows to that table. And then we are next going to query that using cross-database queries. But yeah, let's run this and let's create those objects to this Lakehouse. And remember that here we're using Spark SQL. Since we cannot use TSQL to modify Lakehouse, we can use TSQL to read only the Lakehouse. And now our code has run and we can see that we have a new schema here and we have a new employees table. And now let's go back to our warehouse. And now we can start to query that Lakehouse's TSQL endpoint, that is a read-only endpoint, and use that to load data to this warehouse from that Lakehouse. And here we can actually attach that TSQL endpoint of that Lakehouse to this warehouse view here. So here we can see that Lakehouse and here we can see SQL Analytics endpoint. We can also see that there are these warehouses in this workspace. So here we can differentiate that do we have a warehouse or do we have SQL Analytics endpoint, meaning that the SQL read-only interface. And I will use this UI here and attach this Lakehouse to this workspace. And here we can see the schemas, and here under the schemas we can see the table that we just created here. And then we can use this 3-part naming convention to query this table here. So we have to specify the data store that we are querying, and then the schema, and then the table. And now let's run this query and let's see that we can combine these 2 data here. So let's run that. For some reason there seems to be some type of issue with the data here. I don't know, there wasn't issue previously when I tried to do this, but we can query only from the Lakehouse TSQL endpoint the data and see how does that look. And it looks all right. And in my opinion, it looks the same as the data in our other employees table. So I should be able to combine these, but for some reason I can't. I don't know if that's a bug going on in Fabric or what is the issue there. But let's move forward. Let's try to insert data from this Lakehouse to that warehouse table that we had there. So let's run an insert statement and let's see if this will go right. And now it is running and we should be done. Yep. And let's try to query only the warehouse table to see if those rows went there all right. Actually, they didn't, and we can see some null rows here. I don't know what's going on there. Is that like a data type mismatch or what is the issue there? But yeah, I don't have the time to figure that out right now. But yeah, let's lastly talk about cloning tables. So cloning tables allows us to create those 0-copy clones that we covered in the theory section. Basically, this means that we're just copying the metadata and the physical files will stay in the same place. So we use that metadata to point to those same physical files as with the original table. This means that when we use those zero copy clones here in the warehouse, the storage cost is very minimal with those. And this is a very easy way to back up the data. And here we can see how we would create those table clones. So we say create table, and then we say that table name. So now I'm creating employees clone as clone of, and then we tell the table we want to use as the original table. So let's run this. And also the good thing to note here that we can also use this at and then to define the timestamp in UTC and then create a clone for like a previous version of the table, so that we're basically utilizing the time travel feature when cloning. But for now, I just wanted to create a clone for the current version of the table. And then we can query that clone here. And we can actually see that clone here in the UI. And here we can see that data that we have in that clone, and also those null rows that came from that Lakehouse table. And then now I'm going to insert a new row to this original table, and that new row has been inserted there. Now when we would query this clone table, we shouldn't have that 12 employee number there, and we don't have it here. And if we would query the original table where we inserted that row, we see that there. So there's the John Smith that we inserted there. And then we can, for example, truncate the original table, which means that we will wipe it clean, and this shouldn't affect the clone table at all. So now this table should be clean. Now we don't have any data in our original table, and we should still have data in our clone table. Yep, but we don't have this row here because this row came there after we cloned that table. And now we would be, for example, able to insert rows from the clone table back to the original table using this statement here. And now we should have again some rows in our original table. Yep, but we are missing this row because this came there after the cloning. But of course, if we want, we would be able to create a new table clone after this row was inserted, and then use that clone table to insert back those rows to that original table. Next, let's have a couple of questions related to topics covered in this episode. But before that, I would encourage you to check out this website called certiace.com that I have created with few friends. This website offers practice questions to certification exams. These questions here are custom made, so they are quite similar to those questions that you would see in the actual exam, but not exactly the same. So after watching this video, if you want some practice questions, for example to DP-700, go check out the certiace.com. Let's have our first question. Which of the following is true about table cloning in Microsoft Fabric Warehouse? A. Clone tables always create full physical copies of data to support sandboxed analytics workloads. B. Clone tables can be created across workspaces as long as the schemas are identical. C. Clone tables inherit attributes like row-level security and dynamic data masking from the original table. D. Cloning requires exporting the table to OneLake and re-importing it as a separate asset. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, since clone tables do inherit attributes like row-level security and dynamic data masking from the original table. A is incorrect since we are not creating a physical copy when we do a clone. Instead, we use zero copy clones and only copy the metadata and point to the same physical files in OneLake as the original table. B is incorrect since currently cloned tables can't be done across workspaces. D is incorrect since cloning doesn't require exporting and importing tables. Let's have another question. You want to query data from two different Fabric warehouses. Which of the following is required to do this work successfully? A. Both warehouses must be in the same workspace, and you must use the three-part naming. B. Warehouses must expose its Power BI semantic model to support cross-querying. C. You must create an external table using the Lakehouse shortcut feature before querying across databases. D. You have to use Spark Notebook since cross-database queries are only supported using Spark, not TSQL. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is A, since we can do cross-database queries within a same workspace and use three-part naming convention. B is incorrect since this is not a requirement. C is incorrect since no external table is needed. D is incorrect since cross-database queries work with TSQL and Spark is not needed for that. This is the episode 14 in this DP-700 exam prep series, and in this episode we will cover fundamental concepts of data models and especially focus on slowly changing dimensions, since understanding those is one of the key topics in the DP-700 exam. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. First, let us talk about why we even do data modeling. When we collect data, it is usually messy. It might come from many different systems like databases, CSV files, APIs, or even manual Excel files. If we try to use raw data like that for analysis, it becomes very difficult and very slow. So, we do data processing and data modeling to organize the data into a clean, structured format. This makes it easier to find answers to questions later and use that data to all kinds of use cases. Good data modeling also improves performance. Queries run faster because the system knows how the data is related and stored in the optimized way. It also ensures data quality. When we define relationships and rules, we avoid problems like duplicate records and missing information. Also, data modeling supports business goals by aligning the data to real business processes like sales, inventory, or customer management. Other important reason is scalability. When the amount of data grows over time, a well-designed data model can handle it without problems. Also, a key thing in data modeling is to reduce data duplication by normalizing the data in a way that same things do not repeat over and over again in the data. And in upcoming slides, we are going to cover what this normalization and denormalization means. And finally, data modeling makes it easier for developers and analysts to work with the data and create reports, and this way provide value to the business. That is typically the end goal here. So, what exactly is a data model? A data model is like a blueprint or a map of your data. It defines the structure of the data, meaning how the data is stored, what tables exist, what columns are inside those tables, and how the different tables are related to each other. Here on the screen we can see two tables, customers and orders. That could be part of some simple data model. Key concept in data models and data modeling is to define relationships between tables or views. For example, in this case, a customer table has to be connected to an order table so that we know which customer placed which orders. This is done using keys. First, a primary key is a column that uniquely identifies each record inside a table. For example, customer ID in the customers table or order ID in orders table. Each customer and each order has a unique ID that can be used to identify each row. Second, a foreign key is a column that links one table to another table's primary key. For example, the customer ID in the orders table connects back to the customer table. We can then use these keys to join these tables together. Of course, we could also have one big table named, for example, customer orders, and repeat those customer names and countries in each row, but then we would end up with a lot of repeating data in our table, since the same customer could be doing multiple orders. That's why it is good to reduce that repetition by normalizing the data. Here on the screen we can see the example I just described by having that larger customer orders table where we repeat customer information each time a customer makes an order. Then below that we have a normalized version of that same data where we have split that data to two tables so that we can reduce the amount of data repetition. In this case, we would normalize that one big table to one fact and one dimension table. So let's talk about the concept of facts and dimensions next. In the world of data modeling, we often divide tables into two main types, fact tables and dimension tables. Fact tables store measurable data, meaning the numbers we want to analyze. For example, sales amounts, number of products sold, and profit amounts. Facts answer questions like how much did we sell or how many products did we sell. The fact is usually the central table in a data model. Then we have to use foreign keys to link fact table to dimension tables. Also, it is good to note that typically fact tables tend to be way larger than dimension tables due to their nature. Dimension tables store descriptive data, meaning the context for facts. For example, information about customer, products, stores, or dates. Dimension answers questions like who made the purchase, what was bought, and where it was bought. Relationships are then created between fact table and the dimension tables. For example, customer ID links orders to customers and product ID links orders to products. When you hear about star schema or snowflake schema, they are based on this idea having facts in the middle and dimensions around them. And next, let's talk about those two types of data modeling schemas that are the most typical ones used in the analytical use cases. When we design a full data model for analytical use cases, we can use different types of structures. Two of the most common ones are star schema and the snowflake schema. In a star schema, the model is simple and flat and resembles a star in a way. The fact table is at the center and then the dimension tables are directly connected around it. In Snowflake schema, we have more structure since dimensions could be split into multiple tables. Thus, dimensions in star schema are more denormalized compared to the Snowflake schema. Because there are fewer joins between tables in star schema, queries tend to be faster when compared to Snowflake schema. However, star schema can take up more storage because some data may be repeated. Also, it can be argued that star schema is easier to use since the structure is simpler. Thus, in my opinion, it is better option for simple reporting and dashboards. Snowflake schema is then better for more complex cases where you have, for example, changing dimension data. And to one more time highlight the differences between these two, you can think about that in star schema we just have one big customer dimension table that tells all the information about customers. In a Snowflake schema, we can split that customer dimension into multiple tables, and one could store basic information about the customer, then one address information, and one region information, etc. Also, there could be some cases when the data in dimensions changes. For example, a person moves to a different country, and that needs to be shown in the dimension table. So let's cover how we can handle changes in dimensions. Slowly changing dimensions or SCDs is a very important topic for the DP-700 exam and also for real projects. Sometimes the descriptive information in a dimension table changes over time. For example, a customer may move to a new country or change their last name. We need to decide how we want to handle these changes. There are different types of SCDs based on how we manage these changes. In SCD type 0, we do not change the data at all. Even if the real-world information changes, our data model keeps the original values forever. This type 0 is good for fixed data, like a person's date of birth that shouldn't change ever. Also, one classic example is a date dimension that stores date values and more information about dates like which quarter to that date belongs, etc. Then, in type 1, we simply overwrite the old data with the new data. No history is kept. For example, if James decides that he doesn't want to live in the UK anymore and decides to move to Thailand to enjoy better weather, then in SCD type 1 we would just update the row to show that James is now living in Thailand. Of course, since we don't keep any history, we lose the information that James was previously living in the UK. And this information could be important when we look at past orders or transactions that James has made since he used to be an UK customer. And in analytics, we most often look at past data, so in real-world use cases, type 1 doesn't really usually fulfill the reporting needs. For tracking history, we can use SCD type 2. In this type 2, we create a new row when something changes. Each row has its own start and end dates so that we can know when that row was valid. This way we can keep track of the full history of how data has changed over time. There are many variations in how the change tracking can happen in SCD type 2, but one very typical way is to use start and end dates and maybe have a current flag that indicates is the row current or past version for easy filtering. Also, in this case, we can't use the customer ID as the primary key for table since we could have duplicates for it, as we can see shortly. Thus, we can, for example, create a surrogate key that is always unique and then use it to link the SCD2 data to the fact table. But as I said, there are many ways how SCD type 2 can be made, but the key thing to remember here is that we track changes on their individual rows and add new rows when something changes. If we repeat the same situation that we had with James, that he moves to Thailand from UK, in type 2 we would then create a new row and end the previous version of that row and start a new row from the same date as the previous one ended. Also, we have a new surrogate key for the new row, since now we would have a duplicate in the table if we would use the customer ID as the primary key for this dimension. Then we have type 3. In this, we store the previous value in another column inside the same record. For example, we can add a previous country column. When the country changes, we move the old country in the previous country and update the current country. Type 3 is good if we only care about tracking the last change, but not full history over time. In the case of James, the table would look like this after he moves to Thailand. There is also a few other types of SCD, but they are out of scope for this series. But please explore them on your own if you are interested. Next, let's go to Fabric and do a demo/tutorial about these different types of SCDs together to really understand this topic, since, like I said, this topic is very important in the DP-700 exam. Now we're in Fabric and I have my warehouse open here. I'm going to use the warehouse to demonstrate these different types of SCDs. Actually, we could be also using a Lakehouse and maybe Spark SQL or PySpark to do the same thing, but I think that the most people watching this series are most familiar with TSQL, so we will go with the warehouse today. And here I have this SQL script that I have created to demonstrate these SCDs. Let's start by creating a new schema to this warehouse. So we create a new schema for the episode 14 that we're currently doing here. Then we want to start to demonstrate the SCD type 1. We're actually going to skip the SCD type 0 because that is basically a static table and there is not really anything interesting to demo there. So let's first demo the SCD type 1. So overwrite the existing data and we don't have history in this slowly changing dimension. So let's create a table and then insert few rows to that table and then display that table. Let's run these commands here and then we should see how does the table look. And we should have there 2 rows of data, laptops and headphones. So basically we have some product information here and we are using like this product dimension to demonstrate this SCD logic. And here we can see that we have the product ID, product name, and then we have the price. And next we would like to demonstrate how the change happens in the type 1 SCD. So I would update one of these rows and we're going to update this product ID 1, meaning the laptop, so that we have a new price. Inflation has been high here, so we add 100 euros or $100 to the price. So it will get a bit more expensive. So let's update the product price and then display the data. So this will reflect that how we see things happening in the SCD type 1. So we lose the history about the previous change there. So we don't really store things that have happened previously to that specific item in the dimension. So SCD type 1 is very simple in my opinion, but it doesn't fulfill the use cases in the real world scenarios, since now we don't know what was the product price previously, and if we would like to report things that happened in the past, we wouldn't have that price available here. Next, let's cover SCD type 2. So basically in this SCD, we will add a new record for every change, so we can see the full history for the data. So let's again create a new table, but this time let's have more columns, since the SCD type 2 logic will require us to have more columns typically than in the SCD type 1, since we need to have some logic that we know what is the validity of each row and when it was valid, etc. Also, we will need that surrogate key, since we cannot use the product ID any longer as the primary key in a real-world scenario, since we can have multiple rows for the same product that have been valid in different times. So let's create the table for the SCD2 and then also insert the same 2 rows there, but now with slightly different columns, and then we can display the data. So let's run this SQL here and we can see how does the data look. So we can see that we have the surrogate key, product ID, product name, price, and then we have the record start date, record end date and is current. And one thing to note about this record end date, that this is just one way of doing the SCD and setting this like a record end date to the very far into the future. For example, like this 1,000 years to the future almost. One other option would be, for example, have these as null values, so that basically those are null if there is no later version for that row. Then in many cases we have some type of flag in the SCD2 table that indicates that is that row the latest or the current version of that specific row, so that we can easily filter out the latest version of each row from the table without using these timestamps here. So it will just make the usage a bit easier. And now let's simulate the situation that we had there previously, that the laptop price will change. So basically we will first update the first row and set it as inactive, and we will set the end date for it, and then we will update the current flag to be 0. And then we insert a new row to that table that is valid. And now let's run these two steps and let's display the data so we can see how does the SCD2 logic works. And now we can see how does the result look after the update. So we have now there the product ID 1 2 times, meaning that we have two rows for laptops here, but we have different prices. And we can see that this first row here was valid previously, but it is not valid anymore, and it has ended now. And then we have this new row that is valid from the same date as this previous record ended, and that is valid for that like 1,000 years into the future. And there we can see that the isCurrent flag is also 1 for that. And now we have this one where the isCurrent flag is 0. So it would be very easy for us to filter now the current versions of the data if we would like. Next, let's cover the SCD type 3. And in this type, we track the previous value, but we don't have the full history. So let's create a table for the type 3 and then insert those same two rows there and then display that data. And I will explain the columns to you shortly. So now we have a similar table that we had in type 1. So we have the product ID, then we have the product name, then we have the current price, but we also have this column previous price. And this current valid from tells the date from which onwards this current price is valid. So we can see that these have been valid since January. And now let's simulate a situation where we again change the laptop price here. So now we would update the row and we don't actually insert any new rows to this SCD. So we will set the previous price to be the current price and then update the current price with the latest price. And then we change the current valid from to this date. So from this date onwards, we can see from the table that this price has been valid. And let's run that update and then display that data to see that how that works. And here we can see how does this look now. So we don't get any new rows to the table, but we have this previous price now for the laptop. And then we also have the current price. Then we have also updated the information that this current price has been valid from this date onwards. But as you can see with this SCD, the history tracking is quite limited and we can only see the previous value. And in many cases, many people don't even add this current valid from to this table. So basically we got very little information about the historical changes. And actually I have to admit that I have never used the SCD type 3 in a real world scenario before. But type 2 I have used so many times that I cannot even count, because it is the most typical one to use. Next, let's have a couple of practice questions about these different types of SCDs, so that we can make sure that you get every question correct in the exam about these. But before we do that, I would like you to know about this website called certiace.com that I have created with few friends that offers free custom-made practice questions to certification exams like DP-700, DP-600 and also DP-900 is coming very soon. Here you can practice to those exams and use these custom-made practice questions to test your knowledge. But now let's have those two practice questions. Let's have our first question. A data engineering team needs to update the product dimension in Mux Fabric warehouse. When a product's price changes, the business requires that The current price must be updated, the previous price must be stored, no full historical tracking beyond the last price is needed. Which slowly changing dimension type best matches this requirement? A. SCD type 0, B. SCD type 1, C. SCD type 2, D. SCD type 3. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, SCD type 3, since it fulfills these requirements the best. Type 0 and 1 don't store history, so they won't work. Type 2 would technically work, but since the requirements say that no full historical tracking beyond the last price is needed, the Type 3 is a better option than Type 2 that tracks the full history. Let's have another question. A company is building a customer dimension in Microsoft Fabric Warehouse. When a customer moves to a new city, the business needs to preserve the old addresses for historical reporting, create a new version of the customer record, track which version was valid at the time. Which slowly changing dimension type should they implement? A. SCD type 0, B. SCD type 1, C. SCD type 2, D. SCD type 3. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, type 2, since it is the only one that is able to fulfill these requirements to preserve the old addresses for historical reporting. Type 3 won't work since we are not specifying that we want only the latest addresses to be stored, and we have to assume that we need the entire history. This is the episode 15 in this DP-700 exam prep series, and in this episode we will cover Eventhouse. That is the last data store that we have not yet covered properly. We have already written data to this data store when we covered event streams, but now we are going to dive way deeper into it. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials of Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Eventhouse is a data store that is optimized for real-time data and analytics. It is designed to handle large volumes of fast-moving data, like telemetry, clickstreams, and IoT events. Eventhouse is actually a logical grouping of KQL databases, so you can think of Eventhouse as a container or a folder of KQL databases, and each one of these KQL databases inside Eventhouse is optimized for fast event ingestion and high-speed analytics. This makes Eventhouse ideal for scenarios where you need to quickly collect and analyze streaming data. The primary way to query Eventhouse data is by using Custom Query Language or KQL. However, you can also use TSQL for some basic exploration tasks if needed, since typically people are more familiar with SQL than KQL. But to get most out of this data store, you really need to learn KQL, since everything is not supported using TSQL syntax. Another important feature is OneLake availability. Eventhouse can be made available in OneLake, which means it can be accessed across the Fabric services like warehouses, lakehouses, and Power BI without using the KQL database engine in between. But we are going to come back to this feature in following slides, since this is an important feature in Eventhouse. Finally, Eventhouse supports flexible data ingestion from many different sources. You can ingest data from local files, OneLake storage, real-time event streams, Azure Blob Storage, Amazon S3, and also use Fabric data pipelines or data flows. So overall, Eventhouse gives you a very flexible, high-speed platform for working with real-time data inside Microsoft Fabric. Next, let's talk about the strengths and weaknesses of this data store to better understand what is it good for and when you should consider another data store. Let's start with strengths. Eventhouse is optimized for real-time streaming and telemetry data ingestion. It is built to handle very high volumes of fast-moving data like logs, events, and sensor readings. It is designed for low latency analytics. This means that you can run queries and get fast results even when the data is constantly arriving. So if you have a case that needs some near real-time capabilities, then Eventhouse could be a great option for it. Also, Eventhouse is ideal for semi-structured or event-based data. For example, if you're working with JSON logs or IoT data, Eventhouse is a great choice. So data coming into Eventhouse doesn't have to be structured as in the warehouse, for example. Eventhouse is also highly scalable. It can handle millions of events per second without slowing down. Of course, this also requires a lot of fabric capacity, but still it is doable with Eventhouse. Finally, Eventhouse supports real-time dashboards, anomaly detection, and operational monitoring. This makes it a strong platform for real-time decision-making and alerting if you are facing those kinds of challenges in your business or projects. Now let's talk about the weaknesses of Eventhouse. Eventhouse is not designed for traditional relational modeling. It is not optimized for classic star or snowflake schema models like, for example, warehouse that we covered in the previous episodes. Also, transaction support is limited compared to the relational engines like SQL databases. You will not get a strong ACID guarantees like you would do in a relational database. And this is not the data store for that kind of use. Short data retention is typical. Eventhouse is usually used for short-term, real-time analytics. It is not the best place to store multi-year historical archives. Soon we are going to talk about data retentions that are typically used with Eventhouses and KQL databases, since in many cases we don't want to store years and years of telemetry data, for example. Also, with Eventhouse there is a limited support for complex multi-table joins. You can still join tables, but it is not as powerful or flexible as in relational database. And finally, like I already mentioned, to really unlock the power of Eventhouse, you need to master Custo Query Language or KQL. It is different from SQL, so there may be a learning curve for new users, even though it's not super difficult language to learn, especially if you already know SQL, since there is a lot of similarities and same type of logic applies to it. Let's now go through the key objects and concepts you will need to know inside Eventhouses and KQL databases. First, we have query sets. A query set in Fabric is an item that organizes multiple saved KQL queries. It is quite similar to a notebook as an object. And when you create an Eventhouse, it automatically creates a KQL database and one query set to that database that you can then use to query data. Next, we have tables. Tables are the core storage units where the event data is ingested and queried. If you have worked with basically any database before, you should be very familiar with tables. The main difference here compared to traditional database tables is that KQL database tables are a bit more flexible with the data types and support some semi-structured data types as well, so your data doesn't need to be entirely flat. Then there are materialized views. These are pre-computed query results that can boost performance, especially when you're building dashboards and reports. We are going to discuss these in more detail shortly and also do a demo about them in the demo section of this video, since materialized views are an important part of DP-700. We also have functions. Functions are saved reusable pieces of KQL logic that can help you simplify complex queries. We will come back to functions in the demo section as well. Eventhouse and KQL database also support shortcuts. Shortcuts we have covered detail in the episode about Lakehouse, but basically they allow you to query data stored in one lake or in external data stores without duplicating that data to Eventhouse. These shortcuts could be a great, for example, to some type of reference data that is needed with your event-based data. For example, a reference table about IoT devices that provides more information about those devices that are sending readings to Eventhouse. Next, let's talk about policies and start with retention policies. Retention policies control how long data is kept before it is automatically deleted, help managing storage costs, and keep Eventhouse focused on fresh data. Then we have caching policies that allow you to cache new data so that you can access it faster. However, this important query performance comes at the cost and it will increase the storage costs. So you should be mindful about how much data you really need to cache. Also, you can't have a caching policy that extends over the retention period, since that wouldn't make any sense. Finally, we have one-lake availability. When enabled, one-lake availability makes Eventhouse data accessible across Fabric services by exposing it as open Delta Parquet format. We're going to have a separate slide about this shortly. But here are the main building blocks you need to understand when working with Eventhouses inside Microsoft Fabric. Of course, there are other concepts and objects as well, but these are the main ones you should know in the DP-700 exam and also in general. Now let's talk about materialized views inside Eventhouse. A materialized view is a way to store pre-computed query results as managed tables. This means that instead of running a heavy query every time, the system keeps the results ready for you. Here on the side we can see an example statement for creating a materialized view. We are going to break down the syntax shortly. Materialized views are great for improving performance, especially for dashboards and often run queries. They are ideal when you want to do aggregation, filtering, or light transformations on streaming data without overloading your database. There are two important properties to remember when creating a materialized view that are also being used in the example query. First, we have the backfill option that can be used to control do we want to have historical data in our materialized view, or do we want to just include the data that has arrived after we have made that view. Then we can use effective datetime property to determine how far back we want to backfill our view. Now let's break down the syntax a bit since we are going to have this example in the demo section shortly. If we start from the top, we say .create async materialized view, and that is the create sentence for creating these views and similar to create sentence in SQL. Defining that async there is optional, but it ensures that materialized view is created immediately even though the historical backfill would be still running and not done. So for example, if you have very large dataset, most of that dataset probably is not yet processed when you can already start to use the view. And if you would have a ton of historical data, the view creation could actually even time out if you are not using the async option. Next we have those properties/options that we can specify for the view. Here I'm just using 3 properties, but there are a lot more that are out of the scope for this video. Those 2 we already covered, so we want to have a historical backfill for this view and starting from 1st of December 2024. Then that doc string can be used to add some documentation what this materialized view is about. Next we have to specify a name for our view, and then we have to tell based on which table this materialized view is created on. And lastly, we specify the query that is being used to create the view. We are going to come back to this example very shortly in the demo section and actually use this exactly same query as part of the demo. Overall, materialized views are a powerful tool in your arsenal when you need fast real-time analytics based on fresh event data. Now let's talk about OneLake availability inside Eventhouse. By default, when you ingest data into Eventhouse, it is stored in a format that is optimized for very fast KQL querying. However, this default storage is not automatically accessible by other Fabric engines like Warehouse or Spark. And if you would like to query the data in an Eventhouse or a KQL database using, for example, a data pipeline or a notebook, it would have to use the KQL database engine for accessing the data, since it is not in a very native format, for example, for Spark to read. OneLake availability solves this problem. When you enable it, Eventhouse data is stored in OneLake as a Delta tables, which is an open and standardized format and very widely used in Fabric. You can enable OneLake availability either at the database level or at the individual table level. This gives you flexibility depending on your needs. Once enabled, your Eventhouse data becomes available across Fabric. You can query it using Power BI, Warehouse, Lakehouse, notebooks, and more, all without making copies or doing manual exports, since that replication is handled by Fabric on the background. The data retention policy that you defined inside Eventhouse is also applied to the Delta Lake file stored in OneLake. So if your table is set to automatically delete old data, the same rule is enforced in OneLake storage too. There are some important limitations you should be aware of. When OneLake availability is turned on, you cannot rename tables, alter schemas, apply row-level security, or delete, truncate, or purge data. If you'd like to do some of those operations, you would first have to disable the OneLake availability and then do them and then re-enable it. Overall, enabling OneLake availability makes Eventhouse much more powerful by opening your real-time data to the full Fabric ecosystem in a better and more native format. Next, let's go to Fabric and do a demo/tutorial about these topics that we just covered here. Now we are in Fabric and I have my DP-700 tutorial workspace open. And as we can see, we already have one Eventhouse in this workspace that I created in the beginning of this series when we covered the introduction to the all things we are covering in this series about Fabric. And in that Eventhouse, we can see that we already have one KQL database there and also one query set. And those objects are created automatically when we create an Eventhouse. But yeah, let's open up this Eventhouse and let's check a few topics here about it. And here we can see the Eventhouse view here. And like I explained in that first section, Eventhouse is basically a container for KQL databases. So it acts as a folder or container, so Eventhouse itself doesn't really do that much things. So basically here we can just monitor and get this monitor view what's happening in those KQL databases that we have in our Eventhouse. And from this Eventhouse level, we can actually create more databases to this Eventhouse by clicking this plus database icon here. Then we also can monitor our databases that we have here. And here we can see that not much have been happening in this database that we have here since the last ingestion has happened in February, where we covered the real-time analytics and actually ingested some data to this KQL database here. And here also we can control the minimum consumption of our Eventhouse. This gives us some control over how much capacity our Eventhouse is actually consuming, but we are not going to change these here right now. So let's close that. Then we also have some Python plugins that can be used with the Eventhouse. And then we can also toggle and untoggle this Eventhouse details here. And here we can get, for example, the query URI or the ingestion URI for this Eventhouse if we would like to use those. But yeah, we are not going to utilize those in this demo. And here we also get some basic information about the Eventhouse, like the region it is located and do we have those Python plugins installed or no. And now let's go to that KQL database and talk more about that. Let's open the only KQL database we have in this Eventhouse, and we can see that we have here already a bunch of tables that we have been adding here when we have been doing tutorials here in Fabric, like the introduction and also those ones where we wrote data here using event streams. And like said, event streams is only one possibility how you can get data to the KQL database. And here we have a bunch of different options. So for example, we can get some sample files from Microsoft or upload local files or get some data from our OneLake and then use that event stream option, or from Azure Blob Storage, Event Hub, Amazon S3, using a data pipeline, Dataflow, or real-time hub. So there are plenty of options how you can ingest the data into the Eventhouse. And then we have these possibilities to query our Eventhouse. We can use these KQL query sets, or we can use, for example, a notebook, or we can attach a real-time dashboard to this KQL database and use the Eventhouse that way. And next we have those data policies here that we already covered in the theory section, but here we can apply them. So we can set that retention period after which the data in our KQL database is actually deleted. Then we have this caching policy here, and basically we can use this to determine the time our data is in the hot cache, meaning that it is more readily available and stored in this very fast SSD. But this means that storing our data costs more. So even though it is faster, it is more costly. So you can specify here, for example, that you want to only have 5 days of data in that hot cache, and after that the data will be moved to that cold cache so that the querying it is slower but it costs less to store it. Let's close this, and then we have the OneLake availability. Basically, this is the OneLake availability that allows us to set this OneLake availability on the database level. We can also configure this on the individual table level if we want. I'm not going to turn this on now on the database level, and we are actually going to turn it on table level shortly and see how that will behave. Next, let's talk about these different objects that we have in this database. First, we have the tables here, and of course, if you have been working with any database before, you basically know that in databases, data is stored to tables. Next, we have shortcuts here that we can use to bring in some external data or data from our OneLake to this Eventhouse without actually copying it here. And here we can create a new shortcut if we want, and we can choose, for example, our OneLake to be our source for that shortcut, or then we have some of these external sources like S3 buckets, Azure Blob Storages, Dataverse, or Google Cloud Storage. This would allow us to bring in some data to this Eventhouse. For example, we could have a reference table about our IoT devices that are sending data to this Eventhouse, and then use that reference data to enrich our data that is coming in from those IoT devices. But now we are not going to create any shortcuts to this Eventhouse. And next we have the materialized views that we are going to come back shortly, and also functions that we are going to cover shortly as well. But now let's try out that OneLake availability, and let's turn it on for this temperature data here. And here we can actually turn it on this table level, and let's click on, and now this data will be made available in OneLake. And now if we would go back to our workspace and we would, for example, open up our Lakehouse and we would try to create a shortcut here, we should be able to shortcut that data. And we can create a shortcut to, for example, to this DBO schema, and let's create a new table shortcut. Let's choose Microsoft OneLake, and then we are going to select our SQL database and then click next. And here we can see that the only table that is available here is that one that we had now at OneLake available. So we can only shortcut now the tables that we have made OneLake available. And since I have only made that table, it is the only one that we can use here. And also now when we have made that table OneLake available, we could actually use it in a notebook in a very similar way we use Lakehouse tables. We just have to define the path to that table in OneLake, and then we can query it like we would query any other Delta table. Otherwise, if we would query these tables in the SQL database using notebooks, we would have to use the SQL endpoint and use the SQL engine to access those tables. But when we make them OneLake available, we can skip that SQL engine in between and query that in a more native way for Spark. Next, let's do a demo/tutorial together about materialized views and functions. And remember, if you would like to get this material and the code that I will be using in this demo, it can be found by clicking the link in the description. That will take you to the Google Drive where I have all the materials for this course. But yeah, I have this query set here, and in this query set I have two SQL queries. The one is empty, and in the other one we have the demo. So let's start with the demo. So we are going to create this table about the website visits. So we are going to have a visit ID, then we are going to have a visit timestamp, and then we're going to have the page that was visited. And now let's create this page and let's run this. And now the table has been created, and then we want to ingest some data to that table. And I'm using this SQL inline syntax to ingest some rows to that table. So we have few rows of data going to that table, and let's run that. And now let's query that table and let's see that we have those rows here. And now we can see that we have those website visits in that table. And next we are going to create a materialized view on top of that data. So first we are going to create a materialized view without backfill. So if you remember from the theory section, we would actually have to provide this backfill true if we want to backfill our materialized view. But in this first example, we are not going to do that, and we are just going to specify the document string for this and tell that this is daily website visits without backfill. And then we have this SQL query that will then define that. And we are going to name this materialized view as episode 15 MV daily visits no backfill. And this SQL query here actually groups by those website visits per day. So basically here we are creating a new column called visit day, and then we are going to use that visit day there to summarize the visit counts for that day. So we know how many website visits there were in total per day. So let's run this materialized view and let's create that. And now that has been created, and then we can query that. And as you can see, we don't have any data in that materialized view, and that is because we didn't specify any backfill for it. For now, if we would ingest in some new data, that will actually show up in the materialized view, but automatically we do not backfill that view with that old data that we already had there. And here we have the code that will actually backfill that materialized view with some old data. So here we are specifying that we have backfill true, and then as an example, I'm also specifying this effective date time property here. And with this, we can control how much history we want to that materialized view. So if we don't want entire historical data sets about that specific data that we are going to use for the materialized view, we can limit that using this effective date time here. So that we say that, for example, we want to backfill only last 3 months or so. But yeah, let's create that, and the query here is exactly the same that we had in the first case. So let's run this, and then let's query that materialized view, and let's see, do we have data? And now we actually have some data in our materialized view since we backfilled that, and we can see that we had there 2 visits on the first day, and then on the second day we only had 1, and then on the third day we had 2. And then as an extra command here, I'll just show all the materialized views that I have in this database, and here we can find some information about them and also see that document string there that tells more information about those materialized views. So it is good practice to always specify that doc string to let people know what your materialized view is all about. Next, let's ingest some new data into our table. So let's run this and let's ingest 2 new rows. And now let's query our original table again, and we can see that now we have more rows since we ingested a couple of more rows to that table. And then let's query our first materialized view that has not been backfilled. So we should only have data about these 2 rows that we have here. So let's run that, and we can see that for the 4th day we have those 2 visit counts, and that's correct. Then let's check our other view that was backfilled, and we should have the old data and also this new data there. So let's run this query, and we can see that we have the old data there and also that new data that we just added there. And this demonstrates you how the backfill functionality works, since this is an important topic in the DP-700 exam. So remember this. And next, let's do a quick demo about functions. And here I'm specifying this function get daily visits per page, and then we have 1 parameter page name going to that function. And we are going to use that page name to filter our website visits per page, and then we are going to use the same logic we had in those materialized views and get views grouped by for that date. But now we are filtering that result per page. So before we do those summarizations, we are actually filtering the data for that specific page. But yeah, let's define that function here. And now we have defined that function, and we should also see the function here, and we can also see the materialized views here as well. And now we can use that function, and we can call that get daily visits per page, for example, to the home page. And we can run this query and order it by the visit day. So let's run this and let's see what is the result. And here we can see how many visits we had to the home page per day. And then we can run this function again for the blog page and see the similar result here, but now for the blog page. And we can see that we have only had 1 visit to the blog page, and that should be correct if we query our original data here. And we only have 1 visit to the blog page, and that was on the 3rd day. Next, let's have a couple of questions related to topics that we covered in this episode. But before we do that, I would like to tell you about this website called certiace.com that I have created with few friends that offers free custom-made practice questions to Microsoft certification exams like DP-700 and DP-600. And here, if we open up the DP-700, we can find questions per module here. So if we, for example, open the first module here, we start to get these example questions that we can use to practice to the DP-700 exam. And always when we answer to these questions, we get the explanation for the correct answer, and then we also get the related learning material that we can use also to check why the specific answer was correct. So after watching this video, go check out certiace.com. But now let's have those practice questions. Let's have our first question. Which of the following statements about backfill and async behavior in materialized views is true? A. Without async, creating a materialized view can fail or time out if backfilling a very large historical dataset. B. If backfill equals true, the materialized view can only include data ingested after the view creation time. C. When async is used, user must manually trigger the backfill process after view creation. D. Setting backfill equals false automatically applies a 7-day lookback window by default. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is A. Since when not specifying async when creating materialized views, long backfills can cause creation to fail or time out because the system waits for full backfill to complete. B is incorrect since backfill equals true means that old historical data is included, not just the new data. C is incorrect since backfill starts automatically when async is used. No manual action is needed. D is incorrect since backfill equals false disables backfilling completely and no automatic lookback is applied. Let's have another question. Which of the following statements about enabling one-leg availability for an Eventhouse or SQL database is true? A. After enabling one-leg availability, you can freely rename or truncate tables in the database and then that is reflected in the one-leg. B. One-leg availability allows data to be stored both in the Eventhouse internal storage and in one-leg as Delta Parquet format. C. One-leg availability is enabled by default for all new Eventhouse databases. D. When one-leg availability is enabled, only newly ingested data is stored in one-leg and historical data export has to be triggered manually if needed. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B, since this is the behavior of one-leg availability feature. A is incorrect since you cannot do those operations once one-leg availability is enabled, and you would have to turn it off if you want to do them. C is incorrect since one-leg availability is not enabled by default. D is incorrect since historical data is automatically also exported to one-leg. This is the episode 16 in the DP-700 exam prep series, and in this episode we will cover mirroring. That allows you to bring in data from various different sources to Fabric without building complex data pipelines, and have that data in near real time in Delta Parquet format available to Fabric to use. In my opinion, this is one of the coolest features we have in Fabric, and I'm really excited to cover it in this episode. Like in every episode in this series, we will start with a theory section followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Let's start with what mirroring means in Microsoft Fabric. Mirroring is a feature that brings data into Fabric in a fast and simple way. It copies data from different sources like different types of databases, Azure Databricks, or even from some custom application directly into one-leg, which is the central data store used in Fabric. You don't need to build any complex data pipelines. After you set it up, the data stays automatically synchronized. That means that your reports and analytics are always working with fresh data. The mirrored data is saved in a Delta Parquet format that we have already talked about multiple times during this series, but basically it is this open source, highly scalable and optimized data format that Fabric uses as default data format for storing data. And after the mirrored data is in a Delta Parquet format, it can be very easily accessed with different tools in Fabric like Power BI, notebooks, data pipelines, and data flows, etc. So, in the big picture, mirroring is quite simple to understand, but now things get a bit more complex since not all mirroring works in the same way, and on high level we have 3 different types of mirroring. Let's go a brief overview of each one of them before we dive deeper into them on following slides. First, we have database mirroring that replicates databases and tables in those tables directly to Delta Parquet format. There are already quite a few databases that are supported with database mirroring to Fabric. Then we have metadata mirroring that is being used with Azure Databricks Unity Catalog. This type of mirroring only syncs metadata to Fabric and then uses shortcuts on the background for the data access. Then lastly, we have open mirroring. That enables basically any application to mirror data to Fabric using database mirroring, but this typically requires you to write some code or to use some custom application that handles the logic you need for mirroring that data using CDC or change data capture that we are going to talk more about shortly. Also, Fabric does some mirroring internally as well. For example, when you create and use Fabric SQL Database, Fabric will automatically create a mirrored Delta table version of that database for you to use. To summarize this introduction, mirroring provides a streamlined, low-latency solution for replicating data from various sources into Fabric's OneLake. Now let's dive a bit deeper into these different mirroring types, and let's start with database mirroring. This mirroring type creates full copies of the table in the source database to Fabric's OneLake. Also, it is good to highlight that regardless of the source, the data is written to Delta Parquet format, so that is easily accessible using Fabric's tools. After this mirroring is up and running, it will keep the data in OneLake fresh using near real-time syncing. This means that it eliminates the need to build data pipelines that would fetch data from the source, since mirroring handles this automatically. Also, it is good to note that database mirroring is read-only, and you can't update the source tables from Fabric using those mirrored tables. But all the changes that happen in the source database and tables are automatically reflected in the mirrored database in Fabric. For example, if you would add new columns or rows or update the data in the source, it would be automatically done to the mirror as well. Also, you can choose to add new tables automatically to the mirrored database as well if you so desire. And mirroring will also handle deleting data and tables from the mirrored database if such operations are done to the source database. So, to summarize, when we mirror a database, we mirror tables in that database, meaning rows and columns in those tables. And then we also mirror schema of the database, like table structure and data types, etc. And of course, some basic metadata like table names are mirrored as well. Cool, now you would have a mirrored database up and running in Fabric, and now you could be wondering what you could do with it. Well, the answer is quite simple, since you can use it like any other data in Fabric. You can, for example, query the data using the automatically provisioned SQL Analytics endpoint, like you can do with Lakehouse. You can use the data in the mirrored database on your Power BI reports or read it with many other Fabric tools like data pipelines, notebooks, and data flows. And since data in the mirror is in a Delta Parquet format, it can be used to build shortcuts to other data stores in Fabric, for example to a Lakehouse. So there are a lot of possibilities that you can do with this data, since it is in this very usable Delta Parquet format and stored in OneLake. At the time of recording this video, database mirroring is currently supported for 5 different external databases: Azure Cosmos DB, Azure SQL DB, Snowflake, Azure SQL Managed Instance, Azure SQL Database for Postgre Flexible Server. Many of these are still in preview and there could be some limitations with them, so please check the current status with the database you are interested in mirroring to Fabric. In the demo section of this video, we are going to mirror Azure SQL Database to Fabric and use it as an example of database mirroring. Next, let's cover our second mirroring type, metadata mirroring. That is at the time of recording this video only available for Azure Databricks Unity Catalog. Like the name implies, this mirroring type only mirrors the metadata of Databricks Unity Catalog and doesn't copy physical data to Fabric OneLake. The reason why this mirroring can be done this way is that Databricks uses the same Delta Parquet as its default data format and stores that data to Azure Data Lake/Azure Blob Storage. So the physical data is already in the same format as Fabric likes it to be and in an easily accessible location for Fabric to read it. So this metadata mirroring actually uses Fabric's shortcut feature in the background. If you're not familiar with shortcuts, I recommend you to watch the episode about Lakehouse, where I covered them more in depth. You could be doing these shortcuts by yourself, but this mirroring makes it more convenient, since it pairs those shortcuts with the data store metadata and handles managing and creating them. So this method mirrors only the source data store's metadata, which means the table structure, data types, etc. Even though this data is just shown in Fabric using shortcuts, you can still use it in the same way you could be using data mirrored using database mirroring, since the underlying data format is the same Delta Parquet. Then we have open mirroring. That allows you to mirror data from basically any source system or data store you desire, but it is not always that straightforward process to set up. Open mirroring is based on the idea that you can provide this change data capture or CDC from your source system or data store. This means that you can provide a data feed that tells the actions that are happening in the source system. Then the source needs to write this CDC in CSV or Parquet format to this landing zone in OneLake. So in those CDC files that are landing to the landing zone, you can indicate using specific rules the changes that have been happening in the source system. So without sending all the data that there is, you just send the information what has been changed and what type of operation that was. So only when setting up the mirroring all the data has to be copied, and after that only the changes to that data are being transferred so the data movement is as minimal as possible. After you have managed to land the CDC feed aka CSV or Parquet files to the landing zone, Fabric will handle the rest and create delta tables to the mirror database based on your CDC feed. And then those tables will act in similar fashion than in database mirroring that we covered previously. So basically we just have to find a way to set up that CDC, since it is not provided out of the box like it is with those native database mirroring sources. This open mirroring is a very convenient way to set up mirroring from any source you want, but of course you need to build that CDC logic on top of that system somehow. Luckily, there are many third-party vendors that are offering these CDC solutions for many commonly used systems and data stores like Oracle and SAP. And I would expect this offering to grow a lot in the near future. For example, for SAP, there are already multiple vendors who are offering CDC solutions on top of SAP systems so that data from those can be mirrored easily to Fabric. In the demo section, I will explain a bit more about open mirroring, so don't worry if you didn't entirely understand what this is all about and how that CDC works. And speaking of the demo, this was the last slide in the theory section, and next let's go to Fabric and let's do some demos there. Now we're in Fabric and I have my DP-700 tutorial workspace open here. First, we start by covering the database mirroring. And if we go here and click these three dots and hit the Create button, we can see that under the Data Warehouse section, we have quite a many different mirrored options available here in Fabric. We have the Azure SQL database that we are going to create shortly. Then we have the Cosmos DB, Snowflake, and then the Postgre, and then the managed instance. So those are the database sources that are supported out of the box. Then we have that mirrored Azure Databricks catalog, that is this metadata mirroring that we are also going to cover in the demo section. Then we have this general mirror database, and this is the open mirroring that we are also going to talk about at the end of the demo. But yeah, let's start with this mirrored Azure SQL database here, and let's create that. And this time I'm actually going to mirror this Azure SQL database that I have been created to this resource group that I have in Azure. So basically we are going to mirror this database here. And there are actually few things you need to consider before mirroring your own SQL database. And I will show them to you. First, you need to open up the SQL server and then go to this Identity tab, and then you have to check that you have enabled the System Assigned Managed Identity for your Azure SQL server. So basically, this status should be on. And then the next thing, you need to make sure that you have the appropriate access rights to that database if you are going to use your own account for the connection. And one of the most easiest way is to go to the SQL server and check out this Microsoft Entra ID tab here and make sure that you are Microsoft Entra ID admin for that SQL server. And as you can see, I am the admin for that server, so that I have the full access to that database and to that server. Then you also need to go to the database and also check that you have the appropriate tier for mirroring available. So if you go to the compute and storage, you have to check that you are using one of the tiers that is supported for mirroring. For example, you have to use one of the vCore tiers, or you can use also the DTU-based model, but then you have to have at least 100 DTUs allocated to your database in order it to support mirroring. But once those are in place, you could start mirroring your database to Fabric. And now let's go back to Fabric, and then we want to configure this Azure SQL database mirror. So let's click that. And then we have to provide the connection string for this server. So we need basically the server connection string. So let's go back to the server, and here is the overview. And here we can get the server name / the connection string, and we can paste it here. And then we need to say the database. So if we go back to the databases, here is the database. And basically our database name is the database that we are looking for here. And here I have the connection, and I have already created this connection, so I don't need to create a new connection. But for the demo purposes, let's create a new one. And we don't need the gateway for that. And then we are going to use the organizational account, and I'm going to use my account. And we are going to use the encrypted connection, and then we can click connect. And now it is start to connect to this data source, but we don't actually have any data in this database. So let's open up the SQL Server Management Studio and let's run some SQL scripts so that we can create some data to that database. And here we have the SQL Server Management Studio, and with this I'm first going to create a schema, then we are going to create a customer table, and then we are going to create a product table, and then we are going to create a sales table, and then we are actually going to create views on top of those tables so that we can demonstrate what happens with views when we mirror data, and then we are going to insert some data to those tables. So these things I want to run first. So let's execute these. And now they are done, so we should have some tables in our database. Yep, we have, and we should also have some views in our database. And next we can go to Fabric and check out, can we see any tables when we are creating this mirror? But we shouldn't see those views because views are not supported for mirroring. And why is that case? Because basically views are these kind of a stored SQL queries. So they don't physically contain any data. So that's why views are not supported for mirroring. And here we can see that we have those tables now here in available that we just created there. Then we also have this option here that we can choose automatically mirror future tables, so that if we create any new tables to this database, they are automatically mirrored as well. But yeah, we are now going to mirror all those 3 tables that we have here. So let's click connect. And then we have to provide a name for that mirror database item in Fabric. We can go with the default name and create that mirror database by hitting that create mirror database button. And now it will start that mirroring process. This should finish quite fast since we only have few rows of data in those tables and we don't have like a ton of data that needs to be replicated to Fabric when we do this initial mirroring. And now mirroring is already running for those 3 tables that we have in the database, and it should be done very soon. And while this is running, we can go back to our workspace and we can see that we have this new item in our workspace. But we can also see that we have this semantic model and also SQL Analytics endpoint that are created by default when we mirror stuff to Fabric. And you can see that these items are exactly the same that we have, for example, with Lakehouse. So when we create a Lakehouse, we get this semantic model and SQL Analytics endpoint, and we get those same items when we create a mirrored item to this Fabric workspace, because basically the technology under the hood is quite the same than with Lakehouse. And these items are needed if you want to interact with data. The semantic model is needed if you want to get that data to your Power BI report, and this analytics endpoint is needed if you want to query that data. Now let's go back and check, is our mirroring already done? It is still running, but I think it should be done very soon. And now we can see that our initial sync is done. So now we have copied all the data from the database to Fabric, and now we can start to track changes in our database. So we don't need to replicate all the data from the database to Fabric again, we just track changes that are happening in our database. So now we can, for example, open up the SQL Analytics endpoint and start to query the data that we have here. And here we can, for example, query the product data that we have here by selecting a new query and selecting top 100 rows from that table. And we should be able to get that data to Fabric. And here we have that data that we have mirrored to Fabric from that Azure SQL database. And we can see that mirroring actually creates this one extra column to the data. But now let's do some changes to our data. And here we have few changes that I'm actually going to do to the data. So we are going to add a new customer, add a new sales, and update customer email, and then delete one sale. So let's run these and let's see what happens in the Fabric side when we run these. These things should be quite soon available in Fabric when we have done these changes to the source database. In Fabric, we want to check that we have a new row in our customer table, and then we want to check that we have a new sale in our sales table with the ID of 1005, and then we want to see that we have updated the Alice Johnson email to this new domain on customer table, and then we have deleted this 1004 sale from the sales table. So let's query those tables and let's see, do we already have them here? First we have the product data here, but to this data we didn't do any changes. Then we have the sales data, and we can see that we have that sales ID 1005 and that 1004 is gone. So this change has come through the Fabric. And then we have the customer data here, and we can see that we have that new customer there, and then we have also updated Alice Johnson's customer email there. So that data change also came through the Fabric fine. Next, let's create a new table to our database. So I'm creating this support ticket table and adding few rows of data to that table. So let's create that and let's see that this table is added to Fabric automatically. And we don't have that table here yet. This can actually take a little while when we get that new table here because it has to do that initial sync. That will take some time, but we should have that table here shortly. But yeah, let's refresh this and let's see when it will be available here. And also we can double check here that we have added this automatically mirror future tables selection on so that we get tables automatically added to this mirror when they are available. And now we can already see that support ticket there, and it should sync the data soon here. But I don't think we are going to wait that, since it will just sync the table here and then we are able to query that data than we would with any other data. So let's save some time and let's start to talk about metadata mirroring. So basically, like I described, we can only metadata mirror Databricks Unity Catalog data to Microsoft Fabric. We can hit this create button here and create a new mirrored Azure Databricks catalog, and let's choose that. And here I have to specify a connection to our Azure Databricks, and I will choose this new connection here. And here we have to first input the URL for our Databricks workspace. And we can go to our Databricks workspace, and basically the URL can be found here. So it is basically this URL here until the .net here, and we can select that, and then we can go back to Fabric and input that here. And I have already defined that connection previously, but we can choose to create a new connection here. Also, before you can mirror any data from Azure Databricks Unity Catalog, you need to check few things. First, let's go to this catalog view, and then we can select this settings on this catalog level. And here we can select the Metastore settings, and you have to have this external data access enabled in order to mirror data to Fabric. So make sure that you have enabled that. And then you also need to make sure that you have the appropriate accesses. The easiest way is to go to the catalog you want to mirror and then go to the permissions, and then you want to grant basically all the privileges and make sure that you have this external use schema also. So you can tap all of these and then click grant. And then basically you have all the accesses that you can think of to that specific catalog, and you should be able to do the mirroring using your personal account very easily. And also I have this notebook that I have already used to create some data to this catalog. So in this catalog DP-700 demo, I have this DP-700 episode 16 schema, and in that schema I have the customer table, and then I also have this customer view as well. But this is the same thing that we had with our database source, that we cannot mirror views, so we can only mirror tables. So keep that in mind when setting up these mirroring things. But yeah, let's go to Fabric, and then we want to use that connection that I have defined, and then we are going to use the organizational account, meaning my personal account. We have also service principal here. That would be the proper way when using this in a real world scenario, but for demo purposes I'm going to use my organizational account, and I'm going to log in now. And then we can click next, and next we are going to choose data from the catalog, and I'm going to choose the catalog that I have created there. And from that catalog, I can choose the table that I have here. So basically, I'm going to mirror the DP-700 demo catalog, and under that catalog, I'm going to mirror default schema and also that DP-700 episode 16 schema and that one table in that schema. And here we can already see some metadata about that specific table there. But yeah, let's click next. And then we can provide a name for this Azure Databricks catalog mirrored item in our Fabrics workspace. So here is the name for that, and then we click create, and this will create that mirrored Azure Databricks catalog to our workspace. And now that mirroring has started, and it is actually saying that it is creating shortcuts to that data. Because like I explained in the demo section, this mirroring type actually uses shortcuts in the background, so it is not physically copying any data to Fabric's OneLake, but it's just establishing shortcuts and using some metadata from the Unity catalog to show those shortcuts in a better way here in Fabric UI. And now this mirroring is done, and we can see this customer table here. And actually, if we look closely, we can see that tiny shortcut icon on top of it. And by clicking the table, we can preview the data, and we can see the data that I have added there using that Databricks notebook. But like I said, you cannot mirror views, so we cannot see that customer view here. And if we go back to the workspace level, we can also see that for this mirrored Azure Databricks catalog, we have also that default semantic model and SQL Analytics endpoint created by default. And we can use those to interact with the data, basically just read it, because this is also a read-only mirroring method. Next, let's talk about the open mirroring a bit. So let's go again and hit that create button, and then let's scroll down a bit and let's select this mirror database. And let's click that. And let's provide a name for our mirror database, and let's click create. And this will start to create this open mirror database here that we can use to mirror any kinds of systems that we want. But for that, we would need to build that CDC process that I described to you in the demo section. And I'm actually going to talk about that CDC process a bit shortly. And now we have this mirror database here that is ready for open mirroring. And here we could actually upload files manually to that landing zone that I described in the theory section that would then process that data into Delta tables and show that mirror data in Fabric. So basically here we have some documentation about this kind of an open mirroring landing zone. So here we have some description that we have this landing zone to which we can then upload or send data in CSV or Parquet formats. And this data has to be in a specific format described in this documentation. And then we have to indicate in that data, did we have an insert operation, update operation, or delete operation, or upsert operation. So with those flags, we can just send those changes to the Fabric and then determine how to change that mirrored version of the database or source system that we have in Fabric. And here we have some description of this. So basically we need to have that row marker column in our data, and with that row marker we can indicate the type of operation that we had there. And these different numbers here in the row marker are actually the same numbers that we just checked there. So basically with these numbers we just describe to Fabric that what kind of changes we had in our source system. So basically if you want to build your own logic, you could for example mirror data from your own computer to Fabric, but you just need to build the logic that handles that CDC process and provides that CDC feed in the format that Fabric is expecting. So if you can handle that, then you can have your own mirroring up and running. I have already seen how people have built their own CDC processes and, for example, mirrored Excel files to Fabric using this method. So this is very flexible and very nice method to do your own mirroring projects to Fabric if you so desire. But we are not going to dive that much deeper into this open mirroring today. But leave some comments to the comment section down below if you'd like to see me build an open mirroring project and create a video about it. Next, let's have some questions about mirroring in Microsoft Fabric. But before we do that, I would like to tell you about this website called certiace.com that I have created with few friends that offers free custom-made practice questions to Microsoft certification exams. Here you can find questions to DP-700 and DP-600. And if we open the DP-700, we can find that we have all the modules here that are in the learning material. And for example, if we select this second module here, we start to get these practice questions. And always with these questions, we get the explanation for the correct answer. And then we also get a link to the related learning material where you can read more about that specific question. But now let's have those practice questions. Let's just have one question today. You are configuring database mirroring in Microsoft Fabric. Which of the following statements is true? A. Database mirroring enables you to update data directly in the source system through Fabric. B. Database mirroring only mirrors the metadata and the physical data is accessed using shortcuts. C. Database mirroring replicates schema and data to Fabric where it becomes readable but not editable. D. Changes made in Fabric are automatically written back to the source database. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, since this is the behavior of database mirroring, since it mirrors the schema and data to Fabric where it can be read but not edited. A is incorrect since mirror database doesn't allow you to update data in the source. B is incorrect since this description is for metadata mirroring and not for database mirroring. D is incorrect since mirroring is read-only and doesn't write data back to the source database. This is the episode 17 in this DP-700 exam prep series, and in this episode we will do a deep dive into Fabric's access control and cover it from all the way from the tenant level to the item level. Then in the next episode we are going to dive even deeper and cover object, row and column level access. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials from Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Before we do a deep dive to access control, let us quickly recap the core structure of Microsoft Fabric that we already covered in the beginning of this series. You might remember that Fabric sits under a Microsoft Entra tenant. That tenant is like your organization's control center. It handles identity and access control across all Microsoft cloud services, including Fabric. Fabric itself is a cloud data platform that is enabled per tenant. Workspaces are where you build solutions. Every Fabric user gets a personal My Workspace, but you can also create shared workspaces for different teams like finance or supply chain. These workspaces are then linked to a capacity. To run anything in Fabric, you need capacity. Capacity means compute resources. It is what powers all the workspaces and data workloads. Bigger capacities mean more compute, but they also cost more. Capacity is main cost driver in Fabric. To manage governance, workspaces can be grouped into domains. Domains can represent business areas like sales or finance. Inside the domain, you can also create subdomains for more detailed grouping, like separating international and domestic sales. Inside each workspace, you create Fabric items. These include things like Dataflows, notebooks, pipelines, Eventstreams, and Lakehouses. These items are the core building blocks you use to build data solutions. Some items like warehouses or lakehouses allow you to go even deeper and create objects. For example, tables, views, and stored procedures. So this is the full picture. Even though Fabric is one platform per tenant, all of these layers help us manage access and governance inside Fabric. And here on the next slide, we can see the structure of Microsoft Fabric represented in a slightly different way. I have intentionally removed domains and subdomains from this picture to keep it focused and clear, and we will come back to those later in this episode. You can also see that Fabric is just one of the services that organizations typically have. In many environments, services like Microsoft Teams and SharePoint are also part of the setup. All of these services are part of the same Microsoft Entra tenant, which handles identity and access management for the entire organization. In this episode, we are going to focus on how access control works across different levels of Fabric. We will start at the top with the tenant level and then move through the capacity and workspace level, and finally we will reach the item level, where you can create things like lakehouses, warehouses, and notebooks. In the next episode, we will go even deeper and cover more granular access control features on object level. That includes object level permissions, row level security, and column level access. Now let us take a moment to talk about one of the most important access control principles, the principle of least privilege. This principle is very simple to understand, but extremely powerful when applied correctly. It means that we should give users the minimum level of access they need and nothing more. So instead of giving someone broad access just to make things easier, we want to assign the smallest set of permissions that still allows them to do their job. Why this is so important in Microsoft Fabric and basically in any other system or service? First, it reduces the risk of data leaks and accidental changes or misuse of sensitive resources. By keeping access tightly controlled, we lower the chances of mistakes or security problems. Second, it improves manageability. When permissions are clearly defined and limited, it is easier to keep track of who can do what and why. Third, it helps contain damage in cases something goes wrong. For example, if account is compromised. If the account only has access to workspace instead of the entire platform, the impact is much smaller. And finally, it supports auditing and security reviews. It is easier to validate the access when you know that each user only has the permissions they actually need. So as we continue learning about access control in Fabric, we want to keep this principle in mind and apply it whenever we assign roles and permissions. In the DP-700 exam, you might hear the mention about this principle, and then you should be able to narrow down the options to the access that gives least amount of access on top of the access that the user really needs. So if you need to give an access to a lakehouse, just grant that and not an access to the entire workspace. Now let's start our rabbit hole with these different Fabric accesses, and let's do this in a top to bottom manner so that we start all the way from the tenant level and from the highest possible admin role that can be granted, that is the global administrator. Basically, this is the highest level of access that can be granted at the tenant level and gives keys to the kingdom in a sense. A global administrator can manage all aspects of Microsoft Entra ID and also manage all Microsoft Cloud services that rely on Entra identities. So the scope of this admin right far exceeds Microsoft Fabric scope. From the Microsoft Fabric's perspective, the global administrator has full control. They can assign any role within the tenant, including assigning other global administrators. They can also promote themselves into any role in Fabric. Good thing to note here is that this role doesn't get automatic admin access to the workspace level, but can easily grant themselves to have that access if need be. They can enable or disable Microsoft Fabric for entire organization. They can also access tenant-level Fabric settings and view activity through the admin monitoring workspace. Because how powerful this role is, you need to be very careful with who has it. In most cases, you don't want to give global administrator rights to just anybody. This should be limited to only few trusted people in the entire organization. If somebody only needs to manage Fabric and not other services, it is usually better to assign them the Fabric administrator role instead. That role has a much narrower scope and comes with fewer risks. So, to summarize, the global administrator can access and control everything. They sit at the very top of the hierarchy and can override all other roles. This role should be always used with caution. Next, let's talk about Fabric administrator role that is far better option than global administrator role in most cases, since it is scoped only to Fabric. Here I have a table comparing these two admin roles. First, scope. The global administrator has access to the entire Microsoft tenant. This includes all the services like Teams, SharePoint, Exchange, and Microsoft Fabric. In contrast, the Fabric administrator only has access to Microsoft Fabric. They do not have visibility or control over other services. Next, access level. Global administrators have full access to all services. Fabric administrators only have access to Fabric-related settings. Their permissions are limited to the data platform space. Then, access management. A global admin can manage all users, groups, and roles across the tenant. They can even assign or remove global admin rights from others. Fabric admins, on the other hand, can only manage access that is related to Microsoft Fabric. They cannot touch Entra ID or tenant-wide user settings, which means that they can't grant other people with Fabric admin role. Now, Fabric settings. Global admins have the power to enable or disable Microsoft Fabric for the whole tenant. They can also assign or remove Fabric admin roles. Fabric admin can manage Fabric settings only if Fabric is already enabled for the tenant. Next is security settings. This is a big difference. Global admins can configure security features like multi-factor authentication, conditional access, and identity protection policies. Fabric admins cannot access or modify any of those. They are limited to settings inside Microsoft Fabric only. So, from the point of view of the limitations, the global administrator role has no limitations. On the other hand, Fabric admins are restricted to Fabric scope. They cannot touch services, settings, or identities outside of Microsoft Fabric. Finally, the use case. You should use the global administrator role for full tenant level control. This role should be only given to few trusted people in the organization. The Fabric admin role is more appropriate for those who only need to manage Microsoft Fabric without having broader administrative access to the other systems. And as a side note, there is also Power Platform Administrator role. This role gives administrative access to Microsoft Fabric, but also includes other services like Power Apps and Power Automate. So it has a wider scope than a Fabric admin, but still more limited than the global admin. For these admin roles, Microsoft Fabric includes a special workspace called Admin Monitoring Workspace. This workspace gives administrators visibility into what is happening across Fabric, including all workspaces, items, domains, and capacities in use. It provides a series of pre-built reports and dashboards, like this content sharing report, which you can see here. The Admin Monitoring Workspace is automatically available to Fabric and global admins. You do not need to build these reports yourself. They are included and updated by Microsoft. So if you want clear, centralized view what is going on in Fabric, this is your go-to place. Let's now take a look at the Capacity Administrator role in Microsoft Fabric. Unlike a global or Fabric administrator, a Capacity admin can only manage a specific capacity, not the entire tenant. That means that their responsibility is limited to the defined set of compute resources inside Microsoft Fabric. The Capacity admin controls which workspaces are assigned to that capacity. They can divide which teams or solutions get access to the compute power of that capacity unit. They can also configure workload settings such as Spark behavior. This allows fine-tuning how different data workloads run on shared capacity. Also, capacity admins can even override some tenant-level settings, but only with the boundaries of their capacity. This is helpful when different departments or regions have slightly different needs. This role can be assigned from the Fabric admin portal or from Azure, if the capacity is managed through Azure resources. You can think of that capacity admin is like a building manager. They control which teams are allowed to use the building, how much electricity or water each floor gets, and when maintenance is done. But they do not have keys to enter the rooms. In summary, the Capacity admin role is perfect for delegating operational control over compute resources without giving broader admin rights over the whole tenant or the entire Fabric platform. Next, we have a very important topic for the DP-700 exam, and that is the workspace level access and roles. These 4 different roles, admin, member, contributor, and viewer, can be granted on workspace level. I have copied this table directly from the Microsoft Learn documentation, and now let's go through it. We will start with the viewer role. A viewer can view and read contents of items like notebooks, data pipelines, Spark jobs, and event streams, and read the contents of SQL databases, SQL query sets, and real-time dashboards. They can also connect to the SQL endpoints of a Lakehouse or warehouse and read data using TSQL. Viewer can also see execution outputs. This role is for users who only need to consume content or checking data but not modify anything. Next, we move up to the contributor role that grants you very wide access to the workspace. Basically, you can do almost everything in the workspace with this role, and this role is typically ideal for developers that need to build things in the workspace. However, this role doesn't grant rights to give workspace level accesses to other people or identities. But that we can do with the member role that gives that ability, and also the ability to allow others to reshare items. And finally, we have the admin role. Admins can do everything the previous role can, and more. They can update and delete the workspace itself, add or remove any people including other admins. This is the highest level of access at the workspace level, and it should be reserved for trusted users who need full control. Try to memorize this table as well as possible for the DP-700 exam, since most likely you are going to have some questions about this. On this slide, I will walk you through quickly how to give these different workspace level accesses. The easiest way is to open up a workspace, and then on the top right corner you can see this Manage Access button. Then click that, which will then open up the Manage Access tab. And there you can add more people or groups and also identities like service principals to that workspace to different roles that we covered on the previous slide. Now let's take a look at how domain level role assignments work in Microsoft Fabric. Like covered in the beginning, domains allow logically grouping workspaces together. Let's first cover what Fabric admin can do with related to domains. The answer is actually quite simple, since it is pretty much everything that is possible, since Fabric admin is the king of the service. They can manage all domains in the organization. This includes adding or removing domain admins, assigning and removing workspaces from domains, and editing domain metadata. They also have full access to the domain tab in the admin portal. This means that they can view all domains regardless of ownership. Fabric admins can override tenant-level endorsement settings for individual domains. They are also responsible for creating new domains and assigning domain admins to manage them. However, they do not automatically get access to the workspaces unless they are added to those separately. But Fabric admins can easily add themselves as admin of any workspace if they so desire, but this access is not automatically given like we covered in the earlier slides. Next, we move to the domain admin. A domain admin can manage only the domain they are assigned to. They can add and remove contributors, assign workspaces to the domain, edit domain metadata, and remove workspaces if needed. They also get access to the domain tab in the admin portal, but only for the domains they manage. They cannot see or edit other domains outside of their own scope. Also, important thing to remember and highlight here is that domain admin is not a higher level role from the workspace level roles in a sense. Since granting domain admin role to somebody doesn't grant workspace accesses, and domain admin can't grant those accesses to themselves like Fabric admin can. So in that way, this admin role is similar to capacity admin role that we covered previously. The scope here is just different since now we are managing the domain and not the capacity. Now we move on to the domain contributor role. This role can be a bit confusing since this role is for workspace admins who have been given permissions to link their workspaces to a domain. They can add their workspace to a domain or change it to some other domain they have access to. But that is all. They cannot edit domain settings or manage contributors. They also cannot access the domain tab in the admin portal. So in short, Fabric admins manage all domains, domain admins manage their own domains, domain contributors only connect workspaces they are admin of to domains that they are assigned as contributors. And one final note, subdomains do not have separate admins, they inherit their admins from the parent domain. At least this is the case for now. Now let's take a look at how access control works at the item level in Microsoft Fabric. Inside a workspace you can manage permissions for individual items. To do that, you go to the Items menu, select Manage Permissions, and then you add the user you want to give access to. If you don't give any of these additional permissions, user will just get a read access to that item. So the first additional permission is share. This allows the person to share the item with others. It is also known as reshare access. Next is edit. This gives the permission to change the content of the item. For example, edit code cells in a notebook. This is also known as write access. And then there is run. This lets the person execute the item. For example, to run a notebook. This is sometimes called execute permission. But here is an important note. The run permission is not available for every item type that you can give access to. For example, a notebook you can execute, but Spark environment you can't. And thus, if you would open the same menu for it, you wouldn't find this execute permission there. Also, not every item in Fabric supports item-level access management yet, and few items like lakehouses and warehouses have more granular item-level access management since they are data stores and can contain objects like tables in them. So let's take a look at them next. Let's first take a closer look at how item-level access works for a lakehouse in Microsoft Fabric. When you open the same item-level access menu for Lakehouse, we get quite different options there. On the top, we have this text. People you share this lakehouse with can open it and its SQL endpoint and read the default dataset. To allow them to read directly in the lakehouse, grant additional permissions, which means that if we would just share this lakehouse without any additional permissions that can be seen lower in the picture, we would already get some access to this lakehouse. So let's break that down. When you share a lakehouse without any additional permissions, the person you share with it can open it and connect to its TSQL endpoint, and this applies to tools like SQL Server Management Studio. However, they can't read any data that is in this lakehouse. So what is the point of sharing lakehouses without any of these additional permissions? Well, the main reason is that since users can now connect to this lakehouse, you can give them more granular object and row and column level accesses that we are going to cover in the next episode. Also, this access allows users to read the default semantic model of the lakehouse. And if you remember, we can also store files to the lakehouse, but with this access, you can't get any access to those files without any additional permissions. Next, let's talk about those additional permissions that can be given when sharing a lakehouse. First, we have read all SQL endpoint data. This gives the user read access to all the data available through the SQL endpoint. It works like the DB data reader role in traditional SQL Server, if you are familiar with that. Second, we have read all Apache Spark and subscribe to events. This allows the user to work with Spark notebooks and jobs and access raw files in the lakehouse. It also enables event subscriptions from this lakehouse. For example, if you'd like to build event triggers based from this lakehouse, like for example file arrivals, etc. Also, very important thing to highlight here is that this access is needed if you'd like to shortcut the data in this lakehouse to another lakehouse in Fabric. As third additional permission, we have then build reports on the default semantic model. This allows the users to connect to the semantic model from tools like Power BI Desktop or Service and create visual reports. But this doesn't give direct access to the tables or files behind the model. So overall, you have fine-grained control over what users can do with a lakehouse. And the most important thing to remember, not all permissions are needed in every case. Always follow the principle of least privilege and only grant what is necessary. Let's now take a closer look at how item-level access works for warehouse in Microsoft Fabric. Just like we saw with lakehouses, when we open the item-level access menu for warehouse, we see a permission panel with a similar structure but a slightly different options this time. On the top, we can see a message that says, people you share this warehouse with can connect to it. To give additional permissions, select them from the list. This means that even without any additional permissions selected, the user will get some basic access to the warehouse like with Lakehouse. So let's break down what this actually includes. When you share a warehouse without selecting any extra permissions, the person can open it and connect to it using tools like SQL Server Management Studio, but they cannot read any data unless further permissions are granted, just like with Lakehouse. So what is the point of sharing warehouse without those extra permissions? The answer is the same as with Lakehouse. Once the person can connect to the warehouse, you can apply object, row and column level security to give them access to only the data they should see and not all the data in the warehouse. Now let's take a look at the additional permissions available when sharing a warehouse. First, we have read all using SQL. This gives the person read access to all the data in the warehouse using TSQL. Next, we have read all OneLake data and subscribe to events. This grants access to OneLake file system that sits behind the warehouse. It also allows the person to use Spark notebooks to read warehouse data and subscribe to OneLake events that are generated for that warehouse. This is similar to Spark access in Lakehouse permissions. Although the data structure and use cases are a bit different, the logic is still the same. Then we have build reports on the default semantic model. Just like in the Lakehouse, this gives access to the dataset through the tools like Power BI Desktop and Power BI Service. It doesn't give direct access to the database tables or files. It works only through the semantic model. Next is the monitor permission. This gives access to dynamic data management views, often called DMVs, and query insights, so that users can monitor queries running in the warehouse. Then we have the audit permission. This allows access to audit logs using TSQL so that you can investigate who did what inside the warehouse. And finally, there is reshare access. This means that user can share the warehouse with others along with the permissions they have been granted. So, to summarize, just like with lakehouses, you have a flexible and layered control over who can do what with the warehouse. And just like before, the most important thing is to follow the principle of least privilege. Only grant the permissions that are necessary and nothing more. So don't just aimlessly tap all of these additional permissions if they are not really needed. And one more thing that I want to say about this item level access is that it doesn't really matter what accesses you give at this level if the user already has, for example, contributor access to the workspace, since it will override that access that you have given at the item level, so keep that in mind. But now let's go to Fabric and let's do a demo about these topics together. Now we're in Fabric, and I have created these two new workspaces to Fabric, Marketing Analytics and Sales Operations. Then I have also created this new user to Fabric called Aleksi Partanen 2, and I'm going to use this second account to demonstrate the access control to you by gradually giving it more access. And here in this picture, we can see the setup that we are going to use to give those accesses to that account. So there we have those two workspaces that I just showed to you. So we have the sales operation workspace, and then we have the marketing analytics workspace. And under that sales operation workspace, we have a Lakehouse and some other resources. And in that Lakehouse, we have, of course, the SQL endpoint and the Spark/OneLake endpoint. And we can see that the SQL endpoint will give accesses to tables, and the Spark/OneLake endpoint will give accesses to tables and also files. And then I have also this one domain there called sales and marketing, and then I have a new Fabric capacity for sales and marketing also. And now we are going to start to give some more access to that second account. And this time we will start from the bottom and go to the top. So now we are going to start from the item level and go up from there. So the first access that I'm actually going to give it is to share just the Lakehouse there without giving any additional permissions. So let's do that. So here we have the sales operation workspace, and here we have the Lakehouse in that workspace. Now I'm going to click this manage permissions here, and I'm going to actually add that user that I have created and grant that permission for it. So let's find it, Aleksi Partanen 2, there it is. And I'm not going to notify him when I give these accesses, but now I'm not going to give any additional permissions. So I will just share this Lakehouse with that account, so that account is then able to connect to this Lakehouse using TSQL endpoint, but can't actually query any data. So I will grant that, and then we are going to see a new row in these accesses here. And now I will go to that second account. And here I have that second account, and every time you can see this red or crimson top bar here, you know that I'm using this Aleksi Partanen 2 account here. And we cannot actually see that workspace where that Lakehouse is, but we can actually connect to its TSQL endpoint by using, for example, SQL Server's Management Studio. And now I need a connection string to this Lakehouse, and we can find it here. So we open the Lakehouse, and then we open these settings here, and then we have the SQL Analytics endpoint, and here we have the connection string that we can use with SQL Server Management Studio. So let's open the SSMS now. And now we are in the SQL Server Management Studio, and here we can connect to that endpoint by using the connection string here. And we can click this connect button, and then we are going to use that second account to connect to that endpoint. And now we should have the connection. And indeed, we have the connection, and here we can see that Lakehouse database there. But we cannot actually see any tables in that Lakehouse, because we don't have any permissions to read data from here. We just have the permissions to connect here. So now we would be able to use like object and row and column level security to grant some access to this account. But that is the topic for the next episode. Now I'm going to go back to Fabric and grant more access to that account. And now I'm going to actually add this read all SQL endpoint permission, which will then grant us read access to all the tables and views that we have in that endpoint. But it is good to keep in mind that this access won't grant you access to the Lakehouse files, since those files are not exposed through the TSQL endpoint. So now we are going to expand the accesses to this Lakehouse and also select the read all SQL endpoint data and grant that. And now we have granted that, and now we can go back to the SQL Server Management Studio and let's see, does anything change there. And now under the table section, we can see this DPO sales data. And we are actually able to query that data and see the contents in that table. But it seems that that's the only table that we have in this Lakehouse. And we can see that there are few rows of data. And we can go to this sales operation workspace and check out our Lakehouse and indeed see that there is only this one DPO sales table. And we can also see that we have some content under the file section as well. And there is also this sales.csv that actually contains that same data that we have in the table, but now in CSV format. Next, we are also going to add this read all Apache Spark permission for that account. So then we are able to get access to that file section as well. And cool thing that this also enables us to build shortcuts from this Lakehouse to another Lakehouse. And now I'm going to grant that read all permission to that second account by clicking these three dots here and clicking read all. And now we can see that we have read and read all permissions to this Lakehouse. And in the My Workspace of that second account, we can open up the Lakehouse, and now we can, for example, create a new schema shortcut, and we can click this one lake source here, and here we can see that Lakehouse to which I have given those permissions to. And we can click next, and now we should be able to see this sales table here, and also under this file section we would be able to see that CSV file in this staging folder. And with this permission we would be able to create a shortcut to this workspace from that other workspace where we only have that item level access to. But yeah, we're not going to actually create a shortcut now. Next, we are actually going to give the first workspace level access to that account, and I'm going to grant this viewer access to this sales operation workspace. So we would be able to see other resources also in that workspace and also the entire workspace, but we wouldn't be able to change anything with that viewer permission because it's read only. So with this main account, let's go to the workspace level and then click this manage access and then add people or groups. And then I will have to find my second account here, and there it is. And then I'm going to only grant the viewer role for it to this workspace. So let's click add, and now it has been added, and we can see that that second account is now a viewer in this workspace. And now if we go back to that account, we should be able to see the workspace here, and here we can see that workspace. And now we have the viewer/reader access to all the resources and items that we have in that workspace. But with this access, we cannot actually change anything here. And now we move one step above the workspace level, and we are going to actually grant domain admin access for that second account. But like we covered in the theory section, domain admin access doesn't give any accesses on workspace level. So this access is only for managing that governing domain where those workspaces are grouped to. So you will get only the access to manage that domain, but not any access to those workspaces. And now let's check out how we can give that domain admin access. Here on my main account, I will go to the settings and then open up the admin portal. And here we can see this domains tab here, and we can open that. And here in the domain tab, I would be able to see all the domains that we have in this tenant, but now I filtered these with the DP-700. And here we can see that sales and marketing domain, and we can open up that. And we can see that we have two workspaces in that domain. We have that sales operation workspace, and then we have that marketing analytics workspace. And here we have the domain settings for this domain, and here we can assign new admins to this domain. So let's find that second account here, and there it is. And now we can click apply and apply this domain admin for that account. And now we will go to that account. And now with this second account, we can open up the settings and go to the admin portal. And we can see that with this account, I cannot see a lot of stuff here in the admin portal. That's because this account is not Fabric admin or global admin. But yeah, we have these domain tabs here. And here we can see that sales and marketing domain to which I have access to. But you can see that I can only see that domain. And now I have the admin access to this domain, and I would be able to modify this domain and add new workspaces to this domain and also modify the domain image and this kind of a description, but I cannot actually rename the domain here. So I have a little bit limited access to this domain, but I can do this like general administrative tasks with it. But like I said, the domain admin doesn't actually give any access to these workspaces that we have here. And here on the workspace tab, we can only see the sales operation workspace because we gave that viewer access to that workspace previously. But to that marketing analytics workspace, we don't have any access, even though we are the domain admin. So the domain admin role is really scoped to this only one specific thing here in Fabric. And next we are going to add some capacity admin access to that second account. And like with the domain admin, this capacity admin is also strictly scoped, so that it only gives admin access to that capacity. And I have this sales and marketing capacity to which I'm going to assign this kind of a capacity admin to that second account. And keep in mind that this capacity admin is really only scoped to that capacity so that we can manage that compute resource. So it doesn't give any accesses to domain and workspaces. We only have these accesses because we have given them in the previous steps. So if we would only give that capacity admin and we wouldn't have these accesses here, these boxes should be also red. Capacity admin can be actually given in two places if you have your Fabric capacity in Azure. It can be given here in the capacity settings here in the admin portal, but it can also be given here in Azure. And here I have this Fabric capacity resource here in Azure, and here we have this capacity administrator tab. And here I would be able to add new capacity administrators to this capacity. But yeah, we can go back to the admin portal and add it here. And then we can go to this Fabric capacity tab, and here we can see the capacity that we are talking about here. And let's open up that. And here we have these admin permissions, and to here I can add that second account as admin, and then I can apply those changes. And now that second account has admin access to this capacity and can manage this capacity here in the admin portal. And now with this account, we can open up the capacity settings tab. And this account should only see that capacity to which we have given that admin permission to. So we can see that we only have this one capacity here in Fabric capacity tab. And we can open up that. And now here on the capacity settings, we would be able to manage this capacity and, for example, turn on the search protection or manage these other settings here. And here in this other tab, we can also override some tenant settings that have been defined on tenant level so that we can override them on the capacity level so that we have some control over these settings on capacity level as well. But yeah, the key thing to remember about the capacity admin is that it is this very tightly scoped admin access so that we can basically only manage the capacity with it, and it doesn't give any other accesses. And as a last access here, we have the Fabric admin access. And with this access, we would actually get automatic capacity admin access and also automatic domain admin access. But like said, workspace accesses are not given automatically to Fabric admins, but of course Fabric admin can get access to workspaces if he or she so wants. Fabric admin is actually given at tenant level, and we manage it here in the Entra ID. And here we can see that on my first account I have the global administrator rights. So with this account I would be able to give Fabric admin rights to my second account. And in my second account I don't have any assigned roles here, but here I would be actually able to do a role assignment and find that Fabric administrator and grant that to that second account. But I'm not actually going to do that because propagating that access will actually take a while and I cannot wait right now. So I'm not going to give that. I can use this account to demonstrate what kind of things we can do with the Fabric admin access. So basically we have all the access to the admin portal as we can see here. So we can see a lot more tabs here than we can see with that other account. And we can access this workspace tab where we would be able to give access to any workspace we want. And also with these Fabric admin accesses, we would be able to access admin monitoring workspace that we can see here. But I think this is enough for this demo section today. And before we have those questions about today's topic, I would like to tell you about this website called certiace.com that I have created with few friends. This website basically offers some free custom-made practice questions to certification exams like DP-700 and DP-600. So after watching this video, go check out certiace.com. But now let's have those practice questions. Let's have our first question. You have two lakehouses in Microsoft Fabric, Lakehouse A in Workspace A, Lakehouse B in Workspace B. A data engineer needs to create file shortcuts from Lakehouse A to Lakehouse B. Which accesses should be granted for the data engineer? Follow the principle of least privilege. A. Workspace contributor on Workspace A. B. Workspace admin on Workspace A. C. Read all Apache Spark and subscribe to events on Lakehouse A. D. Read all SQL endpoint data on Lakehouse A. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, since read all Apache Spark grants the data engineer this access and it is only scoped to the Lakehouse itself. A and B would give the data engineer also the ability to do the shortcuts, but also give access to the entire workspace, so the scope is wider and thus it doesn't follow the principle of least privilege. D wouldn't give the data engineer an ability to do that shortcut, since the data engineer would be only able to use the SQL endpoint of the Lakehouse and read data through it. Let's have another question. You are designing access control in Microsoft Fabric. One user needs to assign workspaces to a specific domains, manage metadata for those domains. According to the principle of least privilege, which role is the most appropriate? A. Workspace admin, B. Domain admin, C. Domain contributor, D. Domain member. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B, domain admin, since it is the only one out of these who can manage the metadata for those domains. A is incorrect since workspace admins doesn't have access to domains. C is incorrect because domain contributors can manage metadata for domains. D is incorrect because this kind of role doesn't even exist. This is the episode 18 in the DP-700 exam prep series, and in this episode we will cover object, row and column level access control in Microsoft Fabric. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Before we get started, let's do a quick recap what we covered in the previous episode. So in the previous episode we covered access control from all the way from the tenant level to the item level. So if you haven't seen that episode, please watch it before watching this one, because otherwise some of the things that I will be talking about in this episode might not make that much sense to you. So the focus of this episode is going to be the most granular level of access that happens inside Microsoft Fabric items, meaning data stores like lakehouses and warehouses. This granular access control means giving access on object, row and column level. Alright, so now let's talk about this granular access control in more detail. There are 3 different levels of access that you can control inside Microsoft Fabric item like a lakehouse or a warehouse. These are object level security, column level security and row level security. Let's start with the object level security or OLS. This means controlling access to full objects like tables, views or schemas. If a user doesn't have a permission, they will not even see that the object exists. So it is a great way to completely hide sensitive tables or views from a certain users. Then we have column level security or CLS. This allows you to hide specific columns inside a table. A common example would be hiding a salary or personal ID column while still letting the user see the rest of the table. So the user can query the table, but they will only see the columns they are allowed to see. And finally, row level security or RLS lets you filter which rows a user can see. For example, a salesperson might only see rows related to their own sales region. This kind of filtering happens automatically based on who is running the query. So these three types of security can all work together to give you very precise control over your data. And in this episode we are going to cover each one of them step by step and piece by piece. Let's now take a closer look at object level security or OLS in the context of Microsoft Fabric Warehouse and Lakehouse's SQL endpoint. So we are going to talk about how to implement OLS using the SQL statement in those data stores. Object-level security means that we're controlling access to entire database objects like tables, views, or even full schemas. If a user is not granted access to a table, they will not even see that it exists. In this example, we have a warehouse with two schemas, marketing and HR. Each schema contains different tables. To give access, we use grant statements. For example, if we want to give access to entire marketing schema, we can write grant select on schema marketing to john@example.com. This gives John access to all current and future tables inside the marketing schema since we are granting the access on schema level. We can also grant access to individual tables or views using statements like we can see on the screen that would grant access to those three tables in the HR schema. Good thing to know that if we grant access this way, new tables in the HR schema are not given access to since we are not providing any schema level access. So if new tables are added, we need to give access to them table by table. If we want to block access to a specific object, we can use a deny statement. For example, deny select on marketing budget to john@example.com. Even if John has access to the full marketing schema, this deny statement will override that and block just the budget table. To remove a grant or deny, we can use revoke statement. Revoke does not block access or grant access. It simply removes whatever there was before. For example, revoke select on HR salaries to john@example.com. This clears the permission for salaries table that were previously granted to that. And since the default access has been that there is no access for John, he loses access to that table. Of course, if we would have a person that has access to entire schema or data store, and then we revoke deny access from some table, that user would be then able to see that data after the revoke has been ran. So, to summarize, grant is used to give access, deny is used to block access, revoke is used to remove access rules. You can apply these at schema level or at table level depending how detailed you want your control to be. Also, you can use database roles to grant these accesses as well, meaning that you create specific grants or denies to a role and then you add that role to users you want to apply these object securities to. Now let's move to column level security or CLS. Column level security is similar to object level security, but instead of blocking or allowing access to entire tables, it works at column level. So you can let someone read most of the table, but hide just one or two sensitive columns, like salaries, IDs, or personal information. In this example, we are looking at the HR employees table. The table has three columns: name, unit, and salary. In this case, we want to let the user see the name and unit columns, but not the salary. To do that, we use the grant and deny statements. First, we grant access to the columns we want the user to see. Grant select name unit on HR employees to John. This allows John to see only those two columns. Then we explicitly block access to the salary column with the deny statement. Deny select salary on HR employees to John. This would make sure that John cannot query the salary column. Of course, in this case, running this deny statement is not mandatory since we only gave this name and unit access to John and he didn't have any access to that table in the first place. And if we want to undo one of these permissions, we can use the revoke statement in a very similar way we used it with OLS. This removes whatever permissions was set before, whether it was grant or deny. Also, these column level accesses can be controlled via role, like object level accesses that we covered previously. Now let's talk about the row level security or RLS. Row-level security allows us to control which rows in a table user can see. Instead of showing or hiding entire tables or columns, we can show only the specific rows that the user is allowed to access, based on their identity. In this case, we have two tables in sales schema, user region and region sales. User region contains information to which region each user belongs to, and region sales contains sales data per region. Now we would like to use row-level security to only show the rows in region sales table that belong to the same region than the person who is querying and using the data. To set this up, we start by creating a new schema called sec. This is just to organize our security-related objects. This step is optional since you could create those security-related objects to any schema you want, but managing them is easier if you have a dedicated schema for them. Then we define a function that contains the row-level security logic. This function takes in a region from the row that is being queried and checks if the current user is allowed to see that row and region. Inside the function, we compare the region of the row with the list of regions assigned to the user. This information comes from a user region mapping table. The username function tells us who is currently running the query. So if the region in the row matches the user's region, the function returns a result, and that row is shown to the user. Next, we create a security policy that uses this function to filter rows in the sales table. Whether someone queries the table, the function automatically checks which rows they are allowed to see. On the right side of the slide, we can see an example. The user John is only allowed to access the North region. So when John runs a select query on the sales table, he only sees the rows for the North region. All the other rows like South are automatically hidden. That is how row-level security works. It gives us row-level control and it runs silently behind the scenes. The user only sees what they are allowed to see and nothing more. And like noted at the bottom, row-level security can be combined with object and column-level securities to create a complete and flexible access control setup. Next, let's go through a few important things to remember when using object, column, and row-level securities in Fabric. First, object, column, and row-level securities all work both in Lakehouse SQL endpoint and warehouse using TSQL. So the same techniques we saw earlier apply in the both data stores. That said, there are few practical things to consider when sharing accesses with users. It is usually better and easier to start by giving users only basic access, just enough to open the Lakehouse or warehouse, and then add more permissions as needed. This is often much easier than giving too much accesses and then trying to take away those later by using deny statements. This approach follows what is called the principle of least privilege. This means that the user should only get the minimum level access they need to do their work and nothing more. So this means that when we are sharing access to Lakehouse and warehouse, we don't want to check these additional permissions that can be seen here on the screen. Like said, when using these object, row, and column level accesses, it is usually the best start without any additional access and then use grant statements and row level security to give access that is needed, rather than giving full access by giving the user read all data using SQL and then removing accesses that they shouldn't have by using deny statements. So always review what you're sharing and make sure access is limited to what is necessary. This will help reduce the risk, keep things simple, and make security easier to manage across your Fabric environment. Until this point, we have been only talking about managing access using TSQL, meaning inside warehouse and using Lakehouse's TSQL endpoint. Now I want to talk about the brand new feature in Fabric called OneLake Security. At the time of recording this video, this feature is currently in preview and not part of the DP-700 scope. However, I'm 100% sure that this feature will be added to the DP-700 scope in the near future, and thus I'm covering it here. Like we already know, when we use Lakehouse, we are actually storing our data to OneLake under the hood. And using Lakehouse, we can store table data and then we can store raw files like CSV and JSON files to OneLake. Then we can use different engines in Fabric to access that data. We have the TSQL endpoint/engine that we can use to read tables from our Lakehouse. Then we can use access control in that engine to manage access to that table. And that is what we have been covering in this video until now. So those object, row, and column level accesses that we covered are happening inside this specific engine. But since SQL Endpoint is not the only engine we can use to access the data in our Lakehouse, and we have other engines like Spark, Power BI, etc. that can be also used to access tables and files sitting in our Lakehouse. The problem here is that all of those object, row, and column level accesses that we were setting up using the SQL engine are not available when using those other engines. This could lead to a situation where the user is able to access different data depending on the engine that is being used. This is where OneLake Security steps into picture. By using OneLake Security, we can drop down the access management below those engines and have one access control that all of those engines use. So it doesn't matter where you're accessing the data using TSQL, Spark, Power BI, Excel, or OneLake File Explorer, the same access control will apply. So OneLake Security allows users to define granular role-based security to data stored in OneLake and enforce that security consistently across all compute engines in Fabric. And this is going to make access control so much more straightforward. OneLake Security uses role-based access control or RBAC, so you can manage access using roles. It works across multiple engines, which means security stays consistent no matter how data is accessed. And it gives you centralized control over who can access what and how. Now keep in mind that when I'm recording this video, OneLake Security is still in preview. And one last note, OneLake Security replaces the older data access roles feature that was released back in April of 2024. If you'd like to learn more about OneLake Security, then I would recommend you to watch the video OneLake Data Security Controls in Microsoft Fabric on Microsoft Mechanics YouTube channel, since in my opinion this video explains it very well what this feature is all about. But now let's go to Fabric and let's do some demos/tutorials there. Now we're in Fabric and I have my DP-700 tutorial workspace open. And I have actually already opened a warehouse in this workspace, because we're going to use warehouse to demonstrate these row, column, and object level accesses. But yeah, here I have this setup script that will first create a schema and then create some tables to that schema, like employees, sales, and then finance, and also this user regions table, and then also add some rows to those tables. So let's first run this first part of the SQL script so that we get those objects there. So what we're going to do next, I'm going to use my second identity that I created for the previous video to access this warehouse. And now our SQL script has ran and we have those tables here in this warehouse. Let's refresh this and we should have those tables there. There they are. And now I want to only give connect access to my second account to this warehouse so that I will be able to connect to this warehouse, but I won't be able to see any data. And then we are going to use object, column, and row level accesses to give some access to that user gradually. But yeah, let's go back to my workspace and then we have to find this warehouse here, and then we are going to go to the manage permissions, and here I have given that access to my second account, so this Aleksi Partanen 2 account. And what I have done here, I have only clicked this add user button, and then I have deselected all of these permissions here and only shared this item with that user, so that it will get access to connect to the warehouse, but will not able to see any data there. And next I will open up SQL Server Management Studio and we will connect to that warehouse, but we shouldn't see any data there. So we can close this and let's go back to our warehouse. And here we have the settings for the warehouse, and under these settings we can find this SQL connection string here. We can copy that. And next we're going to open up the SQL Server Management Studio. And here we have the Management Studio, and then we're going to copy paste the connection string here, and then we are going to click this options button here, and then we are going to specify that we want to connect to that specific warehouse so that we're able to make the connection. But yeah, now we can connect and we're going to use the MFA authentication and it will connect to that server. And here we can see some databases, and we can only see that specific database here because we have only granted access to that one. And under this we shouldn't see any tables, if I'm correct. Yeah, we cannot see any tables or any views because basically now we only have the connect access to this data store. And now we would need to use that more granular access control mechanisms to grant more accesses to this user. So let's do that next. And here I'm giving these select permissions to finance, sales, and user regions table. So basically we are giving a select/read access to those tables for that account. And let's run these SQL commands here, and then we can see that we have access to those tables using that second account. So let's go back to the Management Studio, and now we can refresh the tables, and we can see those 3 tables there. So for now, we can only see these 3 tables here. We cannot see the employees table, and we cannot see other tables in these other schemas. And now we could try to query these tables and see that can we get data out of them. So for example, let's query the finance table, and here we can see the data that we have in the finance table. And next, we could use the column level access control and grant some accesses to that employees table. And let's check that in that employees table, we have actually 4 columns. So we have the employee ID, full name, department, and salary. And now I'm only granting accesses to those 3 first columns. So I'm actually excluding the salary column so that we are not going to give access to that. And let's run this grant statement, and now we have access to that. And now when we refresh the table list here, we should have also that employees table available once this refreshes. And there we have the employees table. Now let's try to do select top 1000 rows from that table, and it will give this error message. The select permission was denied on the column salary, because we don't have access to that column. So we cannot actually query that. So let's remove that column there, and let's try to query that table. And as you can see, we can query the other columns in that table, but we cannot query that salary table because we have not given access to that. Then we can also quickly demonstrate how the revoke will work. So I'm going to revoke access from the department column, and we are going to run this, and now we shouldn't have access to that department column anymore. So if we run this same code here again, so we don't have access to that department column. But remember that the revoke statement only removes those access controls, so it is not grant or deny. It will return them just back to the default that was there previously. And because the default with this user is that we don't have any access, then the revoke will default it to the scenario that we don't have access to that place. But if we would be playing this game other way around, that we would have access to the entire database, and then we would just start to remove accesses by using deny statements, then this situation would go other way around. But yeah, let's move forward with our tutorial. Next, we are going to talk about the row level security. So with row level security, we have to actually create that function first. That will filter that table to which we are then going to apply that row level security to. The first step of creating row level security is to define this function that we are actually going to run row by row when we query the table. And this function will then evaluate whether or not the querying user has access to that specific row. And here we have defined that we're going to pass down this region as parameter for this function. And we are going to use this region to check that whether or not currently the user who is running the query has access to that specific region. And then we are going to basically return true or false if that user can access that row or not. And then this function will only return the rows to the user that he or she is allowed to see. And like said, we could have way more complex logic here in this function to evaluate which row the user is allowed to see, but I only have this very simple example here. And next we have to define this security policy that will then actually use that function that we defined there and apply to the table we want to use that for. And then we have to define that this security policy is actually on. And by running these commands here, we are able to create that function and that security policy so that we actually now have that row level security in place. And when we come back to this Management Studio here, we can see our previous result that we were able to query 4 rows out of that sales table. But now if we rerun this query, we would only see 2 rows, I assume. Yeah, we can see only 2 rows there, because basically this user that we are using to run these queries is this second account, and we have specified in this user region mapping table that this account has only access to the North region. Because we then have that logic in that function that will then use the data from that table to evaluate the row level security logic. I hope that this demo has now clarified to you how these different object, row and column level securities work here in Fabric. But remember that here we're only using the TSQL engine to define these, and in the future you probably want to use the one-leg security to define these accesses so that they are applicable in all engines when accessing the data. Next, let's have exam-like questions about the topics that we covered here. You need to allow a user to read data from finance reports table that is in your Fabric warehouse, but they must not see the salary column. User can connect to the warehouse but currently has no access to the finance reports table. What should you do? A. First grant select on finance reports and then revoke select on salary column. B. First grant select on finance reports and then use row level security to filter out salary data. C. Just grant select to the columns user needs on finance reports. D. Just deny select on salary column on finance reports. Now think about the answer for a moment and pause the video. I'll reveal the answer in 3, 2, 1. The correct answer is C, since user didn't have any access to that schema in the first place, so we can just grant access to the columns that the user needs. Option A is incorrect, since we would be granting access to the entire table and then trying to revoke access on salary column to which we don't have specified any access, so there is nothing to revoke here. Option B is incorrect, since we are not looking for row level security here because we need to hide a column, not rows. Option D is incorrect, since user doesn't have any access to the table and thus denying access to salary column doesn't give us the access to the other columns. This is the episode 19 in the DP-700 exam prep series, and in this episode we will cover dynamic data masking in Microsoft Fabric Warehouse and Lakehouse's SQL endpoint. This is a feature that adds cherry on top of the cake when we're talking about securing sensitive data in Fabric. And this feature will complement nicely those other security features that we have covered in the previous episodes. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in the episode, so that you can test your knowledge. But now, let's get started. Let's start by covering what dynamic data masking actually is. Dynamic data masking, or DDM, is a built-in feature in Microsoft Fabric. It gives you a simple way to protect personal or confidential information directly at the query level. You can use dynamic data masking both in Data Warehouse and in the Lakehouse's SQL endpoint. So this is a TSQL way of implementing data masking that we are going to cover in this episode. One key thing to remember with this feature is that masking doesn't change or modify the actual data. The actual data stays exactly the same. What changes is what the user sees when they run a query and try to view the data. So, why do we do masking? It helps protect sensitive information like names, phone numbers, or salaries. If someone doesn't have the right permission, they will only see a masked version of the data, not the real value. This helps prevent accidental data exposure and improves compliance with data protection policies. In Fabric, you can apply masking to specific columns, and you don't need to mask every column in a table. For example, you can only mask columns with information like names, emails, and credit card numbers. You decide which columns need protection and how they should be masked. This is useful for keeping sensitive fields safe while still letting users query the data. Masking can be a really useful feature in real-life scenarios, and especially in some industries like HR, healthcare, and finance. Think about an HR data that stores salary details or healthcare data with patient names. In these cases, not everybody should be able to see full details. Masking allows you to hide those sensitive values. In Microsoft Fabric, there are 4 masking functions available, and we are going to take a look at those in the next slides. But now let's have a small example how dynamic data masking will change the data. This is how the data looks for a user with full access. You can see the actual names, emails, and salary values. Nothing is hidden. Now let's implement dynamic data masking and let's see how that data could look like after it has been implemented. The names are replaced with X's, the emails are partially masked, and the salary is also 0. The user can still work with the data structure, but without seeing the private information. This is the power of dynamic data masking, protecting sensitive data while keeping the tables useful. Now let's talk about the default masking function, which is one of the most basic type of masking functions in Masked Fabric. This function replaces the entire value in the column with a simple predefined mask. The actual data is hidden completely, nothing is shown from the original, so this is useful when you want to be extra cautious and not leak any details. One reason the default function is so widely used is because it's so easy to apply. You don't need to customize it, you just use it as is and it works across many types of columns. Fabric automatically picks a suitable mask for the value depending on column's data type. For a string column, you get one type of mask, and for a number, you get another type of mask. The main goal is very clear: hide sensitive values from users who shouldn't see them. And here is the syntax. It is just default with brackets. We are going to take a look at the full syntax of implementing masking using TSQL, but this syntax part is the one that changes per function. Let us now look at what this actually does with different data types. For strings like names or titles, the value is masked with something like XXXX. So if someone's title is a manager, it gets fully replaced. For numeric values, the mask is just 0. Even if the number is large like 1, 2, 3, 4, 5, 6, it just shows as 0. For date and time columns, the default mask is the beginning of year 1900. It doesn't matter what the actual date is, the users who will see the masked data will only see that specific date for all of those columns. And finally, for binary types like var binary, the masked output is an ASCII value of 0. This works even if the original value is a long encoded binary string. So to summarize, the default masking function is a safe and simple way to hide values across different column types. Now let's look at the masking function that is made specially for email addresses, the email masking function. This function is built just for email style data. It shows only the first character of the email's username, that is the part before the @ symbol. The rest is replaced with the letter X to hide it. What comes to the domain part of the email, everything is masked. So no matter what the original domain was, it is always replaced with 4xs.com. This keeps the structure of email but hides everything sensitive. Also, this mask works even if the email is short, unusual, or some type of invalid string. Now let's take a look at some examples. We can see that no matter the domain, the ending of the mask is that 4xs.com. Also, we can see that this is really a string mask and doesn't care about if the email is valid or not, since we can see that mask for a random string is in email format. Thing to highlight is that blank values will be masked with this default type of mask, and then null values are not masked at all. To apply this mask, you just use the syntax email with brackets. Let's now look at the random masking function, which is designed for numeric columns. This function replaces the original number with a random value, so the actual number is never shown to the users without required permissions. You can define the range of values you want, a minimum and a maximum. For example, you can choose to only return random numbers between 1 and 1000. The masked value is created at query time. It is not stored at the table, so the underlying data stays unchanged. Whatever the user sees is generated dynamically. And here is something important. Because it is generated on the fly, the results can be different every time the user runs the query. So if someone queries the data again, they probably will see a new random value for each row. Let's now look at an example where we can see this random masking in action. We can see that the masked results are always in the specified range. And like with email function, the null values are not masked, and actually none of those masks will return null values. And like with email function, the null values are not masked, and actually none of the masking functions will mask null values. To apply this mask, you just use the random function with the start and end of your desired range. In this example, we are using random 1 to 1000. Let's now look at the custom string masking function, also known as partial function. This one gives you the most control. It lets you decide exactly which part of the string should be shown and which part should be hidden. This function is useful when you want to show only a few characters at the beginning or at the end of a value, and mask everything in between. You can choose how many characters to show at the beginning of the value. For example, you might want to keep just the first letter or two. You also choose what to display in the middle, that is the masked part. It can be a custom string like stars, dashes, or even a fixed word like masked. And finally, you decide how many characters to show at the end of the string. This could be useful if the ending is important, like in an ID or account number. No matter what the original value is, the masked result will always follow the same structure that you define. Let's see how this works in practice. The important thing to point out that if the value is very short, then the mask might hide the whole thing since there is not enough characters to show before and or after end of the masking part. In this case, we just see stars. That is the mask that we have defined. And we have the same thing with null values as previously. In the below, we can see the syntax for this mask. That means keep one character at the start, mask the middle with 5 stars, and keep 2 characters at the end. So far we have looked at how different masking functions work. Now let us see how to apply them to columns and how we can remove them when needed. The first option is to apply masking when you create a new table. In this example, we define 4 columns and each one has a different masking function. The name column uses the default mask, the email column uses the email function, the number column is masked with random values, and the ID column uses partial function. By adding masked with function directly to the create table statement, the masking is applied immediately when the table is created. But what if the table already exists? No problem, you can use the alter table statement to ask masking to a column later. Here we are adding a default mask to the name column. Just make sure that the data type matches with the mask that you are using. And if you ever need to remove masking from a column, you can use drop masked command. In this example, we are removing masking from the name column by running alter column drop masked. Let's now talk about how security and permissions work with dynamic data masking amongst Fabric. In Fabric, not all users will see masked data. If someone is an administrator, member, or a contributor in the workspace and they have elevated permissions to the data store, they will automatically see the real unmasked values, even if the masking is applied. There is also a special permission called unmask. If a user is not in a privileged role but you still want them to see the real data, you can grant them unmask access on a specific table or schemas, and of course you can revoke it later if needed. We can grant unmask access using grant statements and we can take it away using the revoke statement. Also, good thing to point that you can also grant these for roles as well, so you don't have to use individual accounts when granting and revoking. Now, this part is important. Dynamic data masking is not a strong security boundary. It is designed to reduce accidental exposure, not to protect against malicious users. So, if someone really wants to get around masking and they have the access to the data, masking will not stop them. That's why we say that masking is helpful, but it should not be used as your only line of defense. In this example, the salary column is masked with the default mask, but the user runs a query with the where statement that targets the masked column. The query will return 0 in the masked column, but the actual values behind the mask are in the range of the where statement, and thus the user knows that the salaries of those 2 people are actually in between of those values that have been specified in the where statement. For better protection, you should combine dynamic data masking with other features like object-level security, column-level security, and row-level security. Next, let's go to Fabric and do a demo/tutorial together about dynamic data masking. Now we are in Fabric and I have my warehouse open here, and to this warehouse I'm going to create a new schema, and to that schema I'm going to create this table called masking demo. And we can see that we are masking bunch of columns in this table. So we are using bunch of different masking functions here to mask the data, and then we can take a look at how does those columns look when we apply the mask. And we're also adding bunch of rows to that table so that we can see how the mask is applied in different scenarios. But yeah, let's create this table and let's add those rows to the table, and then I also grant access to my second account to this specific table so that we can use that account and see the masked data there. But yeah, let's run these first statements here so that we get the data there. And now it is executing and should finish quickly. And now it is done. And we should be able to query the data by using this select statement here. And we should see those actual values because I'm the workspace admin. So like I said, these masks won't apply when you have this kind of a higher level access like admin or contributor to the workspace and items in that workspace, like this data store that we're using here. So here we can see how does this data look. But soon we are going to use that second account and connect to this warehouse and take a look at how this data look when you don't have those privileged accesses to this data store. And to be able to connect to this warehouse, we would need this connection string here, so we can copy that. And then we are going to open SQL Server Management Studio, and with this tool, we are going to use that second account and connect to this warehouse. So let's define a new connection, and always remember to define this database here to which you are connecting if you have already granted the connect access to that item. But yeah, I have defined that database here and I have the connection string here, and then we can click connect. And this should use my second account and connect to this data store. And we can see that now the connection has been made, and there we can see that I'm using the second account for this connection. And we should only see this specific data store here and should see some tables here. We can see a bunch of tables because I have previously granted access to those schemas and tables. But here we have that masking demo that we are now interested in. And by the way, if you're wondering about the access that I have given to this warehouse, I have went to this manage permission here and only used this add user and only granted the access to connect to this data store. So only granted this access without these additional permissions here. But yeah, here we can see that we have only the read access with that second account to this data store. And now with the second account, we can run the same query that we ran previously, and we can see how does the data look. And we can see that the data looks quite different when we compare these side by side. So we can see that the full name is not masked yet, but all the other columns are basically masked and we have different values there. And there are a few things that I want to point out here. For example, you can see that the null values are not masked ever, no matter what masking function we are using. And then we can see that we are, for example, using that email masking function for this email address column, and we can see that we have a bunch of invalid emails there, but those will get masked as well, and we can see that empty strings will get masked with that default mask. And then we can see this bunch of other masks here that are doing their masking things. And we can also see this default mask for this kind of a date column, and we can see there the beginning of 1900. And next I'm demonstrating how to add a mask to a column when you have already created the table. So basically here we are adding the mask to the full name that was not masked previously. So let's run that, and then if we re-query the data here, we should have the mask there, and there we can see that now the full name has been masked. And then we can use this drop masked statement to drop that mask from that column if we want. Also, we can talk about this unmasked permission. So basically, I can use this grant unmask statement here to grant unmasked access to this second account. So if we would run this here, so that grant unmask to that specific table to my second account, we should now see the unmasked data if we run this query. So now we can see that data is no longer masked, and I have not elevated accesses for this user. I have just only granted that unmasked permission. But yeah, then we can revoke that unmasked by running this statement here so that the user will once again see that masked data when he queries the data. And we can requery the data and see that data is once again masked. Yeah, it is masked again. And now I want to demonstrate that security issue that I talked about in the theory section with this dynamic data masking. For example, if we are running this where statement to the salary, we can run this with this first user that is able to see those salaries. And we can see that we get these two persons that are in the range of those two salaries. But if we would use this second account here, we would be also able to return those same users that we were able to return there, even though we don't see those salaries. But by running this query, we know that the salaries of these two persons is in between those two numbers. And with this, we would be able to specify or identify the exact salaries for those persons. And here I can demonstrate that we can run these exact where statements and expose those values that we have here. And here you can see that when I use this custom ID in the where statement, I'm actually able to get the Alice Johnson row, even though I don't see that custom ID, but I know that it is this one, like we can see in here below. Next, let's have a couple of exam-like questions related to dynamic data masking. But before we do that, I would like to tell you about this website called certiace.com that offers free custom-made practice questions to certification exams like DP-700, DP-600 and DP-900. I have actually made this website with two of my friends and we're constantly adding new questions and new updates here. So after watching this video, go check out certiace.com. But now let's have those questions. Let's have our first question. Which of the following statements about dynamic data masking in Mux Fabric is true? A. It encrypts the data stored in the table. B. It masks data for every other workspace role than admin by default. C. It doesn't mask data for workspace contributors by default. D. It replaces all null values with masked values. Now think about the answer for a moment and pause the video. I will reveal the correct answer in 3, 2, 1. The correct answer is C. It doesn't mask data for workspace contributors by default, because like I explained, these kind of privileged roles to the workspace like contributors, members and admins won't see that masked data. Option A is incorrect because it doesn't encrypt the data in the table. Option B is incorrect because data is not masked for workspace contributors and members also. And option D is incorrect because those null values are never masked like I showed to you. Let's have another question. You are implementing dynamic data masking to Mux Fabric warehouse. You need to mask column email in the table like in this example. Which dynamic data masking function you should use? A. Default. B. Email. C. Random. D. Partial with this configuration. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is the D, partial function, because that will actually provide the mask that we are looking for here. The key thing to spot here is that on the first row, when we're masking the domain, we can see that there is that .org. So we cannot use the email masking function because it will mask all the domains as .com. So that's why this partial function is correct here. Even though in the typical case you would probably want to use the email masking function for masking email addresses. But I wanted to have this kind of a trick question so that you can test that you really understood what's happening with these different masking functions. This is the episode 20 in the DP-700 exam prep series, and in this episode we will cover governance features that are in the scope of DP-700 exam that we have not yet covered in this series, like item endorsements, tags, sensitivity labels, and lineage views. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now let's get started. Let's first start by talking about endorsing items. When you work with a lot of data and reports, it can be hard to know which ones you can trust. This is where endorsements can help. There are 3 different types of endorsements in Mux Fabric that can be given. Those are promoted, certified, and master data. And now let's break down each one of them to understand what those mean. First, we have the promoted endorsement. This is the most unofficial out of these 3, since this is just for highlighting that specific item, which means that that item is seen as a valuable asset and the person who has promoted it recommends it for others to use. This promoted endorsement doesn't really require any special permissions to be applied, and people who have right level permissions to a specific item can add promoted endorsement to it. This is the only endorsement option that is available for all Fabric users by default. So basically the point of this endorsement is just to encourage the collaborative use and spread of content within an organization. Next, we have certified endorsement. This is a step up from the promoted endorsement, and it means that the item meets the organizational quality standards. And what these quality standards mean in practice? Well, each organization has to come up with their own rules what they consider as certified content. However, it could be said that when item has been certified, it is typically regarded as reliable, authoritative, and ready to use for across the organization. What comes to the permissions, this endorsement is not available for everybody to use by default, and Fabric admins can manage the certification process to meet the organizational needs and specify who is able to certify items. Lastly, we have the master data endorsement. If an item has been labeled as master data, that means that the item is regarded by the organization as being core, single source of truth data, such as customer list or product codes. But like with the certification process, you have to make your own rules how to use this master data endorsement. Also, like with the certified endorsement, Fabric admins can control this master data process and who can approve items to have this endorsement. And here we can see how this endorsement look in the workspace item list. Also, it is good to note that given item can have only one of these endorsements. So for example, you can't have items that have promoted and certified endorsements at the same time. Another good thing to know is that master data endorsement can be only applied to specific items that contain data, like lakehouses and semantic models, since it wouldn't make any sense to label, for example, a data pipeline or a data flow as master data, since those items don't contain any data and they just move and transform it. On the other hand, promoted and certified endorsement can be added to all Fabric and Power BI items except Power BI dashboards. Now let's talk about tagging items in Microsoft Fabric. Tags are like custom labels that you can add to Fabric items. They help you to keep things organized and easy to find. So basically, tags are just some configurable text labels that can be applied to different items. And in those example pictures, we can see that bronze and finance tags have been applied to that lakehouse. The purpose of tags is to enhance data categorization, organization, and discoverability. And you can, for example, filter items based on the tags that have been applied to it. What comes to the permissions related to tags, only Fabric admins can create, rename, or delete them. But after those tags have been created in the admin portal, any user with right permissions to an item can apply and remove tags. There are a few limitations that are nice to know about tags, and those are that the maximum of 10,000 tags can be created, and each item can have up to 10 tags. And it is good to know that all tag-related actions can be performed programmatically via Fabric Admin REST APIs. So if you want to do some tag-related automation, the capabilities are already there. Next, we have sensitivity labels that can be also applied to different Fabric items. Sensitivity labels help you to classify and protect your Fabric items and data. They can apply things like encryption, watermarks, and usage restrictions, especially when content is exported outside of Fabric, like to an Excel or a PDF file. These labels are created and managed in Microsoft Purview, which is part of Microsoft data governance tools, which means that you cannot create new labels inside Fabric. You can only apply the sensitivity labels made by the people who manage your Microsoft Purview. What comes to the permissions related to sensitivity labels? In order to use them, your Fabric admin must first enable the feature in the admin portal. Also, you need specific licenses like Microsoft Purview Information Protection in order to make and have these sensitivity labels in Fabric. So if you don't have those, you can't even start to use this feature. If you meet all the requirements for using sensitivity labels and your admin has enabled them, then you can apply them to items you have right permissions to. So in that way, they are very similar to tags and endorsements that we covered previously. In the screenshot, you can see a label called confidential that has been applied to a lakehouse. It also says that this label has been automatically applied to downstream items. This means if you create a dataset or a report from this lakehouse, they will also get that same label, since they are using data from this item that has been defined as confidential. This is an optional setting that can be turned on or off from the admin portal. Now let's take a quick look at the workspace lineage view in Microsoft Fabric. This view shows you a visual map how different Fabric items in your workspace are connected to each other. For example, in this screenshot, we can see that data flows from Azure Data Lake storage into a Lakehouse, and then from that Lakehouse it is being used by different Fabric items like notebooks. To open the lineage view, you just click the lineage icon in top right corner of your workspace. Lineage is useful because it helps you to understand dependencies. You can quickly see where data is coming from, how it moves through the notebooks or pipelines, and where it ends up. This is especially helpful when you are debugging, doing impact analysis, or working with a larger team. So lineage is just not a nice diagram, it gives you a clear end-to-end view of your data flow. Then we can also open item lineage view for individual items. This view is very similar to the workspace lineage view, but now the scope is an item rather than the entire workspace. This view is also helpful for identifying dependencies and do some impact analysis for the item. Next, let's go to Fabric and do a demo/tutorial about these topics together. Now we're in Fabric and I have my DP-700 example workspace open here. Let's start by discussing endorsements. I have this Lakehouse here that we have been using in this tutorial series here. Let's open this and let's open settings for it. And here we can see this endorsement tab. And here we can see those endorsement options that we just talked about in the theory section. So that by clicking here, we could, for example, promote this item or certify this item, or label this as master data. And of course, I can only do these certified and master data endorsements because I have the right permissions for do them. But all the users should have already the permissions to promote items if they have the right permissions to them. And in the admin portal, we can control things related to these certified and master data options. And here in the Fabric admin portal, we can check out some settings for this kind of a certified endorsement. First, we have this certification and we can enable it here for the organization. And I have already enabled this for my tenant. And here we have also these options to specify this custom documentation URL and how this URL would be actually used. Well, when we have these certified and master data endorsements here, we have this link beneath them. If a user will click this link, it will take you to this Microsoft Learn documentation. But if we specify a custom URL here, that link will actually take you to the custom page. And on that page, we could have some information about the certification and master data processes in our organization. But for now, I don't have any custom URLs to specify here. But basically, we could specify any URL we want here. Then we have this other important setting here, make certified content discoverable. And what this setting means that if we have turned this setting on, the users can see certified content in their Fabric portal, but they are not able to access it. But if they see it, they are able to request permissions to that certified content. So basically, this setting will make your data more discoverable in your organization. For example, if you have this customer dataset that has been certified by your organization, users can see it after you have turned this setting on, and if they think that they need access to that customer dataset, they can request access to it. But like I said, this doesn't give the permission to access that dataset automatically. It just makes it more discoverable by the users. Then in the admin portal, we have also this separate setting for turning on the master data endorsement. But remember that this endorsement can be only given to some specific items that are data store, like lakehouses, for example. And now, just to play around with this feature, we can turn master data endorsement on for this Lakehouse. But remember that in the real world scenario, this wouldn't be probably this easy, and you would need to have some type of review process before some item could be labeled as master data or certified. But promoted, every user could add. But yeah, let's add that master data endorsement there. And now we can see here in the workspace UI that we have this master data label here. So in this endorsement column, we can see items that have been endorsed in this workspace. And then if we, for example, open up this Eventstream here and then add a promoted certification here, we can see that we don't have master data endorsement here available because this Eventstream is not a data store. But yeah, we can close this with the promoted endorsement, and now we can see that that Eventstream is promoted. And next, let's go back to the admin portal and let's talk about tags. Here in the admin portal, we can see this separate tab for tags. And here I have actually created a bunch of tags. So I have created this finance, HR, bronze, gold, and silver tags. And here we would be able to create more tags. And remember, like I explained in the theory section, these tags could be actually created and managed also programmatically via Fabric Admin REST APIs. But yeah, now I have created a bunch of tags here. And remember that only Fabric admins are able to create these tags here. But yeah, now we have a bunch of tags here, and now we can go back to the workspace and open up this Lakehouse's settings again. And here we can see another tab for tags, and here we can apply some tags to this Lakehouse. For example, we can apply finance and bronze tags to this Lakehouse. And now we have applied 2 tags here. And here in the workspace UI, we can see that some tags have been applied to this Lakehouse, and we can see these tags here. And the nice thing with tags is that we can filter items in our workspace using these tags. For example, if we want to filter out all the finance related items here, we can use these tags to label them and then use this filter to find them more easily. Also, in the admin portal, we have a bunch of settings related to sensitivity labels, but unfortunately, my tenant that I'm using to record these videos doesn't meet the requirements to use those sensitivity labels because I don't have the right licenses in place. But here in the admin portal, you can find settings to enable the sensitivity labels so that you can add them to your items. But remember that sensitivity labels are not created in Fabric, and they are created and managed in Microsoft Purview. That is a different tool, but it is a Microsoft data governance tool, so that is a good place to manage them organization-wide. Because those sensitivity labels are actually not just Fabric specific, and they can be applied to, for example, Excel files. Also, in the theory section, we talked about this lineage view that can be opened here in the top right corner of our workspace. And here we can see the lineage for our workspace. And for example, here we can see that we have some data coming from Azure Data Lake Storage Gen2 because a shortcut from that storage have been created to this Lakehouse. And then data from that Lakehouse is actually being used by multiple notebooks, and one of those notebooks is also ran in a pipeline. But yeah, this workspace lineage view is great, for example, for doing some impact analysis. For example, if we are planning to change this Lakehouse somehow, we can see what are the notebooks and pipelines that are using data from this Lakehouse and then consider if our change will affect those. And also, like I showed in the theory section, we can open up this kind of a similar view for a specific item and view item lineage. And here we can just see this lineage for a specific item. That is also good for doing that impact analysis, but in the scope of that item. Next, let's test your knowledge about the topics covered in this episode. But before we do that, I would like you to know about this website called certiace.com that I have created with few friends that offers free custom-made practice questions to certification exams like DP-700, DP-600 and DP-900. So after watching this video, go check out certiace.com. But now let's have that practice question. Our question today is, which of the following statements about endorsements in Microsoft Fabric is correct? A. Only Fabric administrators can promote, certify, and apply master data labels to any item in the workspace. B. Master data badges can be applied to any item including notebooks and dashboards, as long as they contain metadata. C. Certification requires the item to be promoted first and then approved by a workspace admin. D. You can add certified tag and master data endorsements at the same time to a Lakehouse. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D. You can add certified tag and master data endorsement at the same time to a Lakehouse. Well, this is a very tricky question, since here we are talking about certified tag and not certified endorsement. If we would be talking about certified endorsement, we wouldn't be able to add certified endorsement at the same time with master data endorsement, because we can only have one endorsement active for a given item at the time. But since we are talking about tag and we have this tag called certified, we can add that at the same time as master data endorsement. What comes to our incorrect options, A is incorrect since Fabric administrator role is not required for those operations. B is incorrect since master data can be only applied to data stores and not items. Even though items would contain metadata, they are not still data stores and master data cannot be applied to them. And lastly, C is incorrect because certification doesn't require item to be promoted first. This is the episode 21 in the DP-700 exam prep series, and in this episode we will cover version control in Microsoft Fabric. This episode will cover all the necessary information about version control with Fabric, like settings, usage, and permissions. However, we are only going to cover a very brief introduction to version control as a concept. So, to get most out of this episode, you should be already familiar with the basic concepts of version control and Git. Like in every episode in this series, we will first start with the theory section, followed by demo/tutorials on Fabric, and then we end the episode with few questions related to topics covered in the episode, so that you can test your knowledge. But now, let's get started. Let's first cover why to bother using version control in Microsoft Fabric and what version control is for. So basically, version control is a system that helps you in many ways. Version control is a system that keeps track of changes to your work over time. It also helps teams to collaborate without accidentally overwriting each other's changes. And if something breaks, you can go back to the previous version of your work. From version control, you can see who changed what and why, if it is being used properly. And there are actually quite a many different strategies and options how you could use version control for your development work. In this video, we are going to focus on basic principles that are applicable regardless of your chosen way of using version control. And now let's shift our focus to Fabric and what the version control means in the context of Microsoft Fabric. Well, with version control, we can connect and sync our workspaces to a Git repository. This connection lets you track changes in both directions, safely test features in separate branches, and even roll back changes when needed. Fabric items like notebooks, pipelines, and lakehouses are saved as folders and files like Python, JSON, or SQL inside your Git repo, and we are going to look at this structure a bit later on in this video. With Microsoft Fabric, you can currently use either Azure DevOps or GitHub as the service of your version control. In the following slides and in the demo, we are going to use Azure DevOps, but the process and principles are more or less identical with GitHub. Next, let's take a look at Fabric's tenant level settings in the admin portal for using version control and Git with Fabric. At the time of recording this video, there are 4 different settings that play a direct role with Git usage. These settings can be found under Git integration in the admin portal. The first option lets users sync Fabric workspaces with the Git repository. This is enabled by default. If this setting was turned off, it would block everything else that we're going to cover in this video, since Git couldn't be used with Fabric in this specific tenant. The second setting is about cross-region Git commits. For example, if your workspace is in Central US and the Git repo is in West Europe, this setting decides whether that's allowed or not. Also, it is good to note that it is currently only applicable to Azure DevOps since GitHub doesn't currently support this restriction. The third one controls if users can export items that have sensitivity labels to Git. These sensitivity labels come from Microsoft Purview, and we talked about them in the previous episode on governance. Even if you would allow syncing these items with sensitivity labels to Git, the labels itself wouldn't be committed. And finally, you have a specific switch to enable GitHub support. This is disabled by default and needs to be turned on if your organization wants to use GitHub for the version control rather than Azure DevOps. Lastly, like with other tenant level settings, these settings can be applied to entire organization, or you can limit them to specific security groups or users. However, in my opinion, using version control is a best practice with development work, and I would encourage everyone to use it with Fabric. Now let's move from the admin portal to the workspace level. When you open your workspace settings and go to the Git integration tab, this is where you can actually connect your Fabric workspace to a Git repository. The first step is to choose your Git provider and sign in. This could be Azure DevOps or GitHub depending on what your organization uses and allows to use, like we covered on the admin portal settings. In this example, we are using Azure DevOps, and after logging in, we fill out the required details. First, we have to specify to which Azure DevOps organization we want to connect to, and of course the required access to that organization is needed to be able to make this link. Next, we have to specify the DevOps project within that organization that we want to use. Then next, the Git repository in that project. Then we have to choose a Git branch in that repo. Lastly, we have the option to specify a folder to which we want the contents of our workspace to be added to. This setting depends on the agreed Git setup and strategy within your organization, and are you going to have something else in that same repo than the contents of the workspace that you are connecting Git to. If you leave this Git folder option blank, then the contents of the workspace will be added to the root of the repo. Here we only covered Azure DevOps as an example, but like I said, the process with GitHub is very similar since both services are using Git as the technology for version control. With GitHub, you would be using personal access tokens instead of Entra ID login. Now let's take a look at how version control actually works inside Fabric Workspace. After you have connected a specific workspace to a Git, you can see this new source control button in the top right of your workspace view. With this button, you can open up the Git panel where you can do all of your Git operations. In this panel, we can see that we have some changes in this workspace that haven't been yet committed and pushed to Git branch that has been connected to this workspace. Those status icons next to those items help us understand what type of changes have been made. We have 4 different icons available. First, we have a green icon for status new, and this indicates that the item is completely new and it hasn't been committed to Git previously. Then we have a yellow icon for modified status, which means that this item has been committed to Git previously, but now there are some changes. Then we have this red X for conflicted change, which means that this item has been modified by 2 or more people and Git doesn't know which version to keep. And lastly, we have an icon for deleted status, which means that the item that is in Git has been deleted from the workspace and now Git would like to delete it from the Git repo as well. Then when making these changes, it is a good practice to add some type of message with your commit that explains a bit what was changed and why. And after you have selected the changes you want to make and added that commit message, you can commit those changes to Git, which will actually also push them to the repo. Also, we can see that we have some updates as well, and now let's discuss what those updates mean. In this update tab, we can see that we have one notebook with the status of modified. These updates are actually changes that have been made somewhere else than in this workspace to that branch that has been attached to the workspace. Most likely somebody has modified the contents of this notebook directly to the repo in Azure DevOps. And now Git is telling us that we have some changes in the branch that have not yet been synced back to this workspace. In the previous step, we were committing and pushing items from the workspace to the repo. Now we would be doing it other way around and fetching, or in Git terms, pulling changes from the repo to the workspace. These changes can be pulled by clicking this Update All button, and this will then perform that Git pull action and update the contents of the workspace from the Git repo. Next, let's click this tiny icon in the Git control panel to open yet another tab that let us do even more actions with Git. In this tab, we can check out a new branch that would be created from the current branch that has been attached to this workspace. Or we could change the connection of the workspace to another existing branch. Also, here we could branch out to another workspace. That is a really cool feature in Fabric, and thus it deserves its own slide, and that we are going to go through next. So, branching out to another workspace. What is so cool about this feature, you might ask? In my opinion, this is the coolest feature that we have in Fabric that is related to version control. Let me explain what this feature does. Let's imagine that we have our main workspace that is attached to a Git repo in Azure DevOps. This is the thing that we covered on the previous slides. And now we would be able to sync changes to both directions here. So what happens if we are in this main workspace and we want to branch out to another workspace? Well, let's imagine that we decide to do so and branch out to a completely new workspace. We would fill in the required information to the panel on the left, like the name of our branch and the workspace, and then click Branch Out. After that, Fabric and Git would create a new workspace for us and also a new branch to that Git for that workspace. This means that now we have an identical copy of our main workspace with exactly the same resources we had in our main workspace that we used for this branch out, with few limitations that we are going to cover shortly. In this workspace, we could be now doing all of our development work and experimenting with new stuff without impacting the original workspace at all. And after we would be done with our changes and made something useful there, we could merge those changes back to the original main branch and have them available there. This is very powerful, since this allows every developer to have their own isolated development environment. That is not really possible in many other data and analytics platforms, since typically they have shared resources that couldn't be replicated easily. However, the SaaS or software as a service nature of Fabric makes this magic possible. First, the uncommitted changes to the workspace are not copied to the branch-out workspace. Second, the items that are not currently supported by Git are not included to the branch-out workspace. And third, you would need to have admin, member, or contributor access to the source workspace and also permission to create a new workspace if you are going to branch out to a completely new workspace. We're going to come back to these permissions related to using version control on following slides, but these were good things to mention here already. Overall, like I said, this is a really cool feature and we are going to use this in the demo section of this video. Now let's take a look at how the workspace and its items look in the Git repo after it has been synced. Here we can see a familiar view where we have a workspace with some items and also few folders that have some more items in them. Next, let's take a look at how this same workspace looks in a Git repo after we have attached a Git to this workspace. Here we can see that items in the workspace are actually folders in Git repo. In each folder we have some different types of files that describe the item and its metadata that is required to create the item. We can also see both of the folders here in Git as well. In the demo section of this video we are going to take a look at these different items in Git repo more closely. Next, let's talk about what is actually synced and saved to Git and what is not. Let's first cover some general guidelines and things that are synced and saved to Git. The idea of Git is to save metadata and code, so like shown in the previous slide, item metadata is saved to Git. This metadata and possible source code, like with notebooks, is the required information that allows us to create those items to a blank workspace if need be. Also, the workspace folders are saved to Git like shown on the previous slide. With Warehouse, the object structures are saved to Git, which means that we have, for example, create table statements in Git that allows us to create the Warehouse tables. Actually, Warehouse uses Database Project for handling the version control, and we are going to cover a database project in an upcoming episode, so we will come back to it later on. With Lakehouse the story is a bit different, or at least that is the current status, since only the basic metadata and shortcuts are supported by Git. Next, let's talk about what is then not synced and saved to Git. The most obvious thing for experienced Git users should be that the actual data in our data stores is not saved to Git, since Git is not a data store and it is a version control system for our item metadata and source code. Also, schedules are not saved there. So, for example, if you have a schedule associated with your data pipeline and/or notebook, that is not saved to Git. Permissions are another thing that are not saved on any level, and you would have to add them some other way if you set up a new workspace based on some repo. Workspace settings are not saved and those should be configured per workspace. With Lakehouse, table and folder structure are not saved, so here Lakehouse is a bit different than Warehouse, or at least that is the current status of things. Also, typically new Fabric items that come out are not supported by Git out of the box, and it will take some time until they receive that support. I don't want to list here all the things and items that are supported or not supported by Git, since Fabric's Git support is changing and getting better fast, and thus that kind of list would get most likely outdated very soon. The important thing here is to understand that Git is meant for source code and item metadata, and not for data itself. So based on Git, we would be able to create empty shell of our solution very easily. But then populating our empty data stores with data would be then a whole new conversation that Git itself doesn't really solve. But yeah, Check the latest status, what is supported by Git and what is not, especially if you're watching this long after I have released this. For example, a little while ago, shortcuts and workspace folders were not supported by Git, but they are now supported. Now let's talk about workspace roles and permissions for those roles that are related using Git. If you have been watching this series from the beginning and the episodes on access control, you should know that we have 4 different roles in the workspace: admin, member, contributor, and viewer. Now let's cover some operations that could be done with Git and which role is required to perform which operation. For connecting the workspace to Git, we would need admin rights to the workspace, since that is the only role that would allow us to do this operation. Same applies to syncing and disconnecting a workspace from a Git repo. Switching branch in the workspace or doing any changes to Git connection will also require admin rights. And the same thing applies to creating a new Git branch from within Fabric. And here are all the Git related operations/tasks that are logged behind the workspace admin role. So viewing Git connection and details and seeing workspace Git status can be done with member and contributor access also. Same applies to update/pulling changes from Git and committing and pushing changes to repo from Fabric, since these operations can be done with those lower level accesses. That branching out to another workspace could be also done with member and contributor roles. However, it is good to keep in mind that permission to create a new workspace has to be provided to the user if the user wants to branch out to a completely new workspace. Also, like we covered in the beginning, Fabric admin has to first allow the use of Git from the admin portal before we can do any of these operations on workspace level. Luckily, this is enabled by default, so in typical case, no extra help from the admin is needed. And since we are using external services like Azure DevOps and GitHub, the user doing these operations would need to have the appropriate access to those services that are being used for the Git repo. To really understand these permissions, let's summarize a bit. Workspace admin can perform any Git operation in the workspace, and the workspace admin is only limited by the role or permission in the chosen Git service like GitHub or DevOps. Workspace member and contributor can't connect the workspace to Git or change the configuration, but they can commit changes and update things. And again, a limiting factor can be the role and permission to the Git service. Then lastly, a viewer cannot see or do anything related to Git. Maybe a bit tricky can be to remember that viewer cannot even see any Git related info. But overall, this list is quite easy to remember in my opinion, or at least easier than the general workspace accesses list that we have covered previously. Next, let's go to Fabric and do a demo/tutorial about Git together. Now we're in Fabric and I have my DP-700 tutorial workspace open here. And since the last episode, I have done some organization in this workspace and added these folders here. And to each folder, I have added those items that have been associated with the correct episode. So for example, here I have the episode 4 folder, and in that folder I have the notebook that we did in that episode. But now we would like to discuss some Git related things in the workspace. So let's open up the workspace settings here. And here we have this tab Git integration. And next I would like to connect this workspace to a Git repository in my Azure DevOps. But before we do that, let's go to the Azure DevOps and let's create a new repository here. So let's click new repo. And we can name our repo. Let's have there, for example, DP-700, and then we hit create. And this will create this kind of a blank repo for us with only this README file, to which we could possibly add some instructions for using this repo. But for now, I'm not going to touch this README file. But yeah, now this repo has been initialized here in Azure DevOps. And now we can go back to Fabric and then we can choose the Azure DevOps as the provider for the Git. And then I'm going to use my credentials to connect to that DevOps And here, then we would choose the organization, and I'm going to choose my organization, and then we have to pick the project, and I only have one project in that organization, and then we have to select the repo, and I'm going to select my DP-700 repo. And next, we would have to provide the branch, and currently we only have the main branch there, and I'm actually going to connect this workspace to the main branch. And now we are not going to provide any Git folders. And if we would provide this folder, all of these items here would actually go under that folder to this repo. But because we are not using this monorepo strategy here, we can just have all the items in the root of our repo. But yeah, now we can click this connect and sync, and this will actually start the Git sync process and sync all of these items that I have in this workspace to that repo. And one thing is good to note here that not all the items are probably supported by Git. I would imagine that, for example, this mirrored Azure Databricks catalog is not yet supported by Git, and we have to see what the status is going to be. But if I remember correctly, we are not able to sync this to Git. So now we are only syncing the items that are currently supported by Git. But eventually, I think every item in Fabric should be supported by Git, because that's the proper way of doing development with version control. And now we can see that that sync is now done. And we can see that that Azure Databricks catalog that was mirrored is not supported. But I think all the other items that we have here have been synced to Git. Yep, we can see that those have been synced. And now we have this source control button here. But before we click that, let's go back to the DevOps and refresh this repo here, or this main branch. And here we can see all of these different items that we have synced here. And here we can see that when we have those folders here, it will actually create these folders to the Git as well. And for example, here we can see a notebook inside this episode 4 folder. And in that folder we have only this one notebook, and this notebook is represented as a folder here in Git. And under that we have these do files. So here we have the notebook source code, and then we have this platform file that describes some metadata about the notebook. And when we open up these other folders here, we can see that, for example, here we have an Eventstream, and this Eventstream is actually represented as 3 different files here in Git, and we have some properties related to the event stream, and then we have the event stream as this JSON template that would be able to create the event stream if we would deploy this Git contents here to blank workspace. And also here we can see that we have the data stores that I have here. For example, we have the Eventhouse, and then we have the Lakehouse. And where is our warehouse? It is the last one here. And with warehouse we can see that we have a bunch of more things, because with warehouse we actually have those table statements, or the create table statements here, that are able to create schemas and tables, and we have also this SQL project here. But yeah, this SQL project is something that we are going to cover in a later episode, so we are not going to focus on this. But remember that version control with warehouse is a bit more complex and more sophisticated than with Lakehouse and Eventhouse. But yeah, we are going to come back to this version control and this database project with warehouse. But yeah, here you can see how those items are represented in Git. Next, let's go back to Fabric, and then let's click this source control button here. And here we could do actually those Git related operations. And let me move my face a bit so it's not on the way. And here we can see that we don't have any changes nor any updates coming to this branch. And if you remember, here we have this another tab where we can do more operations. And now I would actually want to branch out to another workspace. That was the feature that we covered on the theory section. So let's click this branch out to another workspace. So I want to create a new workspace for this new feature that I'm developing in this episode. And then I want to have my own isolated development environment for developing that feature. And that is possible with this branch out feature. First, we have to provide a branch name that will be created when we branch out to another workspace. I'm going to use this very generic feature episode 21 name for that branch, and then we have to provide a name for our workspace. And now we can click this branch out. And remember, before you can do this, you also have to have the permission to create a new workspace. Otherwise, this won't work. But if you don't have that and somebody can create that workspace for you, then you can use this existing workspace feature here as well. But now let's click this branch out and let's see what happens. Now it is branching out. So what happens now that based on the information or the items that we have synced to Git, we will actually create a new workspace based on those descriptions that we have in Git that we just took a look at. So when we connected that previous workspace to Git, we were syncing items from the workspace to Git repo, and now we are actually syncing items from the Git repo to this new workspace. And there we can see that we are already syncing some items here to this workspace. And depending the amount of items you have, this could actually take a little while. So let's jump a little bit forward. And now the sync has been completed and we can see that we have all the items that we had in the previous workspace now in this feature workspace. But there's actually one item missing, and that item is that mirrored Azure Databricks catalog that was not supported by Git. Because this process doesn't sync items from this workspace to that workspace, it actually syncs items from this workspace first to Git and then from Git to that workspace. And because this item is not supported by Git, it is not synced here. Before we move forward, let's compare these two workspaces a little bit more. Let's go back to the original workspace and let's open up the Lakehouse. In this Lakehouse, we have some data that is related to tutorials that we have been having. But if we open up the Lakehouse to this new workspace, we can see that it should be almost empty. We can see that it is almost empty. We only have this one folder here. And I will explain you shortly why that folder is in place. But these other folders are not here. And this only folder is there because there is a shortcut in this folder. Because shortcuts are actually synced to Git, which is very cool. And this shortcut is pointing to Azure Blob Storage. And here we can see files in that blob storage. And here we have the corresponding shortcut in that original workspace that is pointing to the same place. And this is really cool that shortcuts are now supported in the version control. And next, let's go back to the original workspace and let's check out the data warehouse where we had a bunch of different tables and some data in those tables. Here, for example, we have the episode 4 data and we have this assignments table here, and if we query the top 100 rows from that, we can see that there are 6 rows. And now let's go to the feature workspace, and in this feature workspace we have the data warehouse, and here we also have the schema for the episode 4, and there we have also the assignments table. And if we query the top 100 rows from that table, we can see that that table is empty. So with warehouse we get these table structures and object structures in place, but the data store itself is completely empty. And now we would have to find a way to populate with data if we would need some data in this feature workspace for the development work that we are doing here. Next, let's simulate a situation that we would be developing a new feature in this feature workspace, and that feature would require us to develop a new notebook. But first, let's create a new folder for this episode to which we are then going to create that notebook. So now we have episode 21 folder there, and to this folder we want to create a new item, and that new item is actually going to be a notebook, and then we would have to name that notebook. And that notebook name will be this feature. And here we could actually write some code, and I'm going to just write a print command here and print feature here. And we can try out that this notebook works and we are able to print that string feature there. And there we can see that we were able to print that, so that notebook is working fine. And now we can actually stop the session and we can actually close this notebook also. And now we have that new item in this workspace, and now we can go to this source control panel here. And here we can do those Git related operations, and here we can see that we have added one new notebook, and also this Eventhouse or this SQL database has changed. I don't know what's going on there, but let's not allow that to bother us. And I'm going to choose that I want to commit this notebook to the version control and to the Git. And here we can see that we are connected to that feature branch and not to that main branch. And here I'm going to actually add a commit message, and I'm going to say this is a super cool feature, and here I will tell what and why was developed here. And now we can commit this notebook to the version control, and now that is being committed, and now that has been done, and we can go to the Azure DevOps and actually change the branch to the feature branch, and here we should see that folder, and here we can see the notebook we just developed. And here we can see the contents of the notebook, and we can see the print command that I added here. And here I can also see the commit message that I made there. And now let's imagine that we are happy with this feature, and now we are ready to take it back to the main branch. So we can do that by choosing this pull request here in the Azure DevOps and creating a new pull request. And here some text is already added based on my commit message. And then we can go and check out that which files we are planning to merge back to the main branch, and we can see that we have only that notebook that I added there, and actually also the folder associated with the notebook. And we have see here, then we can see here that we have only that one commit that I made. But yeah, here we can create that pull request. And here we can see that we didn't have any merge conflicts, and we are actually ready to merge this feature back to the main branch. And actually in the real world scenario, you would probably want to have some type of review process here and add some colleagues or some other people to review the work that you have done before merging it back to the main development branch. But yeah, now I'm going to complete this pull request and merge this feature back to the main branch. And here we can actually choose the merge type that is being used for this pull request. But this is out of scope for this video, but I'm going to go with the squash commit. But leave some comments to the comment section down below if you would like to see me do more videos on version control that are out of scope for DP-700, but very useful in the real world scenarios. But yeah, now we are ready to merge this pull request back to the main branch, and I'm going to choose to delete the feature branch after merging, because I don't do anything with that branch after this has been completed, and I'm going to actually delete the associated workspace as well. And now that has been merged, and we can go back to the file section here, and we can see that now we only have that main branch, and then we can see that we have that new notebook here. But remember that now we have done things here in the Azure DevOps. So we have not yet synced this notebook back to Fabric. And we are in that original workspace, and we can open up the source control, and now we can see that we have one update incoming. This means that there are some changes in the Git repo that have not been yet synced back to this workspace. And the only thing that is there is that new notebook that I added using that pull request. And now I can click this update all button that will actually perform this kind of a git pull command that will pull changes from the repo back to this workspace. And let's click that, and now it will start the sync process and start to pull those changes, and it should only pull that one notebook that has been changed. And now the content has been synced, and we can see that now we have that episode 21 folder there, and in that folder we have that one notebook, and in that notebook we have those comments that are added automatically, and then we have that print command. So as a recap, we were able to branch out to another workspace and then do the development work in that workspace, and then we did the pull request and merged our changes back to the main branch, and then we synced the changes from the main branch back to the workspace here in Fabric. Next, let's have a couple of questions related to topics covered in this episode so that you can test your knowledge. But before we do that, I would like to tell you about this website called certiace.com that offers free custom-made practice questions to certification exams like DP-600 and DP-700. And I am actually one of the co-founders of this website. But after watching this video, go check out certiace.com. Let's start with the question 1. You are using branch out to another workspace feature in Microsoft Fabric to create a new development environment. You create a branch called feature new pipeline from the main branch and use it to branch out to a new workspace. Which of the following best describes what gets included in the new workspace? A. The new workspace includes all schedules, permissions, and items from the original workspace. B. The new workspace is empty until you manually import items from the original workspace. C. The new workspace includes only Git-tracked items that were committed. D. The new workspace includes all workspace items, but only Git-tracked items are editable. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C. The new workspace includes only Git-tracked items that were committed, because that is the behavior that we covered already in the video. A is incorrect because schedules and permissions are not currently supported by the version control. B is incorrect because the items that are in Git are automatically synced. D is incorrect because we could have their items that are not supported by Git and are not committed to Git, so they will not appear in the new workspace. Let's have another question. Fabric Workspace is connected to a Azure DevOps Git repository. A team member with a member role is trying to switch the Git branch in the workspace settings, but the option is grayed out. Which of the following best explains why the action is unavailable? A. Switching branches requires contributor role with build permission. B. Only users with admin role can change Git connection settings. C. The user must first disconnect the Git repo before switching branches. D. Members are allowed to switch branches, but only for GitHub connected workspaces. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B, because only admin can change the Git connection settings. A is incorrect because contributor cannot do this even with some build permissions that are kind of nonsense in this sentence. C is incorrect because the user with the member role cannot disconnect the Git repo and this wouldn't help. And finally, D is incorrect because the same rules apply to GitHub and also Azure DevOps. This is the episode 22 in the DP-700 exam prep series, and in this episode we will cover deployment pipelines. The whole CI/CD/deployment topic with Fabric is quite wide, and in this video we are going to cover topics that are relevant for the DP-700 exam. Also, we are going to cover a few nice to know things that are not in the scope of the exam, but could be very helpful to understand and know in the real-world scenarios. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now let's get started. Let's first start by covering what are deployment pipelines and what they are used for in Microsoft Fabric. Let's imagine that we have 3 workspaces in Microsoft Fabric and each one of those workspaces represents one environment, meaning that first we have a workspace for development work, then a workspace for testing, and finally a workspace for production where our data solutions provide insight and value for business. And now we would be developing a data solution in development workspace that results us having some Fabric items like data pipelines, notebooks, and data stores. And now we would like to take our cool data solution to the test environment for testing. Of course, we could manually copy all of our work to that environment, but that sounds like a poor way of doing things for me, and we are not going to go through that route. So we are actually going to set up a deployment pipeline in Microsoft Fabric that will deploy our items from the development workspace to the test workspace for testing. And after we are done testing our new data solution, we can use the deployment pipeline to deploy those same items from the test workspace to production workspace, where our data solution then starts to provide insight and value for the business. So, to summarize, deployment pipelines are built-in tool in Microsoft Fabric that help manage content lifecycle. And since this is a built-in tool in Microsoft Fabric, it is very easy to set up and no coding is required to get your deployment pipelines and processes up and running. They can be used to deploy changes from one workspace/environment to another. They help teams develop, validate, and release content in a controlled way. Now you should have an idea what deployment pipelines are all about on the surface level, and next we can go a bit deeper and learn how to configure and use them. Now let's take a look at how deployment pipeline UI looks in Maxed Fabric. Here on the screen we can see a deployment pipeline as it looks in the Maxed Fabric. There are many things and concepts that I want to point out from this picture so that you will understand more about deployment pipelines. We can see that in the UI we have three different blocks: dev, test and prod, one for each environment. If we are using three environment setup, that is quite typical in data engineering work. In deployment pipeline terminology, these blocks are called stages. So we have three different stages in this deployment pipeline. Basically, stage represents one step in the content lifecycle. Each one of these stages is linked to a separate workspace, and we have one workspace for development work, one for testing, and one for production. In a deployment pipeline, there has to be at least 2 stages, and there could be a maximum of 10 stages. Changes are then compared between the different stages so that we know what should be deployed from one stage to another when we are doing the deployment. And we are going to dive deeper into this comparison shortly. In this screenshot, we have actually the test stage selected, so we are going to deploy from dev to test. The selected stage is called a target stage, since this is the target of our deployment. Then the stage we are deploying from is called a source stage. In this case, that is the dev stage. We can also see in the UI that we have test stage selected and we are deploying from dev. Next, things get a bit unlogical from the UI perspective in my opinion, when we take a look at the comparison process underneath our stages. We can see that we have selected stage items column that actually represents the items that are found in our target stage, meaning in the test workspace in our case. Then on the right side of that, we have our source stage items that represent items that we have in our source stage, meaning in the development workspace. In my opinion, this can be a bit confusing, since I would rather want to have them other way around, since the stage UI on the top is moving from left to right, but this comparison UI is moving from right to left. But this is how things are currently in Fabric. Maybe for somebody else this logic works better than for me, but let's not allow this to bother us too much. When deploying items with deployment pipelines, there is a process called item pairing that happens. This means that Fabric keeps track of the item between different stages to know how a specific item has changed. Items are actually paired based on their unique internal IDs and not just by their name, so that Fabric can identify that if some item has been just renamed or is it a new item. Based on this item pairing and comparison, each item is given one of 4 statuses. First, we have the status same as source, which means that no changes to that specific item has been detected, and thus there is no need to deploy that specific item. In the screenshot, we can see that both lakehouses have this status. Then we have the status different from source, which indicates that this specific item has changed somehow. Basically, the most kinds of typical changes to the item will trigger this status. In this example, we can see that the notebook has this status, so most likely some new development work and changes have been done to that notebook after our last deployment. Also remember, since we are not pairing with names and we are using internal IDs, name changes will be also seen with this status. Then we have the status only in source. That indicates that the item is new and has not been deployed from the source stage to the target stage previously. And lastly, we have a status not in source, which means that the item doesn't exist in the source stage. This typically happens when somebody creates an item manually. In this case, we have a notebook called Random Testing Notebook. That can be found in the test workspace, but not in the development workspace. Now, if you're wondering what will happen to that notebook when we do deployment from dev to test, the answer is nothing, since deployment will not have any impact to this item. This takes me to my last point that I want to cover on this slide, that is that this deployment process can be done in selective manner, and we can choose the items that we want to deploy, so we don't have to deploy every item every time. Of course, it could be debated that should we deploy everything when we do the deployment, but deployment pipelines give some flexibility in this manner. Next, let's talk about deployment rules that can be used in deployment pipelines to change configurations of some items between stages. Let's imagine that we have again 3 environments set up, which means that we have a deployment pipeline with 3 stages. In our development workspace, we have a notebook and 2 lakehouses. One of those lakehouses is being used as a default lakehouse for the notebook. Now, if we would deploy these items to test workspace without using deployment rules, the default lakehouse would be the test workspace version of the lakehouse we had in the dev workspace. In the most cases, this is the desired outcome of the deployment. However, it is possible to define deployment rules and change this default lakehouse to be something else. Now let's do a deployment from test to prod and define a deployment rule that will change the default lakehouse to point to that other lakehouse in our prod workspace. Notebook is not the only item that currently supports deployment rules, and there are a handful of other items that can be seen on this table. As we can see, the current coverage of deployment rules is not very extensive, but it's good to remember that in some cases deployment rules could be used to solve some issues where a specific item is pointing to a wrong place after deployment. For example, with a mirror database, we can use deployment rules to change the data source to be a different database for each stage/environment. That could be useful in some cases. So, to summarize, deployment rules in Maxed Fabric let you change settings like data sources or parameters when moving content between stages. This helps to make sure that each stage uses the right setup without manual changes. It keeps deployment smooth and reduces errors. Of course, defining these deployment rules can be quite annoying if you have a ton of items that require them. And lastly, remember to check the current coverage and state of deployment rules, especially if you're watching this long after I have released this video. Before we go to the demo/tutorial part of this video, let's cover a few more things about deployment in Maxed Fabric that are good to know, but not that much in the scope of DP-700, or at least the current iteration of it. First, it is good to know that not all items are supported by deployment pipelines, and typically brand new items that are in preview are not supported. Typically, deployment pipeline support goes hand in hand with version control and Git support. Also, there have been cases where item is already in general availability and it is still not supported by deployment pipelines. Just keep this in mind and check the latest support status for items that you're interested in having as part of your data solution. Another good point to highlight here is that deployment pipelines can be used with Git-enabled workspaces. Also, it is good to note that deployment pipelines don't use Git when doing the deployment, and they just compare raw items between workspaces or stages. In one typical setup, you could have a Git-enabled development workspace, and then deploy items to non-Git-enabled test workspace, and from test to non-Git-enabled prod workspace. What comes to permissions related to deployment pipelines, you can grant access to users and groups to deployment pipelines that you make. Currently, it is only possible to grant admin-level access to deployment pipelines, and we don't have any other roles. Item ownerships are another thing that I want to mention here briefly. So basically, the user who will do the deployment will be the owner of the deployed items. This could play a role in many cases, since typically in Fabric the item owner's credentials are being used to execute the item when it runs. One thing that could be used to mitigate some of the dependency to personal user accounts as item owners is to run the deployment pipeline via API using Service Principal or SPN, because then the SPN would be the owner of the items. This way you could also tie Fabric deployments as part of the other possible deployments in Azure DevOps or GitHub, for example. Also, it is good to know that there is an alternative way of doing these deployments by using Fabric CI/CD Python library. This is a code-first solution that uses Fabric's REST APIs in the background for doing the deployment. This is not in the scope of the current iteration of the DP-700, but just wanted to mention this here briefly so that you can explore this option if you want. Then we have a relatively new item in Fabric called Variable Library that can be used to create workspace-level variables. With Variable Library, you can create variable sets and alternative versions of those variables that can be activated in different workspaces/environments. This item is a very nice addition and it already works with data pipelines, notebooks and Lakehouse shortcuts. However, at the time of recording, this feature is not part of the DP-700 scope and I will not cover it more in this video. All in all, Fabric deployment and CI/CD support is no means perfect, but it has been getting a lot better lately and especially variable library has a ton of potential making deployments way smoother. In an ideal world, no manual steps would be needed when deploying solutions to production, but this is not the case yet. There are still things like item level accesses that cannot be done via any API and must be added manually. Let's hope that in the near future we get to a situation where not a single manual adjustment is needed when deploying solutions to a completely empty production workspace, and everything can be handled via deployment processes and APIs. But like said, many of the things covered on this slide are not in the scope of DP-700, at least not yet. So leave a comment to the comment section down below if you'd like to see me cover more advanced and in-depth topics in upcoming videos about deployments and CI/CD that are not in the scope of DP-700. But now it is time to open Fabric and do a demo/tutorial together about setting up and doing deployments using deployment pipelines. Now we are in Fabric and I have my DP-700 tutorial workspace open here that we have been using for most of the tutorials in this series. Then I have created two new workspaces. I have this DP-700 test workspace and then I have this DP-700 prod workspace. But as we can see, both of these workspaces are empty. And now I would like to deploy the contents of this dev workspace first to the test workspace and from to the test to the production workspace. And for that, we are going to use the Fabric deployment pipelines. So let's start by configuring a deployment pipeline. We can find deployment pipelines here from the three dot and then clicking deployment pipelines. Then we want to create a new deployment pipeline. Let's name this deployment pipeline DP-700 and then we could add a description what this pipeline is all about. But I'm not going to add that description now. So let's click next. And now we can see these different stages here. To each stage we would define a workspace to which we want to do the deployment. Now we have this development stage here, then we have the test stage here, and then we have the production stage here. And of course we could add here more stages by clicking this plus button here. And remember that we can have maximum of 10 stages here and we need to have at least 2 stages. But yeah, I think we're happy with these 3 stages and we can have these development, test and production stages that correspond with our workspaces. Then we can click this create and continue. And now we can choose the workspace that is used for each stage. And for this development stage, I want to, of course, assign this development workspace. So let's assign that from this list. Now we have assigned that workspace and we can see that some of the items in that workspace are not supported by the deployment pipelines like we discussed in the previous section, that not all items are supported. But yeah, let's click continue since we are not going to care about that too much there. For example, we have that mirrored Azure Databricks catalog that is not supported by Git and not supported by deployment pipelines. Then next we want to assign our test workspace to this test stage and let's do that. And now we have assigned that and we can already see that comparison here that we are going to come back shortly. And now let's assign this production workspace to our prod workspace. So let's find that and there is the prod workspace and then we can click and assign that. And now we have assigned all the workspace to these different stages in this deployment pipeline. And now we could actually do a deployment from the development environment to the test environment. So if we click this test environment stage, we can see a comparison between the development stage and the test stage. But like I showed to you, this is a little bit funky in my opinion because we can see the test as a selected stage here and then we are comparing it to that development stage and items in that development stage can be seen here. So in my opinion this logic here is other way around as it should be. But here we can actually do that selective deployment, so we can select the items that we want to deploy. So we don't have to deploy everything that we have in our development workspace. But in this case, I actually want to deploy all, so we can click here and this will actually select everything that we have in the development workspace. And now we can click that deploy button here, and that will actually start that deployment from development to test. And now we can click this deploy button here. And here we can see that we are deploying a bunch of new items to that test workspace. Of course, because that test workspace is completely new and we haven't done any deployments to that workspace from dev, so there is no item pairing yet between these two workspaces. And here we could actually add a node to this deployment, so I will add some node here so that we can see how that will look later on. But now we can click deploy then, and this will start the deployment. And this deployment will actually take a little moment, so I will skip a little bit forward from here. And now our deployment is done and we have successfully deployed all the supported items from the development workspace to our test workspace. And we can go to the test workspace and let's refresh this and we should see some items here. And we can see all the same items here that we have in the development workspace, excluding those unsupported items, like that mirrored Azure Databricks catalog. But now the deployment is done and we can go back to the deployment pipeline. And here we should see a comparison between these two stages. And here we can see that some items have actually changed after the deployment. I don't know why the KQL database keeps changing always after the deployment, but typically we should now have the same as source status in almost everything. And with folders, we have to go inside that folder and see what is the status of the item. And since we have now done our first deployment to the test workspace, we have some item pairing going on between these two stages, so that Fabric knows what is the state of that same item in these two different workspaces, so that it can track those changes like we discussed here. But this already opens up us the possibility to create deployment rules by clicking this lightning bolt icon here. That will open up this deployment rules tab. And here we can define deployment rules to some of the supported items. I don't actually know why this is already showing data pipelines here, because to my understanding we cannot yet define deployment rules for those. But we can click, for example, data pipeline open here and we can see that we cannot define rules here. But for example, for this mirrored database, we can define data source rule. And here we would be able to configure this rule for this mirror database so that we would, for example, use a different connection in the test environment that we are using in the development environment. So basically that we would have this to connect to a different database than in the dev environment. But yeah, I'm not going to define that kind of a rule here and we can close this. But this is the place where you could be able to define those rules for these different items that are supported by the deployment rules. Now let's close this. And I can show to you quickly that with production stage we cannot define those rules because we haven't done that deployment there. So there can be this kind of a chicken and egg problem when defining these rules, that you first have to do the deployment and then define the rule. It would be helpful that if you could define those rules before the deployment. So in my opinion that would be more of a correct approach with these. But for now we have to do it this way. And remember that with these deployment pipelines, we are actually comparing the development workspace to test workspace. And after we have deployed items to the test workspace, then we are comparing the contents of the test workspace to the production workspace. And if you remember, we have connected our development workspace to Git. But like I discussed in the theory section, the Git and the deployment pipelines are completely separate features. Of course, version control and deployment pipelines complement each other nicely, but they do not talk with each other. With this Git integration, we are able to update the items in the workspace, and then the deployment pipeline will just read the contents of the workspace, and it doesn't really know that is our workspace attached to Git or not. But yeah, with Git you can do many other cool things like branch out to another workspace and develop your features there and use this Fabric in a version control manner. So I would encourage you to use both of these features in your environment. Next, let's take a look at some of these tabs that we have here in covering deployment pipelines. Here first we have this deployment history button, and if we click that, we can see a deployment history for this specific pipeline. And here we can see that we have been deploying to test, and that was the initial deployment that I did. And here we can actually see that note that I added to that deployment. And here we can see the ID for this deployment. But yeah, this will tell you some information about the past deployments that happened with the deployment pipeline. And then we have this manage access, and here we can actually add more people to be admin of this deployment pipeline. But currently we have only the option to add admins here, so we don't have any other roles like, for example, deployment pipeline contributor or deployment pipeline viewer. So the admin role is currently the only one that we can grant for the deployment pipeline. Then we have the settings tab, and here in the settings tab we only have basically the name and the description, so nothing interesting here. And then behind that 3 dots we have this delete pipeline, so if we would like to delete this deployment pipeline, it could be done here. And next we could do a deployment to the production workspace, but now let's do a selective deployment, and I will just select some specific items that I want to deploy from the test workspace to the production workspace. And now I have done that selection, and I want to deploy this Lakehouse, and then I want to deploy this one notebook. So we can click this deploy button and just deploy those 2 items. And here we can see that we are deploying those, and let's click deploy. Now this should be a lot faster since we are only just deploying those 2 items. And now the deployment is done, and it took like 10 seconds compared to the previous deployment that I did that took like 2 minutes or something, that it was way longer. But now we can go to the production workspace and refresh this, and we should see only those 2 items here. So we have the Lakehouse and then we have that notebook. So we have successfully done this selective deployment there. And if we go back to the deployment pipeline, we can see now if we click the production stage here, we can see that when we are comparing to the test stage, we can see that we have there 2 items that are the same as in the source, and then we have those other items that were not deployed yet, so we can see that those are only present in the source. Next, let's have a question about these deployment pipelines so that you can test your knowledge. But before we do that, I would like to tell you about this website called certiace.com that offers free custom-made practice questions to Microsoft certification exams like DP-700 and DP-700. And I'm actually one of the co-founders of this website. So after watching this video, go check out certiace.com. But now let's have that practice question. Our question today is, which of the following statement about deployment pipelines and Git integration in Microsoft Fabric is true? A. Deployment pipelines require Git integration for each workspace that are used in the deployment pipeline stages. B. Deployment pipeline uses the latest state in the Git repo for deployment in each stage. C. Git integration is only mandatory for a workspace that is used as the first stage of a deployment pipeline. D. Git integration is not needed at all for using deployment pipelines. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, since like I explained in the video, Git integration is no means mandatory for using deployment pipelines, and they are completely separate features. I really want to highlight this since this is a different approach compared to many other platforms and to data platform setups using Azure tools. Of course, Git integration nicely complements the use of deployment pipelines, since you want to do your work in a version-controlled manner. But the deployment pipeline doesn't use Git in any way directly, and it just compares whatever is found in the source workspace / stage, whether those items are synced to Git or not. This is the episode 23 in the DP-700 exam prep series, and in this episode we will cover SQL Database Project. In the previous episode we have already covered deployment pipelines and successfully deployed a warehouse using those. Now we are going to cover an alternative method for warehouse deployments using SQL Database Project. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in the episode, so that you can test your knowledge. But now, let's get started. Let's first start by covering an overview of the SQL Database Project and its deployment process. Let's first imagine that we have a Microsoft Fabric workspace that is dedicated for development work, and in that workspace we have a warehouse called Warehouse 1, and in that warehouse we have a DBO schema, and in that schema some objects like tables, views, and stored procedures. Now we would like to deploy the contents of this warehouse to our testing workspace. For that, we can use the SQL Database Project. Our options here are to sync the warehouse to a Git repo that will then expose its structure in the SQL Database Project format, or we can download this same structure from the Fabric UI as a zip file. In this case, we have synced this warehouse to a Git repo that exposes the structure of the warehouse in the SQL Database Project format. Basically, warehouse is represented as folders and files. We have dedicated folders for each schema like DBO, and under those folders we have more folders for different types of objects like tables, views, and stored procedures. And in those folders we then have SQL scripts for creating those objects, like for example the employees table in this picture. We're going to take a look at this structure more closely in the demo/tutorial section of this video, but this gives you the idea how the warehouse looks in the version control and as a database project. Then we can sync the Git repo or open the contents of the zip file that we have downloaded in a tool like VS Code that can be used to interact with the SQL Database Projects. Then in VS Code, we can edit the files in the SQL Database Project and, for example, define new SQL scripts that could create more objects to the warehouse. Also, it is good to highlight that since the data itself doesn't get committed to the version control, we have only the create table statements, etc. here to work with, and not the actual data. After we have done our possible changes, we can proceed to our next step in our deployment process and use tools in VS Code to build the database project into a DACPack file. And you might ask, what is a DACPack file? Basically, a DACPack file is a special file that stores the structure of a database that in this case is our warehouse. You can think of it like a zip file for your database structure that has been validated, since a successful build of a DACPack file can be done if there are some errors in the code or some dependencies between objects are not defined correctly. For example, that we have a view that is pointing to a table that doesn't exist. Then after that, our DACPack file can be then deployed to our target warehouse in the test workspace using tools in VS Code. And that will then make changes and populate our test warehouse with objects coming from the DACPack file. And remember, this just means populating the structure and not the actual data. Also, it is good to note here that the build and deployment of the DACPack file can be easily scripted and automated. Those who have more experience working with Azure SQL databases and warehouses could be familiar with automating this part in Azure DevOps or GitHub deployments. In that workflow, we would commit the changes to our database to Git repo and then use a deployment pipeline in those services to handle the build and deployment of the DACPack file to the database in the next environments. We are not going to cover this in the demo, but it is good to know that this is possible with SQL Database Projects. The last thing that I want to highlight on this slide is that using the SQL Database Project is an alternative method to using Fabric's deployment pipelines. When you use deployment pipelines, you don't have to deal with building the DACPack and deploying it, since Fabric deployment pipelines will handle that logic for you. Next, let's take a look at prerequisites that you need to set up in order to use database projects and do deployments from your local computer that we are going to do in the demo. First, you would need to install Visual Studio Code, that is commonly known as VS Code. That tool is going to be used as the tool for making changes to SQL Database Project and building and deploying the DACPack file. Then you need to install Git. Of course, this is not totally mandatory if you would just download the database project without syncing your workspace to Git. But I would highly recommend trying out database project with Git integration. And that is what we are going to do in the demo/tutorial. Then you need to have .NET SDK installed that is needed to build the DACPack file. And lastly, you need to install the SQL Database Project extension for VS Code. That is the dedicated extension for interacting with SQL Database Projects and doing deployments from VS Code. And as a final note, I want to say that VS Code is only one of the tools that can be used to do the steps we are going to do in the video. Very common is to see the use of Visual Studio as well for interacting with SQL Database Projects. Also, command line interface can be used to build and deploy Datacamp files, and that is the tool that is used in Azure DevOps and GitHub deployments. But now let's go to Fabric and do a demo/tutorial together. Now we are in Fabric and I have my DP-700 tutorial workspace open here. And in this workspace we have this one warehouse DP-700. And in this warehouse we have a bunch of different schemas and tables and other objects that we have been creating to this warehouse in the previous tutorials in this series. Let's see when this warehouse will load up, and here we can see that we have a bunch of different schemas, and in these schemas we have different types of objects like tables and views and stored procedures, etc., depending on the folder or depending on the schema that we have there. In the previous episode, we already deployed the contents of this warehouse to our test workspace using a deployment pipeline. But today I want to deploy the contents of this warehouse using an SQL database project. And the warehouse to which I want to deploy the structure of this warehouse is in this warehouse deployment test workspace. And here I have this warehouse that is currently completely empty, and we shouldn't have anything here because I haven't deployed anything to this warehouse yet. And here we can see that we only have the standard and default schemas in this warehouse. But yeah, remember that we have already attached this workspace to Git in previous episode, and here we have that Git repo. And here we can actually see that warehouse in the Git. And here we can see that this warehouse is already represented in SQL database format in Git when we sync this. And this is the default format how the warehouses are represented in version control. Here we can see that we have those different schemas here, and under those schemas we have some different objects. For example, in this 13 schema, we have some tables, then we have some views, and then we also have some stored procedures. So we have different types of objects here, and here are their create statements in SQL. Then these create statements can be used to create the structure of our warehouse to an empty warehouse. And that is what the database project will do, and also the deployment pipelines will do the same thing. Also underneath here we can also find this SQL project file, and from this file we know that basically this is a SQL database project. Next, I would like to clone this repository to my local computer, and then on my local computer do some changes and build the Datacamp file out of this database project, and then deploy that Datacamp file to that other warehouse that I just showed to you. We can quite easily clone this repository in VS Code by going to the repository level and then clicking this clone. And here we have this option to clone in VS Code, and I'm going to click that. And this will then prompt us to open the Visual Studio Code, and I'm going to click that. Then next we have to select the folder to which we want to clone our Git repo. I have already this Git repos folder here, and I'm going to clone that Git repo here. So let's clone that there, and now the VS Code will start to clone that, and then we can open up that. And here we can now see the local version of that Git repo here in VS Code. And remember that you need to have those prerequisites installed that I covered there on the theory section in order to do these steps with me. And remember that one of the crucial things that you have to install is this SQL Database Projects extension that you can find in the VS Code marketplace, but I have already that installed. And after you have installed that and cloned your Git repo, then you can open up this Database Projects tab here. And this will identify that I have two database projects in my Git repo. I have that staging warehouse for Dataflows that I'm not going to use in this demo, and then we have that project for this warehouse DP-700 that we are going to actually use in this demo. This SQL Database Project extension would allow us to do quite many operations with our SQL Database Project that are way out of scope for this video, since DP-700 will only require some basic knowledge about database projects. But here we can see, for example, if we right-click this, that we can define some new tables, new views, stored procedures, and pre- and post-deployment scripts to this project. But those are things that we are not going to cover here now. But then we have also these build and publish buttons here that we are going to use shortly. But in this view, we would be able to make some changes to these create table statements that we have, for example, in this episode 4 folder. For example, here I have a create table statements for assignments that would create that assignments table when we do the deployment. Also here we could actually modify these. For example, we can change the assignment ID to be assignment ID underscore 123. And now this would be the table that would be added to that DACpack file and then deployed to that following warehouse. And I can actually leave this change here because I'm not going to commit the changes that I do here back to the version control. But of course we could do that as well. Next, from this view, we could actually build that DACpack file that could be then deployed to our target warehouse. And to build that file, we can right click to warehouse here and then we can select build. And this will start the build process here that will build that DACpack file. And now that build is going on and we can soon see a result, was that build successful? And there we can see that build succeeded. This means that all the dependencies and all the code is correct in the database project. We can actually do some tiny modification here that would cause error in the build. So if I add here some random letters and then I save this and then we would try to build this, we would result into an error. So let's try to run this again with that error now there, and now the build shouldn't succeed. And we can see that build failed because the build will validate our code and check for those dependencies. But yeah, let's remove this error for now and let's save this so that it won't cause any issues when we are doing the actual deployment. And next, let's publish/deploy that DACpack file to that new warehouse that I have in that new workspace. In order to do that, you can right click that warehouse there and then click this publish button. And here we want to select publish to an existing SQL server, and then we don't need to use the profile, and then we are actually going to create a new connection profile here that will point to that workspace and to that warehouse. So let's click this create connection profile, and here we have to define that connection profile. And here we first have to provide a name for our connection, and I'm actually going to use the workspace name here because basically this is a connection to that Fabric workspace. And next we have to provide the server name, and that is actually going to be the connection string of the workspace. So let's go back to Fabric. And here in Fabric we can get that connection string from multiple different places, but one easy place is to get that from the settings of our warehouse, and here we can find the SQL endpoint, and this is basically the SQL endpoint of the workspace. And now it has been copied, and while we are here we have also this option here to download the SQL Database Project. Basically this would then download a zip file that would contain that same structure that we just saw in the Git repo, but in that dedicated zip file that we could then use to do the deployments without using Git at all. But of course, like I have covered previously, using Git is a best practice here. And now since we have that connection string, we can input it here, and there is the connection string, and then the authentication type, I'm going to select the Microsoft Entra ID, and I'm going to use my account for doing that connection. And then basically we can click connect. And now the connection to the workspace's SQL Analytics endpoint has been made, and underneath here we can see that warehouse, since it is the only data store in that workspace that has that SQL Analytics endpoint. And under that warehouse we shouldn't see much since we haven't done any deployments to that warehouse yet, nor created any items there. But now we have that connection, and now we would be able to actually deploy the contents of that warehouse project to there. So let's go back to this slide where we are managing that database project and then redo that thing that we just did. So let's click publish and then publish to existing SQL servers. Don't use profile, and then we select the connection that we just made there, and then we click that. And next I think it will prompt us to select the database, and here we have that warehouse DP-700 deployment test. I'm going to select that, and then we can generate the script or publish, and I'm going to actually click the publish button. But before we do that, I will change the position of my face so that we can see what's happening underneath my face. But yeah, I'll click this publish. But now we can see here that deployment is in progress and the build has already succeeded. And it is now publishing that DACpack file to that warehouse. And now after like 10 seconds that is done and the deploy DACpack has succeeded. Okay, let's recap a bit what just happened here. So basically we just built the structure of this warehouse into that DACpack file, and then we used that DACpack file to deploy that contents to that warehouse that we have in that new workspace. And soon we will go to Fabric and check out, do we have the same structure that we have in this SQL database project there in that warehouse, including this tiny change that I made to this assignments table here. But yeah, let's go to Fabric. And here we have that new warehouse. Let's refresh this and let's see, do we have more schemas here? And indeed, here we can see that we have new schemas here. And let's check out, do we have that tiny change here that I made to that assignments table? So let's click that. And there we can see that we have that 1, 2, 3 there. But as you can see, we don't have any data here. That is because the data is not committed to version control and not included to the database project. We cannot deploy the data itself. So now we would need to run some data pipelines or do some other things to get data to the warehouse. But yeah, like I said, now we're just scratching the surface what comes to these database projects. But since DP-700 doesn't really require that in-depth knowledge on the database project, we are not going to cover those in this video. But leave some comments to the comment section down below if you'd like to see me more advanced topics related to database projects and warehouse in upcoming videos after I'm done with this DP-700 series. Next, let's have a question about database projects so we can test, did you learn anything in this video? But before we do that, I would like to tell you about this website called certiace.com that offers free custom-made practice questions to Microsoft certification exams like DP-600 and DP-700. And I'm actually one of the co-founders of this website. But after watching this video, go check out certiace.com. But now let's have that question. Our question today is, what type of file we get as an output when we build a SQL database project into a deployable artifact? A. SQL Pro J, B. XMLA, C. JSON, D. DACpack. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D. DACpack, and this should be the obvious answer to anybody who has watched this video, since we have covered multiple times that the DACpack is the output artifact when we build SQL database project. This is the episode 24 in the DP-700 exam prep series, and in this episode we will cover choosing data engineering tools and data stores in Fabric. In this series we have already covered the essential tools and data stores to know in the DP-700 exam. But in this episode we will compare those side by side to learn about their strengths and weaknesses, to be able to decide when to use given data store or data engineering tool. This episode is going to be a bit different from the typical formula, since we are only going to have a theory section and then few questions about the contents covered in the episode, so that you can test your knowledge. But now let's get started. Let's first do a quick recap of the data engineering tools that we have already covered in this series in their dedicated episodes. First, we have the data pipeline tool that is a great tool for orchestrating your data solutions, since this tool is able to call and use different items in Fabric like data flows and notebooks, etc. However, in this episode, when I refer and compare this tool to other tools, I am mainly talking about the copy data activity in the data pipeline that allows copying data from place A to B, since it is the main data ingestion and light transformation tool that is actually built into the data pipeline. Other activities in this tool are typically calling some other items and services that can then handle data ingestion and transformation, but in those cases the data pipeline itself is not really doing those things. Next, we have Dataflow Gen2. This is also a low/no-code tool like the data pipeline, but this tool has a lot more data transformation capabilities, and you can actually do some heavy data transformations with this tool. Then we have the Eventstream, yet another low/no-code tool. This tool's specialty is to capture and process real-time streaming data. It is designed for scenarios like IoT, telemetry, logs, and live event data. The data transformation capabilities of this tool are somewhere in between Dataflow Gen2 and a data pipeline. As a last data engineering tool, we have Spark Notebooks. This is the tool that lets you write your own code by using this notebook interface. This tool can be really the Swiss Army knife of a data engineer because it offers so much flexibility. Of course, if you don't know how to write code, then this tool can be a lot harder to get started with compared to those low/no-code tools. There are also other notebooks in Fabric, but in this episode we are talking about Spark notebooks that utilize the powerful Spark engine that we have covered in a dedicated episode in this series. Also, keep in mind that Spark can be run by using Spark jobs also. That basically means that you submit your Spark code to a cluster without using this interactive notebook interface. Now let's compare these 4 different tools side by side, since to be able to decide which tool to use in which scenario is an important topic that is measured in the DP-700 exam. And you could be wondering why it says Alex's version in the title. Well, that is because there is this kind of comparison table found in Microsoft Fabric's documentation, and we are going to take a look at it on the next slide. But to this slide I have picked the things that are in my opinion the most important to know in the DP-700 exam. Let's first compare these tools on transformation complexity, meaning how complex data transformations we can do with each tool. With data pipelines copy activity, we can't really do much. Only some lightweight things like flatten some hierarchy in JSON to some extent, rename columns, combine data from different tables. Basically, data transformation capabilities are very limited, and this is mainly good for copying data from place A to B. With Dataflow, we can do more complex transformations, since it has over 300 transformations available. Eventstream also can do some light transformations using its different transformation nodes, but the flexibility with those is not close to Dataflow's capabilities. Then with Spark, we can basically do anything we want if we know how to code it. So if in the exam the question is saying something about high complexity with transformations, that is already pointing towards Dataflow and Spark and eliminating data pipelines and Eventstream from the choices. Next, let's cover how much coding each tool requires to be able to use them. We kind of already covered this in the introduction, and all the other tools are no/low code except Spark notebooks and jobs. So again, if question is talking about low/no code preference, then it is already eliminating notebooks. Then the next point is developer skill set. Here the most important points to highlight are that if M or Power Query is mentioned, then the question is pointing you towards Dataflow Gen2. On the other hand, if anything is mentioned about writing Python, Scala or R, then this is pointing heavily towards Spark notebooks and jobs. Development interface is also somewhat obvious one. One thing to highlight here is that both Data Pipeline and Dataflow also offer a wizard interface that allows getting started with some of the things without using the canvas. But this is something that is not most likely going to play a role in the DP-700. Next, we have a custom row for data refresh cycle that is not found in the official table in the documentation. But in my opinion, this is a very important part of choosing between these tools. Both Data Pipeline and Dataflow are meant for batch type of data, meaning that we run data in batches based on schedule or in some cases using event-based trigger system. But these tools are not meant for handling data streams. With Eventstream, we can handle streaming data in near real time, and that is the primary use case of that tool. With Spark, we can use Spark structured streaming to handle data stream, but we can also handle batch scenarios as well. So if in the exam near real-time data is mentioned, this is pointing towards Eventstream and Spark. Then something about the connectivity what comes to sources. Data Pipeline has quite many native connectors that can be used to fetch data in. With Dataflows, we have even more native connectors. Eventstream has its own native connectors that are basically meant for some event-based streaming like CDC and Kafka. With Spark, we have a ton of different choices, since again we have the power to write our own code and use libraries and code that other people have made. Then about destinations. With Data Pipeline, we have almost the same number of native destinations than we have sources, and we can write data to all data stores in Fabric. Dataflow is more limited with its destinations, since it is not really a tool that is meant to write data out of Fabric, and it is mainly used to bring in and transform data. But still, we have few different data stores available in Microsoft ecosystem. Eventstream is typically used to write data to Eventhouse, but it can also write data to Lakehouse as well. Also, you can use Eventstream to set up Activator alerts and write data to another Eventstream and also add a custom endpoint. With Spark, we have again the power of code on our side, and we can connect to most places that have some type of API or other interface to which we can write data. In the exam, you are most likely going to have some combinations of different points that we covered here. So based on these differences, you just have to narrow down those options in the exam. Here on this screen, we can see how that table looks in the official Microsoft Learn documentation. Here we can see that we also have a copy job in that table. That is not currently part of the DP-700, or is not at the time of recording this episode. But basically, copy job is very similar to data pipeline's copy activity, and you can think of it as copy activity that has been separated to its own fabric item. I have made a video on copy job to my YouTube channel, so if you're interested in learning more about it, then check it out. I think eventually they add copy job to be part of DP-700. Next, we are going to have a similar comparison to data stores. Again, let's do a quick recap of the data stores that we have in Fabric that are in the scope of DP-700. First, we have the warehouse that resembles the most closely a traditional database. In this data store, we have our typical database objects like schemas, tables, views, functions, stored procedures, etc. Data here is stored in a very typical and traditional table format. This data store can also do some data transformations by using stored procedures and by implementing logic to views. So in some aspects, we could consider this to be a data transformation tool as well. Then we have the Lakehouse. This data store can store data in tables like warehouse, but also has the ability to store raw files as well, meaning that you can land and store any type of data here. Also, this data store offers a read-only SQL endpoint that acts like a warehouse that you can just use for reading data from tables and views. Lastly, we have the Eventhouse. This data store is meant for event and log type of data and supports more flexible schema with its tables than warehouse. And remember that Eventhouse is actually a collection or container of KQL databases. Next, let's do the same thing with these data stores as we did with the data engineering tools. Again, here we have my version of the comparison table, and I have changed few things here and there compared to the one found in the documentation to highlight the things that are important in the DP-700 exam. First, let's compare the type of data we can store to these data stores. Lakehouse is the most flexible data store out of these three, since it can store raw files and you could even dump their video and audio files if you so desire. What comes to the warehouse, it is on the opposite side of the spectrum, since it is mainly meant for structured data and can handle some semi-structured data like JSON, but the functionalities with that are limited. Eventhouse is then in between, since it is more flexible than warehouse, but you can't really store raw files there like you can with Lakehouse. With Eventhouse, you can just be more flexible with your data schema, and that's why it can support different types of data. If in the exam you hear anything about storing raw files, then Lakehouse is your most likely answer. Then what comes to developer skill set? Lakehouse is primarily used to interact with Spark, even though it has read-only TSQL endpoint with limited functionality. What comes to warehouse, it is closest to a traditional SQL database, and thus SQL and more specifically TSQL is needed there. With Eventhouse, the primary language is KQL, but SQL can be also used with this data store to some extent. For reading Lakehouse, we can use the mentioned Spark languages or the TSQL endpoint. With Warehouse, we can use TSQL and some limited read functionality using Spark. What comes to Eventhouse, we can read it using KQL, TSQL and Spark, but the KQL is the most native language here, like I just mentioned. Then let's look at the write operations. For writing, Lakehouse basically only supports Spark. With Warehouse, the main language is again TSQL, and also there is a relatively new Spark connector with limited functionality. To Eventhouse, the write can happen via KQL, Spark, or using some of the connectors found in the KQL ecosystem. Let's stop here for a moment. So, as you can see, Spark can be quite widely used to interact with all of these data stores. With Warehouse, the connectivity is limited, and thus if the exam question talks about using Spark as preferred way of interacting with the data store, I would first drop Warehouse from the options. Usually when Spark is mentioned and preferred, that is already heavily pointing towards a Lakehouse, but beware that there could be trick questions in the exam. Also, with TSQL, things can be tricky, but if right operations via TSQL are mentioned, then pick Warehouse. What comes to KQL, I can confidently say that if question is talking about it, then the answer is most certainly Eventhouse. Then we have a point about multi-table transactions. I will first explain briefly what this even means. If multi-table transactions are supported, we can update multiple tables within a single operation, so that for example if one of those fails, then none of those will go through. Multi-table transactions allow us to guarantee consistency between different tables. These kinds of operations are not supported for Lakehouse, but are for Warehouse and to Eventhouse to some extent. So if this is a requirement in the question, then the answer is not a Lakehouse. Then we have primary development interface. For Lakehouse, it is the Spark notebooks and jobs. For Warehouse, we use SQL scripts in different tools. For Eventhouse, we use KQL query sets. Then about security for the data stores. For Lakehouse, we can use row, column, and object level securities and dynamic data masking via the read-only SQL endpoint. Also for Lakehouse we have the one-leg security that is a preview feature at the time of recording, but it will in the near future provide those same security features but on one-leg level so that they are applicable to all engines reading the data. Then for Warehouse we have the same security features as for the Lakehouse's SQL endpoint. And lastly, for the Eventhouse we only have row-level security. Then about accessing data via shortcut, the answer here is quite simple, that all of these data stores can be accessed via shortcut, and with Lakehouse you can access the raw files as well. Advanced analytics support is very similar for Lakehouse and Warehouse, because they have a lot of same technology under the hood, and both data stores are good for large-scale processing, parallelism, and fault tolerant. Eventhouse then has some different capabilities, and it has native support for time series and geospatial data. So if you hear those keywords in the exam, then the most likely answer is going to be Eventhouse. Advanced formatting support is also similar to Lakehouse and Warehouse due to the same underlying Delta technology. Eventhouse is a bit different again. Then with ingestion latency, the same story continues, and with Lakehouse and Warehouse, the ingested data is instantly available for querying, but with Eventhouse there could be a tiny delay. Again, most likely in the exam you will hear multiple points from this table mentioned, and then you would need to narrow down your choices to the correct data store or data stores that the question is after. And here we have the original table from the Microsoft documentation that has few things written differently than in my table. Also to my table I added few things and removed few things here and there to make things easier to understand and highlight. Here we also have one helpful decision guide that can be found from the Microsoft documentation that can help you to decide between Lakehouse and Warehouse. If we go from left to right, the first question is how do you want to develop? And of course if your team skills are in Spark and you prefer that, then go with Lakehouse. And if you have a bunch of TSQL developers, then Warehouse is most likely a better choice for you. Next, we have a point about those multi-table transactions that we covered, and since Warehouse is the data store that supports those, then if you need them, then go with Warehouse. Then about the type of data. If you plan to store only structured data, then Warehouse. If you need any support for unstructured data, then go with Lakehouse. And if you don't have an idea about that, then go with Lakehouse because it gives you the flexibility that could be needed. Also, you can very well have both of these data stores in your setup, and for example have a Lakehouse as your bronze and maybe silver layer data store, and then for gold layer use Warehouse. So in many cases you could be leveraging both data stores as part of your setup and architecture. Next, let's have few practice questions about the topics covered in this theory section. Let's have our first question. A healthcare organization needs to build a data processing solution in Microsoft Fabric with the following requirements. Ingest patient monitoring data generated every second by connected devices in hospitals. perform real-time transformations and filtering immediately, store raw and processed streaming data for later analysis to a lakehouse, enable business analysts to perform data cleansing and preparation of the historical dataset. Low-code tools are preferred. Which combinations of tools you would recommend? A. Eventstream and Dataflow Gen2. B. Pipeline copy activity and Spark. C. Eventstream and Spark. D. Eventstream and data pipeline copy activity. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. A is the correct answer because it best satisfies the need here. I highlight some of the keywords and requirements to look for in this question. With Eventstream, we can do those real-time transformations, and it also satisfies the requirement for low-code preference. Dataflow Gen2 is also a low-code tool, and that we can use for historical dataset cleansing and preparation. B is incorrect, since Spark is not low-code and copy data is not really needed here. C is incorrect because of Spark again. D is incorrect, since we don't have a tool for cleansing and preparing the historical data, since copy data doesn't have the required capabilities. Let's have another question. A logistic company is building a data solution in Microsoft Fabric with these goals. Capture vehicle telemetry data in near real time as trucks move across the country. Perform real-time filtering to only keep events where the temperature exceeds safety thresholds using a low-code tool. Store these filtered events in a lakehouse for compliance reporting. Periodically combine the streaming data with historical shipment records and run advanced analytics using Python to identify risk patterns. Which combination of tools meets all these requirements? A. Eventstream and Dataflow Gen2. B. Pipeline copy activity and Spark. C. Eventstream and Spark. D. Eventstream and pipeline copy activity. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, Eventhouse and Spark, because with this combo we can fulfill the need here. Here again some keywords to look for. We see the requirement for real-time and low-code that Eventstream will be able to fulfill. And then we have a requirement for running Python for historical data that can be done with Spark. A is incorrect since Python can't be used with this combo. B is incorrect since with this combo we don't have low-code streaming tool and copy data doesn't really fulfill requirements here. D is incorrect also due to the Python requirement. Let's have one more question. Financial service firm must architect a data solution in Microsoft Fabric with the following requirements. The system must store large volumes of structured data and transaction data as well as unstructured market news and sentiment data. Analysts need TSQL transformation support, including the ability to do multi-table transactions across financial tables to ensure consistency. Which Fabric data store configuration best satisfy all these requirements? A. Lakehouse and Eventhouse. B. Lakehouse. C. Warehouse. D. Lakehouse and Warehouse. Now think about the answer for a moment and pause the video. I'll reveal the answer in 3, 2, 1. The correct answer is D, because with this combination we can satisfy all the needs here. I highlight again some of the keywords to look for in this question. We can store unstructured data to Lakehouse, and then with Warehouse we have that TSQL transformation support with multi-table transactions. A is incorrect since with this set we can't really do TSQL transformations with multi-table transactions. Even though Eventhouse has some TSQL support, it is very limited and not really a suitable data store for financial tables that require consistency. B is incorrect because of the multi-table transactions. C is incorrect because we can't store unstructured data to Warehouse alone. This is the episode 25 in the DP-700 exam prep series, and in this episode we will cover Activator, that allows capturing different types of events and taking actions like running Fabric items, sending emails and Teams messages based on those events. Like in every episode in this series, we'll first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in the episode, so that you can test your knowledge. But now, let's get started. Let's first start by covering what the Activator is. Basically, Activator is a service or item in Fabric that automatically watches for data events. And when an event happens, Activator can trigger actions. So Activator treats all data sources as stream of events. Activator supports multiple different sources that can send events to Activator. Here we have some of the typical sources for an Activator. We can, for example, use an Eventstream as a source, which will then allow us to connect to multiple different sources that are supported by event streams. Then we can also use KQL scripts as event sources and, for example, run a KQL query to an Eventhouse and then take actions based on the query results. Also, we can use Azure Blob Storage and OneLake as a source, and in this case, watch for events like file creations and deletions. Then we have the possibility to watch for Fabric Workspace and item events, which include things like item creations and item execution failures. Also, a cool thing is that we can use Power BI dashboard and report data changes as an event source. For example, that some value on a report exceeds certain threshold, which would then be captured by the Activator. After we have captured some events from our sources, we can then configure Activator to do some actions based on those events when certain logical conditions are met. For example, that we want to only trigger an action when a file with a specific name is written to OneLake. There are currently 4 different types of actions that can be taken with Activator. We can send emails and Teams messages. That could be great if you are, for example, monitoring actions that are happening in your Fabric environment and when some values on your Power BI reports exceed certain thresholds. Then we can trigger Power Automate workflows from the Activator. And lastly, we can run Fabric items. At the time of recording, only data pipelines and notebooks are supported. But this functionality will already enable us to use event-based triggering, which we are going to look at in the demo section more closely. Now you should have a basic idea what the Activator is all about. So basically we watch/monitor events and then take actions based on those events. Next, let's dive a bit deeper into core concepts of the Activator. With Activator, we have 4 main core concepts, and we are going to start with events that we already discussed a bit on the previous slide. Basically, Activator treats all data sources as stream of events. And here we can see an example where 2 different temperature sensors are pushing data to a Fabric event stream that then is pushing data to Activator. Here we can see how does that event stream source and data coming from it look in the Fabric UI when looking it in the Activator. We can see our data source, that is the event stream, and then we can see all the events that are coming from that source on a timeline. And then we also have this row view that allows to look at the incoming data in a row format like in a database table. Also, a good thing to note is that when you create sources for Activator, many of them will require creating an event stream item as well. With some sources, event stream is not created, at least not visibly, but I imagine that for those sources Microsoft is using event stream technology on the background, but we just don't have access to it. To really highlight what the concept of events is all about, here we have few example events like a file added to OneLake, temperature reading from a sensor, condition met in a Power BI dashboard, and messages arriving to Azure Event Hub. So basically events are just rows of data that arrive to the Activator. Then let's move to the second core concept, objects. Objects, or formerly known as business objects, are defined entities that Activator monitors. These objects can be either physical, like locations, vehicles, and users, or conceptual, like ad campaigns, customer accounts, or user sessions. The basic idea here is that we can define some business rule to the data that is coming in, and we say that we have a unique identifier in our data that is able to separate 2 different entities from each other. We can also pick the columns, or in Activator terms, the properties that we want to include to the object. In our temperature example, we have data coming from 2 locations, Atlanta and Vienna, that are the locations for the next Microsoft Fabric community conferences. From our incoming temperature event data, we can define a temperature object to the Activator and say that location is actually a unique identifier in the data. This way we are able to identify that in our data we have actually data for 2 different entities or places that are Atlanta and Vienna. And then we are able to observe events for a specific location and separate them from each other, which can make building rules and actions easier and more convenient. Next, let's talk a bit more about properties that are also a core concept in Activator. On the previous slide, we already covered that when creating an object, we can choose the properties that we want to include. Like said, properties are basically columns in our incoming event data. A cool thing is that in the Activator, we can include some calculations for our properties. In our temperature example, we can, for example, calculate average temperatures and then use that logic in our rules and actions that we define. Then, as a last core concept, we have rules that determine the actions that are taken after configured conditions are met. We actually have 3 different types of rules that can be defined in the Activator. First, we have event-based rules that can be triggered by individual events as they occur. These rules can be created for the raw data streams without defining objects. For example, we could just monitor our data stream and send email if no incoming data is detected in 10 minutes. Next, we have object event rules that can be triggered when an event is added to a specific object. With these rules, we can, for example, monitor a specific entity within an object. In our temperature example, we could monitor data silence for Vienna temperatures and get notified when there is no new incoming data for Vienna in 10 minutes, even though we would be still getting that data for Atlanta. Then, as a last type, we have object property level rules that can be triggered based on the current state or properties of an object. So, for example, we could monitor Vienna temperature averages and then do actions when a certain threshold is exceeded. Next, let's cover how rules are created and defined by using our event-based rule as an example. First, we have to choose the data that we want to monitor with an event-based rule, and that is the entire incoming data. Then we define conditions that should be met before an action is taken. We have quite a lot of flexibility with these conditions and a lot of things to choose from. In this case, the condition is that no data has been detected in the last 10 minutes. Next, if we would be defining an object or object property rule, we could add a filter that would, for example, filter a specific location. A good thing to note here is that by defining multiple conditions, we can achieve the same result as with filter, since we can, for example, create a condition that says that the location should be, for example, Vienna. Then we get to the most interesting part, that is defining the action that should be taken when conditions are met. We already covered these on the first slide, but as a recap, we can send emails, Teams messages, run Fabric items, or trigger Power Automate workflows as an action. With emails and Teams messages, we have room to configure what will be added to that email or Teams message that is going to be sent out as an action. After we are done and happy with our rule configuration, we can actually test the rule and see how does our message look and does it come true, or is our Fabric item triggered by the rule. And after the testing, we can decide to start the rule. And we also have the possibility to just save the rule and not start it yet, and we can pause existing rules if we so desire. Next, a bit about event triggers for data pipelines that we are going to cover in the demo section. You might have seen this Add Trigger button in the data pipeline development view. From that, we are going to be able to define an event-based trigger for our data pipeline. After we click that button, we have to specify a few things. First, we have to specify the event source that will trigger our pipeline. In this case, I have selected OneLake events and done the required configurations for it that we are going to go through in the demo. We also have some other possibilities like job, workspace, and Azure Blob Storage events available here in the data pipeline UI as well. Then, as an action, we already have the information of this pipeline pre-configured, since we are creating this trigger from a specific pipeline. And lastly, we have to specify the location to which we want to save the trigger to. And that location is going to be an activator. Now someone could be wondering that could we create this trigger from the activator as well? And the answer is yes. And we could actually trigger this pipeline from the changes that we have in our temperature data that we have been using as an example in this theory section. However, I have done some testing and it seems that we have to configure this trigger from the pipeline in order to get some parameters from the trigger as dynamic content to our pipeline. When you use the dynamic content in a pipeline, you should see this trigger parameters tab. That has those trigger parameters that are passed from the activator to this pipeline, and then these can be used to build pipeline logic. And this is all for the theory section, and next let's go to Fabric and take a look at the activator there and configure an event-based trigger for a data pipeline. Now I have my DP-700 tutorial workspace open here, and to this workspace I have actually already created an activator. And I have also two Python scripts running on my local computer, one for Atlanta and one for Vienna, and both of these are sending these fake temperature readings to the event stream that I have in that same workspace as well. But basically these scripts are very similar to a script that we have already used in this series when we covered event streams. But yep, let's go and check out that event stream to which those scripts are sending that data. I have that in the episode 25 folder, and here I have that event stream. And let's open that up. And here we can see that this is a very standard event stream, that we don't have any transformations here. And this event stream is basically just pushing that data to the activator. And soon we should see a quick data preview what's happening in this event stream. But we are just using this event stream to route those temperature events to the activator so that we would be able to take actions based on those events. And here we can see the preview for the data. So basically we have data for two locations, and then we have a timestamp, and then we have a temperature reading and event ID. And then we have these columns that are created by Eventstream when we ingest data. But yeah, let's go to Activator and let's see how does this data and events look there. So now we are in Activator, and here we can see that we have a bunch of events coming in. We are now looking at this 2-minute window, and we see that we have many events coming in the last 2 minutes, since those scripts that I have running on my local computer are sending events every few seconds. But yeah, we can see that we have a bunch of events coming in. So now we have some events coming to our activator, and based on these events we could already build some rules and take actions. Let's not create any rules yet. Instead of that, let's create a new object. And we can call this object a temperature, and then we have to specify that unique ID. So now we are creating this business object and telling the activator that we actually have a unique identifier in this data. That is going to be the location. And then we can choose the properties that we want to include to that object. And we can, for example, pick the temperature and timestamp. And then we can hit create. And now we were able to create this temperature object to the activator that has the location as the unique identifier. And we can now see that the activator is able to separate that we have data for Atlanta and then we have data for Vienna, so that we have actually two different streams of data in that one event stream. In this view, we can only see the raw events that are happening per location. But for example, if we click the temperature property here, we can see the actual temperatures that are coming in per location. And like we covered in the theory section, we can actually add some calculations for these properties. And we can click this edit details here, and here we have the possibility to add summarization. For example, we can calculate the average temperature over, for example, 1 minute. And then we can click save, and this will start to calculate that average temperature for 1 minute. And then we can close this. And then if we go to this definition page, here we can see that computed average temperature for each location. And next we can configure some rules by using these properties and the incoming stream itself. And we can, for example, click this incoming data stream, and then we can click this new rule. And this will open up this tab where we can configure the condition that should be met before the alert is sent out. And to this condition, we have many different functions that we can use to configure this. But for example, I can now use that no presence of data, and then I can specify that, for example, if I don't have incoming data in 10 minutes, then I want to send an email out. And here we can configure information about that email. And remember that we have also the possibility to send Teams messages and also to run Fabric items. And with these Fabric items, we have only the possibility to run notebooks and data pipelines currently, but I assume that at some point they will expand the selection and we are able to run different items as well. But for now we have to stick with data pipelines and notebooks. But yeah, let's cancel this and let's not configure this rule yet, since I want to actually create that event trigger for a data pipeline. So let's talk about that next. Here we have this very basic data pipeline with just wait activity, and then we have this set variable activity. We're going to take a look at this set variable activity more closely soon. But now I want to add a trigger to this pipeline, and we can click this Add Trigger button. That will open up this tab where we can do the necessary configuration for the trigger. And first we have to pick the source for our trigger events. Basically, what is the event that will trigger this pipeline? And here we have some possibilities like the job events, OneLake events, workspace item events, and then Azure Blob Storage events. Now I'm going to go with the OneLake events. And here we have some different OneLake event types that can trigger a data pipeline. We can, for example, trigger a pipeline from the file creation, file deletion, file renaming, folder creation, folder deletion, or folder renaming. But for now, I want to trigger this pipeline from only the file created event. So let's choose that. And next we configure the source for our events. And I'm going to select the Lakehouse that I have in this workspace, and we can click Next. And then we have to choose the folder that will be monitored for those events. We could actually select the entire Lakehouse to be monitored, but for now I want to monitor only this folder that is meant for this episode. And I'm going to click that folder and click Add. And next we would be able to define filters here. And these filters would be able to filter out, for example, a specific file that we have incoming, so that not every file would trigger this data pipeline, but the specific file would. For the file name filter, we could actually use this subject property here and then use some string operations to select only a specific file that is coming in. But for now, I don't want to specify any filters to this, and we can remove that. Now we can see that we have already this applied filter to the subject since we selected that specific folder. So now it's already filtering out only the events that are coming from that specific folder. And here we would configure the item that we want to run, but this is already pre-configured to the pipeline that we have here because we are creating this event trigger from the pipeline UI. And next we have to select the location to which we want to save this event trigger to, and that actually has to be an activator. So we select the activator that I have already created to this workspace, and then we can click create, and this will create that event trigger to that activator. And now that trigger/alert has been created, and we can check out that in the activator. But before we do that, let's check out the dynamic content that I have in this set variable activity. And here I have configured this expression where I'm using these trigger parameters that can be found here. So we are able to get some information out from that event trigger. For example, the file name, the folder path, the source, and the subject and the type. So this is some information that is passed from the activator to the pipeline as a parameter. And by the way, you don't have to define any parameters to your pipeline in order to get these, since these are handled on the background. But yeah, basically you can use these to then build logic in your pipeline. For example, if you have some information in your trigger file name that you want to use in the pipeline logic. But yeah, it is good to be aware that these are available here and can be used. But let's close this and let's go to the activator. And now in the activator, we can see that we have a new source for events. That is that Lakehouse, and we can actually click this manage source here and see that it's pointing to that Lakehouse. And what is the event type there? It is the file created, and then we are also filtering only the events that are coming from that specific folder. And then under that, we have the rule that will trigger that data pipeline if we have any events incoming to that event source. Next, let's go to that Lakehouse and let's upload one file there in order us to see what happens. So let's open up that Lakehouse, and here we have the folder, and to this folder I want to upload files. And then we can find the file that we want to upload. And here I have this trigger file.txt that I'm going to upload to that folder. And remember that since we didn't define any file name filters, any file that I would upload to this folder would actually trigger the data pipeline. But yeah, let's upload this file here. And now it is being uploaded, and it is a small file, so it was already uploaded. And then we can go to the activator and let's see, did anything happen here? And now we can see that we actually have one event coming in. And here in the live feed, we should see some row level information. And here we can see all the information that the event produces. So we have the timestamp ID, the source, and the subject. And as you can see, the file name is in the subject. So if you want to filter out, for example, a specific file name, then you could use the subject to do that. And then we have a bunch of other information about that event. And now let's go take a look at the data pipeline that did it trigger. So let's open up the data pipeline, and here we can view the run history for this data pipeline. And we can actually see that we have already one run that succeeded. And we can open the information for that run. And here we can see that it succeeded because it only has those two activities. And then we can take a look at the output of our set variable activity where we had those trigger information as dynamic content there. So let's look at that. And here we can see that we have the file name there, then we have the folder path there, and then we have the source information there, and then the subject information, and then the type. And these were the information that are available as like trigger parameters in the data pipeline that we could use to build some logic. But yeah, it seems that these came through fine here as well. So this triggering seems to work. Next, let's have an exam-like practice questions about the Activator. But before we do that, I would like you to know about this website called certiace.com that offers free practice questions for certification exams like DP-700 and DP-600. And I'm actually one of the co-founders of this website. And all the questions on this website are custom-made, so you won't find them anywhere else. But now let's have that practice question. Our question today is, which of the following is not a type of rule you can create in Microsoft Fabric Activator? A. Event-based rule, B. Schedule-based rule, C. Object property rule, D. Object event rule. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B, schedule-based rule, because every other rule type we can actually configure in the Activator, but the Activator is not a tool for scheduling, and that we can done in the individual items. Remember that in the theory section we talked about these 3 different types of rules that were event-based rules, object property rules, and object event rules. This is the episode 26 in the DP-700 exam prep series, and in this episode we will cover monitoring. We have already touched this topic a bit in the previous episodes, but in this episode we are going to really focus on this topic to really understand the different monitoring features in Fabric. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in the episode so that you can test your knowledge. But now let's get started. Let's first talk about the monitoring hub in Microsoft Fabric, since it is probably the most common place or feature that comes to mind when someone mentions Microsoft Fabric monitoring. Also, monitoring hub is a very important part of the DP-700 exam. If you have been using Fabric at all, you most likely have noticed that compass icon in the sidebar and maybe even clicked it, which will then take you to the monitoring hub. Basically, monitoring hub is a central built-in dashboard that tracks recent activities across entire Microsoft Fabric tenant. So from here you can see activities that are happening and have happened in all the workspaces you have access to. Monitoring Hub will then help you to track runs, check for errors, and understand what has recently happened. From this hub, you can easily filter, sort, and even drill down the runs and activities that you are interested in. Also, a good thing to note is that Monitoring Hub view can be customized, and you can add many new columns to the view that are not there by default, but could be useful to have. This is something that we are going to check out in the demo section more closely. But what exactly is monitored here? If we think about Monitoring Hub in the context of DP-700 exam, most of the data engineering tools can be monitored here, like data pipelines, Dataflow Gen2s, notebooks, Spark jobs, and semantic model refreshes, and also many other items that are not part of the DP-700 exam. However, it is good to highlight that event streams can't be monitored here, at least not at the time of recording this video. Then what about permissions related to Monitoring Hub? Any Fabric user can use the Monitoring Hub, however, the Monitoring Hub displays activities only for Fabric items you have permission to view. Next, let's talk about the capacity metrics app that is probably not as important to know in the DP-700 exam than Monitoring Hub is, but it is good to know what this is all about. So, Capacity Metrics app is a Power BI app provided by Microsoft That allows you to monitor Fabric capacity and storage usage. And like said, you have to install this app, which will then create a new workspace with the semantic model and a default report that gives you the view that we can see here. Also, it would be possible to create your own reports on top of the semantic model if you so desire. But I think the default report is already quite good, and they also keep updating it with new features. So, with this app, you can monitor your capacity consumption and then make decisions like scaling up or down your capacity based on the metrics. A good thing to note is that the data in the semantic model is refreshed automatically once per day at midnight. However, you can trigger refreshes manually or via API, like using a refresh semantic model activity in a Fabric data pipeline. So, what exactly is monitored here? The most common thing is the capacity consumption all the way to the item level, since here we can see how much capacity units each item is consuming, which can be very helpful information to identify poorly built data pipelines or other solutions that are not very capacity optimized. Then from the same report, we can get information about storage consumption, since that will generate costs as well, so we can see how much data we have. Then there is this relatively new feature that enables separating Spark compute from the capacity to its own compute pool, which means that it wouldn't consume the same Fabric capacity as the other items, and it would be built separately. This feature would have to be enabled per capacity, but if we have enabled that, then we would be able to monitor Spark compute here as well. Then a bit about the permissions related to this monitoring feature. To be able to install this app, you have to be a capacity admin, which means that you have to be an admin of at least one capacity. Then you would be able to use this app to see metrics for capacities that you are admin of. Like said, this capacity metrics app is not a super important part of the DP-700, but it is good to know that there is this possibility to monitor Fabric capacity and storage consumption. Next, let's cover workspace monitoring that is currently not part of the DP-700, but I imagine that it will be added to the exam quite soon, and that's why I want to cover it here, so that this series won't be outdated soon. Also, it is always nice to learn something extra that you can use to impress your colleagues at work. So, to enable workspace monitoring, you have to go to Workspace Settings, and there you can find this Monitoring tab, and there you are able to create the Monitoring Eventhouse for the workspace. This will then create some new items to the workspace. One event stream called Monitoring Event Stream that collects data about the workspace, and then Monitoring Eventhouse and Monitoring SQL Database to that Eventhouse, to which the event stream writes the workspace log data. And there are many different tables for different types of log data that is written to the SQL database. So, to summarize a bit, workspace monitoring is a mixed Fabric SQL database that collects and organizes logs and metrics from a range of Fabric items in your workspace. Also, it is good to note that you can't modify these monitoring items since they are read-only. Then you can query the SQL database to gain insights into usage and performance of your workspace. However, at the time of recording, workspace monitoring monitors only a very small subset of things, and those are Eventhouses, mirror databases, semantic models, and GraphQL operations. What comes to permissions, workspace admins can enable workspace monitoring for a workspace they are admin of, after it has been enabled by Fabric admin in the admin portal. So if you don't see this option in your workspace, then check from the admin portal has it been enabled. And then for accessing the data, at least contributor access to the workspace is required. And as a last point, I want to highlight that these monitoring items, meaning Eventstream and the Eventhouse, consume the same Fabric capacity as your workspace. So keep this in mind that workspace monitoring can eat up quite a significant portion of the capacity, since Eventstream and Eventhouse are quite capacity heavy items. Then a bit about admin monitoring workspace that we have already talked about in a previous episode in this series. To recap, the admin monitoring workspace is a specialized environment designed for Fabric administrators to monitor and manage workloads, usage, and governance within their tenant. The workspace itself contains few pre-made reports that can be used for monitoring. The admin monitoring workspace is automatically available in Fabric and it is installed the first time it is accessed. So you don't really have to do much to get started with admin monitoring, and basically you just have to open it once and then Fabric will set it up for you. Data is then automatically refreshed once per day around the same time that the workspace was installed for the first time. Also, it is good to know that the first data refresh begins around 5 minutes after the workspace is installed and usually completes within few minutes. Via Admin Monitoring Workspace, you can monitor many things like usage and performance, like for example how many users have been using some workspace and how many activities have been happening in a workspace. This could, for example, help to identify workspaces that are no longer used. Then we can get information about workspace items, like how many items there are in a workspace and who owns those items and how many users have access to those items. Then also some governance and security information is provided here. This includes things like using domains and endorsements and security labels in your tenant. Like said, this workspace needs to be installed before it can be used, and Fabric admin role is required to do this. After that, access to the workspace can be granted to other users than admin by using workspace and item level accesses. Next, let's talk about monitoring a warehouse and SQL endpoint, since this is an important part of the DP-700 exam. Some warehouse and SQL endpoint monitoring can be done via capacity metrics app that we already covered, but there are other ways and methods that can be used for monitoring. Let's first talk about monitoring connections, sessions, and requests, meaning the users and entities that are connected to warehouse and things they are currently doing there. For monitoring those things, we can use Dynamic Management Views or DMVs. There are 3 different DMVs that are provided automatically for warehouse and SQL endpoint that you can use to get insights you need. They are all found in SysSchema that is created automatically with warehouse and SQL endpoint. First, we have DM-exec connections that gives information about each connection that has been established. So this view gets you connection information like IP addresses, is the connection encrypted, and what is the connection protocol, and so on. Then we have DM-exec sessions that tells information about each session that has been authenticated. From this view, you get information like the login name of the user, status of the session, meaning that is it actively doing anything or just sleeping, how much memory and CPU the session is using, and so on. Then lastly, we have DM-exec requests that gives information about the active requests that the sessions are doing. For example, what type of SQL queries are being run at this moment. All of these views have relationships between each other, since first you have to establish a connection to the data store, and after that you can authenticate and start a session, and when you have a session you can start doing requests, meaning querying and using the data store. Here we have an example query that will join data from 2 different views, connections and sessions, to show more detailed information about connections like the user who has established those connections. Then here we have another example about finding long-running queries that could be eating a lot of capacity. First, we would use the requests view to identify those, and then after we have found a long-running query, we could use the session ID that we got from the first query and then filter session view using it to get more information about the user running the query. Then also it is good to know that we can use kill command then to terminate and end the session so that the request or query will stop running. Then a bit about access related to these views. A workspace admin has permissions to use all 3 views and see all the information there. A member, contributor, and viewer can only see their own information when querying DMVs. Also, when sharing a warehouse, there is a possibility to grant access to DMVs by giving a monitor permission as an additional permission. Then lastly, the usage of kill command is only for workspace admins. Next, let's talk about monitoring queries and past sessions. For this information, we have a dedicated query insight schema that has 4 views that can provide information about past and active queries and also about past sessions. First, we have exec requests history that provides information about each completed SQL request/query. Here you find the exact queries that were executed and who has executed those queries. Next, we have exec sessions history. That tells information about completed sessions. And now I want to highlight that both of these views are for looking at past data about sessions and requests. The views that we covered on the previous slides were for looking at current data. So if the exam is talking about current connections and sessions, then the answer is one of the DMVs in the sys schema, and if talking about past activity, then the answer is one of these views. Just keep this in mind in the exam. Next, we have long-running queries view that tells information about query execution time. Here you are able to see how many times a given query has run and how long the latest run has taken and what has been the median for all the runs. Then lastly, we have frequently run queries view. Like the name implies, this view tells information about frequently run queries. This has some duplicate information with the previous view, but a bit more detailed statistics about the past executions, like min and max execution times and how many times query failed, etc. Also, it is good to note that at least at the time of recording this video, these views store data for past 30 days. And here we can see a few examples how these views can be used. For example, identifying queries that you have been running in the last 30 minutes, or identifying queries that consume a lot of CPU, or identifying long-running queries based on the substring. Also, a good thing to note is that it can take up to 15 minutes for completed queries to appear in the query insights. So if you can't see your queries immediately there, wait a moment. Then about access and permissions, Workspace Contributor or above is required to use these query insight views. Also, there is an additional permission when sharing an access to Warehouse that can grant access to query insights and also to DMVs. Currently, this is only available for Warehouse and not for SQL Endpoint. Also, there is a way in the Fabric UI to access query insight information. When using Warehouse or SQL Endpoint, there is this Query Activity button in the top bar. Clicking that button will open this view where you are able to access the same information that those Query Activity views have. Important thing to note is that this view is only available for Workspace admins, even though information in the underlying views is also available for contributors and members, and also with that special item level permission that is available for Warehouse. I think the reason for this could be that in this view you are able to cancel query runs as well by selecting an active query and then clicking cancel, but this is just my speculation. This was the last slide in the theory section. Next, let's go to Fabric and do a demo about these monitoring features there. Now we are in Fabric and I have my DP-700 tutorial workspace open here. To this workspace I have created a new folder, and in this folder I have a bunch of items. These items are actually part of this data solution that I have built for this tutorial, so that I can demo some monitoring here. I can quickly show you what these items do on a high level and how they are part of this data pipeline. Here we can see the data pipeline that these items are doing. In this data solution we are fetching data from this Pokemon API using a notebook. With that notebook, we write the data from that API to Lakehouse's file section as JSON files. Then we have another notebook that processes those JSON files to a table format. And then we have a data pipeline copy activity that copies data from the Delta table in the Lakehouse from a warehouse staging table. From that staging table in the warehouse, we then move data to this reporting table using a stored procedure. And then we have this view on top of that table that is used in the semantic model and then in the report. And here we can see how does that data pipeline look in the data pipeline UI. And I can basically open that same data pipeline here, that is this load Pokemon data. And here we should see these same activities here. But yeah, the point here is not to dive too deep into this data solution, but just see how this looks via Monitoring Hub. Since I have scheduled this to run every 15 minutes, so we have quite many runs for this solution. Next, let's go to Monitoring Hub and let's check out how we can see this data pipeline there. And we can open up the Monitoring Hub here in the sidebar. And here in the monitoring hub, we can monitor the current and the past runs for that data pipeline. We can see that now we only see some succeeded runs here and we don't have any runs currently running here. But for example, here we could monitor the latest run for that pipeline, which was this run here. And we can click this to get more information about the run. So here we have, for example, that data pipeline. And then if we click this, we go to the execution of that data pipeline. And here we can see that all the steps in the data pipeline have went through fine. And here we are able to get more information about the individual activities that happened in this data pipeline. For example, if we want to check out what happened in this notebook, this fetch Pokemon data, we can actually click that activity here in the activity list, and then we can open up this notebook snapshot URL. And this will actually take us to the notebook execution log. And here we are able to see what happened during the execution of that notebook. For example, if we had some print commands or something like that. For example, here we can see that we passed some parameter from the data pipeline to this notebook, and then we had some code here, and that code executed, and here we can see the prints that this code produced and said all Pokemon pages processed. But yeah, here is some information that we can get about that notebook execution, and then we can go back to the pipeline view. And about the pipeline activities, we can usually get more information about those by, for example, if we have this copy data activity here, we can click this copy data activity here in the list, and this will tell us some information about that copy data activity. And for example, here we can see that we read one file from the Lakehouse that was basically the delta table, and then we read a little bit over 1000 rows from that table, and then we wrote those rows to the warehouse table. And here we can see more information about this copy data execution. That could be interesting in some cases. For example, if something has gone wrong, you could use this information to investigate what happened here. Also in this view, we can open up this Gantt view, and here we can see visually how long each activity took. So we can, for example, identify some bottlenecks in our data pipeline. But yeah, let's close that view. Also, these inputs and outputs are also a very important part of investigating issues with data pipelines, because here we can see what kind of inputs are going into the activities. For example, here we can see that we are passing there a parameter, and then we're also using a session tag there. Then we have also these outputs that provide information about the outputs of the activities. And you can use these inputs and outputs to determine more what happened during the pipeline execution, especially in cases when something went wrong. Also, from this view, we can actually rerun the pipeline by clicking this rerun button here. And we have here also other possibilities for rerunning. For example, if this pipeline would have failed, we have the possibility to rerun from failed activity or rerun from a selected activity. But now let's go back to the monitoring hub. Here in the monitoring hub, we can actually filter this table that we have here. And here I have actually already applied one filter, and I have filtered only the runs that I have triggered. Then we have also the possibility to filter by status. So for example, we can filter only the failed runs that we have here. And these failed runs happened because I had my capacity paused during the night. But yeah, you would be able to filter different types of statuses here. Then we are also able to filter by item type, and here actually we can see all the items that are currently supported by the monitoring hub. Here we can see that we have a bunch of different items that are supported here. Then we can also filter by start time. Then we are also able to filter by location, meaning the workspace. Then we can also customize this view like I talked about in the theory section, and we can add some new columns here. For example, if I want to have the capacity information here, I could add that, and then I would click that apply, and now I have this capacity column here, and now we are able to tell which capacity is used for executing that specific item. And now we can actually see that we have the next iteration of that Pokemon data pipeline running there, and it is actually already running the fetch Pokemon data notebook there. And now let's talk about the workspace monitoring. That can be enabled from the workspace settings and going to this monitoring tab. And here you are able to enable the workspace monitoring, and I have actually already enabled it for this workspace. After it has been enabled, 3 new items are created to the workspace. We get this monitoring event stream that collects the log data from this workspace. And then we have the monitoring event house, and there in that event house we have this monitoring KQL database. And we can open up this monitoring KQL database and check out that. And here we have these different log tables that collect data from those supported Fabric items. For example, a semantic model logs can be found here. But remember that at the time of recording this video, this workspace monitoring only supports a small subset of Fabric items. And this is not a comprehensive Fabric monitoring, at least not yet. And also an important thing here is to remember that these workspace monitoring items consume the same Fabric capacity as the workspace. And because we are using Eventstream and Eventhouse, this could be a significant portion of your Fabric capacity. But keep this in mind. Next, let's talk about the Fabric Capacity Metrics app. And remember, this is a Power BI app that you have to install. And I have already installed that, and here we can see that Fabric Capacity Metrics semantic model, and then I have this Fabric Capacity Metrics report. That is this default report that Microsoft is providing and updating. And in this report, we can see a bunch of information about the capacity. And here we can, for example, see all the way to item level how much capacity each item is consuming. And here I can only see the capacities that I'm admin of. And here we can see that now I'm using this F4 capacity, and average utilization is around 50%. So here we are basically able to get a lot of information about the capacity usage and are we over or underutilizing our capacity. Then on this same report we are able to get information about storage so that we can see how much data we have sitting in our environment. Then we have also a tab for that autoscale compute for Spark if we have that enabled, but I haven't enabled that for my capacity so that we cannot see anything here. Next, let's talk about the admin monitoring workspace. And here I have the admin monitoring workspace open, and here we can see that in that workspace we have 3 different semantic models, and then we have 3 different reports. And these reports here tell us information about our Fabric environment. For example, here we can see some item information about this environment, and actually I'm now filtering with the capacity here so that we cannot see everything that is in this Fabric environment. And then we have these other reports here like feature usage that tells information about the Fabric environment as well, and then also this purview hub that tells information about some governance features in this Fabric environment, like about using sensitivity labels, endorsements, domains, and etc. As a last thing in the demo, I want to talk about monitoring warehouse and SQL endpoints using those views that we covered in the theory section. We can start with those system views that we have here, those connections, sessions, and requests. We can check out what kind of data we have in those views. For example, here we can see the connection view, and here we can see a bunch of information about the connections that have been made to this warehouse that are currently there. There we can find things like about the protocol and IP addresses, etc. Then we have the session view, and in this session view we have more information about the users that have authenticated to this warehouse. For example, here we can see my name that I have authenticated to this warehouse. Then lastly, we have the requests view, and here we can see more information about the things that are running in this warehouse. Here we can see that there are many background tasks that are currently running. And actually I have authenticated to this warehouse by using my second account, Aleksi Partanen 2, and I'm currently running a query to this warehouse here, and I'm using this wait for delay command that is basically running this query for 30 minutes. And we can check out how we can see this request/query that is currently run by this other user. For that, I have prepared this SQL command that is combining data from those 3 different views. So first we are joining connections to sessions, and then we are joining sessions to requests. And we are also filtering by session status is running, and then the login name is my second account. So let's run this and let's see what kind of information we get. So basically we get the connection information from the connection table, then we get bunch of session information, and then we also get information from the request table. So we get the command that is being ran, and there we can see that we have this wait for command being ran by that account. And actually, here we have that session ID now, and we could actually use the kill command and kill this session, and we could see what happens in the management studio if we kill that specific session that is running that specific command. So we run this kill 207 session, and let's run this. And now let's check out the SQL Server Management Studio, and we can see that we got this error message. And now we could actually start to rerun this same query here. But yep, let's leave that running. Then, if you remember from the theory section, we also had those query insight views, and we had 4 of those. So in the query insight schema, we have those requests history, sessions history, frequently run queries, and long running queries. And here we can see, for example, the request history, and here we have some historical information about past requests / queries that have been done to this warehouse. And then we have the session history, and here we have information about past sessions that have been happening in this warehouse. And in this frequently run queries view, we get quite a lot of detailed information about queries that have been running in this warehouse. For example, here we get the number of runs for some specific query, and we get like min and max duration for that query and also the average duration. And then we also get number of successful runs and number of failed runs, a number of cancelled runs, etc. And then finally, we have this long-running queries view that has some same information as the frequently run queries, but actually a little bit less information here. And like discussed in the theory section, for workspace admins, we have this query activity tab here that provides same information that we can get from those views, but via Fabric UI. And for example, here we can see that query that is being run by the second account. We have also information about long-running queries and frequently run queries. This is a great place if you would need to think about optimizing some queries or data solutions. You could find information about queries that are being ran and maybe check out that is there a room for optimization of those queries. And here, like I said, we can also cancel queries. For example, we can cancel this query that is being ran by that second account. So if I click this cancel, then we should see that same error message pop up again here in the Management Studio. And here we have that same error message. And now let's again rerun that. So that's running again there. And now we should soon see that in here as well, since I started that again. And here we can see that now the query is again running. Next, let's have a couple of exam-like questions about the topics that we covered in this episode so that you can test your knowledge. But before we do that, I would like to tell you about this website called certiace.com that offers free practice questions to certification exams like DP-600 and DP-700. All the questions on this website are custom made, so you don't find the same questions anywhere else. And I'm actually one of the co-founders of this website. But now let's have those practice questions. Let's have our first question. You need to investigate performance issue in a Fabric warehouse. You want to identify problematic queries, review their minimum, maximum, and average execution time and failure count, use built-in system view without writing complex joins. Which of the following should you use? A. sysdm exec requests. B. Query insights frequently run queries. C. sysdm exec sessions. D. Query insights long-running queries. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B. Query insights frequently run queries, since this view has all the information that you are looking for. Option A is incorrect, since this view contains information about active requests / queries, and we are not able to do analysis from those. Option C is incorrect, since this view gives information about sessions and not queries, and also it gives information about current and not past data. Option D is also incorrect, since it doesn't provide all the information that we're looking for here, since it doesn't have those minimum and maximum execution times and failure counts. Let's have another question. Which of the following statements about the monitoring hub in Mux Fabric is true? A. Only capacity admins can access the monitoring hub. B. It allows filtering by workspace, status, and item type, but not by user. C. The monitoring hub can be used to monitor Fabric capacity usage in detail. D. You can monitor Spark job runs from the monitoring hub. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, since Spark Job is one of the supported items for monitoring via Monitoring Hub. A is incorrect since you don't need to be capacity admin to access Monitoring Hub. B is incorrect since filtering by user is supported. And C is incorrect since you can't really monitor capacity usage there, and better place to do that is the Capacity Metrics app. Before we end the video, there are a few additional things that I want to mention that can help you to prepare for taking the exam. Firstly, I want to say that the exam scope doesn't stay static, and Microsoft will update it after I have released this video. Thus, I would encourage you to check out my DP-700 playlist that can be found in the description. To that playlist, I will be adding additional episodes that continue this series after Microsoft has updated the exam and added new tools and topics. Next, I would encourage you to join my Discord server. There you can connect with other people taking the exam and people who have already taken it and passed it. And also you can connect with other experienced Fabric professionals. There you can find help with things and topics that are not clear to you. Then also remember to check out my CertiAce platform that can be found at certiace.com. On that platform you will be able to benchmark your knowledge with high-quality custom-made practice questions. Then I have also added some recommended courses to the description that can help you to prepare to DP-700 and learn more useful data skills. So check out those as well. And I want to remind you that if you join as a channel member, you get a lot of perks. And one of those perks is a bonus DP-700 episode where I cover very valuable tips and strategies for the exam. That could give you many extra points and make sure that you don't fail the exam to time management issues. Also, the channel members are able to download all the slides that I have covered in this video. Also, it is always nice if you mention and tag me on LinkedIn and other platforms if I have helped you to pass the DP-700 exam. This will help my channel grow and keep me motivated to produce more quality free content about Fabric. And lastly, I want you to know that I spent hundreds of hours of my free time during the last 6 months making this course. So it would be very nice if you hit that like button and subscribe to the channel for more Microsoft Fabric content. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. But now I wish you a good luck for your DP-700 certification journey and see you in the next video.